Hello and welcome, I'm your Code Monkey. Welcome to my complete free C# course. By going through this course, you'll be able to make games, websites, apps, robotics, and literally anything. C# is an extremely versatile language. Here we're going to learn everything about the language itself. We're going to start with the beginner section, focusing on the absolute basics, like how code executes line by line and what is a variable. Then we're going to cover some intermediate topics, things like what are interfaces, generics, and events, and how you can use them to build some really awesome things. You'll also learn the theory behind how to choose good naming rules, clean code guidelines, and learn about design patterns. And finally, in the advanced section, on that one, we're going to cover some very interesting topics like reflection, async programming, and multithreading. So in this course, I did try to cover pretty much everything related to C#, everything from beginner to intermediate to advanced. In total, this complete course, there are 97 video lectures. Then the companion project, that one has 587 frequently asked questions, 567 quizzes, and 177 interactive exercises. This really is very complete. I put my 10 years of C# knowledge in this one course. If you know absolutely nothing about C# and you go through this entire course, and you do that, going slowly, bit by bit, making sure you understand everything, every step along the way, if you do all of that, then by the end, I guarantee you will have gained an awesome new skill set. You will have knowledge to build pretty much anything you want. Personally, I really love C#, it's a really great language. I love the syntax, and I love how it can be used for literally anything. So I think it is a very valuable skill, and I really hope this video helps you a lot in your learning journey. This free YouTube video contains all the video lectures for all the sections, so the beginner, intermediate, and advanced. Like I said in a previous video many months ago when I first announced this course, back then my goal was to publish the video lectures here for free if the premium version sold a certain number of copies, and I'm happy to report that it has indeed passed that threshold. That's why this massive video is available for free right here. So thank you so much for everyone who can afford and who did buy the course. You are the reason why so many people can access all of this awesome knowledge completely for free. The premium version of the course has all the video lectures for all the sections, as well as a bunch of nice bonuses. So speaking of that, here are the bonuses in the premium version. I came up with some that I think are really awesome and definitely worth it if you can't afford them, while at the same time not putting any knowledge behind the paywall, so even people who can't afford it, they can still learn from the free video lectures. They really just need to do a little bit of extra work themselves. The premium version is really just selling convenience, making it really easy for you to truly gain the knowledge. The premium version comes with a companion project. This is a Unity project that contains a bunch of extra content. Basically, the video lectures, while being pretty massive themselves, they're still really only half the course. The other half of it is inside of this project. It has a bunch of custom edited windows to guide you through each lecture, and each lecture has a section on frequently asked questions. These are common questions that have some really detailed answers that provide even more details on what is covered in the lecture. Then there are some quizzes. These are multiple choice questions, again, all with very detailed answers. It's really not just correct or incorrect. If you pay close attention to each lecture, you should be able to get most of these right. But whether you do or don't, by reading the extra explanation that will help you truly learn that topic. Then the interactive exercises, I'm really happy with this feature. I think this will really help you learn. Learning by doing is always much better. And these exercises encourage you to put what you learned into practice instead of just blindly watching the video lectures. I designed a ton of handcrafted exercises for all the lectures to help you put into practice and truly learn the contents of each lecture. There are all kinds of exercises. Some are about spotting and fixing errors, others are about asking you to define some function or class or implement some kind of logic. There are some where you just write code, and some where you write code and then play the code in Unity in order to complete the exercise. Then each exercise also contains a hint just in case you get stuck, or a solution in case you get really stuck, as well as a video walkthrough of me going through that exercise and completing it while explaining everything in detail. So if you're the kind of person who gets stuck in tutorial hell, then I truly believe that this will really help you escape it. In order to learn, you need to actually do things, and these exercises encourage you to do that. They encourage you to do it as opposed to just blindly watching the video lectures. Then the companion project also has a companion window. Basically, this window is also listening to a bunch of errors, and if it finds one, it will help guide you in the right direction. I manually wrote a ton of text for when it detects lots of errors, all of them based on common errors that I see people ask about in comments in my own videos. So this should help prevent you from getting stuck in your learning journey and allow you to get help instantly. Then the course also has an AI to help you answer questions. This one was trained on the contents of the course and my own knowledge, so it should be very accurate and helpful. But more than that is simply the fact that it is extremely fast. You post a question in the course comments, and within a few minutes the AI will respond with probably a very good answer. Although of course, I myself will also still be answering all the questions manually. The goal with this AI is really speed, so you get a response almost instantly, and then within the next few hours I will manually answer myself. Then a simple bonus is how the premium version has the course split into lectures, as opposed to here on YouTube where it will be one giant video. It has to be that way due to how the YouTube algorithm works. This is a small thing, but it can be helpful, especially if you take your time to slowly go through the course just like you should do. Remember that the only goal is really that you are actually learning yourself. It does not matter how quickly you go through it. So separate lectures help with that so that you can pause and actually try out your knowledge before going further, and you don't have to memorize specific timestamps. And over here on YouTube, the videos have the normal YouTube ads as usual, whereas the premium version has no ads, so there's nothing to interrupt you while you're learning. Another two great bonuses is the private Discord and the live study group. You get access to a private Discord with a really nice community of people on their own learning journey. I'm there myself as much as I can to answer questions or really just chat. And every week I also do a private live QA. You can join me on the live stream and ask anything you want, and I'll do my best to help. So these are the nice bonuses that I came up with that I think are really nice and really awesome while not taking away anything or putting any knowledge behind the paywall. If you can't afford it, then I highly recommend the premium version. These bonuses will help you truly learn, and learn much faster than the 10 years that it took me. But if you can't afford it, that's okay. Like I said, there's no hidden knowledge hidden behind the paywall. You really just need to put more effort in yourself in order to actually apply the knowledge that you gain. So whether you get the premium version or watch the free lectures, I really hope you learn a lot. But back to this free YouTube video. Like I said, if you can't afford the premium version, then that's fine. The premium version is mainly for convenience. It is great if you can't afford it, but it's not required. There's really no knowledge hidden behind the paywall. All the knowledge is contained over here in the video lectures shown in this free video. At the end of every lecture, there's also a really nice slide that contains the titles for the frequently asked questions, the quizzes, and exercises. On the premium version, you can just easily go through those in the companion project. It's all pre-prepared for you to make it very easy to test your knowledge. But again, if you can't afford the premium version, then that's fine. You can use those, you can use that last slide as a guide. So look at all the titles and basically guide yourself to find the answers to these questions and manually do all the exercise. I highly encourage you to do this to make sure you're actually learning. You'll learn if you actually put in the effort, so make sure you do it. Also, just in case you're new to my channel, so a bit about me and my credentials or why you should listen to what I have to teach. For me, I've been programming for over 25 years and specifically using C# for over 10 years. I'm a professional indie game developer with several successful games published on Steam covering a wide range of genres. My games are usually focused on complex systems since I am primarily a programmer. It's what I really love to do and what I love to teach. Also, a couple of years ago, I started over here this YouTube channel making free video tutorials to basically share my knowledge to help you learn how to make your own games. There's already over 800 free videos over here on this channel if you want to continue learning beyond this course. Or look at my other courses. If you want something on making a specific game, you can watch my free Kitchen Chaos course. In there, we build a game from start to finish, and then on a second video, we add multiplayer onto it. Then for something more intermediate, for that, check out my turn-based strategy course. This one includes a really nice turn-based strategy game with actions and enemies and all kinds of things. Or if you're an advanced user, if so, then check out my Unity Dots course. Unity Dots is an extremely powerful, very advanced toolset that can help you write code that runs literally 100x faster. Or in general, for Unity, you can check out my Ultimate Unity Overview course. This one covers over 70 tools and features that Unity has. Also, even though this video is for advanced users, let me reiterate my usual advice for pretty much anyone trying to learn. That's really just take your time, take it slow. Remember, this is your learning journey, it's really no one else's. So the only thing that matters is that you learn. It does not matter how long it takes you. It does not matter if someone else learns faster. You're really not in competition with anyone but yourself. Remember, you are not expected to go through this entire course in 1 week or even 1 month. Like I said, this course contains knowledge that took me over 10 years to gather. So take it slow, take your time, really just focus on learning. And just one final request, if you find this video helpful, if it helps you on your learning journey, if so, go ahead and hit the like button on the video and subscribe to the channel. It's a tiny thing, but it really does help. Alright, so let's get to it. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to see a quick overview of the entire course from start to finish. Alright, so here's every lecture and what we're going to learn in each of them. Starting from the very beginning, first we're going to learn what is C# and what are the many use cases for it. Then on the Getting Started lecture, we're going to install Visual Studio, which is where we're going to run our code. Then we're also going to install Unity and learn the Unity basics. This is an optional step, but it's important since the interactive exercise and quizzes, those exist in a Unity project. After that, we're going to load up that project to see how the interactive exercises work, and then is a really useful lecture covering some very common errors. You should refer back to this one whenever you encounter some issues. After that one, we can finally start writing some code, beginning with the absolute basics, learning how the code is written, how it executes, what is a code block, and how code is case sensitive. Then we're going to learn about variables. These are containers for data. The data needs to have a specific type, so then we're going to learn about the various built-in data types, things like int, bool, string, and so on. Next, we're going to learn about if statements. This is a core pillar of any programming. These are conditions which affect how your code will execute. After that, we'll learn a different way of handling conditions using a switch statement. Next, we'll learn about another core pillar, functions. This is how we can place logic in separate functions and call them when needed. After learning about functions, which involves different code blocks, then we are going to learn about variable scope, which is basically from where that variable can be accessed. Next, we'll learn about comments. The syntax for this one is actually really simple, but it does bring up a lot of interesting questions regarding writing good, clean code. Then we're going to learn how to store, multiple pieces of data in one container using arrays and lists. Afterwards, we're going to learn all about loops. This is how we can run certain logic multiple times, like for example looping through all members of a list. Then another crucial pillar of object-oriented programming, we're going to learn the basics of classes, how to define one and construct it. Next, we will be ready to learn about static, what is the difference between making something static and non-static. Then learn about access modifiers. This is another one that is super simple in terms of syntax and extremely important in terms of learning to write good clean code. After that comes one of the most important lectures in this whole entire course. It's a lecture on naming rules and how you should be very careful and very deliberate about the names that you use in your code. And after that is yet another extremely important lecture, this one covering the theory behind why you should write good clean code, as well as some nice simple guidelines that you should follow. With all that done, we will have learned the absolute basics, so we will be ready to inspect a nice beginner project that involves everything we learned in this section. All of that makes up the beginner section, and afterwards comes the intermediate section. We're going to take things up one level and learn some more complex stuff, beginning with something very important that I debated whether I should put in the beginner section. It's going to be Visual Studio Shortcuts. I end up putting it here because for beginners, technically it's more important to learn how to write the code, and it's not as important to be extremely efficient with how fast you use your IDE, but for intermediates this is a must-have. So we're going to learn about a ton of shortcuts to help you write code and navigate your environment much better. Then comes one of the most important lectures in this whole intermediate section. It's all about refactoring. This is the process of rewriting your code to make sure it is as readable and understandable as possible. As an intermediate, you absolutely need to know that this is a natural part of the code writing process and something you should not skip. Next is a lecture on enums. Pretty simple and very useful. It's how you can define a specific list of values that you can use in many ways. After that, we'll learn about properties, which are kind of like a mix between variables and functions. Then we're going to learn about multidimensional arrays, meaning arrays that can hold multiple dimensions of data. After that, we're going to learn about nested loops, which is especially important in order to cycle through multidimensional arrays. Next, we're going to learn another method for doing some looping logic. We're going to learn about recursion. This is something that, for people with a math background, it might actually be similar to understand than regular loops. Then we're going to learn about an extremely useful data type, the dictionary. This is a key-value pair that has tons of really awesome use cases. After that, we're going to learn about some more collections like queue and stack. Then we're going to learn about the params keyword and what exactly does it do in a function. Next, we'll learn about optional parameters, how to define them and how to call them from a function. Then another crucial lecture for intermediates. This one is on learning the differences between value and reference types. This is extremely important. If you don't know this difference, then you will go crazy at some point in the future, wondering why something isn't changing, and it's usually going to be because you don't know you're working with a copy and not a reference. Related to that is the lecture on structs. These are similar to classes, but importantly, they are a value type. Next, we're going to learn some more intermediate use cases for classes. We're going to learn about inheritance, polymorphism, and a bunch more. Then learn about interfaces. This is one of my favorite features of C#. It allows you to write some really nice modular code. Related to that, we're going to see various ways of testing for types and converting to and from various types. Also related is the lecture on switch pattern matching. This is a really simple way to do a switch, not just on value, but also on type. Then we're going to learn all about delegates, lambdas, and anonymous functions. This is how we can store a function itself inside a field. Next, we're going to learn the differences between lambdas and local functions. After that, we'll learn about events, which is how we can have one class be notified when something happens. Then the next lecture, that one is going to be all about generics. This is another super powerful C# feature that makes your code work with multiple types. Next is a simple lecture on constants and read-only, what they are and what are the differences between those two. After that is a lecture on exceptions and how to handle them with a try-catch. Then a lecture on implementing IEnumerator, so we can add support for something like a for each for some custom types. Next, we're going to learn about namespaces, what they are and how to make your own. Then a really important lecture on one of the most important design patterns, the Singleton Pattern. And after that is a general overview of a bunch more design patterns. And finally, after doing all of that, we're going to check out the intermediate project that uses all of this to make something really interesting. That concludes the intermediate section, and afterwards comes the advanced section. This one covers lots of interesting C# topics. We're going to start off with an interesting advanced topic that I actually only started seriously using just recently. It's reflection. I had to learn this myself in order to make the exercise for the companion project. Reflection is how you can dynamically inspect your code and work with it without directly calling any functions or reading any fields. Next is going to be a simple but interesting one. It's how you can make some function extensions. This allows you to extend a type with more functions without having to modify that type itself. This is really useful when you don't have access to the type itself, when you don't have source code access. Then we're going to learn about static constructors. These are kind of like the normal constructor, but they run just once for the entire class. After that, we're going to learn about the typeof keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then a lecture on nameof. This one helps you get a string name for some kind of type. This is really useful to help you avoid strings in your code. Next is the sizeof operator. This one lets you get the size of your types. Like for example, you can see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps you know how much memory your code will use. Then a lecture on default. Simple and very useful way to get the default value of some type. If you do the default of an int, you get 0. If you do the default of a bool, you get false. If you do the default of some object, you get null, and so on. So using this keyword is much better than hard coding some default values. After that, we're going to have a lecture on expression-bodied members. This is a really interesting, very compact way to write simple short functions. There's no need to write all the usual function boilerplate code. This one is basically just a lambda. After that, we're going to see a lecture on records. This is a super simple way to create immutable types to organize your data. Next, we're going to learn about the null conditional operators. This is how you can easily test for null before doing something, like for example, before firing off an event. Then a lecture on the Null-Coalescing Operator. This one lets you quickly test against null, and if it is null, return a default value. After that, we're going to learn about the Ternary Conditional Operator. This is an excellent, super compact syntax for making a very simple if. You have the condition with an if and an else, so it's all very tiny, very useful. Next, we're going to learn about the main function in a console app and how to pass in some command line arguments. This is a really important one because there are many interesting programs that you can build that don't need any kind of UI. So a simple console app that you can control with some command line arguments, that one is always going to be an excellent option. Then a lecture on Nullable. This is how you can make any type support null. Even value types like int or bool, you can make them nullable to support null. This can be much better than having to predefine some special value, something like -1. Next, we're going to see a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create a new object. This one is basically just a pointer, meaning it is insanely performant. Then a lecture on Bitwise Operators. This is how you can work with individual bits of data. In this lecture, I'm also going to teach the basics for how binary works. Next, we're going to learn about Enum Flags. This is how you can turn your enums into bit masks, which then allows you to make some interesting combinations. Then a lecture on Preprocessor Directives. With this, we can give orders to the compiler itself. We can define symbols and include or not include some code in the compilation. Next, a lecture on the keywords ref, out, and in. These are really useful. They help you get more data out of a function than just a single return type. And they also help you work with types as references, even if they are value types. After that, we're going to learn about data boxing. Now, this does not have anything to do with punching people. It's really all about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we're going to learn about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields on that type, on that object, even if they don't really exist. That validation logic is only going to run at runtime, not at compile time. So this dynamic, this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, you can make your own custom types, support access through an index, just like a list or array. You can add whatever logic you want and make it read-only or read-write. Next is a lecture on attributes. With this, you can add metadata to your code. Then that metadata can represent whatever you want. You can use reflection to analyze it and do something to it. After that is a lecture on anonymous types. Really interesting, quick way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that is the next lecture on tuples. These are very similar. They also allow you to organize some data without first defining a type. In this lecture, I also cover the differences between anonymous types and tuples. Next is going to be a lecture on using IDisposable. This is a really interesting code block and interface that helps you make sure you don't forget any kind of cleanup code. After that, we're going to learn how to create custom override operators. Using these, we can add support for our own classes to do things like addition or multiplication. We can define the logic of what exactly it means to add two custom player classes together, and also define the logic for comparing two custom types, meaning defining the logic for what exactly does it mean to do an equals. Next is a lecture on LINQ. With LINQ, we can easily do query operations on any collection of data, whether it be a list or array or some XML or some kind of database. We grab that data, then we can query for some conditions and select just a few elements. We can sort some things, we can do a union and so on. If you're familiar with SQL, then LINQ will be quite familiar. Afterwards, we're going to learn about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop the components. Here, I'm also going to talk about the other visual program tools, things like WPF and .NET MAUI, as well as how Unity itself doesn't have to be used just for making games. You can make normal applications with Unity. Next is going to be a lecture on DllImport, the library import, how to use extern and work with the Windows API. So this one is going to be a great lecture to learn how to interact with external libraries. Then a lecture on asserts and unit testing in general. With this, you can validate your own code to make sure everything is behaving exactly as intended. Next is going to be a lecture on writing unsafe C# code and working with pointers. Now this is a very, very advanced topic. Technically, if you know what you're doing, you can make some impressive stuff with unsafe code, but C# has a safety for a reason, so definitely only use this wisely. Then we're going to learn about asynchronous programming, specifically how to use async, await, and task. This is how you can have some code that takes some time, like for example, contacting a web server, and keep waiting for a response without blocking your program. This is extremely important in making sure your program feels nice and responsive. After that comes a super important advanced lecture. This one is all about multithreading. This is how you can take advantage of all the cores in the CPU to make them all do work at the exact same time. When done properly, you can get some insane performance improvements, but it is also very, very easy to make mistakes. So this one is very much a definition of an advanced topic where you must know exactly what you're doing. Alright, so that's everything we're going to learn in this complete C# course. Like I've said many times, you are not expected to go through all of this in just one day or 1 week or even 1 month. It took me 10 years to learn all of this, so always remember that and take your time and really just focus on actually learning. This is your learning journey, so that's really all that matters. Take it slow, really pay attention, do all the content in the companion project, and I guarantee that if you do that, then by the end you will have gained a massive amount of knowledge. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn what exactly is C# and what it's used for. Okay, so C# is a programming language. It was created by Microsoft in the year 2000. It is an object-oriented, general, multi-purpose language with tons of use cases. For me specifically, the main way that I use it is for game development with Unity, but you can also use it to make websites with ASP.NET or Blazor. You can use it to make native mobile apps with Xamarin. You can do tons of stuff in the cloud. It's especially easy to use with Azure, which is Microsoft's cloud service. You can develop on Internet of Things devices, or you can use it to make some simple desktop apps to help you in your daily life. You can make console programs or visual desktop applications. So it has tons of use cases. It is multi-platform, meaning you write C# and you can run it on Windows, Mac, Linux, and other platforms. The language is constantly evolving. Despite being 24 years old, it is still actively being developed with new versions coming out on a regular basis. It is also one of the most popular and in-demand languages, so it's a great one to learn. Personally, I also believe that it's a great first language to learn. I especially like how it's type-safe, meaning it has very specific types, and if you write some code incorrectly, you will get a compiler warning instead of having an error suddenly show up while the code is running. And if you're not a complete beginner, if you already know Java or C++, then chances are you will pick up pretty easily since it is relatively similar to those languages. So yeah, personally, I'm a huge fan of C#. I've been using it pretty much every single day since I started game development with Unity over 10 years ago. I've made tons of games with it, and I've also used it to make some personal desktop apps, and I also use it when I explore the cloud. So it is a great, very valuable language to learn, and if you pay close attention to this course, then by the end you will have gained a massively valuable skill. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to go over how you can get help when you need to, and how to get the most out of this course. Okay, so learning programming can be a little bit tricky at first, especially if you are a complete beginner. Right away, let me say that is perfectly normal. If you are a beginner and some things seem quite confusing, that is perfectly okay. That's all part of the regular learning process, so there's really no point in getting frustrated. Just take your time and really just focus on trying to learn. Here's also a quick guide on how to ask a good question. For example, do not just say it's not working. Just saying this is really not helpful. Technically, not working can mean a million different things. For example, do you have a compile error? If so, what exactly does it say? Specifically, what line of code is throwing that error? Or if it's not some kind of compile error, how exactly is it not working? So did you expect one result but got another? Did the code seemingly not run? Are you getting some different results from what you see in the video? In order for me to be able to help you, I need as much information as possible. There's really not much I can do to help if the only message I have is it's not working. So when posting some questions, be very specific about what exactly is the issue so I can do my best to help. Then there is a really important lecture covering a bunch of common errors. If you have errors in your code, chances are the error has an explainer in this lecture. Also, when you have some issues, the first step is to actually identify what exactly is the issue. And for that, the best way to find it is to add tons of logs in your code at various places to see exactly what the code is doing line by line. There are many cases when beginners think the code is doing something, but in reality it's doing something completely different. Adding logs is a super easy way to help you visualize exactly what the code is doing. Then you can post questions as comments in this video and I'll try my best to answer. I try to go through every question every single day. And then at the end of every lecture, there's a slide with the titles for the frequently asked questions, the quizzes, and exercises. These will answer many common questions that you might have. On the premium version, you can just go through those in the companion project. It's all pre-prepared for you to follow it and test your knowledge very easily. But if you don't have the premium version, that's fine. Here on the free version, you can use those as a guide. So look at those titles and guide yourself to find the answers to those questions and manually do those exercises. I highly encourage you to do this to make sure you're truly learning. Alright, so that's the many ways you can get help throughout this course. Just keep in mind what I said in the beginning. If you are a beginner, it's perfectly normal that some things seem quite tricky to understand. That's all part of the regular learning process, so don't get stressed about it. All that matters is that you'll learn. It really does not matter if it's easy or hard, if it's fast or slow. As long as you're learning, then you're doing great. Remember that I've been programming for over 25 years. So if you manage to get through this entire course and fully learn everything in it in just a few months, then you're doing so much better than me. So really just take your time, use all these tools at your disposal to really learn, and let's get started in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to install and set up Visual Studio, which is where we're going to be writing our code. Okay, so let's see where we're going to write our code. You can use whatever IDE you want. IDE stands for Integrated Development Environment. Some common examples for C# are Visual Studio Code, JetBrains Rider, or normal Visual Studio. You can follow this course using whatever IDE you want, but if you're a beginner then it's probably best to use the exact same as me. Here I will be using Visual Studio 22, the community version. This one is free. Also an important distinction, it is Visual Studio, not Visual Studio Code. It's a bit confusing how the names are very similar, but those are two completely different programs. Here I will be using the regular Visual Studio, so let's download it. Go to visualstudio.microsoft.com, then click on Downloads and download the free community version. Then go ahead and open up the executable file. After installing, right away it opens up the Visual Studio installer. This is the main program that manages all of your installed versions of Visual Studio. And right away we can install Visual Studio Community alongside a bunch of modules. Like I mentioned in the previous lecture, C# can be used for a lot of stuff, and in Visual Studio you can also develop on other languages, so here you can see tons and tons of modules. The ones that we're going to need in this course are the .NET Desktop Development. This will let us make console apps, which is the main template that we're going to use to learn C#, so make sure to include that one. And then since the interactive exercises, since those are built in Unity, also make sure to include game development with Unity. Okay, so these are the two main ones that we need, so let's go ahead and install. This will download all of the modules and install them. Okay, it's done and launches Visual Studio right away. Now it's asking for a sign-in. This can be useful to transfer your settings across devices. So if you want, go ahead and sign in or just click on skip for now. Then for the theme, again, you can choose whatever you want. Personally, I'm going to go with the light theme, which is what I like, but you can use whatever you prefer. And right away, let me answer the question that I inevitably get every time I say that I prefer the light theme when so many people seem to prefer dark theme. For me, my eyes simply get really messed up in dark mode. If I try focusing on white letters on a black background, I get a massive headache really quickly. So personally for me, I use light mode, but this is really just a visual change, so choose whatever you prefer. Okay, with that, let's start using Visual Studio. And yep, right away we can see the project list, although it's empty right now. We can open a project or create a brand new one, so let's do that. Then here we can choose the templates. Let's go ahead and make a simple console app, which is the most basic thing possible. So you can search for a console up here. And now, yep, it is this one right here, the one that has the C# icon in the corner. It is not this one with VB, that's for Visual Basic, and also not this one for F#, this is for F#, and it is also not this one that says C# but also says .NET Framework. It's a bit confusing, but .NET and .NET Framework, those are two completely different things. Right now in here we want .NET and not .NET Framework. So yep, it's this template. Also, if you don't see it, then go back into the Visual Studio installer, click on Modify and install some modules, and then make sure .NET Development is checked. Okay, so this is the template that we want, the console application, so let's use this one. Okay, now let's give it a name. You can name it whatever you want. Here I'm going to go with the basic hello world, then go ahead, pick a location to spawn your project, and leave the solution the same name as the default. Okay, so like this, let's go on next. Then over here we can choose the framework. So for this, let's go with .NET 8. And now there's a pretty important option here, which is whether or not to use top level statements. Basically, if you leave this unticked, so like this, then the project won't be created and look pretty much empty. Whereas if you tick this, then the project will be created and look like this with a namespace program and a main function. The option for this difference, this was added relatively recently, so if you watch older C# tutorials, they might show this template. But for complete beginners, this completely empty option is actually easier to follow, so we're going to use this one. Later on, after we learn the absolute basics, we will make another project with the more complex template. But really, the main takeaway that I want you to learn from here is really just code is code, meaning that for everything we're going to learn in the absolute basics part using this simpler template, all of that can also be done in this more complex template. The difference is simply in how in the basic template you just write code here, but in the more complex template you need to write that same code inside the main function. If you write code in a different place, you can get some strange errors, so that is why for beginners the simpler template is much easier. So over here, to keep things simple, let's first use that basic template, so make sure to leave this one unticked, so example like this, and let's create. Alright, yep, so here is our empty template. And by default it already has the standard hello world print. You don't need to understand this line of code just yet, I will explain all of this in detail soon. Right now we can just run this test. So on the top, right on the middle, you can see this nice little play button, or alternatively the default shortcut is F5, so go ahead and press either one of those. And up here is the window. Our program ran, it did indeed say hello world, and everything finished. Alright, awesome. Okay, so we can already start writing some C# code and run it. Now let's change some things in Visual Studio. There's a really nice extension that I really like, which adds a bit more colors to the code, which I find that it makes it much easier to read and write. So up here on top, let's go into extensions and then manage extensions. Then go ahead and find Viasphora. You can go to the online tab and search for it. Now I believe that this one is actually only available on Windows, so if you're on Mac you might not be able to find it. Maybe there is an alternative, but I'm not sure. Either way, this is just an optional extension just to add some visual, so technically you don't absolutely need it. But if you are on Windows, then I highly encourage you to install it. Let's go ahead, close Visual Studio to let it install. Okay, great, so done. Let's open up the same project again. Alright, so now for some more settings. You can go into Tools and Options, and over here let's scroll down to find Viasphora, and here are the settings. Now for the most part I believe the ones that I have here are the defaults. You can pause the video and compare my settings with your own. I believe I really only changed some colors over here on the rainbow braces. Right away, if we look at our default hello world code, it should already have some colors that make it a bit easier to read. Again, this is not a requirement. You don't need this extension, but I do find it quite useful. I find it helps to make the code more readable than having almost everything as gray. Next, for some text formatting rules, let's go up here into Tools and then go into Options. Then over here let's scroll down and find the text editor. And again, pause the video if you want. I think over here, I have everything as defaults. Then let's expand upon this one and look specifically at the C# options. And over here, again, pretty much the same defaults. I think the only thing different is over here, I disabled the automatic brace completion just because personally I don't like it. And let's expand upon it, see a few more things. So the scroll bars, then over here the tabs, pretty normal. Then on advanced, again, I think all of this is pretty much the defaults. On IntelliSense, right like this. And then inside the code style. On general, I think over here I didn't touch any of this, so I think the only thing I touched was over here on formatting, and the main thing that I changed was over here on the new lines. Basically, the default is to have all of the curly braces, all of them on a new line, and over here I switched this ones in order to make them spawn on the same line, which personally I prefer. But again, this is very much personal preference. The code really doesn't care whether the braces are in the same line or new line, so you can use whatever format you prefer. Personally, I prefer it like this. I've been using this code style for 25 years now, so this is what I will be using in the course. But it's just a visual thing, so if you really prefer it on new line, then go ahead and place it on new line. Okay, so after all of that, Visual Studio is set up and ready to go. Now let's continue on to the next lecture, where we're going to install Unity and learn the absolute basics. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn the basics of Unity. Now like I said, this part is technically optional. If you're just looking to learn C#, then technically you don't need to learn Unity. But since I won't be using Unity to build the interactive exercises, and also using it to showcase some example code with some fun visuals to help you learn better, because of that, even if you don't specifically want to learn Unity, still make sure to watch this lecture just so you're not confused when any Unity code shows up. First, we need to get Unity Hub. Now since we selected Unity Game Development when we installed Visual Studio, it already automatically installed Unity Hub. In your case, if you accidentally did not tick that box, you can just manually go to unity.com and download it. Then open up Unity Hub. This is the program that manages all of the various Unity versions. In case you see something that looks like this is actually the older version of the hub. So like it says here, there's a button to update, so let's do that. And yep, here we are in the updated Unity Hub. It asks you to sign in, so go ahead and do that. If you don't have an account, you can create one, it's free. Unity itself has a free personal version, so you don't have to pay anything. Go ahead, create an account and log in, and right away it selects a version version to install. Here you can install this version right away, but we're actually going to install a specific version that might or might not be the same as the pre-selected version, depending on when you're watching this. So over here, either way, you can either install or skip this. Then here we have Unity Hub open. On the left side, we have some buttons. We can manage our account, we can install various Unity versions, or check out the projects. So over here on the Projects tab, we can add a project. On the premium version of this course, you can download the companion project. Here in the free version, let's just look at how that works, and you can create an empty Unity project instead. So go ahead and download that. It's a simple zip file. Just open it and extract it somewhere. And now back here in Unity Hub, let's go in the Projects tab, and then up here, let's add a project. Select the one we just downloaded, and let's open. Okay, yep, so here it is. And over here, it says the version that this project was built with. If you don't have this version, you can click this button to download it. And yep, it will download the correct Unity version. Now, technically, I should say you can load the project with a later Unity version. Doesn't specifically have to be this one, but in order to avoid any confusion with menus being in different places, in order to avoid any of that, I highly encourage you to use the exact same version. Like I said, here in the free version, just create a brand new empty project instead. So there it is, everything is installed, everything is ready. So now we can click to open up this project. And yep, here is the project open. Now let's just do a little bit more setup. For example, let's go up top over here and let's go into edit, and then let's open up the preferences. Then over here on this window on the left side, let's scroll down into external tools. And over here for the external script editor, make sure you select your Visual Studio installation. Or if you prefer, you can obviously use a different IDE. But if you're following everything along with this course, make sure you select Visual Studio, okay? Then for the extra options, you can leave everything like this. And here's a screenshot of my general options. I believe all of this is the default. So now we can close this window. And now if we have correctly set the external editor, if we go up here into Assets and then click on Open C# Project, yep, this one should open your Visual Studio. Okay, great. So far, so good. Now, just one thing, you should already see the code kind of like this, meaning with a bunch of colors. So for example, if I place the mouse over here on top of mono behavior, it should correctly identify this as a class inside Unity Engine. This is a Unity specific class. If you don't see it, if you mouse over this and doesn't recognize this type, or if you see this as written in completely gray, if so, then perhaps something went wrong during installation, so you might need to manually install the Visual Studio Tools for Unity. You can just Google Visual Studio Tools for Unity, you'll be able to find this page and you can download it. But if you followed everything, then everything should be working correctly. Okay, great. Okay, so here we have the default Unity layout. Now, first things first, let's just familiarize ourselves with the various Unity windows and create our custom layout. You can see there's a lot of tabs everywhere, like for example, the Scene tab, the Game tab, and so on. You can click and drag and move these tabs anywhere. You can make them into separate places, or you can dock them into various kinds of places. So you can basically set up the editor in any way you want, but it will be easier to follow this course if you're following the same layout as me. So let's see the layout that I normally use. First is over here, the inspector on the right side. This way we always have a nice view of the selected object and whatever scripts it has. Then for the hierarchy, personally, I prefer that instead of here, I click and drag and I put it right here next to this one. I like having the hierarchy over here on this lower left corner. We're going to make sure our scene is always organized, so we don't need the hierarchy to take up tons of space. Then with the project files next to it, and with the console tab on the next tab. Next over here in the center, here we have the scene view, and right next to it the game view. This way we can easily view all of our objects, the console, project, everything is nicely accessible. So this is the basic layout that I normally use. Now for just a couple more options, over here when the project files window is selected, on these three dots on the top right corner, on these personally I like to select the one column layout. It showcases all the project files in a nice compact view. Then on the console next to it, once again on the three dots, over here we have some options. For example, over here on the log entry, I like to set it to 1. This makes the console nice and compact, which personally I prefer. You can see a bunch more logs without taking up too much space. Then the timestamp are either enable or disable, doesn't really matter. One very important thing are these three buttons over here. These are the type of messages that are going to appear on the console. So the left one, this one is for regular messages. We're going to use this quite a lot. The second one is for warnings, and finally for errors. Basically, if you untoggle any of these, then those types of messages will not show up over here on the console. So if you ever come across an issue where nothing is showing up on the console, make sure these three buttons are ticked. Then over here on the left side, for the clear, we have some options. So on this little arrow, I like to set it to clear on play, which means the console will be cleared every time we start playing our game. Then for the collapse, this one basically collapses messages that are exactly the same into just one entry. Personally, I do not like this. I think this is very confusing. I want to be able to see every single message as it comes out, even if it's identical to a previous one. I've also seen this lead to a lot of confusion for a lot of beginners. They think their code is just firing one message, when in reality it's actually firing hundreds. So to avoid any confusion, leave collapse untoggled. And then for the error pause, this will automatically pause the game when some kind of error occurs. So for this one, you should definitely have this toggled. If there is an error, you want to know about it. You want to know when it happens so you can actually fix it. Okay, so that's it for the console. And now on the game view up here, and over here on the button that says free aspect, let's select full HD 1920 by 1080. This is the standard 16:9 aspect ratio. Then on that same button, you can also enable VSync. This can be helpful because some of these demos are really simple, so if you disable it, they might run at like 1000 frames per second, which is going to put a ton of unneeded stress on your graphics card, so just leave it as VSync. And then just one thing, if you see your game view is looking a little bit too pixelated, make sure on this here, on this slider, you are not fully zoomed in. If I fully zoom in, I can see this becomes a little bit pixelated. This is basically just increasing the size of this window. So on this one on the scale, make sure it's pushed all the way to the left. Okay, so that's the game view setup. Then for the scene view, for this one, pretty much on default, should work just fine. Just one thing to know, some demos are in 2D. So for that, up here on the top right corner, there's a button to swap between 2D or 3D. This just changes the scene camera. And then one important thing is on the top left corner, over here, there's these two buttons. This impacts where the handles are actually going to show up. Usually you want to keep them just like this, meaning this one on pivot and this one on local. If you ever see your handles on some weird places, always come back to this. You almost always want it to be on pivot and local. Okay, so here we have our basic layout. It will be easier to follow the course if you're using the exact same layout as me, so ideally you should be using this. But again, all the windows are customizable, so if there's something you absolutely prefer differently, then go ahead. You can drag your windows and place them anywhere. Once you have a layout you're happy with, you can go on the top right corner, and over here where it says default, you can click on it, and we can basically save a layout. So you can go ahead, save it to something, and then if you ever find any issues, you can reload a previous layout. So here we're back into default, and if I click it, yep, now back into this one. Okay, so now that the layout is all set up, let's go through the basics of the Unity editor. So first, just some basic controls. Over here with the scene view selected, this is where we can move around and view the entire game world. You can hold the right mouse button in order to look around. Then if you're holding the right mouse button, you can press WA, S, and D in order to move around. If you press on Shift, it increases the speed. While holding the mouse button, if you use the scroll wheel, you can either increase or decrease the speed. Alternatively, you can stop holding the right mouse button and just press the middle mouse button in order to pan around, or hold Alt and left click in order to rotate around any kind of object. And if you have some kind of object over here on the hierarchy, if you get lost, like for example you're moving way far away and you have no idea where the object is, you can just select it and then press the F key and it's automatically going to focus that object. Then here on the hierarchy window, this shows all of the game objects that exist in this scene. A game object is really just a name for an object in Unity. So each one of these, each one is a separate game object. To create a game object, we can simply click on the plus icon, and over here we got a bunch of presets, like for example inside the 3D object, let's create the 3D cube. Let's press F in order to zoom in onto it. Yep, there you go, there's the basic cube. When an object is selected, we can see the various gizmos, the various handles that we can move our object. So over here by clicking and dragging on these arrows, we can move our object in any way. Then on the left side, we see the various tools. So the first one is just for panning around. The second one is the move tool, so we can use it to move our object. Third one is for rotating in any way. Then we've got the scale tool, we can scale in any direction. Then the rect tool, this one is mostly used for 2D and UI stuff, but yeah, pretty much also does some scaling. And then the multi-tool, which contains pretty much everything. Another similar one for editing the bounds volume. Although this one only affects the collider and not the actual visual mesh, so you should probably not be using this one. Okay, so with the game object selected, over here on the inspector, we can see a bunch of stats for this game object. Unity is really based on components. So here we can see all of the various components attached to this game object. Each component does all kinds of things. For example, this cube game object, first of all, this one has a transform component. All game objects are going to have this component. This is basically what gives it a position, rotation, and scale. Then specifically for this game object, this one, as we can see, it has a cube visual. So that visual is composed of the cube mesh filter component. This is what holds the actual mesh that is being rendered, and the mesh render component. This is what actually renders that mesh. And finally, by default, this one also has a box collider, which is used in physics. So in general, the main thing to remember is that Unity is made up of scenes. Then each scene is made up of game objects, and each game object is made up of components. Let's see an example from the interactive exercise. They're all split into different scenes. They're organized by folders. So for example, let's go inside the lecture teaching all about if conditions, and let's open up this one for the distance. The way we open a scene is just with a double click, and we can see this is a scene because it has a nice Unity logo. So let's go. In this case, I don't want to save the sample scene, and up here is the scene. And like I said, most of the demos, these are actually in 2D. So we can click the 2D button in order to visualize it in 2D. In order to play the game, you simply click on the play button right up here on the middle. And up here, the game view now is playing on whatever logic is in this particular scene. This one is on the lecture talking about ifs. And if I click to move and showcase how doing a simple if in order to test the distance. So in this case, for example, let's inspect the player component. So select the player game object on the hierarchy. And over here on the inspector, we can see it as a player script. So we can double click in order to open it. And yep, it opens up Visual Studio and opens up to the player script. So here we can see a bunch of code. Again, don't worry too much about what exactly this is saying, what exactly this is doing. This course will teach you everything about C#, so everything that we're seeing here, we're going to learn about through the entirety of this course. Right now, the only thing that I want you to learn with regards to Unity and C# is that Unity scripts have some default functions. They've got an awake function and an update function. Again, I won't cover what exactly are functions in detail in a little bit, so just know that the awake or also the start function, those only run once, whereas the update is going to run on every frame. So if our Unity window is running on 60 frames per second, then this code will execute 60 times per second. Then for some Unity specific things, in order for a script to be attached as a component, it needs to extend this MonoBehavior class. In the Unity scripts, many times we are going to access the transform component. So this refers to the transform component attached to whatever game object this script is attached to. And finally, debug.log. This is just a way that we can write any messages to the console. So pretty much the same thing as the console write line that we're going to see in a little bit. Okay, so that's the absolute basics of Unity. Like I said, you can use C# without Unity. I'm only using it to make the interactive exercises and to make the lectures a bit more visual, which should help you learn better. Also, by the way, after you watch this whole course, if you want to learn how to make games in Unity, then check out my entire course on making the game Kitchen Chaos. It's a beginner course starting from the absolute basics of Unity and game development, and it takes you step by step until we have a nice, complete, fun game. If you fully understand everything in this course, you won't be able to easily understand everything in that one. Okay, so in this lecture, we installed Unity and learned the basics. Now we are ready to learn how the interactive exercises work, which we're going to see in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how the companion project works. Now, the companion project, this is one of the bonuses of the premium version of this course. I left this lecture here in the free version just so you can see what the companion project looks like. And again, remember what I said previously, if you can't afford the premium version, then that's fine. There is no hidden knowledge behind the paywall. All the knowledge is contained in the video lectures right here in this free video. The companion project is mainly for convenience to help you make the learning process easier. But here in the free version, you can look at how the companion project works and then combine it with the final slide on each lecture and use that to guide yourself to find the answers to those questions and quizzes and try making up your own exercises and complete them. Okay, so the companion project is something that I work really hard on to help you truly learn the contents in this course. If you do what I say, if you make an effort to go through everything, all the content inside of this companion project, if you do that, then by the end you will have definitely mastered C#. If you're following along, you already downloaded and installed the project. If not, go ahead and download it from the link under this lecture. So the companion project contains a ton of stuff. First of all, everything is over here on the project files, all separated by lectures. So all the demos that I showcase in the videos, you can come here and inspect them in order to see all the code that makes up those demos. But also the main way to interact with this project is through a bunch of custom editor windows. The main one is the main window, so it should be open already if you imported the project. If not, you can go up here onto the CodeMonkey menu and let's open up the main window. And yep, it is this window. Now, the first thing this window actually has is an update checker that runs automatically. As I add more exercise or quiz or questions to the project, as I do that, I will update the project. So when that happens, you will see a nice pop-up where you can click, which will take you to this very lecture where you can always find the latest project version. Then over here, you've got some nice stats, so basically it tracks your completion. As you go through all the content in the course, it won't keep track of all of it. The goal is for you to get to 100% completion by the end. Then we have a button that takes us to the lecture list. So over here, you can select what lecture you're on. Like for example, let's say we are inspecting the variables lecture. And now we can browse the 3 parts for each lecture. There are frequently asked questions, quizzes, and exercises. Each of these has a separate Unity window. By clicking on it, it should open that window. So for example, here's the one for frequently asked questions. This one shows some common questions, and if you click through it, you get a very detailed answer. So these provide even more clarification on the topic covered in the lecture. Next, we have the quizzes. So these are multiple choice questions. You get a question and various options. Again, these are related to the contents of that specific lecture. So if you fully understood everything, you should be able to get all of these questions correctly. But whether you get them right or wrong, either way, you get an answer with a nice explanation with some extra clarification. And then the exercise window. These are exercises that, rather than just answering questions, you have to actually write code. For example, here's a basic one from the variables lecture. It asks you to define a certain speed variable. So here on the text, you need to edit some script, declare a variable of type int with the name speed, and assign the value 5 to it. Right away, we can click on Start Exercise. This is basically going to load up all the files for that exercise. Now this one is pretty simple, we just need to follow the instructions. So in this case, we just need to define a speed variable. So we can open up the exercise.cs file. It should open up automatically, and over here we see some more instructions in the comments. So now here all we have to do is just complete whatever the exercise is. And if you get stuck in any exercise, all of them, they all have hints, which should help point you in the right direction. Then if you get really stuck, you can also just view the solution. So this will tell you exactly what you need to do in order to manually complete the exercise, or alternatively, there's a button to apply a solution. This one is basically going to overwrite the exercise files with the correct solution. Then once you complete the exercise, you can see a nice completion message. And something very important is the button here for the video walkthrough. This one is exactly what it says. It's basically me going through the exercise, explaining how to complete it and what exactly the exercise is teaching. Then when you're done, you can click the button to complete the exercise. This will basically clean up all the exercise files so you can go back and go on to the next one. Also, some exercises have a Unity scene like this one. So you need to complete the exercise, you need to write the code, and then you need to hit play over here inside of Unity in order to test your code and see if you have actually successfully completed the exercise. If so, then again, same thing, just stop playing, complete the exercise, and go on to the next one. Also related to the exercise window is a separate companion window which you should also open. It should be opened by default in this corner. If not, again, go into CodeMonkey and open up the companion window. So yep, this is a really nice companion window that listens to a bunch of compiler errors and gives you some guidance. This one is separate from the exercises. So this is constantly reading for errors whether there's an exercise active or not. So this can be helpful even if you're trying to write some regular code, if you're trying to test out how something in some lecture actually works. This provides a bunch of useful guidance for tons and tons of compiler errors. So you should keep this window open and visible at all times. I've said many times that the way that you truly learn is by writing code, not just by blindly watching the videos. You need to actually do something. You need to apply your knowledge in order to truly learn. So I'm really happy with this companion project that I built, especially these exercises. They really encourage you to write code related to the content of each lecture, and in doing so you will actually solidify the knowledge you gained. There are many exercises for every lecture. This is something that took a ton of work to make, so I really hope you make the effort to go through everything in this companion project to help you truly understand all the contents inside of this course. So as you're going through the course, first watch and listen to the entire video lecture. Make sure you're paying attention and really learning. Pause the video and rewind if you need to. Then after watching that lecture, go on to the companion project. Then over here, load up the lecture list and go on to whatever lecture you're currently on. Then read all of the frequently asked questions and the detailed answers. Then go through all the quizzes and try to answer them all correctly. And then go through all the exercises and really put into practice what you learned in that lecture. You can see there's a bunch of content already for all the lectures up until this point. So take this time right now to pause the video and go through all of this to ensure you are fully understanding everything up until this point. By the end of this course, you should have all of your totals at 100% completion. If you do that, then you will truly have learned C#, which will then allow you to build anything you can imagine. Alright, so we're almost ready to start learning C#. But before we do, let's go through a bunch of really common errors in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about a bunch of common errors that you might encounter. So here's a list of the many common errors that we're going to cover in this lecture. This lecture is really mainly meant to act as a sort of reference. Whenever you have an error, come back to this one to get some guidance on what exactly it means and how you can fix it. I had this lecture right here on the beginning of the course before we get into writing any code, just so you are aware of these various errors. But if you are a complete beginner, then don't worry about fully understanding everything in this lecture right now. For most lectures, I highly encourage you to stick with it and rewatch the lecture if you don't fully understand the contents. But for this one is special. This one is really intended as a reference. If you are a complete beginner, then watch this lecture just so you are aware of the various possible errors that you might encounter. But don't worry too much about understanding all the individual details in the code that we're going to see. Everything mentioned here, variables, classes, types, scope, and so on, these are all things that I will cover in detail in future lectures. So just remember that this lecture exists and refer back to it if you encounter any of these errors. Starting with the most common errors of all, some variation of these three. Usually these mean some kind of symbol is missing or it's in the wrong place. One of the most crucial things about any kind of programming is how code has to be written absolutely exact. If you miss just one symbol, then everything breaks. This is really something that a lot of complete beginners have a lot of trouble with. For example, here this code has an error, and thankfully this one is actually a very helpful error. It is correctly telling us that a parenthesis is expected. Here we have an opening, but we have no close. You always need to match the same number of opening and closing parentheses. So the solution here is pretty simple, just close it, yep. Then here's another similar error. This one is saying there's an ending curly braces expected. And again, same thing, different numbers. So we've got 1, 2, 3 openings, but only 1, 2 closings. So we're missing one here. And here is another really common error. This one is because we have a missing semicolon. The semicolon is what actually defines the end of an instruction. Without it, the compiler doesn't know that this instruction has ended. In C#, new lines don't really matter. So I can paste another line down here. And nope, these are still errors. Having one line of code on each line does not matter. What matters is the semicolon. So always need to add it to this one and to this one. Then on these same mistakes, if you make something slightly different, so if instead of the ending one, you get rid of the first one, now there's a whole ton of errors. In this case, they're not quite as helpful. So that is why you always got to keep in mind you have to write the code perfectly. In here we have tons of errors, so this is quite messy. The one that truly matters over here is this one. It's that the main function must declare a body. So the missing here is once again has to do with the curly braces. We've got 3 closing but only 2 openings, so we're missing an opening on this one. And again, same thing, if for example we forget to add this one, Then again, tons of errors, so again, this one is really tricky to figure out what is going on. The issue here is our missing opening parentheses. So these are really the most common syntax errors. If you see any of these, pay very close attention to how your code is written. Remember, it has to be written perfectly, so don't write some messy text. Write it properly with all of the required parentheses, all of the curly braces, and semicolons. Next really important common error is simply this one. The type or namespace could not be found. So here I am trying to define a variable, but as we can see, we have this error in the code. This is yet another way as to how code must be written perfectly. It is not just the words that matter. Code is case sensitive. This is something that I see a lot of beginners having trouble with. They think, for example, this and this, they think these two are the exact same thing, but they are not. In terms of English, sure, they sound the same, they look similar, but in terms of the code, these are two completely separate things. The code really doesn't understand meaning, doesn't understand English, it really just understands syntax. So always remember how code is case sensitive. Changing something from uppercase to lowercase, just doing that one tiny change, all of that suddenly refers to something completely separate. Again, this is something that I see a lot of beginners struggling with, so this is something that I will repeat quite a lot throughout the beginner section of this course. If you have some error like this one, the type or namespace could not be found, the first thing you should do is always double check the capitalization, double check that you wrote it actually perfect. So in this case, it is lowercase int, and yep, that works. Also, since we're here, one thing that is not an error, but rather a warning, sometimes you might see these green squiggly lines. These are warnings or suggestions for how you can improve your code. In this case, it just says the variable is assigned but is never used. Again, that's because this is just some testing code. In general, just know warnings are not errors. So for example, I can compile this code and it works perfectly. The warning is simply a message that tells you that you're probably doing something that you probably don't mean to. Now here's a similar error. It says the name age does not exist in this context. And again, same thing, capitalization problem. Age all lowercase and age with uppercase on the A. These are two completely different symbols. Same thing over here, which is saying type or namespace player cannot be found. And again, some beginners might see, but it is defined, it's right here. Except, no it isn't. Once again, same problem. Over here, player is all lowercase, and that one is capitalized. So over here, it needs to be written exactly perfectly, and yep, now it works. And up here, also perfectly, and yep, now it works. So as a beginner, the first question you should always ask yourself is, did I write the code correctly? And specifically in terms of case sensitivity, is everything written perfectly exactly as it should be or not? That should be your very first question. Another common error is this one. It says use of unassigned local variable. This one is pretty self-explanatory. Basically, you need to initialize a variable in order to use it. So in this case, we really just need to give it some value, and yep, the error is gone. Related to variables and data types, a common error is some variation of this one. Cannot implicitly convert one type into another one. Like it says, this has to do with trying to convert one type into another for which there is no implicit conversion. This is a common problem over here, defining something as a float and then assigning that float onto something that stores an int. Ints can really only store whole numbers, so that is why this does not work. Floats can store decimal points, but ints cannot. If you absolutely need to do this, then one thing you can do is simply cast a value. So over here, put int. So you cast it like that, and there's no error anymore. However, if you do it, then this will lose some data. For example, if over here, for the number, I store 5.6. If I do this and then I cast it, the value stored over here in age, this one is going to be just 5. If you force the conversion, then basically anything after the decimal is going to be ignored. Or the same error can be due to the data type that you're trying to store. The long data type, this one represents a 64-bit int, whereas the int, this one is only a 32-bit int, meaning that a long can store everything inside an int and more. You can define an int and then assign that int onto a long. This does work, there's no error on this line. However, there is an error on this line. That is because an int cannot hold all the values of a long, so you cannot implicitly convert a long onto an int. Again, if you really want to do it, you can simply cast it onto an int. Or alternatively, trying to do this, again, same thing, cannot convert a string onto an int. If you want to basically parse a string, then you can do it like this. So access the convert class and convert it onto an int32. Related to data types is doing some math. So a common error is doing something like this. So basically you got 1 divided by 10, and you expect the result to be 0.1, but nope, the result is actually 0. That is because when doing math between two ints, the result is going to be an int. And in an int, we cannot store the number 0.1, so again, it ignores everything after the decimal point and returns just 0. The solution here is to cast one of the numbers included in the calculation onto a float, and yep, now the result is correct. Always keep in mind what data type you're using and make sure you're assigning the right data for the right type. Then another common mistake is when doing some conditions. You might write an and like this, so one condition and another one. But this is not correct. With just one ampersand, this is actually a completely different operation. This is a bitwise and not a logical and. So once again, it goes back to how you have to write the code perfectly. For a logical and, you need 2 ampersands, or for a logical or, it's also not just one pipe, it's actually 2. Also for equating values, it is 2 equals. If you use just 1 equals, that actually is the assignment operator. So that is something completely different. If you want equality, you need 2 equals. Then after we learn about functions, a common error is going to be this one. The name age does not exist in the current context. Now in this case, the capitalization is correct. These are both written perfectly exactly. The problem here is that this one up here, this one is a local variable. And by being local, it means that this variable only exists over here inside the main function, and down here inside this other function, down here does not exist at all. This is a problem to do with variable scope, and later on there is a detailed lecture on that specific topic. Also, after we learn about functions and parameters, one common error is this kind of error. This is not a compile error, it's just some behavior difference. Here, a beginner might think that if you define this, then you add this, and this one in turn is going to add 2. You might think that over here is going to add 2 onto that number. But the answer is nope. When we run this line, this one still says 35. So the value inside the age variable, that one is still 35. This has to do with difference between working with something as a copy versus a reference. There's a dedicated lecture on the topic of value types versus reference types in the intermediate section. Int is a value type, which means that it is passed in as a copy. So when we call this function, what this one receives is a copy of the original data, meaning it's just a copy, it has absolutely no connection to the original variable. So when we modify this one, we're just modifying the copy and not the original value. That is why over here when we call this, the original value still stays exactly the same. So always remember whether you're working with a copy or the original data. Then when we start using classes, this is a common error. It says an object reference is required for the non-static field, method, or property to be called. In the class lecture and in the static lecture, I talk a lot about the difference between the class definition and an instance of that class, and that is exactly the problem here. This function over here, this one is not marked as static, but we are trying to access it through the class name itself as if it were static. Like the error says, we need an object reference, meaning we need to create an object of this type in order to create an instance of that class. So we can define a player equals a new player. And now using this object, this instance of that class, now we can call it and yep, everything works. Or alternatively, we can keep the same thing we had previously and simply mark this one as static. So always be very, very careful. Are you intentionally trying to access something through the class itself or through some instance of that class? Another common error that we're going to run into once we start learning about classes is this one. It says something is inaccessible due to its protection level. This has to do with the access modifiers. There's also a dedicated lecture on this topic near the end of the beginner section. By default, if you omit the access modifier, then it's going to default to making it private. And private means that only this class over here, only this one can access this function. So if you want to access it from elsewhere, like for example from this function up here, if so, then we need to mark this as public, and yep, now it does work. Then when writing some more intermediate code, you might encounter something that does something like this, like requires some encoding in order to save some bytes onto some text. But if you just try using the encoding type, if you do, then it says like this. Once again, the same thing, the type or namespace could not be found. Now this one is not a capitalization problem. The class is indeed called encoding. However, this one exists inside the system.txt namespace. So before we can actually use it, we need to be using that namespace. So on top file, we need to add using system.txt in this case. And yep, the errors go away and this now works. Alternatively, you can place a mouse over the error, then click on this little light bulb icon, and this tells you a bunch of things, like for example, it needs using text, and if there you go, it does and it works. Alright, so those are a bunch of common errors. Again, like I said, if you're a complete beginner and you didn't understand anything in this lecture, that's perfectly fine. All of these concepts, variables, functions, classes, and so on, all of this will be explained in detail in future lectures. Just keep in mind that this lecture exists. If you ever get stuck, chances are you're going to encounter one of these errors. If so, come back here for an explanation on what might be going wrong and how you might fix it. So remember this lecture and use it as a reference throughout the entire course. Now that we've covered this, we are ready to begin learning the absolute basics of programming, so let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn the absolute basics of programming. So how the computer executes code, how code is case sensitive, matching parentheses, and a bunch more. Okay, so in the Getting Started lecture, we built this default console app project. Here we have a bunch of code. Again, I will explain all of this in detail in a little bit. This one over here is a comment, and here we've got something running a function in order to print some text onto the console. We can run this code, so again, we can go up here or press F5, and yep, it runs the console, and right away it does say our message. Now, the first thing to learn is how the code actually runs, and that is how the code runs from top to bottom. Meaning, if we have 4 instructions, it is going to first run this line of code, then it's going to run this line of code, then this one, and finally this one. It is always going to execute one after the other, always from top to bottom. Now later on when we learn more about functions, we will see how the code execution jumps a little bit, but in the end it's really all just sequentially running from one to the other from top to bottom. So up here, if I copy this line and I run this function twice, and on the second time I say something else, again, code runs from top to bottom, so it is going to first execute this one and print this line onto the console, and then it's going to execute this one. And if it is exactly like that. Also, one very important thing is in C#, the end of an instruction is denoted by a semicolon. If we do not have it, if I erase this, then the code basically assumes that the instruction is not over. Another thing is how new lines don't really matter to the compiler. So I can add a bunch of new lines and then a semicolon, and now this is perfectly valid code. All same thing when accessing a function. So over here I can add a ton of new lines. Right after the dot I can add a ton of new lines. Now you can't add it in the middle of something, like in the middle of this function name. If I split it, then it does cause an error. But otherwise, new lines generally do not matter. In terms of running the code, all that really matters is the semicolon. That is what actually defines the end of an instruction. A lot of beginners make the mistake of forgetting about that. They usually forget about the semicolon and they get a whole bunch of errors. Which, by the way, if you see a red squiggly line and you just put the mouse over it, it won't tell you the error. In this case, the error is simple, and our helper function actually helps us see what the error is. So in here, there's just an expected semicolon. If we add it, everything's fine. So if you find any strange issues, always make sure to remember that you need a semicolon in order to end an instruction. And also, speaking of things that don't matter, so new lines generally don't matter. Another thing that does not matter is indentation. So right now I can indent this line just like this, and it's going to run, and I can have another one indented a bunch more. So I can have code written like this, and if I run it, yep, everything still runs exactly the same. If you've done some Python programming, then in that language indentation does matter, but over here in C# it does not. This is perfectly valid code. Although of course, bad indentation like this one can make the code hard to read, so even though technically it does not matter for the compiler, it definitely matters to you in order to make the code easy to read, so always make sure you indent your code properly. Another extremely important thing is how code is case sensitive, meaning, for example, over here we've got an instruction, a console.writeLine. If I instead write writeLine with a lowercase l, nope, there is an error. There is no such thing called writeLine with a lowercase l. There only exists one with an uppercase L. So you need to always pay very close attention to how you write your code. This is one of the main things that I see a lot of beginners make their mistake. They write code like this and they don't know why it's not working. They assume that as long as the words are correct, so for example if I write it like this, they assume since this is technically the same thing as over here, in terms of English, they both say the same thing. They assume that because of that it should work, but in reality, no, this does not work, and the answer is always because they did not write the code exactly as it needs to be. It needs to be 100% exact, including capitalization. So it cannot be in lowercase c, it has to be in uppercase C, only that actually matches the console. And writeLine cannot be written like this, the W needs to be uppercase and the L also needs to be uppercase. So if you have issues in your code, the first thing you should check is see if you are writing the capitalization correctly. It is not just the words that matter, it's everything. It's the capitalization, it's the place where you put the dot, the place where you open and close parentheses, the semicolon, all of that matters. So always make sure you write your code very carefully because every single detail matters. And of course, you can always rely on code autocompletion to help you write. Usually after writing a dot, you see the autocompletion, and if you start writing writeLine, over here it shows you exactly as it should be. You can just press enter and everything will be written properly. Now, the next important thing is knowing where to write the code. Now over here in the new template, over here it's easy. You can just write code and all of this will execute without problems. But now here on the previous standard template, on this one, note there's a bunch of curly braces. These curly braces form what is known as a code block. Code is grouped between blocks. For example, everything inside of this code block, everything here belongs to this namespace, then everything inside this code block belongs to this class, and everything inside this code block belongs to this function. Again, don't worry what is a namespace, class, or function right now. I will cover all of those in detail later on. For now, all I want you to learn is what is a code block, which is everything inside a curly braces, and that impacts what kind of code you can write within each code block. So for example, in this one template, in this one here we need to write the code inside the main function. This is where the program actually starts executing. Like I said, the code executes from top to bottom, and as soon as we run this program, it is going to start right here from inside the main function. It starts running from this first line. If we run just like this, if there you go, it still works, has exactly the same thing. However, if I take this code and I remove it from the function, and let's say I paste it just over here, so just inside the class code block, if I do, then obviously I get a whole bunch of errors. This is because we are writing code inside a class block, and inside a class block you cannot execute a normal instruction. You can only define fields, functions, and so on. Now in this case the error isn't very helpful, so really just remember where you are writing your code. If you're writing a regular instruction that you want to execute, then chances are you want to write it inside a function. In this case, chances are you want to write it inside the main function. So always keep this in mind. Like I said, it's very important how you actually write your code, but it's also extremely important where you write it. If you're writing code inside of this own template, then make sure to not write the code out here or directly inside namespace or directly inside the class. If you're writing some kind of regular instruction, make sure you write it inside main. Although in the beginning portion of this course, we're really just going to be writing our code in the simpler, newer template just to avoid any confusion. Over here, we have no curly braces, so there's no issues like that. We can just write all of our instructions over here sequentially and everything will execute once again, top to bottom. And finally, very important is to always make sure you have matching opening and closing symbols. That refers to, for example, code blocks. Every opening curly brace needs to have an ending one, and same thing over here for parentheses. Every time there's one beginning, there has to be a matching ending one. If I go ahead and I erase one of these, like for example over here, opening namespace, we've got 1, then inside the class we've got 2, and inside the main we've got 3, and over here we have 3 closing ones. But if I get rid of one of these, if there you go, now we have an error, and this one is a nice helpful error, so it tells us that one more is expected. So always double check that you have the exact same number of both opening and closing braces and parentheses. Over here, same thing. If I erase one of these parentheses, yep, that's also an error because we did not finish the parentheses that are calling the function. So always make sure the same number of matching opening and closing. If you put the cursor inside of it, it should highlight the opening and the closing braces. So if I put the cursor here, it highlights both those. If I put it here, it highlights both those, and so on. And in general, whenever you make some sort of error, like let's say you forgot to write that, you forgot to terminate the instruction, you see the red squiggly line. So always remember you can place your mouse over it and it gives you a bit more information. Sometimes the error is super helpful like this one, but sometimes it might be a little bit more confusing. So also remember you can refer back to the common errors lecture to see some common issues. Or of course, remember you can always post questions in the comments and I'll do my best to help. Okay, so here we'll learn how code executes from top to bottom. We'll learn how it's extremely important that code is case sensitive and you should always double check that you wrote the code exactly as it should be. And we'll learn what is a code block and where we should write code, as well as the importance on making sure we always have a matching number of opening and closing symbols. Now with this basic knowledge, we are now ready to learn one of the basic building blocks of programming, which are variables. So let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn all about variables, what they are and what we can do with them. Okay, so variables are one of the most important parts about programming in literally any language. They are basically containers for data. So we can define a variable, which is going to be our container, and then we can take some data and put it inside that container. Now variables also have data types, which means different containers can hold different things. So if a variable is meant to store a whole number, I cannot place a text string inside of it. There are some containers that can only hold numbers, some containers can only hold text, others can hold true or false, and a bunch more. Those are the data types, which we're going to cover in detail in the next lecture. And then we can also have some code that uses a variable, and basically when the code is executing that line of code, in there when it reaches this point, it is going to access this variable and grab the value from that variable. So basically it goes inside that container in order to grab the value that is stored. So on the same line of code, if we modify the value that is actually stored inside the variable, basically we modify the behavior of our code. So by writing code that uses variables instead of values directly, by doing that, we have a lot more control over exactly what our code is doing. For example, the exact same code to move a player can make it move fast or make it move slow, depending on what value we store inside that variable. Okay, so that's the theory. Now let's see how to make variables in code. And the way we define a variable in C# is first we write the data type. Now there are various data types depending on what type of data we want to store. Like I said, some store strings of text, others store whole numbers, others decimals, and so on. I'm going to cover a bunch of data types in detail in the next lecture. For example, over here, let's store the simplest data type, just whole numbers. And for that, we write int for the int data type. This is an integer, so basically whole numbers. And also again, like I mentioned in the last lecture, it is extremely important that you write the code exact. Always remember how it's case sensitive. So for defining the int data type, it is exactly like this. So int, all lowercase. If I make this an uppercase I, then the code no longer knows what this refers to. If I put the whole thing in caps, then nope, this is not recognized as data type. So once again, always remember, always write the code properly and perfectly. So in this case, all lowercase int. So first we define the data type, and then we write the name for the variable. The name can be pretty much anything you want. There are only a handful of limitations, like for example, it cannot start with a number, so this is not a valid name, but for the most part, picking a proper name, like for example, let's say age, yep, there you go, just like this. Basically over here, we are defining a variable called age, which is of type int. And now after defining the age variable, we can do an equal sign, and basically we can assign a value to this variable. So let's say 35. With this, we are assigning the value 35 onto the age variable, so basically picking the value 35 and placing it inside the age container. Also, it's very important important that the value matches the type expected by the variable. So over here, I cannot write, for example, 35.2. This does not work. This is an error because again, int can only store whole numbers. So I cannot store a decimal here. So over here, let's make sure to write a whole number. Let's say 35. And also as you write code, you might see some symbols appear in kind of a faded gray, as well as having this green squiggly line underneath. These are not errors. These are pretty much as code suggestions. So in this case, it is saying that we are assigning this variable, but the value is never used. Again, that's because I'm writing the code slowly as I teach what it's doing. So basically just don't get concerned with these green squiggly lines. These won't go away as we actually use this variable. So just remember these are not errors, so don't worry about them. Okay, so yep, here we have defined the variable age, and the variable is basically a container which is currently holding the value 35. If we want to inspect the value inside a variable, for example, one way we can do it is with the very helpful console.writeLine that we've seen up here. So let's write the exact same thing, and once again, always make sure to write the code exactly perfectly. So you can just do writeLine age, and this is basically going to print the age onto the console. So if you go ahead and run this, and if there it is, it printed the value 35. So basically as the code goes to execute this line of code, when it reaches this point, it then looks inside this variable and pretty much just replaces over here with what is the contents inside that variable. So yep, great, it's this simple. Here I have a demo in Unity with this player character. It is being moved using this move speed variable, and basically it is currently moving at this speed. And now if I take and I modify the value inside this variable, there you go, now it moves much faster or much slower. So basically every time the movement function is running, it is always grabbing the value inside this move speed. So if we modify this, then it modifies the actual behavior. So back in our simple console here we have set the age to a value. Then we can also modify variables. So for example, let's print the current age so that it should print 35. Then let's go inside the age and do something to it. For example, let's assign it to a brand new value, and let's print the age exactly the same, and let's see. And if there you go, now it prints both values, both the original value and the updated value. Now instead of assigning to modify the entire value, we can also do some math to it, and we can also use the variable in whatever math we want to do. So for example, let's say age equals age plus 1. So this should increase by 1, so it should say 36. And if there you go, 35 and 36. Also another way of doing exactly this, so incrementing by 1, is you just do plus plus. So both these lines of code are doing exactly the same thing. Both are incrementing age by 1. And yet another method of doing this is plus equals and then 1. So what we have here is exactly the same thing as we have up here. So basically it takes the age and equals age plus 1. So over here, age plus equals, this does the exact same thing as up here. So all of these are really just different ways of writing the exact same operation. Although on this one, on the plus plus, we can only do this once. So this one only increments by 1, whereas these we can modify and put any value. And of course, here we are doing addition, but we can do the same thing with subtraction. So minus minus in order to decrement by 1. So all of these also work. And then on these two, we can also do multiplication or division. Yep, so over here we are taking the age and multiplying it by 2. And over here we are taking the age and dividing it by 2. However, this shorthand, this one only works for incrementing and decrementing. If we try doing slash slash, nope, this one becomes a comment, doesn't actually make a division. So there's lots of math operations you can do with variables. And also up here, when you define a variable, you don't necessarily need to assign a value right away. So this over here is perfectly valid code. However, like the red squiggly line says over here, use of unassigned local variable, meaning we need to actually assign a value before we actually use it. So this is valid code, but before we use it, we need to assign it to something. So for example, like this, and yep, this does work. Also another thing is how you can define multiple variables at once. So you define the type and then define the variable and then a comma and then any other variable you want. So for example, an int for age, int for health, int for power, something like that. So we have defined 3 variables and then we can just assign values to them. Yep, this works. Or alternatively, we can also just define and assign multiple of them right here. Yep, this is also valid code. Then I should also point out that you can do math directly on the variables like this, or you can also do it directly inside a function call. So for example, over here, age plus 2, let's just erase both of these. So that one should say first 25 and then 25 plus 2. And if there you go, 25 and 27. But for example, let's say you want to print out the age and then the health. If you do age plus health, if you do this, then yep, that actually prints 125 instead of actually printing out both values, both as separate things. That's because both of these are both numeric values. So it basically ends up doing math with both these. If you want to print out both values, then you basically just need to convert these into a string. That way they won't do any mathematical operations. So the easiest way is up here, we just add a quotation marks. This basically marks the beginning of a string, and then another one to mark the end of it. Again, remember always to have matching ones. So inside the string, we can add anything, like for example, a comma, and then we add a plus. And like this, basically an int value plus a string is going to convert the whole thing into a string. Then add another int, which is also going to be a string. So this should now print a string that will both print the age and the health. And if there it is, just like this. Okay, so here we'll learn how variables are really basically just containers for some data, and then you can do some operations to modify that data. And speaking of data, importantly is how each variable has a specific data type. So let's learn about those in the next lecture. Hello and welcome, I'm your Code Monkey. So here let's do a walkthrough of everything in the variables lecture. So basically I'm going to manually do everything that you should do after every single lecture. So we just saw the variables lecture, so let's open up over here the main window. Let's go inside the lecture list. In this case we were following the variables lecture, so let's go inside of that one. And let's do them one by one, so let's begin with the frequently asked questions. These usually provide some extra clarifications on the topic on the lecture. So in this case, starting off with the basics, so what exactly is a variable? A variable is a container for data, so think of it as a box, and inside that box you can place some kind of value. Then you can write code that uses a variable instead of a value, and by doing so, when the code executes, it will go inside that variable, grab the current stored value, and continue running the logic using that value. This also means you can have different behavior depending on the value stored inside the variable. The simplest example is just a player object with some movement code. Instead of writing the movement speed directly, you can define a variable, and by modifying the value stored inside that variable, you modify how fast or slow the player moves. So yep, variables are basically just containers to contain some value. Next, why are data types important? So each variable needs to have a certain data type, and that data type defines what type of data we can store inside that variable. There are data types for storing numbers, and if you define a variable of that type, then you cannot store a string of text inside that variable. You always need to use the correct data type for whatever data you're trying to store, and the next lecture covers data types in detail. So yep, every variable needs to have a certain data type, and based on what type you choose, that defines what type of data you can store within that variable. Next, what is a good name for a variable? This is a great question. So a good name is something that describes exactly what that variable represents. Ideally, just by reading the variable name, you should be able to understand what it represents and how it might be used. For example, a move speed variable, this is a good variable name. It clearly communicates that this is a variable that is used as some kind of movement speed. Whereas a bad name would be x. Just by reading it, you have no idea what it represents. Unless, of course, you're making some kind of math equation and x really is the correct name for that element. So you should avoid abbreviations and acronyms. Those might be perfectly clear to one person and very confusing to someone else. There is a very important lecture later on in the course all about naming rules and how to choose good names. Next question, what happens if I write int with capital I instead of int? And the answer is you get an error because there is no such type named int with a capital I. So always remember that code is case sensitive. The compiler does not know English, so as far as the compiler is concerned, int with uppercase and int lowercase, these are two completely separate types with no relation between them. Whenever you get an error, the first thing you should check is if you're writing the code absolutely perfectly. Pay very close attention to capitalization. This is something that a lot of beginners mistake. And yep, this is something that I will continue repeating many times throughout this course. Code is case sensitive. I see many beginners make this mistake on the many comments that I receive, so I'm repeating it non-stop because I want to make sure that you don't make the same mistake. Next question, what is console.writeLine? So this is a function that writes to the C# console. The console, this is actually a class, and writeLine is a function within that class. But like it says here, don't worry about functions and classes right now, those are only explained in detail in future lectures. For now, just know that it prints something to the console, and the alternative in Unity is this, it is a simple debug.log. Basically, if you're working in a console app, use console.writeLine, and if you're writing some code inside a Unity script, for that, the related one is debug.log, and in doing so, it will print some kind of message down here on the console. Next question, what are the various ways to increment a variable? And yep, all of these lines of code are doing the exact same thing, incrementing a variable by 1. So you can do age equals age plus 1, that will increment by 1. You can do age plus equals 1, that will do the exact same thing, so grab age and increment by 1. Or age plus plus, which again, same thing, increments age by 1. All three of these lines of code, these all do the exact same thing. Like it says here, these are just shorthands. The last one is especially useful when working with loops, which we're going to learn in a future lecture. Next and final frequently asked question, what if I define a variable but don't give it a value? If you don't give it a value, then the variable is uninitialized and cannot be used until you give it a value. So if you do something like this, you get an error. So defining int age, and then trying to do a console.writeLine using age. If you do this, you get an error because it says that the variable age is uninitialized. Although later on in the course, we are going to cover classes and class variables, and if you don't define a value for those, it will default to a 0 value. So the 0 value, that means something like 0 for an int field, means false for a bool field, or null for a string field. Again, classes are covered in detail in a future lecture. Alright, so yep, those are all the frequently asked questions. As you can see, they contain a bit more detail, a bit more specifics on what was covered in the lecture. Going back in the main window, we can see we have completed all 7 frequently asked questions. Now let's go through all the quizzes. Starting off with the first one right here, what is the primary purpose of a variable in C#? So is it to name a function, to store data, to execute commands, or to create new data types? Hopefully, if you fully paid attention to the contents of the lecture, you should be able to answer all of these quizzes correctly. So in this case, the primary purpose of a variable in C#, the primary purpose is to store data. And yep, that is indeed correct. Here is the answer with some more details. Variables are containers for data. You define the variable and then put inside whatever value you want based on the data type. Then you can write code that uses that variable in some way, and when that code executes, it goes inside the variable container, grabs the value that is stored inside it, and uses that value to continue running the code. Next question, which of the following is a correct way to declare an integer variable? So is it integer age equals 35, is it int age, int with uppercase I, or all uppercase int? Again, yet another example of how important case sensitivity is. For example, if you were to incorrectly choose, let's say this one with capital I, nope, this one is not correct, the correct one is that, all lowercase. Answer, always be very careful with how code is case sensitive. Int and uppercase int might look similar, but they are two completely different things. The biggest mistake that beginners make is writing code carelessly and then have no idea why it isn't working. So always pay very, very close attention to capitalization, write the code exactly as it should be. Next quiz, how can you modify the value of a variable? Is it by assigning a new value to the variable, by using the modify keyword, or by redeclaring the variable with a new value? So if you redeclare, you're going to get an error because you cannot declare two variables of the exact same name, and there's no such thing as a modify keyword, so the correct answer is by assigning a new value. The answer here, you can define a variable and then assign a new value to replace the previous value. So define int age equals 35 and then replace it with 25. Well, like it says here, you don't redeclare it. If you do, you get an error since you cannot define two variables in the same scope with the exact same name. So over here, if you do this, yep, you get an error, age is already defined. However, you can also have multiple variables of the same name as long as they are on completely different scopes. For example, you can have a local variable named age inside one function and a different local variable on a different function also named age. There's a detailed lecture on scope later on in the course. Next quiz, what does the statement age++ do? So does it reset the value of age to 0? Does it divide the value of age by itself? Does it increase the value of age by 1 or multiply the value of age by 2? This one is the shorthand for increasing by 1, so yep, it increased the value of age by 1. Like it says here, the shorthand for increasing the value stored in the variable by 1. This is a really super useful shorthand, especially when working with loops, which we're going to cover in a future lecture. These are the two main shorthands, so age++ and age minus. Although these two do not work, you cannot do age multiply multiply, this doesn't work, or divide divide, also doesn't work. So this shorthand only works for these two. But if you want to do this kind of math, so multiplication and division, if so, you can use these other shorthands. So plus equals 2, minus equals 2, times equals, divide equals. Next quiz question, what math operations can you do on a variable? So is it only addition? Is it addition, subtraction, multiplication, and division? Or is it only assignment of values? And yep, with variables you can do pretty much all kinds of math, so the answer is this one. You can add, plus, subtract with minus, multiply, and you can divide. Although of course this assumes that the data type being used in the variable is a number type. Naturally, you cannot multiply a string or divide an object. Next multiple choice question, is it possible to declare multiple variables in one line? So yes, by separating them with a comma, or no, each variable must be declared in a separate line. And yep, if you use a comma, you can indeed define multiple variables in one line. So yep, you can do this, this is perfectly valid code, so int age, comma, int health, and so on, this works. Although at the same time, while this is valid code, personally I tend to avoid doing this because I feel like it makes the code a bit more confusing. So while you can do this, personally I would always define each variable in a separate line just to keep the code nice and readable. Next quiz question, how do you print the value of a variable to the console? Is it with console.writeLine and the variable name? Is it console.print or just writeLine? And this is something that you're going to do tons and tons of times, so even if you get it wrong right now, you will certainly get this right soon enough. The answer is this one, console.writeLine, a very common function. You use console.writeLine whenever you want to print anything onto the C# console. And by the way, if you don't understand this syntax, then don't worry, this is a function and a static class. All of that is explained in detail in future lectures. Or alternatively, when working with Unity, the similar function that prints to the Unity console, that one is called debug.log, and then you print whatever you want. Okay, so final quiz question. What does the statement age star equals 2 do? Does it divide the value of age by 2? Does it increment by 2? Or multiplies by 2? And yep, I'm pretty sure that the star is the universal symbol for multiplication, so yep, this one is the multiplication. The asterisk means multiplication, and this syntax is a shorthand for doing some math function on the left side. So these two lines of code are doing the exact same thing. So age star equals 2 or age equals age times 2. Yep, both these are doing the exact same thing. Alright, so that's the questions and we have 8 out of 8 done. Now let's go into the exercise and let's go through all of these one by one. This one is the really important part. After you go through every lecture, definitely make sure you do all of the exercise. So let's do them, beginning with this one. Okay, so lecture variables, exercise title, define speed variable. The goal is to edit the script exercise.ts. We need to declare a variable of type int with the name speed and assign the value 5 to it. So pay close attention to where you write the code. So here's a quick hint right inside the main function. So let's open up exercise.ts. Okay, here is the file, and right away there's just a quick explainer about what are these things in green. These are comments. These are just text. The compiler completely ignores this, so none of this is treated as code. Comments are going to be covered in detail in a future lecture. So the goal is to write some code after this line. But again, very important, like I mentioned in the lecture on programming basics, we need to write it inside the main function. So right here, the goal is to declare a variable of type int with the name speed and the value 5. So like we learned in the lecture, first we write the type name. So in this case, we want an int. And again, always keep in mind, code is case sensitive. So it's int, all lowercase, it is not uppercase. If you do it like this, we got a red squiggly line. Int is not being recognized, so the type name is int. Then after the type, we write the name. So in this case, we want it to be named speed. And then in order to assign a value, we need to use the equal sign and then whatever value. So in this case, let's assign it to the value 5. And yep, this is it. Now, since this is the first exercise, let me just show a few things. So for example, if we make a mistake here, so if we write int with uppercase, again, very important, before you go back into Unity, you have to save. So either go up here into File and then Save, or just press Ctrl S. So as soon as you save, Unity should see the changes and it should start to compile. Or in this case, we have a compiler error, so it doesn't actually compile. And like I mentioned on the lecture on how the exercise work, always make sure you have the companion window open. That way, if you make some kind of mistake that leads to some kind of error, here you can see a little bit more text that might help clarify exactly what the issue is. So over here, the issue is pretty simple. It's because we wrote int incorrectly. So as always, remember how code is case sensitive. So over here, we need to make sure to type int. And again, if we also make another mistake here, like we named sped instead of speed, right now the code is compiling because we have no syntax errors. And if the exercise is still in progress because we didn't actually complete it perfectly. And again, down here on the companion window, we can see some nice helpful message. So did you accidentally write something different? Again, the goal with this exercise is to teach you how to write things absolutely perfectly. So now let's properly construct our exercise. So just like this. So define a variable of type int named speed with the value 5. And if we save and just let the code compile, and if there it is, we have the exercise completed. Then we can also show the hint. Like the hint says here, remember the syntax for how variables are declared. So first the type and then the name, and then optionally assign some value. Always remember how code is case sensitive. So define a variable named exactly speed, not uppercase speed or anything else. And if we were to get really stuck, we can just show the solution. And up here we see the goal is to define a variable of type int named speed with the value 5. So the solution is exactly this. So int speed equals 5. And if we want, we could click on apply solution. And if that overrides the file with the one with the solution, which is exactly what we wrote. So yep, just like this. So like it says here, congrats. In this exercise, you applied what you learned about how variables are defined, how they have a type, a name, and a value. So yep, that's it. Now click the complete exercise button in order to finish the exercise. All right, here is the lecture on variables. Let's see the exercise titled fix error int. So like it says here, edit the script exercise.cs and fix all of the compile errors. And by the way, as soon as you start the exercise or click on this button to open the file, and if you do, and if you see Unity kind of breaking like this, if so, then go into your Visual Studio. And over here, you might see this window telling you that some file has been changed externally. That's because the whole setup for starting the exercises. So whenever you see this window, just go ahead, click on yes to all. And yep, it should reload everything. And yep, here is the exercise file. Again, the goal is to fix this error. And here's a quick tip. Place the mouse over the red line in order to see the actual error. So if we place the mouse over here directly on top of the int red squiggly line, if so, we can see this error. The type or namespace int could not be found. And like it says here, alternatively, we can check the Unity console or check the companion window. So here in Unity, if we look at the console, yep, we see exactly that error. Type or namespace int could not be found. And over here on the companion window, over here we can see a nice little hint on what exactly the issue might be. And yep, in this case, this teaches us exactly what is the solution, what is the problem that we have here. As always, remember how code is case sensitive. Then we can also show the hint. So in this case, the hint is pretty simple. So remember how code is case sensitive. And we can also see the show solution. So there's an error that says int, uppercase I, does not exist. And that is because code is case sensitive and the proper name is int, all lowercase. So the compile error here is pretty simple. Remember how you have to write code perfectly. So in this case, it is not int uppercase, but int, all lowercase. So yep, that's really it. Let's go ahead and save. The code is compiling. And if there it is, exercise completed. Okay, so congrats. In this exercise, you'll learn how to solve the most common error that beginners encounter, which is issues with capitalization. Always remember how code is case sensitive. So int, all lowercase, and int with an uppercase I, those are two completely different things. One exists and one does not. Same thing for all the other types, so float versus float, bool, bool, true, true, and so on. So once again, another exercise to really make sure you fully understand code is case sensitive. The reason why I'm repeating this so often is really because this is the main error that beginners encounter. Okay, so we can now complete the exercise. Alright, so lecture on variables. Here is the exercise, change unit speed. So the goal with this one is to modify the speed variable to make the player reach the target in time. This exercise has a Unity scene. It should be unloaded automatically, so click on Play in Unity to test your code. And just a quick tip, just in case the scene doesn't load automatically, it should do that, but in case it doesn't, just go into your project files, and if you scroll down, you go into whatever lecture you're currently on. So currently we're on the variables lecture. And over here, if we go inside the exercise folder, we should be able to see all the files for this exercise. So over here we have the exercise scene, and yep, it is this one. So like it says here, the goal is to modify the speed variable. Now before we check the code, let's try running this code and see what happens. So the player is moving, some kind of player character, it is moving, and nope, it did not reach the target in time. Okay, so we need to modify the speed in order to make sure it gets there on time. So here's the code. And again, you can ignore these lines that start with 2 forward slashes. These are comments, and the code ignores all of these lines. Comments are covered in detail in a future lecture. So here we have a line of code that is setting some kind of player speed variable. So all we need to modify is this value, and then we can press play in Unity to test our code. And again, something that is going to happen more and more as we see some more complex exercises is some of them have some testing code, so just make sure you don't modify these lines of code, otherwise the exercise breaks. So in this case, all we want to modify is this one, and if we get stuck, we can always show the hint. And like it says here, variables are containers for data, so when the code runs, it gets to the variable and it grabs whatever value is stored in that variable and uses that. So in this case, if we want the player to move faster, then we just need to modify the value that is stored inside the player speed variable. Or as always, you can click on show solution in order to see it. So in this case, the player speed variable just needs a value that is big enough in order to get to the target on time. So for example, float player speed equals 6. So let's put it on 3f. So let's go ahead, save, and over here back into Unity, let's make sure it compiles, and let's hit on play, and it is moving forward, and nope, it still did not reach it in time, so let's increase by a little bit. So instead of 3, let's go with 6. Okay, let's run the code, and it is moving forward really fast, and yep, there you go, success, we didn't get there in time. Alright, awesome. So in this exercise, you'll learn how variables are used in the actual code, meaning how their value actually affects how the code behaves. So over here, by just modifying the value that we stored inside a variable, we managed to see how that actually impacted the behavior for the code, which in turn allowed us to achieve our results. Okay, so let's go ahead, stop playing, and let's complete our exercise. Alright, let's see the lecture on variables, with the exercise titled Fix the Error Uninitialized. So like it says here, fix the error in the console, a variable is being used while unassigned. So here is our exercise file, and as usual, let's place the mouse over the red line in order to see the error. And our error here, thankfully, this one is pretty descriptive, so it says use of unassigned local variable age. This is teaching us that before we can use a variable, we need to actually assign some kind of value to it. So this exercise is pretty simple, and the way that we assign a value, like we saw in the lecture, is by using the equal sign, and then using some kind of value. But again, remember how the value is also dependent on the type that we're using. So since this is an int variable, we cannot put some kind of string of text, this does not work. We also cannot put some kind of decimal value. Nope, here it has to be an integer, so let's put just a whole number, and yep, just like this, and we no longer have any errors. The variable is correctly being assigned with some kind of value, so then we can indeed use it. So let's save our code and see, and let it compile, and if there it is, our exercise has been completed. So good job, here you learn another common error, using variables before assigning a value to them. So always make sure a variable has a value, and the best way to avoid this error is to always give it a default value whenever you define a variable. So yep, always keep that in mind. Remember how before you can use a variable, it needs to have some kind of value. Okay, let's complete the exercise. Alright, so here is the lecture on variables, and let's do the exercise titled double variable. So the goal with this one is double the value inside the age variable. Do not modify the code defining the variable or calling the function result. So we should really just double the value inside the age variable. So we should only double the value inside the age variable, and then we can play the scene in Unity in order to test our code. Alright, so here's the script. And again, we've got some comments that again are ignored by the compiler. These are just text, just to guide us. Then over here, first thing we have is an int variable named age, and it is being initialized with the value 20. And then, like it says here, modify this line down here, set it to double the value stored inside of age. And as a quick hint, remember how you can use math with variables. Now, one obvious thing is you can just do math within your own head. So you can just set it to 40, which is indeed double of 20. And if we hit play in Unity, and technically we got a success, we did get double. However, while the result is accurate, there doesn't seem to be any multiplication. So the goal with this exercise is to teach you how you can use mathematical operations within your variables. So setting it to a fixed value, that doesn't make much sense. So let's complete this exercise properly. Let's set it to double by using actual math, by actually multiplying by 2. So over here, instead of the direct value, We can use math, so we can take our age variable, so that is the one that we defined up here, so it is currently with the value 20. We can take this, and then we can do multiplications using an asterisk, and then we can multiply it by something, so in order to double it, pretty simple, just multiply it by 2. So yep, this is going to assign the age double variable. It is going to be assigned to the value of age multiplied by 2, and the value of age contains the value 20. So in this case, 20 times 2, and age double won't be set to 40. Okay, so that's it. Always remember to save your file. Just let Unity compile the changes, and let's hit on play. And if there it is, we have our success, and our exercise has been completed. So good job. In this exercise, you'll learn how you can do math with variables. Yep, this is definitely something that is very valuable. Always remember how you can take your variables and do math with them. Now we can complete the exercise. And yep, we have 5 out of 5 exercises completed, so everything is fully completed. There it is, the variables lecture all fully on green. So what we did here, basically what I want you to do after every single lecture. So watch a video lecture, then come here and do all of that. Go onto the main window, select the lecture that you want, go through all the frequently asked questions, all the quizzes, do all the exercises, and make sure that everything is nice and green. If you truly want to learn C#, then this is really what you need to do. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about the various built-in data types that exist. Okay, so in the previous lecture, we learned about variables, which are essentially just data containers. And those containers, they need to have a specific type. There's a bunch of built-in types we can use. For example, some containers can only store whole numbers. Other containers can store strings of text. Then other ones can store the value either true or false. And some can store decimal numbers. So there's a bunch of interesting built-in types we can use. Here is the same demo that we saw in the previous lecture, with the sprite just bouncing up and down. And this one has a parameter for a movement speed. This one is defined as an int variable. So that means that over here we can only write whole numbers. If I try writing some text, nope, that does not work. If I try adding a decimal point, nope, I can't put it. Over here, since this type is of type int, it can only hold whole numbers. Here is the code that we wrote in the previous lecture. So I've got an int for an age, and over here, if I try assigning a decimal number, like let's say 35.5, and nope, this one has an error. Like I said, ints can only store whole numbers. If you want to store a decimal value, then one of the types we can use is a double. So we literally just swap int for double, and now this variable, this one is now of type double. And with this, yep, we have no errors, so we can indeed write a value with a decimal point and everything works. Now there are actually 3 types that we can use for decimals. We can use float, double, or decimal. There's a nice table directly over here on the C# docs that shows the maximum numbers and precision, which is what affects all of those types. As you can see, they've got different sizes and different precision. The smallest one is a float, which is stored in just 4 bytes. Then a double is stored in 8 bytes, and a decimal in 16 bytes. And over here, we can see the precision. So basically, if you're dealing with something where precision is paramount, like for example, when dealing with money, for that, you really want to use the decimal type. But for all other use cases, you can either use a double or a float. In regular C# applications, I believe doubles are actually used most often, since in order to write a double, you really just put a decimal point, and yep, this one is a double. Whereas the other type, the float type, for this one, if you just define something with a decimal, nope, it does not work. This one shows an error. And the error is because if we just put a dot, then this one simply becomes a double. In order to make it an actual float, we need to append the f onto it. So like I said, in regular C# applications, I believe doubles are mostly used, since you don't even need to append anything, you just write the number. Whereas for floats, you need to append f. And in Unity game development, which is the thing that I do most of the logic is usually done with floats. So personally, that's the decimal type that I normally tend to use. Now for Unity beginners, one of the things that trips them up is forgetting to place the f at the end. Like we saw, if we don't do it, yep, we get an error because this is a double, and double is not automatically convertible into a float. So if you ever see an error like this, always remember that if you're defining a float, make sure to add f at the end. Okay, so these are the main types for holding decimals. And then there's also a bunch more types for holding whole numbers beyond int. Again, the documentation has a really nice table over here. So int is the one that you're probably going to use most often. This is a signed 32-bit integer. You can store values between minus 2.1 billion to plus 2.1 billion, but there are use cases where you don't need that much precision. There are some cases where you are memory limited, so you want to use as fewer bits as possible. So in those cases, you've got all of these values. And on the other hand, if you want to store a real large number, like for example, the age of the universe, for that, you would normally use either long or long. But for the most part, you will really just be using ints. So don't worry about the rest, just know that those also exist. And also, since we're talking about maximum and minimum, let me just show you what happens if you go above the maximum. So for example, here we've got age defined as an int. Now here we can give it the maximum value for an int. For that, we can access the int class and pass in a dot. This one lets us access a bunch of constants or functions inside the int class. Again, I will cover classes in detail in a future lecture. For now, over here, we can just check the max value. And this one is basically going to represent the largest possible value that we can store inside an int, which like we saw a while ago, the maximum is 2.1 billion. So let's do a console.writeLine on this one. and see what the maximum is. And then let's do something interesting. So let's take the age and increment it by just 1, and let's print again and see what this one prints. And yep, that's the result. So basically first we've got the maximum, so 214, yep, this is the maximum value for an int. And then if we have that value and we increment it by just 1, then we get what is called an overflow, and essentially it really just loops back the value to the absolute minimum. So if you go past the maximum, you really just end up on the minimum. When working with data types, always make sure you define some type that is enough to store whatever value you need to store. Okay, so here we have ints and floats for most of our number needs. Then we can also do operations on them. So on a float, you can do a float times 2, something like this. You can do division, you can do addition, you can do subtraction, so all the usual things. Now, there are some quirks if you do some mathematical operation using different types, like for example, floats and ints. I won't cover type conversions in a little bit, but in terms of numbers, usually you're going to work with mostly with ints and floats. And then another very important data type are strings. These are strings of text. So you define a string by typing in string, so just like the same as any other variable. Then let's call this one name, and let's assign a string value onto it. Now, when making a string, you do it using double quotation marks, and remember to add both the beginning and the ending quotation mark. And as usual, every instruction needs to end with a semicolon. So over here, do not make the mistake of putting the semicolon inside the quotation marks. This one is an error because over here we just have a string with a semicolon instead of having a semicolon to end the instruction. So don't make that mistake. And also it's very important how these are double quotation marks. These are not the single quotation marks. These are completely different things. Those are used for another type that I'm going to cover in a little bit. So it's double quotation marks. We have the start, we have the end, and then inside we can write whatever text string we want. So for example, writing CodeMonkey. And then we can do a console.writeLine, and let's print out our name variable. And if there it is, it prints exactly as intended. As for making some operations with strings, the most basic one is just appending or concatenating a string. For that, you just take a string and then do plus and then another string. Like for example, my name is, and then plus, and then the name. This is basically going to add this string onto the end of this string. If we run this, and if there you go, my name is CodeMonkey. Okay, great. Now also important over here are the spaces inside the quotation marks. These spaces do matter. If we don't put a space here, if there you go, it says is and then CodeMonkey with no space between them. And on the other hand, if we add a ton of spaces, if there you go, now it adds a ton of spaces. So basically just be aware that spaces do matter. These are not just empty. And then when concatenating strings, you can also use it to mix multiple types. So for example, our age up here. So we can do my name is, then plus and add the name onto it. Then we can add some more. Again, let's start by adding a space, and I'm another space, and then let's print the age, plus years old. Okay, let's see this. And if there's our final string putting together all the values from all of our variables. So this is one way to do it. You basically just make one string, then plus add another string and so on. This is one way to do it. Or alternatively, you can use the string interpolation method. To use that one, you basically just put everything inside one string. So let's get rid of all the pluses and all of the things creating brand new strings. So let's write it just like this, except of course, just like this. This is just going to print my name is name and I'm 8 years old. So this is not what we want. For string interpolation, we have an entire string, and then before it, we add a $sign. And now inside it, whenever we have something that is a variable, we can add some curly braces, open and close them. Again, don't forget to open and close. Let's add on both these variables. And now if we print, if there it is, now it says the same thing. So these two are basically doing the exact same thing. They achieve the exact same output. You can either construct a long string by building different pieces and adding them onto one another, or you can just make an entire one and use string interpolation in order to define what is a value and what is a string. Also, here's yet another more advanced tip on strings. Let's say, for example, you want to store a string that contains quotation marks. So let's do a WriteLine, and let's print my name is CodeMonkey. But now let's say that I want to print some quotation marks directly in there. Now, if we do it like this, obviously there's an error. Basically over here, we are starting and finishing one string, then over here starting and finishing another one, and over here we've got some symbols that C# does not understand. So this does not work. Basically, we do not want this quotation mark to end this first quotation mark. Instead, we want this one to be seen as just a character. So if you need to put quotation marks directly inside a string, for that, you can just go before it and add a backslash. And this is basically going to escape this character, which means it is going to consider it as text instead of interpreting as a string quotation mark. So we can just add that one to that one and to that one. And if there you go, exactly like this. And if there's a text and the string does print with all the quotation marks. Okay, great. So another thing that I mentioned is how it's important that you use double quotation marks. The reason for that is because there is another type that is specific to single quotation marks, and that type is char. That stands for some kind of character. And for that, you use the single quotation marks, and inside you can place a single character, like for example, the letter A. Again, this type only stores a character, so if I try putting a bunch more stuff, nope, does not work. This one only represents one character, so that's the only thing that I can store inside it. Now, another very important type is boolean, or bool. So for that, you write bool, then give it some name, like let's say is player. And then for this one, there are only two values we can store inside a bool. It can be either true, or for example, let's say is enemy, and can be false. So the boolean type can only have these two values, nothing else. And again, Again, it's extremely important that you write the code exactly, so it's true like this, all in lowercase. It is not capital T true. Nope, this does not exist. It is not everything in true. Nope, does not exist, so it's all in lowercase. Now this type boolean, this one is extremely important in if statements and conditions, which we're going to see in detail in the next lecture. And there is one more special sort of type that you should know, although it's not really a type, and that is how simply instead of defining a specific type like bool, char, string, and so on, instead of that, you can just write var, then give it some kind of name, my variable, and then give it some kind of value. And basically with this, the compiler will essentially look at the value that is assigned and infer some type of type for this variable. So for example, for this one, since we assigned the value 10, this one correctly defined this variable as an int. Whereas if I put 10.2 for this one, now it correctly identifies it as a double. If I put an f, now it correctly identifies as a float. If I put false, and this one is now a bool. And if I put false in quotation marks, and this one is now a string. So rather than explicitly defining the type, if you want, you can just define it as var and let the compiler infer the type for you. Some people like this because it tends to make the code a little bit more compact, especially when we're working with complex names, when we're working with types like lists and so on. However, personally, I am not a fan of var. Personally, I like being as explicit as possible so that I know exactly what type I'm working with. So personally, I never use var. I always very explicitly write the type that I'm using, but there is nothing wrong with var. It's really just personal preference. So if you like using it, then by all means use it. Here is a demo that I built, included in the interactive exercises. So we've got a bunch of values up here and a bunch of containers down here of various types. Now this value, the value 56, this one is selected, and we need to place it in the correct container. Now if we try putting this in a boolean, nope, that does not work because this is not a boolean. This one is a whole number. So for whole numbers, we can place them inside the int container. Then over here, we've got a string. So this one cannot be a float, cannot be a bool. Nope, this one is a string. Then we've got false. This one is a boolean value. 7, this is a whole number. So let's put it inside the int. Iron Man, this is another string. Let's put it on string. Black Widow, same thing. It's a string. 35, this one is a whole number. So it goes into int. 33.3f, this one is a float. So go inside the floats. True, this is a boolean. So go in there. This one is a float. And this one is also a float. All right, all done. Go ahead and give it a try yourself and see if you get them all right. Now let's just see one more thing on types, which is type conversion. And we actually already saw that. If we do a console.writeLine, and on this one, let's print out the age. If we do this and run, there you go, it did print out the age. So the code is automatically converting our int age into a string that is printed onto the console. Basically, all types can be automatically converted into a string. Then you can also mix types together. For example, let's say number 5 plus and then a string saying number. And this code works. However, like I mentioned in the programming basics lecture, code runs from top to bottom, but also left to right. Meaning over here, let's see what happens if we place first the string number, then let's add the number 5, and then let's add the number 6. So let's see what this evaluates to. And if there it is, a string number 5, 6, okay, great. However, now let's reverse the order. So let's put 5 plus 6, and then the string number. Now let's see what this one evaluates to. And if there it is, now it says 11 number. So this is the difference between how the code runs from left to right. Basically over here, the code is going to see, okay, this is a string and this is an int, and the result from adding a string onto an int, the result from that is going to be a string. So this one is going to concatenate into the string number 5, and then it's going to have another string against another int, so it's going to add the 6 onto it. However, on this one, first left to right, it is going to check an int plus another int. That is a simple mathematical operation, so it is going to add these two numbers together, and then the result is an int, which then adds onto a string, so it is going to do string concatenation. So the second one ends up with 11 number, whereas the first one with number 56. So remember, code executes from top to bottom and left to right. Always keep that in mind. Now, in terms of converting to a string, anything can be converted onto a string. However, for other ones, some types can be converted into others automatically, some have to be done explicitly, and some can't be done at all. When it comes to numeric types, these can be automatically converted if the target type can hold that data. For example, over here, let's define a long, and over here, the value that we put doesn't really matter, so it doesn't have to be a massive value. And then if we define an int, and we try assigning this int onto the one that we had inside the long, and nope, this does not work. If we look at it, we see the error, which is you cannot implicitly convert a long onto an int. The reason for that, once again, goes back into this chart. The long type, this one can store a lot more values than the int can store. So because of that, the compiler does not let us automatically convert this because the conversion might imply some loss of data, and the compiler protects you from that. However, we can do the opposite, since over here the long, this one can store these many values, whereas the int can store this many. So basically a long can store everything inside an int and a bunch more. So because of that, we can do the opposite. So we can define ageUniverse inside an int, and then for the long, we can put it ageUniverse int. And yep, this one does work. Again, that is because long can store more values than just the int, so we have a guarantee that whatever we define inside the int can be stored inside a long. And then same thing for doubles and floats. Doubles have more precision, so we can store a float inside a double, but we cannot do the opposite. And also, like we saw, we cannot have an int and assign it some kind of decimal value. This does not work. However, like the error says here, these are implicit conversions. However, we can be explicit and it will force a conversion, even though it might end up with a loss of data. And the way we do that is we just cast it onto a type. So we open parentheses, we put the target type and then close it. So this is a cast. I'm actually going to cover casting in more detail later on in this course. If we do it, nope, we no longer have an error. However, like I said, you might end up with a loss of data. For example, over here, we are forcing the 35.5 to be placed inside an int. So let's see what this actually returns. So let's do a console.writeLine. Let's see what this prints. And if there you go, it prints 35. Since ints can only store whole numbers, basically when it gets to the decimal point, it just ignores everything out of it. Importantly, it does not round the value. So even if I put this 35.9, nope, it still says just 35. So basically when we are forcing the conversion onto an int, it is basically going to ignore everything after the decimal point. Now on this topic, one of the most common mistakes that beginners make is actually when dividing ints. So for example, let's say the player has some kind of health and it's stored in an int. Let's say they currently have 1 health. And then let's say they've got a health max and the health max is 10. And then you're trying to normalize this value. So you do health divided by health max. So now what do you think this will actually output? In theory, the mathematical answer would be 0.1. So we've got 1 divided by 10. That should be 0.1. But nope, here the result is 0. Again, it's the exact same reason. It's because of type limitations. We are dividing an int by another int, so the result of that calculation will also be an int, and inside an int we cannot store the value 0.1, so it does the same thing that we saw a while ago. It ignores the decimals and just stores the whole number, which in this case just ends up storing 0. Now in solution, this problem is really simple. We just need to convert one of these values into a float, so we can just cast it onto a float. So now here we have some math doing between a float and an int, so the final result will be a float. And if we test, yep, now it does return the correct result, 0.1. So if you ever have any strange results when doing calculations, always double check that you're using the correct type so you're not losing any data. And like I said, there are some types you can convert even with a cast. For example, you cannot forcefully cast a false onto an int. This does not work. And same thing for a string onto a number. Nope, this does not work. If you do want to convert a string onto a number, for that you have two methods. One method is using a class called convert. And then inside it converts a whole bunch of functions in order to convert from all kinds of types. Like for example, convert to int32, which is going to be the regular int. The int64, this one is going to be the long, and the int16, this one is a short. If you're wondering what those numbers are, it's over here. It's the size of the actual value. So the int, that is a 32-bit int, whereas the long is a 64-bit and so on. And on the right side, we can actually see the full name for the types. What we see on the left type is usually what we use, but these are really just aliases. The actual types are the ones over here. So an int is really a system.int32. The long is really a system.int64 and so on. So anyways, yep, here we have a whole bunch of functions. And again, don't worry about what are functions for now. I will cover them in detail in future lectures. But if we were to use this function, then we can indeed convert the value 56 into the health. And yep, this does work. Although of course this only works if the string actually has a number. If you write something, you're actually going to get an error. Alright, so that's a lot of info on variables, data types, and type conversion. This is one of the most important part of the basics of programming, so definitely make sure you fully understand this topic before going further. If you need, go ahead and rewatch this lecture to really solidify this knowledge. It is really important that you fully understand variables and types before going any further. Next, we're going to learn another extremely important part of programming, if statements and conditions. So let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about if-else statements and conditions. We're going to learn how conditions are evaluated, how to do mathematical tests, and logical operations. So let's learn about ifs and conditions. This has to do with one type that we already saw in the previous lecture, Boolean. This is a type that can only be either true or false. Those are the only two possible values. Basically, we write a condition, and then the code evaluates that condition to either true or false. Now, the simplest condition is just equality. So for example, is 1 equal to 1? The answer is yep, so when the code evaluates this one, it evaluates it to true. And if we check is 1 equals to 2, that is obviously false. 1 is not equal to 2, so this one evaluates to false. Then we can use these conditions inside an if. The if has a condition and then a code block. And if the condition is true, then it is going to execute this code block. And if it is false, then it does not execute this code block. And again, going back to what I mentioned in the programming basics lecture, the code executes from top to bottom. So first it executes this if, then checks the condition, and the condition is true, so it goes inside and executes the code inside, then goes back outside, then executes this if, checks the condition, this one is false, so it skips that one and continues running afterwards. So the code is still executing from top to bottom as usual, but by using ifs we can control what code actually runs when. Here is a visual demo in the interactive exercises. We've got a simple if condition testing if a distance is under a certain amount. If so, then we're going to set this target color to green, and if not, we're going to set it to white. So I can click to move the player, and as the distance goes under that amount, yep, that one turns green, and if it goes above, then that one turns white. So depending on whether this condition is true or not, it is running either this line or this line of code. Here in the code, let's see our syntax, and the syntax for an if is really simple. We just write if, and again, remember how code is case sensitive, so it is not if all uppercase, it is not uppercase and lowercase, it is neither of these. Instead, it is if all lowercase, again, very important. If you write it properly, it should change color. Then we write the condition inside parentheses. Remember to have a matching closing parentheses for every opening. The condition can be all kinds of things. They will eventually be evaluated into a boolean, so either true or false. So over here, we can just write true for testing. So you have if, then the condition, and then we just do a code block. And this is the code that will be executed if the condition is true. So for example, over here, just a console.writeLine, let's say inside if. And if we run this, and if there it is, we are inside the if, so we did run that code. Whereas now, if instead of true, if we change this into false and run it, and if now that one does not run because that one is false. So the code goes to execute this line, then it sees this condition is false, so it is going to skip this one and continue afterwards. Now, it obviously doesn't make much sense to manually write either true or false over here on the condition. Usually we want to test some kind of thing, some kind of proper condition, and the most basic thing is simply mathematical operations. So if we test 1 equals 1, if we test this, if that is inside, goes inside the if. Alternatively, instead of just equality, we can simply do some mathematical operations. Like for example, let's see if we are testing if 2 is bigger than 1. So pretty simple, and the result of this test is true since 2 is indeed bigger than 1. So if we run this, yep, there's our message, it works. Basically what the code is doing is that when it gets over here to the if, it gets to this condition, then it evaluates this condition, and again, it is going to evaluate into either true or false, and then if it is true, goes inside it, if it is false, skips it. There's a bunch of mathematical operations you can do. You can do bigger than, you can do less than, you can do bigger or equal, less than or equal. So you have all these standard mathematical operations. And of course, over here, I'm using values directly, but you could replace this with a variable. So like an int for the age, 35, then let's say if age is under or equal to 40, and yep, obviously this works. So you have all kinds of operations, and then you also have the equals. Now here's another extremely important thing. When you want to test for equality, you do a double equals. Not just one, it's a double equal sign. The single equals, this one is meant for assignment. Like for example, we define a variable, then we do a single equals, and we are assigning the value 35 onto our variable. But when we want to test for equality, we do a double equals. Again, this is very important. This is a mistake that a lot of beginners do. They do something like a single equals, and they have no idea why there's an error. Over here, the error isn't very helpful. It says the left-hand side of the assignment must be a variable. So if you're a beginner, this makes no sense. But that's because the single equals, this one stands for assignment, and double equals, this one is for equality. And if you try putting that inside a write line, so let's do console.writeLine. If we do age double equals 35, if we do this, yep, there you go, that does return true. However, if now we put just a single equals, and yep, now instead of either true or false, it just says 35. That is because the single equals, this one is assigning the value over there, and it's not actually doing any comparison. So again, don't make this mistake. Single equals is for assignment, and double equals is for equality. So related to equals is the not equal sign, and for this one, we do an exclamation point and then an equals. So the exclamation point means not, so not equals. So in this case, this one will not run because 1 is equals to 1, so 1 not equals 1 is false. Whereas if we put it 2, 1 does not equal 2, yep, that's true. So yep, it does run. And of course, over here, we can simply use Boolean variables. So bool is player. Let's define this as true. And then over here, just if is player. If so, then yep, this works. So over here, we have the code block that is going to execute if the if condition is true. And then we have another keyword that we can add after the if. We can add the keyword else and then another code block. And now this code block will execute if the first if is not true. So let's do another write line inside else. And over here, we define player as true, then we test if is player, so it is going to be inside this one, so it is not going to run this one. If we test, if there you go, it just says inside the if, but then if I swap player to false, so now it is not going to run the if, and instead it's going to run the else. If there it is, just like that. So for example, instead of having two ifs, like if is player and if not is player, which by the way, the not equals, that one can also be applied like this. If you put the exclamation point, then it's basically going to negate whatever comes afterwards. So over here we have not is player. So we are testing if it is player or not is player, which is really the same thing. So if you want to test this kind of thing, then using an else makes it much simpler. That's exactly what the code over here in the demo is doing. It is testing if distance is under 4, and if so, then it's going to set the target color to green. If not, it is going to set it to white. If I had not written this else statement, then as soon as it became green, even if we stood outside of it, it would not change it back. Whereas like this, if it's inside, it turns green. If not, else it turns white. And now here we are testing a single condition, but we can also combine multiple conditions. Let's say, for example, we want to test if 2 is bigger than 1, and if 3 is bigger than 1. The way we write a logical AND is just like this, with 2 ampersands. Again, it's very, very important. Just like the double equals, this is a double ampersands. If you put just one, this is a completely different operation. This is a bitwise AND, which is something that I covered in the advanced portion of this course. But over here for a logical AND, we do not want just one, so we want 2 of them. Again, don't make this mistake. So let's see what this outputs. And if there it is, it runs the code inside the if. So basically here we have 2 conditions, and when the code gets to this point, it is basically going to evaluate each condition from left to right. So first evaluates this one, is 2 bigger than 1? The answer is yes, so this one evaluates to true. And is 3 bigger than 1? The answer is also yes, so this one also evaluates to true. And then we've got an AND operation between a true and a true. And this AND operation, the output of this one will only be true if both conditions are true, which is the case over here, so that's why this one runs inside the if. If we change one of these, so let's say true and false, if so, then the output for this one will be false, so it is not going to run this one, instead it's going to run the else. In order to know what combinations make true or false, you can look at what is called a truth table. So over here we've got the values A and B, and then we've got the result of doing an AND operation or an OR operation between both those. A and B can be either true or false, which by the way, sometimes true or false is represented as simply ones and zeros. So 0 equals false and 1 equals true, really just different representations of the same thing. So over here we have the AND operator, and like I said, the AND, this one is only true if both conditions are true. So if A is false and B is false, both are false, so the AND output is going to be false. If A is false but B is true, again, we still don't have the condition that both of them are true, so the output is still false. Same thing over here, if A is true, B is false, the output is still false. It is only if we have both A and B, both of them are true. If so, then the output of the AND is also true. So the result of an AND is only true if both components are true. Then the other operation that we can see here is the OR operator. This one is going to be true if either A or B is true. So if both of them are false, if so, then the OR is going to be false. But if just one of them is true, then the output of the OR is going to be true. Or if both of them are true, if so, then the output is also going to be true. Over here in the code, the way we write an OR operator is denoted by 2 pipes. Again, pay close attention to the fact that it is 2. If you write just 1, this is a completely different operation. This is another bitwise operation, which again, I cover in detail in the advanced section. So also pay close attention here, it is 2 pipes. So this makes an OR operation. Like I said, this one is going to run our code block if either of these are true. So if this one is true, then yep, this one is going to run. And yep, it does run. The OR only returns false if both of them are false. And if we set this, yep, we run the code inside the else. There is an interactive truth table in the exercises. Here up top we have the inputs, and down here we have the outputs. So for the AND is only true if both are true. So if that one is true and false, the output is false. False, true, that one. And if both are true, that one is true. The OR is only true if either of them are true. So if either of these are true, the output is going to be true. And the NOT simply inverts it. So if it's false, becomes true. And if it's true, becomes false. Now, these conditions, doing an OR or an AND, doing this always works just between 2 elements. But you can also have multiple conditions, not just 2. You can have as many conditions as you want. So here, and true or false, you can have as many as you want. However, it's also important to know they are evaluated from left to right, meaning that whenever doing some kind of or AND operation, it is always done just between 2 conditions. So when the code gets here, first it evaluates this one and gets a result from this evaluation. Then after having that result, then it does the result of this one alongside the result of that one, and finally from this one along with the result of all of these. So it does all those evaluations, and importantly, always from left to right. So for example, let's write if 1 equals 2 or 1 equals 1 and 5 is bigger than 1. So if we have these conditions, if you want, pause the video and try to figure out if the code is going to run or not. Like I said, left to right. So first it evaluates this one. Does 1 equal 2? The answer is no, so this one evaluates into false. Then it is going to evaluate this one. Does 1 equal 1? The answer is true, yep. Then it's going to do an OR operation between false or true. And again, the OR is true if just either of them is true. So in this case, this one outputs a true. Then it evaluates this one. Is 5 bigger than 1? That is true. And then we have a true and true. This one returns true. And yep, we do run this code. Then if you want, you can also have more control over the order of testing simply by using parentheses, just like you do in normal math. So for example, let's write some code like this. So for example, we have false or true. This one is going to evaluate into true. Then it's going to do true and false. That is going to evaluate to false. And then false or true. That is going to evaluate into true. So it is going to run this one. So over here, we can add some parentheses. So we want to do this condition first, and then this condition first. And this way, first it is going to evaluate these 2, then evaluate these 2, and only then evaluate the whole thing. Another important thing is also how conditions can short circuit, meaning let's say we have an OR, and with an OR it is going to return true if either of them is true. So if we have true or false, or actually in this case let's put some proper conditions. So 1 bigger than 2, that is going to be false, and 2 bigger than 1. So if we have this, basically over here 2 bigger than 1, this is going to evaluate to true, 1 bigger than 2, this is going to evaluate to false. Now like I said, the OR, this one is going to be true when either of them is true. So when the compiler starts to evaluate these conditions, it starts to evaluate the first one, again, left to right, and evaluates this one into true. And since that is the case, the compiler is smart enough to know not to waste any power on evaluating this second condition, because the first one is true, then it's already going to run inside the if. So after here we can have a bunch more ORs, and it does not matter. The compiler would only test this one, since this one is true, it just ignores everything after this. However, on the other hand, if we have an AND, if so, then it is going to evaluate this one is true, but then the AND is only true if both of them are true. So it cannot stop executing here, it needs to execute this one in order to see if it's true or false, in order to know does it run inside the if or not. So in this case, the short circuit for the AND would be if this one is false. If this one is false right here, then it doesn't even bother evaluating this condition, because if the first one is false, then the AND is always going to return false. This is the kind of thing that becomes really important in some performance-intensive applications, especially when you're running some expensive function to test something. For example, if you have true or and then over here you've got some kind of function that costs quite a lot in terms of performance. If so, then the compiler is going to be smart enough and it's not even going to waste any time running this condition because the first one is already true. Now over here, let me also make one quick note. Ifs technically do not require a code block. So if you just have an if without an else, if so, technically you can just do this. So you can raise the code block and just write the condition afterwards. If you have just a single instruction inside the if, then this is perfectly valid code. So let's put this one true so it goes inside. And if there you go, it does run the code inside the if. However, I highly advise you to always write a code block. The reason is simply because it is very easy to write an if like this, and then later on you want to write another instruction. So let's say inside if2. So you add this, but you forget to write the code block, and you assume this one is still going to run inside the if. And in this case, if we try running this, we do see if and then the if2. But if we change this into false, ideally we would not want either of these to run. But yep, the second one does run. That is because if you don't include a code block, then the only thing that is considered to be inside the if is just the next line immediately afterwards. Remember that in C# indentation does not matter. So the fact that this one has as many spaces, that does not matter at all. The only thing that matters are code blocks and semicolons. If you don't include a code block, then basically just executes the code inside the if, which is going to be until the first semicolon, till the first instruction. So in order to avoid this mistake, my advice is to always write code blocks in all your ifs. So always put it like this, even if you have just one instruction inside it. And speaking of indentation, like I said, it does not matter. So you can indent the code like this or do anything crazy, anything you want. As far as the compiler is concerned, all of this is valid code inside this if. But for your own personal sanity, definitely make sure to take some time to indent things properly. Now here we have our ifs, and we saw the else as well. Something we can do is simply chain ifs. So let's do an if true and then else. And after the else, we can write if immediately afterwards. So for example, here's some code. We define some kind of age. Then we do the first if, testing if age is under 20. In this case, it is not. So it is going to run the else related to this if. And then inside that else, we've got another if. So if under 30, meaning the code inside here is going to run if the age is not inside this if. So if it's above or equal to 20 and under 30. And if not, then it's going to go into the else connected to this if, and finally run this line of code. And if we test, yep, correct, age 35 is indeed above 30. So you can chain a bunch of else ifs together, or you can simply just do a bunch of ifs. Or if we want, we can also chain a bunch of them just like this. So basically just having some ifs one after the other. Yep, this is also perfectly valid code. Alright, so here we'll learn about ifs. And the last thing that we did was chain a bunch of ifs together. This code works correctly. We have all of our ifs one after the other. But with this many ifs, it becomes really hard to understand what the code is doing. So to solve this particular problem, we have another way to run conditional logic, which is by using a switch. So that's what we're going to cover in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the switch. This lets us very easily test comparisons against multiple possible cases. Okay, so here we have the code that we wrote in the previous lecture. We have a bunch of ifs chained together. Technically, this works, but it becomes a bit hard to read. To do this kind of logic, there is a much better way when we want to test multiple different cases, and for that, we want a switch. To do that, first we write switch, and then we write the value or variable that we want to use in our comparison. So in this case, let's use the same name variable. Then we open and close our code block, and now inside here, we write case, and then afterwards what we want to compare against. So in this case, let's compare against the name CodeMonkey. Then we do a colon, and down here we write whatever code we want to execute if the switch variable matches this value. So let's do the exact same thing. And finally, we end the case by using a break. Yep, just like this. This is a valid switch case. Let's just add the other two. Yep, just like this. So basically what we have down here is exactly the same thing as we have up here, except instead of having a ton of separate ifs, we just have a switch. We just write our name variable once, and then individually each value we want to compare against. And if the value in here, it exactly matches the one here, then it's going to run this code. If it perfectly matches this one, it's going to run this one, and so on. Basically, when the code gets to this line, it is going to grab whatever value is stored inside of name. Then it's going to compare against each one of those cases, and when it finds a match like this one, then the code goes inside and runs this line of code. Then when it reaches a break, this one tells it to break out of the switch, so it skips all of these and jumps and continues executing down here. Basically, the switch is really great when you want to compare one value against many different values. It is much simpler to use a switch as opposed to a ton of if-elses. Then the switch also has a special case called default, and basically the code here is going to run if the value that we choose up here does not match any of the values inside any of the cases. If it does not match any of them, it is going to run the default. So here is the interactive demo. I've got a bunch of buttons up here that I can use to modify the string name. And if we can see which switch is going to run. So if the name is CodeMonkey, then it's going to run this case, and it's going to change the outline color into white. If I click on Iron Man, then the name is now Iron Man, so it is going to run this one and put the outline in white, and put the outline in yellow. If I choose Black Widow, then it's going to run this one. And if I choose Spider-Man, which does not match any of these three, if so, then it's going to run default and run like this. Now, if you forget to write a break, so if I remove this, technically this is still valid code, as long as there's it. This one causes an error. It tells you that control cannot fall through from one case label onto another one. However, if we raise this line of code, yep, now this one is perfectly valid. So if up here I change the name into Iron Man, let's see what this code runs. And yep, it says hello Black Widow. Basically what this is doing is if the value up here matches either this case or this case, if it matches either of those, then it's going to run this line of code. So you can have multiple cases run the same line of code, although normally you usually want the code to execute only the code inside that case. You want each value to execute a different thing. So in most cases, you want to use a break at the end of each one. That way, it is very clear what code runs on what case. Also, if you don't assign a default, so if I erase this and I put, let's say, Spider-Man, if I put it which does not match any of these cases, then yep, it simply does nothing. So if it does not match any of the cases, then nothing inside the switch runs and just continues running afterwards. And over here, I'm using a string, but you can use literally almost anything else, like an int or a char. So we can do int age, and then do a switch on the age, and inside do the same thing. So case 10, and over here we've got age 10. We can do a default, we can do all kinds of things. And yep, all of this works. Okay, so here we learned about the switch, which is extremely useful. Next, let's finally learn one extremely powerful feature in any programming, functions. So let's learn about those in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn all about functions. This is an extremely crucial thing, so make sure you fully understand everything in this lecture. So functions are another core concept in programming. A function is basically putting some code inside a box. So let's say over here we've got a bunch of code. This is all in just one main function. This is our entire program. But instead we can build like this. We basically put some code in a separate box, so this is going to be our function. And then we can easily call that function, meaning run the code inside that box by just calling one line of code. One big benefit of this is simply organization. Our code becomes much easier to understand if we have some clear functions with some clear names that do one very specific thing. That is much better for organization as opposed to having a giant wall of text for your entire program. Another big benefit is how it cuts down on copy-pasted code. Without functions, we would need to write the function code every time we wanted that behavior. So for example, let's say here we got some code that we are copy-pasting and repeating 3 times. Right away, it's bad that we are copy-pasting the same code multiple times. But even worse than that is imagine if we wanted to modify some behavior on this code that we are repeating multiple times. In order to modify it, we need to apply those modifications to every single version, every single place where we are calling essentially the same code. Whereas if we're using a function, it doesn't matter how many times we call it. If we need to modify anything in this logic, we just modify it in one place and automatically updates in every other place. Also, just one quick note, like I've said several times, code runs from top to bottom, and that is still true when it comes to functions, except the code jumps around a little bit. So it starts executing up here, executes all these, then gets to the function, and then it jumps inside the function, then it runs the code top to bottom from that function, and when it reaches the end, basically goes back and continues executing from there. So the execution jumps around a bit, but it's still pretty much the same in terms of working from top to bottom. And now before we see the syntax for functions, we should look into the other more advanced template. So far we've been using this really basic template where we just write our code here. This is really great for the basics, but by now we already have enough knowledge to be able to use the more thorough template. So go ahead and open up Visual Studio, then let's go to create a brand new project. Once again, let's pick a console app. You should be able to see it on the recent project templates, or again, search for it. And again, remember it's this one with the C# icon. It is not the one with Visual Basic or F#, and it is not the one with .NET Framework. It is the one that just says console app in C#. So let's pick this one. Then let's give it some name. I'm going to go with CodeMonkey C# course. Place it anywhere and leave it the same solution name. Let's go next. Then over here, yep, let's use .NET 8. And now importantly is over here, let's make sure to tick this box. We do not want to use the top level statements, which is the simplified template. We don't want to use that. We want to use the standard code. So that's it, just like this. Let's hit on create. And yep, here is the brand new template. For now, you really don't need to worry about the specifics of this. So don't worry about what is a namespace, what is a class, what is static, and so on. For now, you can ignore all of that. Just know that the only difference in this template is all the code that we've been writing. Right now, we would simply write it directly in here inside the main function. If we run this, we should see the exact same hello world. Yep, there it is, hello world, exactly the same as previously. The one very important thing is here being very careful over where you write your code, meaning it needs to be over here inside the main function, inside this code block. It cannot be, for example, over here just inside the class code block. This does not work, this causes an error. And it also cannot be outside here, inside namespace, or completely outside of anything. So all the syntax is all still exactly the same as we've been seeing so far. Just make sure to write it over here directly inside the main function. And now before we see the syntax instead of function, those are usually referring to the exact same thing. Technically in C#, the correct term is method, but both terms are really used interchangeably. Sometimes I call them functions, sometimes I call them methods. Just know that in most cases when someone says either term, they're really referring to the same thing. Now in order to define a function, we begin writing, let's say, outside the main function. Again, it's very important that you write the code in the correct place. We want to start writing over here, which is after closing the main code block, but still inside the class code block. So inside this one, but outside the main. So right here, we begin by defining the data type that we're going to return from that function. If we don't want to return any data, we can use a special type called void. Void means nothing, so pretty much exactly the same thing as our main function here, which also does not return anything. So we have the return type, and then we give the function some kind of name. I'm actually going to talk about the importance of good names later on in the course in a dedicated lecture. It is an extremely important thing. You should always give it a proper name and not something that has no meaning, like for example just the letter X. If you do that, then you have no idea what that is actually doing. So over here, let's give it a proper name. Let's say we want to make a function that just prints hello to the console. So let's give it a proper name and just call it say hello. So that's the name of our function, and then we open our parentheses, and inside we add any parameters that we want our function to have. Although optionally we can also have it with no parameters. So let's just close the parentheses. Again, always keep in mind matching opening and closing. So we define this, and then we just write our code block. So just curly braces, open and close, and yep, over here we have the function code. Now here we can write whatever code we want our function to do. So for example, let's just do a simple console.writeLine, and let's just print out hello. Alright, yep, that's it, pretty simple. Here we have defined a function. Also, just one more thing, in order for our demo to work, we actually need to mark this function as static. So over here, we need to write static, just like we have on the main. Now, like I said a while ago, for now, don't worry about understanding static. I will cover it in detail later on in the course. For now, just know that in order for our code to work, we need both the main function and the say hello function. We need both of these to be marked as static. Okay, so our function is ready. However, if we try running this, and if we still just see hello world, we do not see our second function hello. That's because over here we are defining the function, but we didn't actually run it. Remember how code executes? It executes from top to bottom, and the entry point is over here inside the main function. So right now, all our program is doing is it starts executing over here, then runs this one, prints hello world onto the console, and it reaches the end of the main function, and that closes our program. So just defining a function doesn't actually do anything. We need to actually call it or run that function. And in order to do that, we just need to write our function name. So let's say hello, and then the parentheses for any parameters, which in this one doesn't have any. So let's just open and close. And again, terminate our instruction with a semicolon. Also again, very important, remember how code is case sensitive. So you have to write the name of the function exactly. If I replace this age with a lowercase h, nope, does not work. At a red squiggly line, needs to be perfect. If I replace the s with s, nope, does not work. So always remember code is case sensitive. So just with this, if we test, and yep, we do see hello world and then hello. So basically, like I showed in the diagram, the code is running from top to bottom, so starts executing here, then goes to execute this one, which in turn causes the execution to jump onto this one, and when this function terminates, then it goes back into the original execution, which in turn simply finishes the program. Another extremely useful thing about functions is simply how you can call them as many times as you want. So for example, let's make a bunch more instructions over here. Let's print out hello vertically. Okay, just like this. Now let's say we wanted to print this out 3 times. So we could either copy paste the code literally 3 times, but obviously this looks quite messy, or using functions, we can simply call the function 3 times. And if we test, and if there it is, it did run our function, did run our print 3 times. And also, like I mentioned in the diagram, if we wanted to modify any behavior inside this function, we just need to modify it over here just once in the function, and basically automatically updates whatever that function is called. as opposed to if we were copy pasting, we would need to make that modification multiple times. So just with this simple example, we can already see a ton of benefits from functions. They help us organize our code by splitting our code into functions that each do a specific thing, and also helps us avoid tons of copy pasted code by putting any code we want inside a function and simply calling it. Now that we've seen the super basic function, next thing are parameters. And the way you add parameters is inside the parentheses. Parameters are essentially just variables, so we start by writing the data type for the parameter. Let's say we want one of type string, so we just write string. Then we give it some kind of name, so let's say player name. Again, make sure you choose good names that clearly represent what this parameter should be, what it should represent. And now basically inside this function, we can use our player name in any way you want. So for example, let's say hello and then print out the player name. All right, yep, just like this. And now up here, we can already see a bunch of errors. And the error is saying there is no argument given, which also, by the way, you might hear the name argument instead of parameter. These are again, sort of interchangeable names, just like method and function. Now, technically the definition is that over here, when defining the function, this one is technically called a parameter, whereas when you use it to call something, that one is technically called an argument. So that's what's technically correct, but in reality, most people use both terms interchangeably, so parameter or argument really refers to the same thing. And now here we can see the error, and the error says that there is no argument given that corresponds to the required parameter for our player name. So inside the parameters, we need to pass in a string for our player name. We can either pass in a variable, so define a string variable and pass it in, or just write over here a string directly. So let's say code monkey, and yep, just like this, and if we test, and yep, it does say hello code monkey, which of course means that you can call the function multiple times with multiple different parameters, and yep, it runs the logic with multiple parameters. And speaking of multiple, we can also have more than one over here. We've already seen 0 parameters and 1 parameter, but we can have as many as we want. You really just add a comma and then again, any type and name. Well, let's say int age, like hello player name, you are age years old. Then over here on say hello, just pass in another parameter just like this. And if there it is, hello code monkey, you are 35 years old. The next very important thing about functions are return types. Right now we define this function as returning void, and void means nothing, so it means that this function doesn't return anything. But now let's make a function that does return something. Let's make a function to simply add two numbers together. To get the result, let's play just around with simple whole numbers. So let's put int, we're going to return an int. Let's call it add numbers. Then inside parentheses, let's add two numbers. So let's define int x, int y. Okay, like this. And right away, Visual Studio is showing us an error, and it says not all code paths return a value, meaning if we define some kind of return type other than void, we have to return something. And the way we do that is simply with the keyword return, and then whatever value we want to return. So in this case, adding two numbers, let's just do x plus y. And yep, there it is, super simple. Again, in order to call this, we need to add in static, just make sure that it works. And now up here, now we can call add numbers. Let's add the number 1 and 2, and let's see. Let's actually put this inside a console.writeLine just to see the result. Okay, let's test. And if there it is, the result is indeed 3. So 1 plus 2 equals 3. Another thing you can do is define multiple functions with the exact same name. They just need to have different parameters, either a different number of parameters or different types. So here we cannot define another function named exactly add numbers with also two int parameters. We cannot do this, but if we swap one of these into bool, then all of a sudden this function definition is indeed valid. Or alternatively, if we have int, but then we have a final one. If we do, then yep, this one is also valid. And then up here when calling add numbers, as soon as you open the parentheses, you see this one and you see 1 of 2. So this is basically showing all the various versions of this function. So the first version takes an x and a y, both ints. And the second version takes x, y, and z. And for the types, we can just look inside the console.writeLine, so add the parentheses. And over here we see this one has 18 versions. So this one takes no parameters. This one takes a boolean, a character array, decimal, double, float, and so on. And then of course you can also chain functions together. So basically the return value, this means that whenever this function runs, it is going to run this logic and return some kind of thing. So just like we saw on the ifs and the conditions, basically the code gets to here, evaluates this function, gets some kind of return value. So for example, up here, instead of passing in the number 35, we can call add numbers and pass in something. As long as the return type on this function matches the parameter type, as long as it's like that, then yep, this works. If there it is, that's correct. And of course, we can simply put the result of a function inside some kind of variable. So int number, we can just add numbers. And now if we do a console.writeLine on our number, if we do this, if there it is, it does print the same thing. Now, one very useful type to return from a function is boolean. So for example, let's make another function. Let's make it return bool. And let's say, for example, just is positive. We want to return if a certain number is positive. Let's receive an int x. And we can do if and compare x to 2. So if x is bigger than or equal to 0, I think 0 equals as a positive number. I'm not sure, but I think so. So if so, then this return true. And if not, then return false. And yep, there it is. And again, just in here, we need to make sure to add static in order to make this work. So now up here, let's do a console.writeLine. And let's pass in is positive. Let's say the number 5. then let's add a semicolon, just separate it, and let's say is positive, and let's say -2. Okay, let's see what this does. And yep, it says true and false. So yep, that is correct. 5 is indeed positive, -2 is indeed not positive. Also, by the way, here, instead of doing these returns, instead of doing these ifs, instead we can really just return the condition itself. So we can just do return and just return the condition. So just like this. And yep, everything still works exactly the same. When the code gets to here, it is going to evaluate this condition, which is going to return true or false, and then returns the whole thing and then prints it out. Now back over here on the void return type, on this one, you don't have to call return. Over here, we have no errors. However, if you want, you can also call return. And for this one, since this returns nothing, it returns no type. Instead of calling return, then passing in some value, we just call return, then semicolon. That's it. Basically, what this will do is it will stop the execution of the function directly at this point. So Visual Studio actually helps us. As you can see, this line is in a dark gray, and that is because, like it says here, unreachable code detected. Since we are always calling return over here, then this line of code will never ever run. Speaking of functions and parameters, this is also a great type to see how things work with regards to value types versus reference types. This is something that I cover in detail later on in the intermediate section, but I want to make a quick mention up here. For example, let's keep just the say hello, so let's actually get rid of all these, okay? So let's say I define an int for the age, and let's say I put it at something, and then I call say hello, and then let's put the exact same thing, so that and pass in the age. And now over here inside the say hello, let's do age plus plus. So basically we are incrementing the value of age. So when this line of code runs, instead of printing 35, it should print 36. But now the important thing is now out here, let's say we print out the age again. So right line on the age. So let's print this one out. And now let's see what this one says. And yep, there it is. So inside the function, it says you are 36 years old, but outside the function, it says 35. Basically what is happening is when we call a function, over here when we pass in a parameter, when we do that, we're actually passing in a copy of the value stored inside this variable. So when we increment the variable in here, we are really just incrementing the copy, and we are not actually modifying the original value. That is why when we run here, we see 36, because we are working with this copy that we did modify. But when we exit the function and we run this line of code, when we do that, we are using the original piece of data which has not been modified. Again, this has to do with the fact that some types, like int, those are passed in as copies, meaning that the function receives a copy of the original value, and if you modify that inside the function, you are modifying the copy and not the original value. And then there are other types, which are reference types, which is going to have some different behavior. Those are passed in as a reference instead of a copy. So for those, if you modify them inside the function, then you will also modify them outside the function. Now, if you're a bit confused, don't worry. Like I said, I talk about in detail about value types versus reference types. I talk about what they are and what that actually means later on in the intermediate section. Right now, I really just want you to be aware of that difference. When working, for example, with primitive types, like over here, the int, when you pass it in, always remember you are working with a copy. So just be aware that if you modify something inside a function, it will not necessarily modify it outside the function. Alright, so here we'll learn another really crucial thing about programming, functions. They are extremely powerful, and you will be writing tons of functions with all sort of return types and all sort of number of parameters. So definitely do make sure you fully understand functions before going any further. Watch this lecture a second time if you need to. They are really that crucial. And now that we have introduced functions, which allows us to have multiple separated code blocks, because of that you should really learn the basics of variable scope. So let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about scope, which covers the lifetime of variables and from where they are accessible. Okay, so scope is very important. It's another one of those things that trips up beginners. It comes back again to how code is organized in different code blocks, and variables defined within a code block can only be accessed by that code block and any child code blocks. So for example, if I define a variable up here, I can indeed access it in here, in here, in here, and here. Yep, it is accessible everywhere. However, if I define a variable in here, it is accessible from within these child code blocks, but it is not accessible from a completely separate code block, and it is not acceptable from a code block that is above it. In the previous lecture, we covered functions. So here there is a function, and now up here in the main, let's define some kind of variable. Let's say bool is player. Let's define this variable over here. And now if down here on the function, if I try accessing this and modifying it, nope, this does not work. We have an error. The name isPlayer does not exist in the current context. Context is really just another word for scope. Basically, when we define a variable up here inside the main function code block, inside of here we are defining a local variable, meaning this variable isPlayer. This variable only exists inside this function within this code block. As soon as we exit this code block for something else, like for example this other function, down here, that variable literally does not exist. This local variable only exists inside this code block. And it only also exists after it is defined. Again, code runs from top to bottom. So afterwards we can set isPlayer into true, but before we define it, we cannot do this. Nope, this one does not work. We cannot use the local variable before it is declared. So this is yet another mistake that I see a lot of beginners having trouble with. They define some kind of variable and they have no idea why they cannot use it in a completely separate code block. So always remember where you are writing code, in which code block, and remember that local variables defined within a code block, they are not accessible from a completely separate code block. Also, if you define a parameter variable, like these two that we have here, parameters are also local variables, and they also only exist inside this code block. So for example, if out here, after calling say hello, if I try to access the player name, nope, that does not exist. Because again, player name is essentially a local variable which only exists within this code block. Now, these questions of scope apply to completely separate code blocks like these, but it also applies to code blocks within code blocks. Like for example, over here, if I define an if something, and then I make a code block, within this code block, which is essentially a nested code block inside the main, within this one, I can indeed access player and do something to it. So again, back to the diagram, if we define something over here, we can access it from any nested code block. However, if we do the opposite, so if instead of defining it in there, let's say we define inside that code block, and then over here trying to modify it, and nope, isPlayer does not exist over here. It does not exist because the code block where we are writing player, the code block inside main, that one is a parent code block of the if code block, which is where the variable is actually defined. So as you go deeper inside code blocks, you can access variables that were defined outside of it, above it, but when outside, you cannot access things that were defined inside. Now, if you have a variable that you'd like to access and modify between multiple functions, like something that I want to access both inside the main and inside the say hello function, for that, you can simply make it a class variable. I'm going to cover classes and also the static keyword in detail in future lectures, so don't worry too much about what they are for now. Just again, remember it's all about code blocks. So here we've got the program class, and it exists inside this code block, and inside this class we have our two functions. So just down here we can define some kind of variable. So let's say bool is player, and again, to make this work we need to mark it as static. So with this one defined, we can then access it over here inside the main and also over here inside the hello, because again, these two code blocks are basically nested code blocks of the class code block. But on the other hand, if we define a completely separate class, then over here on this class, which is again another completely separate code block from the one up here, if over here we make some kind of function, and then inside this function code, if we try accessing isPlayer, nope, does not exist, because isPlayer does not exist inside this class. We define it up here, so it only exists inside this program class and any nested functions. So in general, if you ever find some kind of issues, if you ever see this error message saying that some kind of variable does not exist in the current context, if so, then always double check your code to make sure that the variable that you are trying to access, you can actually access it from wherever you are trying to access. If you do want to pass in some data, some kind of local variable to within a function, if you want to do that, then you can literally do exactly what we've been doing. So you define a function with some kind of parameter, you define the local variable over here, and then simply put it in there. And then again, remember the thing that I mentioned in the previous lecture about how parameters, these are really copies. So if we do h++ in here, it is actually not going to modify this one. So if you did want to modify that one, you would simply return something kind of thing. So return the age, and up here simply put age equals that. And now if we do a console.writeLine on our age, and if this one does print 36. So we pass in the local variable to inside the function, then the function we do something, we return it, and with that return value, we put it back on the local variable. All right, so that's scope. This is another crucial thing that I see a lot of beginners struggling with, so definitely make sure you fully understand this. Anytime you see that error again, make sure to come back to this lecture in order to fully understand why it's happening. Next, we're going to learn about something very simple, but also very important, comments. So let's learn about those in the next lecture. Hi there, so quick intermission. How are you getting along with the course? Are you learning quite a lot? Are you making sure to take your time and focus on actual learning? Remember how it's perfectly okay to not understand everything the first time. It took me a decade to learn all of this, so you're not expected to go through this entire course in 1 week or even 1 month. Take it slow, repeat lectures as needed, and just make sure you're actually learning. And if you can afford it, then check out the premium version of the course. I put in a ton of work, specifically on the companion project, to make it really awesome. It contains frequently asked questions and fun quizzes to test your knowledge for every lecture in the course. And importantly, it contains interactive exercise, so you can actually put into practice what you're learning. I designed those specifically so you can learn by doing. Beyond that, it has a bunch more bonuses, including simply the fact that it has no YouTube ads and it's split into several lectures. So if you're enjoying it so far, then check it out. Also remember to like the video and subscribe if you haven't already. Alright, so let's keep learning. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about comments. These are basically just some text annotation that you can add to your code to provide some extra clarification on anything you need. Okay, so comments are really super simple. This is how you can pretty much write any text you want directly inside your code. However, that text is not interpreted as text, meaning comments are just for you, the programmer. The compiler completely ignores them. So as the code is executing line by line, it is executing, it gets to the comment and skips it, and continues executing. So as far as the compiler is concerned, the comment literally does not exist. In terms of syntax, they are really simple. You just write 2 forward slashes and then write whatever code you want. Like I said, this is not interpreted as any instruction or any code or anything. The compiler completely ignores all of this. So I could write some kind of valid code, but nope, this is not registered as code. As far as the compiler is concerned, this line over here does not exist. So you can make single line comments with 2 forward slashes, or you can make multi-line comments with a forward slash and then a star, and then you end it with another star, another forward slash. So with this, anything you put anywhere inside of this, all of this is considered a comment, all of this is ignored by the compiler. Also, comments do not have to be just in their own line. You can write some regular code and then afterwards write some kind of comment. So yep, this is valid code. And alternatively, for this multi-line comment, you don't technically need to do it in multi-line. So you can just open up that one and close it and write anything right inside there. Then also this comment, right after the forward slashes, anything afterwards is considered a comment, meaning that you can't actually make a comment before. So this does not work. The compiler is going to ignore all of this. It is not going to execute this instruction. So technically, if you absolutely need to do this, you would simply do the forward slash star, then close it. And yep, now this would indeed work. This is a comment ignored by the compiler. This is a normal instruction which would run another comment. Although you probably really don't want to do this. Comments right before any kind of instruction, that just makes the code really hard to read. So whilst technically you can do this, you probably really shouldn't. With this, we can see how in technical terms, comments are really super simple to understand. There's a super simple syntax, and then you can write whatever text you want. Now, the more important thing when it comes to comments is knowing what to comment. Something that beginners tend to do is pretty much just explain what the code is doing. So here's an example of some really bad comments. These are bad because they are completely useless. They are really just repeating what the code is doing. So by looking at the code, we can see we've got a variable with the name a being defined with type int. So this comment is completely useless. All of this just adds just some needless noise. And comments like this also have the problem that you might simply forget to update them. For example, if I update the codes over here, instead of incrementing by 2, increment by 1, and all of a sudden, now this comment is completely wrong. So in general, the general rule is your comments should focus on the why and not the how. Meaning, instead of saying what the code is doing line by line, instead of that, you should write why you wrote that code, what problem it's trying to solve. Although at the same time, comments are actually something you should aim to avoid. What I mean by that is your code should have good names for your variables. Your functions and classes, all of that should have great names, so that just by reading their name, you should be able to understand what it's actually doing. That means that your code should ideally be self-documented. In many cases, if you find that your code has a whole bunch of comments, chances are that's a sign that you should refactor your code. For example, over here, if we were to rename this to use some terrible names, so I renamed the function just to say, let's rename this parameter to just p and this parameter to just age. Beginners might do this because for some reason, beginners like to make their parameters as small as possible. And then they might say, prints out a hello to a player, and then you need to clarify p. This one means the player name, and how this one means the age. So this is an example of comments that are technically not as useless as the ones up here, but at the same time, these are very clearly telling you that instead of having these comments, you should refactor this code in order to make the function, in order to make what this is doing much more understandable. You can just do a direct comparison between this and what we had previously, and obviously this version with no comments, this one is much easier to read, much easier to understand. That is why being able to come up with good names when writing good clean code, that is why that is so important. That's a very important topic and something that I'm going to cover in detail in a future lecture. So for now, when it comes to comments, I just want you to learn what comments are, how you can write them, and also to encourage you to avoid writing any useless comments. Alright, so those are comments. And with that, by now we have already learned quite a lot about the absolute basics of programming. We are now ready to take it one step further and learn about some more complex types. We're going to learn about arrays and lists, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about arrays and lists. This is how you can store multiple pieces of data together. Okay, so previously we covered the basic data types. For example, you've got int, bool, string, and so on. The variables are essentially just containers for data. And for example, if you make an int variable, then you can store some kind of int or whole number value. Like for example, the number 56, I can take it and I can indeed put it inside an int variable. However, when I want to store more than one number, so now let's say I want to store this one, nope, that does not work. I can only store one value inside a single int variable. So So when you want to store multiple values, that is where arrays come in. You define an array of a certain type, like for example an int array. You give it some sort of size, which is going to be fixed. You define that size when you create the array, and that basically creates multiple boxes, multiple containers on which you can put any kind of data you want of that type. So for example, now on index 0, I can place this value, and on the next one, I can place this one, then I can place this one, and so on. So like this, I can place multiple pieces of data on a single variable. One important thing about arrays are the indexes. Note how the array has a length of 5, meaning it has 5 elements. But for these 5 elements, the first one is over here on index 0, then the second one is on index 1, and so on. So the positions in the array are always index-based and they always start at 0. Using the index, we can individually either set or read values directly from the array. Okay, that's the theory. Now let's see the syntax. The way that we define an array is actually really simple. We define the data type as usual. So for example, let's say an int array where we want to store ints. So we define data type and then open and close the square braces. Important, it is this one. It is not parentheses, it is not curly braces. Nope, it is the square ones. So you do this and yep, that's it. This variable is now defined as an int array. Let's give it some kind of name like numbers array. So yep, this is our int array, and afterwards we can initialize the array, and for this there are actually several ways to do it. If we want to initialize it with some elements, the simplest way we can do it is just open curly braces and inside put any kind of elements, like let's say a whole bunch of numbers. So if there you go, like this we are initializing the array. Alternatively, you can be a little bit more explicit with the type creation. You can do new int array and then pass in all of the elements. Personally, for me, this is my preferred method. Like I said, I like my code to be as explicit as possible, so personally I do like to be very explicit with how I define the array, the exact type that I'm using. Or alternatively, you can simply create an array without any elements and just give it a certain size. Like this, there's an error, you have to give it a size. So for example, let's say with 5, and there you go, this creates an array, the numbers array. This is an array with 5 elements. And like this, if you don't initialize to anything, then pretty much all of the elements will be initialized to 0. So speaking of the size, this actually brings up a very important topic about arrays. Their size is fixed, and after being created, the size cannot be changed. Over here, we are creating an array with size of 5, and that's it, that cannot change. If you want to check the size of the array, we can see that through the length property. And the way we do that is first we access our variable, so that's the numbers array, and then we write a dot, and this dot basically means that we want to access something inside this variable type. And in this case, this variable is an array, so by typing dot, we are accessing all of the functions and properties that exist in the array type. So it's kind of similar to how previously we saw console.writeLine. Basically, writeLine, this is a function that exists inside the console class. That's what the dot means. It means we are accessing something on the symbol previously defined. Okay, so like this, we are accessing something on the array. And if we want to get the size of the array, for that, we can access the property for the LINQ. So if we just do a console.writeLine on this one, just to see what this says, let's see. And if there it is, it says 5, which is exactly the size that we defined for our array. If we modify this to 3 and run, and yep, now it says 3. So the length, this is going to return the size of the array. Then another thing you are going to do quite a lot with arrays is simply accessing them to read an element on a certain index. And the way we do that is we simply write the array, so numbers array, and then we write the square brackets, and inside it we put some index, like for example, let's say index 0. Again, remember how in C# indexes start with 0. So the one on index 0 is going to be the first element, the one on index 1 is the second element, and so on. So first let's initialize the array, so let's initialize it with something. Let's put a whole bunch of numbers. Okay, so we initialize with a bunch of numbers, and now let's print out the one on index 0. So let's do a console.writeLine on that, and let's just get rid of this previous log. Okay, let's see. And if there you go, it does print out the number 56, which is indeed the very first element on this array. However, also something very important is that we actually initialize the array first. And like I said, we can initialize it like this with some values, or we can simply omit this and simply initialize it with a certain size. If we run this code, yep, it returns 0. Basically, the array initializes everything to 0. However, if we don't do this, if we just find the array, then nope, here we have a compiler error. So we need to actually initialize the array before we can use it. And like I said, the arrays have a fixed size. So when accessing an index, that also becomes important. For example, if we try to access after the size, so for example, over here we have 3 elements. If we try to access the one on index 5, which does not exist, if we do this, then yep, we get an index out of range exception. That is because the index 5, that does not exist, that is outside the bounds of the array. Same thing if we try to go the other way. So if we try to go -3, if we do this, then yep, same thing, same error. Now, if we do want to change the size of the array, like for example, if we want to add another element to the array, like I said, that literally cannot be done. The size cannot change. So the only thing we can do is simply make yet another array, add it with one more element of space, and then copy all these elements on the new array, and then add the new element. So you'd have to make all that logic manually if you wanted to add an element to this array. Or alternatively, for removing an element, once again, same thing, you cannot change the size, so you'd create a new array with one less length, and then copy the remaining elements onto that array. You can manually write that logic with the help of loops, which we're going to learn about in the next lecture. Or in order to add or remove elements to an array, you can simply use a different collection type, namely the list. The list is actually built on top of the arrays and basically has a bunch of helper functions to make it super easy to add or remove elements or do a bunch more things. And to use a list, first we write list, and then we write the angle brackets. So this is a less than sign. Then we write the data type that we want to store in the list, like for example an int, and then the closed angle brackets, so the greater than sign. Again, don't confuse the symbols, make sure you are using these symbols. Like for example, there is a double character, it is not this one, it is a single one, the same one you use for mathematical comparisons. Now the technical term for what we have written here inside the angle brackets, the technical term for this is a generic, which we're going to cover later on in detail in the intermediate section. For now, just make sure you write this syntax exactly. So with this, we have defined the list of ints, so let's call it int list, or actually to keep it the same name, let's call it numbers list, okay? And then to create our list, we have pretty much the same options we have for the array. We can do the full type declaration, so over here put any kind of values. Yep, this is our list. However, on this one, we cannot initialize it just like this. This specific initializer only works for arrays, so for a list, we cannot use this one. But we also have the third option of simply initializing a list just like this. And here, note how I did not put any number inside the parentheses, whereas over here, when defining a new int array, we have to give it a size, but for a list, like I said, lists don't have a fixed size, they can grow and shrink. So when creating a brand new one, you don't have to give it a size. Although technically, if we actually inspect this constructor, we can see there is a version that does take a capacity. Now this is a more performance optimization thing. If you know you're going to need a certain number of elements, you can preset that capacity. But in most cases, and especially right now on this beginner section, you can just ignore it. Just do it like this and it'll create a brand new empty list. So we have created a list, and now we can do, let's say, the same thing that we did on the numbers array. Let's first print out how many elements are on this list. It's pretty much the same thing, we just access the same number list, except right now on a list, this one is actually not called length. If we find length, we can't find anything, so it doesn't have that name. In length, it is instead called count for counting the number of elements in the list. But in terms of logic, it's really the same thing, so it returns the amount of elements within that list. So let's do a right line on this one, and since we just created, this one should return 0, and if there it is, this one does have 0. Okay, great. Then, like I said, one of the big benefits of lists as opposed to arrays is we can very easily add or remove elements. The way we do that is we just access the list and then use the add function, and this one takes an item that we want to add, so let's add the number 12. And if we do this, and afterwards let's print out the right line on the numbers list.count, let's see this, and yep, that one does indeed have one element. And if we access the list on the 0 index in order to see our first element, and yep, we do see our list contains the number 12. Okay, great. So just like this, we can already see just how much better it is to work with lists as opposed to arrays. With this, there's no need to manually create a new arrays with the size +1. We don't need to do that and copy all data. Basically, all of that is handled automatically by the list. We just call add, or alternatively, we go inside the numbers list and we call remove. Either one of these, and we'll either add or remove an element. Over here on the remove, the way this one works is you give it some kind of item. So in this case, the only element inside is the number 12. So if we call 12, this is going to remove the number 12. Or alternatively, there's another one. There's the remove at, which then takes an index. So if we do this and pass in the index 0, it is going to remove the element on index 0. And related to the add, there's also another one, which is the insert. Basically, the add, that one is always going to add the new element to the end of that list. Whereas with insert, over here, you can pass in an index where you want to insert that new element. Another super useful function in our list is for finding elements. Let's add some more elements just to test. So let's add 12, 0, and let's say 89. So we did this, and now let's say we want to find if the number 89 exists inside this list. If so, we can go through the list, and we can call the contains function. And like name implies, this one tests if it contains a certain element. So if we test for 89 and C, and yep, it returns true because it does have that element. Whereas if we put some different number, and nope, does not have that element. Another similar way to find elements within a list is to use the index of. This is basically going to return the index of an item if it finds it. So for example, the index of 89, this one is the third element on the list, so it should return 2. And if there it is, it does have a 2. Or if we include something that is not found, so if we include something that does not exist. If so, then yep, when it doesn't find anything, it returns the index -1. Since -1 is not a valid index, -1 usually means not found. And by the way, actually over here on the array, you can also do something similar to this. You can do an index of. However, it's a bit different, so it is not like this .index of. This does not exist. There's no function called index of within the array. However, it actually exists as a static method. Again, don't worry what static means right now. We'll explain it in detail in a later lecture. But basically, we just need to access through the system.array. We access through that and we can do index of, and this one takes our array, so the numbers array, and then whatever we're trying to find, let's say we want to find the element 1, 2, 3, and if we do a console.log on this, do a write line, let's see, and yep, that one does find it on index 1, and yep, number 1, 2, 3 is over here indeed on index 1. So as you can see, arrays and lists are really excellent, really very useful tools for handling multiple pieces of data. The technical term for these are collections. An array is a collection and a list is also a collection. There's a bunch more collection types for more advanced use cases. You have stacks, dictionaries, hash sets, and a bunch more. I cover all those in detail in a lecture in the intermediate section. For now, just knowing about arrays and lists, it is going to be more than enough. Whenever you need to store multiple pieces of data, you can use either one of these. In most cases, you probably want to use a list just because they are so easy to use, and when you need absolute maximum performance, for that, arrays can be quite useful. Alright, so here we'll learn about something very useful, arrays and lists. You won't be using these a lot in your programming career. And now in the next lecture, we're going to learn about one of the core tools of just about any programming, which are loops. So let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn one of the more fascinating and powerful features of any programming, loops. This is how we can run certain logic multiple times. Okay, so let's learn everything about loops. This is another really crucial core part of pretty much any programming. There are so many scenarios where loops are used. It can be a little bit tricky at first for beginners, especially since the code jumps a little bit, so do pay close attention. Normally the code runs from top to bottom, and when it comes to loops that is still true, although it also jumps and runs the same instructions multiple times. For example, if this loop over here was defined to run 3 times, if so, then it would run this line, then this line, then this line, and then instead of exiting and continuing down, it would jump back to the beginning and run this line again, this one again, jump back, run this one, and then finally exit the loop. We're going to see how this is very useful, especially when combined with the arrays that we learned in the previous lecture. It's how you don't even have to know the size of the array in advance. You don't need to copy paste a whole bunch of code to iterate through each element. You can just write a loop that will jump through all the elements of the array, and then you can do whatever logic you want on each element. We're going to learn about these 4 loop types. So we've got while, do while, for, and a for each. Let's begin by learning the most basic loop possible, which is a simple while loop. This one simply has a condition, and it will basically execute the code inside the curly braces while that condition is true. As soon as the condition becomes false, the code stops executing and jumps after. To write a while loop, it's really simple. We just write the keyword while, then we put some kind of condition inside parentheses, like for example, let's just put true, and then we put a code block with curly braces. Alright, so that's it. Basically now with this, we are going to run the code inside this code block for as long as this condition is true. Now, what I've written here is actually something that usually you want to avoid. For the condition, I just wrote true. And like I said, this code block will run for as long as the condition is true, which right now is forever. Since true, this will never change by itself. So what we have here is an endless loop. If we try putting in a log here, console.writeLine, and we try to see what this does, and yep, there it is. The log is simply printing towards infinity, forever and ever until the end of time. So usually this is something you don't want to do. And by the way, quick tip over here, if you want to cancel this, you can either click on the X button over there, or you can press Ctrl C, and that will automatically stop the code from executing. Okay, so here we made our while with an infinite loop. Now sometimes this is actually desirable, like for example in a game engine, you do want your update code to run every single frame until the player quits the game, but right now we want a loop that actually ends, so for that we just need some kind of condition that eventually becomes false, and the most basic one is just having some kind of counter. So before, let's just define a simple int I. By the way, usually when working with loops, the variable I is commonly used. It stands for the iterator variable. And usually we want to initialize this one at 0 and not at 1. Technically you don't have to, but usually you want to start things with 0. That comes back to what we covered with arrays on the previous lecture, how array indexes always start at 0. So for iterator variables, usually you do the same thing. Now over here, one very important thing is make sure you are defining the variable before the loop, meaning don't place this code inside of here. If you do, then you are basically always defining the variable with the same value. So every time the loop runs, it is always going to have the same value. It would never increment and the loop would never end. So make sure you define this one outside of the loop, so right before. Now over here, instead of true, let's cycle while I is under 3. And in order to make sure that this condition actually ends, that it eventually becomes false, because right now it is still infinite, in order to do that, at the end of our while loop, let's simply increase our iterator by 1. So just I++. Okay, so that's it, pretty simple. Let's see what this is doing. Over here, let's just print out loop, and then let's print out the I. Okay, so let's see. And if there it is, loop 0, 1, and 2. So yep, that is correct. The code inside this code block is running while this condition is true. And when we first run, the iterator is going to be 0. So is 0 under 3? The answer is true. So the first time it is going to execute this one and then this one, which is going to increment the I into 1. Then it goes back, loops, and tests the condition once again. So now is 1 under 3? It's still yes. So once again, runs, increases it. Next loop is 2 under 3, still yes, so it still prints for the third time, but now it increased this one, increased the I to 3, so the next time goes, is 3 lower than 3? The answer is no, 3 equals 3. So at that point, it drops out of the loop and continues executing down here. Also, by the way, what we just did here is actually a great tip for when you're confused about loops. Just go through them in your head line by line to see exactly what things are doing. And of course, always write some logs in order to remember what you're doing with your iterator variable. Like for example, here, if you made the simple mistake of doing I minus minus instead of I plus plus, if you did that, yep, there you go, the loop never ends. It's an endless loop again. Or alternatively, if you did increase, but for some reason you forgot and you increased it just after the loop, and yep, once again, still an endless loop, it's constantly at 0. So always pay very close to your conditions and how exactly you are eventually exiting that loop. Also, let me mention another common mistake that beginners, or really every programmer makes, which is off by 1 errors, meaning they think they're running a certain amount of times, but it's actually running that many times plus 1. So usually the mistake is instead of doing, for example, lower than, or equal. So let's say you wanted to run this 3 times, but if you put less than equals, if so, then yep, the loop actually runs 4 times. So always double check that your condition is correct exactly as you intended, so that the loop runs as many times as you actually think it does. Now, one really important thing about the while loop is how it tests condition before going inside the loop. So for example, for the iterator variable, if instead of initializing on 0, let's initialize it on 5, which is immediately going to have false on this one. So let's see if our code prints anything to the console. And nope, the answer is it does not. If this condition is false right away, then the code inside the loop never runs, not even once. So related to that, let's see the other similar loop, the do while. This one is very similar to the while loop. The only difference is really when the condition is tested. So for this one, first we write the keyword do, and then we open and close our curly braces. So we have our code block, and then we have the while, and then in parentheses, our condition. So let's put the same condition, I under 3. So yep, just like this, and let's do a console.writeLine, do while loop. And let's print out the iterator variable, and inside the loop, again, always remember to increase your iterator variable. Okay, so here we can directly compare, is this one going to run, the one inside the while, which we already saw is not going to run. And then let's see if this one does run, let's test. And yep, there's the result. So the regular while loop, this one did not run, not even once. But the do while, even though this condition is always false, even on the first iteration it is already going to be false, despite that, it is still going to run the code block inside the loop at least once. So that's the difference between these two loop types. This one tests in the very beginning, so it might not even run once, whereas this one tests the condition at the end, so it is guaranteed that the code inside of here is always going to run at least once. And if we put the I back into 0, and then remember to reset it on this one, and if there it is, both of them behave similarly, both them run 3 times. Okay, so while and do while, these are the most basic loops. You just have a condition and then you do something while that condition is true. But another one that you're probably going to use most of the time is the for loop. This one can sometimes look complex to beginners, so definitely pay close attention. This one is split into 3 parts. The first part is the initializer. So here, usually we initialize some kind of iterator variable. Then we have the condition, so same thing, it is going to continue running while this one is true. And finally, we have the incrementer. So usually over here, you increase the iterator variable by 1. So let's see the syntax. Let's just comment this out and let's go up here and write our for. So first we begin by writing the keyword for, and then let's open and close the parentheses. And now in here, the for loop has 3 components and they are split by a semicolon. So the first component is going to be where we're going to initialize our iterator variable. Like I said, the very common thing is usually just define an int, name it I, and initialize it on 0. Okay. So then we do a semicolon and then we can write the second component. The second one is going to be the condition. So let's put the same thing we had in our OI. So I under 3, and yet again another semicolon. And now we have the third component. This is going to be the incrementer. So here usually you want to increase the iterator variable by 1, so I plus plus. Yep, so just like this we have our 3 components, then we just have our regular code block. Now over here we can do whatever we want, like the write line for the for loop and print out the iterator variable. Alright, so let's test. And yep, once again the same result. It runs the code inside the loop 3 times. Now let's go through this piece by piece to see exactly how the code is executing. So basically when the code gets to this line over here, when it does, the first thing it's going to run is this part over here, which is going to initialize the iterator variable. Right after that, it is going to test for the condition, so very much like the while loop, meaning if it is false, it is going to skip it entirely. But if it is true, then the next thing it goes is it goes goes inside the for loop and runs all of the code inside the code block. And then after running the entire code block, after that it runs the third component, which is going to increment the iterator variable. And after doing that, then it jumps back and tests for the condition once again. Then again, keeps doing the same thing. If it's true, continue running this one and then jump back to the iterator, test again, and so on until finally it becomes false and then it jumps outside. Basically, the one great benefit for the for loop as opposed to something like a while or a do while, the one big benefit is how it makes it much easier to handle the iterator variable. Although I should also note that while this does help handle the iterator variable a bit more easily, the same issues that we had with infinite loops, those can also occur here. So for example, if for the iterator, instead of doing I++, you do I minus minus, then yep, this one now becomes an infinite loop. Or if you put I++, but then over here for some reason you put some condition that is always true, then once again this is also going to be an infinite loop. So really the potential for an infinite loop that is always there regardless of what loop type you're using. But generally, since the for loop, since that one at least forces you to use an iterator variable and increment it, for that it should help avoid those unwanted infinite loops. And also remember what we covered on the lecture on scope. The iterator variable over here, the int I, this one is being defined in this special place inside the for loop, and doing it like that makes it a local variable, specifically local to this for loop. So we can access it in here, so here we are printing it, but if we try accessing out here, then nope, this does not happen. This variable only exists inside the code block inside the for loop. So after ending the loop, this variable no longer exists. Whereas for example over here on the while, on this one we define the int iterator outside of the while, so after the while we can still do anything we want with that variable. This is actually usually something you don't want to do, so that's another reason why the for loop is one of the most useful ones. Now the for loop can be used for running some code a certain number of times, or something very useful is when used with what we covered in the last lecture, arrays or lists. So here let's define a string array for the name array, and let's just create a new string array. Alright, so here we have a nice array of various strings. And now if we want to cycle through this array, then a for loop is one of the great ways to do it. We use the usual iterator variable, we increment by 1, and then over here for the condition, we want to iterate through the array for as long as we have elements. So for that, we can check if I is under, and then go inside the name array and access the array's length. This property is going to contain the number of elements inside the array, and once again, don't make the mistake of the off by 1 errors. So over here, make sure it's always less than the length and not less than equals, because this length, for example, this one is going to return 4. We have 4 elements, but again, remember how the indexes start at 0. So this is index 0, 1, 2, and 3. So there is nothing on index 4. And if you put it less than and equals, then the final one is going to be on I of 4. And on I of 4 would give an array because nothing exists on index of 4. So always pay attention to that very common error. And now with this, we can just print out just this name. So let's just go inside the name array and access on the I index. Yep, like this. Let's test. And if there it is, we are printing all the elements in our array. All right, awesome. Also, one quick note, to cycle through a list is pretty much the same thing. So here, if we make this a list of string instead of an array, so a list of string, let's do it like this and initialize our list. And the only difference is like we saw in the previous one, instead of the list calling length, it is called count. So yep, just like this, and yep, the code is running the same way. Okay, so this is great. This is how you can cycle through all the elements in an array or a list. However, there's actually an even simpler method specifically designed for lists and arrays. Instead of a for in handling the iterator variable ourselves, instead of that, we have the for each. And for this one, we define an iterator, which in this one, instead of being an index, it is actually going to be an iterator of the type that contains our collection elements. We have an iterator in some kind of collection. So basically, this one helps us automatically handle all of that cycling logic without us keeping need of some kind of index. Doing a for each is really simple. We just write for each, and then over here we write the name for our iterator variable. However, this time again it is not an index, so we're not going to use an int. We're going to use whatever type we're cycling. So in this case we're cycling through an array of strings. So for each string, then give it some kind of name. So in this case let's call it name, then the keyword in, and then the name array. And yep, now here we can just do console.writeLine and just print out this name variable. Let's see what it does. And yep, basically the same thing. So the for and the for each work the same way. Basically over here, this is going to loop as many times as we have elements in our array, and every time it loops, the for each itself is going to handle updating this name variable over here. So when this runs the very first time, it is going to assign CodeMonkey to that name. Then the second time it runs, it assigns Ironman and so on. So it basically handles updating everything, updating the iterator variable without you needing to keep track of indexes or anything like that. Now, technically, I should also say that the for each, this one works with anything that is enumerable, like any collection. It works with arrays, it works with lists, and a bunch more. I cover more collection types and how to make your own custom types enumerable in a lecture in the intermediate section. Here is the demo for this lecture. This is kind of like a mini RTS game. So I've got a list of all my units, and over here are the various units in the world. Here in the code, the units are simply a list of units. And then I have the simple code that just tests when the player presses the left mouse button. When it does, then does a for each through the entire unit list and tells each unit to go to that target position. So with all the units inside the list, if I click, yep, there you go, they all move straight towards the target. And now by using the exact same code, if I modify the list and remove all kinds of units, so let's remove a bunch of them and leave just one unit. If I do that and now I click, and if there you go, the same logic is now moving just one unit. So this is a great practical example of how useful loops are, and specifically the for each loop. You can write some kind of logic that applies to some kind of list, and that logic will work regardless of how many elements are on that list. Also a note, it is perfectly fine to do a for each or even a for on a list or array with no elements. So if we erase this so that it's pretty much just an empty array, and if there you go, everything still runs, there's no errors. Basically over here, if the length is 0, then 0 under 0, that is already false, so it's going to skip it. And over here on the for each, if the array is empty, then it's also going to skip it. So these are the main for loops. While is the simplest one, but personally I never really use it, and same thing for the do while. I very rarely use these two. Then down here the for, this one is extremely useful in tons of scenarios, and the for each, this one is perfect for doing any kind of logic on lists or array. Alright, so that's loops. It's another really important core component of programming, so definitely make sure you fully understood everything in this lecture before moving on. Next we're going to learn one of the core pillars of object-oriented programming, which are classes, so let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about classes, what they are, how we define them, how we create objects of a type of class, and what we can do with them. Alright, so let's learn about classes. This is one of the core concepts about C# and other object-oriented languages. A class is really just a type. For example, the list that we saw a while ago, the list type is a class, and an object is simply an instance of that type. So in any of those object-oriented languages, you define an object type, meaning some kind of class, and then create individual instances or objects of that type. For example, we can define a class named player, and inside of it we can define a field for a string name and an int health, and then we can create two instances of that class. And on this one, let's say we set the name equals CodeMonkey, on this one name equals Ironman. So importantly, note how each instance of this type, each instance is completely separate. The class defines the structure of the type, but then the instances that are created from that type, each of those has their own memory with whatever that is inside those fields. So the class definition is kind of like a blueprint, and using that blueprint to then create different objects. So here we are in our code. Let's begin by defining our class. And again, it's very important where you write the code. For example, you cannot start writing a class directly here inside a function. This throws an error because we cannot define a class directly inside a function. So make sure you are writing outside the function. And now we can either write inside the program class or we can make it separately. Either one works. In this case, let's make it inside the program code block. So right in here, if you write inside the program class code block, if so, then we're basically making a nested class, which in this case is perfectly fine. So let's do this. We start writing the keyword class and then the name of our class. Let's say we're defining a player, and then open and close our curly braces. Alright, so this is it. Just with this, we have already defined our class, which like I said, a class is really just a type, so it's similar to like an int or something. So up here, usually we've seen defined, for example, an int for the age, and over here we can define our custom player type, player. And if there it is, just like this works perfectly. Note how the color over here is different. That is because this one is correctly identifying the player type. And again, if you're seeing compiler errors, once again, the likely culprit is due to being case sensitive. So here, if instead of player, I just write player, this is an error. There is nothing named player with P on lowercase. So always remember that code is case sensitive. And of course, just to clarify, the name over here can be whatever you want. Doesn't have to be named player. The name of the class can be whatever you want, and the name of the variable that you create from that class, that can also be whatever you want. So with this, we have defined a variable of our custom type. However, we just defined it. We didn't actually initialize it just yet. If we try doing a console.writeLine, then here, nope, we have an error. We cannot do this. So it's the same thing as if we try printing the age, we also cannot do it. We need to first initialize it. Now, in order to initialize it, usually for something like an int, for this, you can usually just assign a value, and yep, this works. But our custom type isn't a number. Like I said, it's some kind of object. So to initialize it, we need to create our object. And the way we do that is with a new keyword, so pretty much exactly like we saw with a list. So we just do new, and then our type, so in this case it's called player. and then just add the parentheses, so open and close. And yep, just like this. And if we do unlog on our player variable, let's see. And yep, it does print log, and it pretty much prints the type. And the type is inside CodeMonkey C# course.program inside the program class, and then it's finally called player. So yep, we have indeed created a new player object, and we assigned it to this player field. So here we have created an instance of our type, and now you might be hearing me say that word, instance, without fully understanding what I mean by that. So what I mean goes back to the idea of the class definition being some kind of blueprint, and then when we do new player, we are essentially creating a new object of our type. So we're using that blueprint to create an instance of that type, meaning that we can create as many instances as we want. Like for example, let's rename this one to the CodeMonkey player, and then let's make another one of type player. Let's call it Ironman player, and let's also do new player. And yep, just like this, we have two completely separate objects that both share the same class. So both were made from the same blueprint, but each of these two objects is our completely separate object. If you want to, you can actually verify this. So let's print out the CodeMonkey player, and then let's print out the getHashCode. This is a default built-in C# function that every object has by default. It basically returns a hash code for that object. So we can print this one out, and then print out the one for the Ironman player. So ironmanplayer.getHashCode. We can print this, and yep, we can see our two objects are indeed two different objects since they have different hashes. So this part is really important for you to understand. The type definition itself is kind of like a blueprint, and then we use that blueprint to create instances of that type. Each instance is different, and each instance has their own memory and their own fields, their own values, and so on. Okay, so now that we've seen the absolute basics, defining a class and creating an instance of it, let's see what else we can do. One of the main things is actually what we're already doing. Over here, when creating a brand new player, this kind of looks like we're calling a function, and it kind of is. Now technically this isn't a function, this is what is called a constructor, which is basically what constructs an object of our type. By default, any class that you define, it will automatically have a constructor just like this, so one with 0 parameters. But if you want, you can also explicitly define it. You just write the exact same name as the class, so in this case player, and then open the parentheses, and then we can add whatever parameters we want or none, so let's just close the parentheses, and then just write a code block. Alright, so yep, this is a constructor, and over here you can write whatever logic you want. Now again, it's very important that the name perfectly matches the class name. If it does not match, there will be an error. If it does not match, then this assumes we're just defining a regular function and requires a return type. In order to define a constructor, which again is a kind of like a special function, for that one it has to be named exactly the same name as the class. Okay, so here we have our constructor, and here we can pretty much build whatever logic we want that is going to be run whenever the player is created up here. For example, we can add a console.writeLine, and over here let's just say creating player. Okay, great, like this. Except we are actually seeing some errors over here. It says that player is inaccessible due to its protection level. Now this has to do with access modifiers, which is a topic that I'm going to cover in a few lectures. For now, let's not worry too much about it. Just know that over here on the player constructor, over here before it, we need to add the keyword public. So it has to be like this, public player, and then the parentheses. So make sure you write that, and there are no errors now. And if we test, and if there it is, we can see we are indeed creating two players. All right, awesome. Now another thing we can do is define functions inside of our class, and we define them just like we already saw. The only difference is right now we actually don't need to mark it as static. I won't cover what static means in detail in the next lecture, but for now just know that if you're writing a function directly inside the program that you call it from main, for that you need to mark it as static because main itself is marked as static. But down here when working with our class, over here we don't need to mark it as static. So for example, let's define some kind of function. Let's return nothing, so void, and let's call it say hello. And over here, pretty simple, we just do a console.writeLine and just print out hello. Okay, great. So with this, our custom type now has a function. As to how we're going to call this, well, up here we have an instance of our player class. So we created our object. We can simply access that object and then press on dot, which again, the dot means that we are accessing something inside the previous symbol. So we're accessing something inside the CodeMonkey player, which is of the player type. And now we can call our function, except actually right now we can't. Again, it's the same thing that I mentioned a while ago. It has to do with the access modifiers that I'm going to cover in detail in a few lectures. So again, for now, in order to make this testing work, let's just make sure to mark this one as public. So public void say hello. And now if we go up here and press on dot, yep, we do see our say hello function. And now we can call it just like we call any other function. Yep, just like this. Now, importantly is we are going through an instance of our object, so we're not going through the object class itself, but rather an instance of it. If instead you do write the class name, so you do player.sayHello, then oh, this is an error, this does not work. To call this function, we want to call it through the actual object that is created of the player type. And now at this point, perhaps you might be noticing that, for example, over here, the console.writeLine, this one is different. For this one, we are not actually creating a console object. We simply access the function, the writeLine function, directly through the console class. And again, that has to do with static, which I'm going to cover in detail later on. So for now, just make sure that the sayHello function, this one is not marked as static. And up here, make sure we are calling sayHello on the created CodeMonkey player. Okay, so with this, if we test, and if there it is, creating the player and then calls hello. Okay, great. Here we can see we are running a custom function inside of our custom type. So since we can define functions, another thing we can do is also define some class variables. And for that, we write them inside the class block. So not inside a function. We don't want to create a local variable. We want to define a class variable. So let's go up here just before the constructor. Let's define a variable like, for example, string name. And if we want, we can even give it a default value. So let's say CodeMonkey. Okay, great. So here we have defined a name variable. And now if you remember from the scope lecture, from that one, basically anything that we define in a code block, like a variable over here defined inside the class code block, that means we can access this variable inside any of these nested code blocks. So for example, over here inside the hello function, over here let's print out, so let's use the string interpolation method, and let's print out the player name. Okay, so like this, let's see. And yep, it does say hello CodeMonkey. Okay, great, so far so good. Now by the way, I'm calling this a class variable or member variables, but sometimes I use the term fields. Again, it's another example of interchangeable names. Technically, the more correct name for this is actually a field. The word variable is more used for when it's a local variable defined inside a function, but those terms are pretty interchangeable. So if you show someone this code and you call this a variable, they will understand what you mean. Okay, so here we have defined a class variable or a field. And now like we saw up here, we can access our object and call this function, and we can access this field in the same way. However, again, the same thing, in order for that to work, we need to mark this field also as public, so we can access it from up here. So over here, we can go through the CodeMonkey player and access the name, and I can set it to something. I can read it or modify it. So for example, for this one, let's set it to CodeMonkey. And then for this other player down here, for the Iron Man player, let's set it to Iron Man. And then let's call the sayHello function on this one. Okay, so let's test and see what this does. And if there it is, creating player, then says hello CodeMonkey, creating the second player, and says hello Iron Man. So here we are creating objects, modifying values inside of it, and also calling some functions. With this, we can also go back and see exactly what I covered in the diagram in the beginning, on how the objects that we create, these are essentially objects that are separate from one another. They are created from the same blueprint class, but each of them are different. Each of them can have different values. That is why over here we are creating two instances of our player type, and then on one of them we are setting the name to CodeMonkey, the other one to Iron Man, and that works because they are completely separate objects, each with their own data. So when over here we are modifying the name inside the Iron Man player, we are only modifying the name inside this specific object, meaning it does not modify the name on the CodeMonkey and does not modify the name on any other player object we have. When we modify this, we are only modifying this data on this object. This is another really crucial thing to understand, how each object, each instance of a class, each of those has its own data stored in memory. Okay, so we've already learned quite a lot about functions, fields, and constructors. Another thing we can do over here on the constructor is we can define some parameters. So pretty much like we would for a function. For example, let's say we receive a parameter for the string name. Then over here, let's print out the name. So creating player and then pass in that name. Okay, like this. And now up here when constructing our players, for this one, let's pass in CodeMonkey. And for this other one, let's pass in Iron Man. And for now, let's just get rid of this other code. So let's just leave those two. So just doing this, just constructing a CodeMonkey player and an Iron Man player. And yep, it works, creating each of them. Okay, good. So now here's an interesting scenario. Let's say we want to define the name over here on the constructor, and then we want to update this field, and then we want to use that field down here. Right now, that is actually not going to work. So let's put the default name to something else. Let's put it just a dash, just to make sure that it isn't updating on the first one. Let's test. Let's just go here, CodeMonkey player, and let's call sayHello. And same thing on the ironman.sayHello. And yep, look at that. So it does create the player and does receive the CodeMonkey string, but then when saying hello, it just has the default dash. That is because even though we called all of these, we call them all name, even though these are actually two separate symbols, when we receive the name over here as a parameter in the constructor, this parameter over here is just a local variable. By itself, this parameter has no connection to this variable. Even though the name is exactly the same, that still does not mean that they have any connection. We need to explicitly define that connection. Also, by the way, here's a quick tip. On Visual Studio, if you just place the cursor on top of a symbol, it automatically highlights all instances of that symbol. So note how over here it is highlighting this one and does not highlight this one and this one. That is a clue that these are two completely separate symbols, even though they do have the same name. If we click on this one, yep, it does highlight this one and this one, but not these two. So these are completely disconnected pieces of data. In order to connect them, basically we just need to assign this variable to the one that we receive here. So over here, you might think to write name equals name with the assumption that the first name is going to refer to this one and the second one is going to return this one. But nope, this doesn't really work. We have a green squiggly line and if we put it inside, assignment made to the same variable. So here, once again, we can use the cursor trick in order to see, yep, here we are referencing the same symbol. We have no reference to this one itself. So one option that we have here is choose a different name. Sometimes people like to solve this problem by adding an underscore on all their parameters. So you could add an underscore here, then one here, and one here. And doing so, yep, now this works. So now these three instances are instances of this symbol. But if we select that one, yep, now that one is that one. And if we run this code, and yep, now it does work, creates a player and says hello with the correct name. So this works. This is one option. You can simply define your parameter names to have different names from your class variables. Or another alternative method, the one that I actually prefer, is to write the exact same name. So over here, let's name this one exactly the same, name, and also this one also name. But here we have the problem. We're always accessing the same thing. So the way we change that, the way we access this field specifically, the way we do that is with the keyword this. This is a special keyword that, like name implies, refers to this object. It refers to the object itself where the code is running on. So by using this, we can essentially reference this object, and doing that, we can reference this class variable. Again, we can put the cursor over in order to highlight, and yep, now we do see these three are referencing this symbol, and these three are referencing this symbol. And if we run this, and yep, now it does work, creates both players and correctly assigns their name. So once again, we have two separate instances of our player class, each with their own data and each with their own name. We are setting that data through the constructor itself, and then we are using that data in some kind of function. Okay, great. So here we learned about classes. This is one of the core building blocks of any object-oriented language like C#. This is yet another topic that you must make sure you fully understand. Rewatch this lecture if you need to. Classes are one of those things you are going to use a ton through your programming career, so definitely make sure you fully understand it. Now in this lecture, I briefly mentioned two things, access modifiers and static, so let's finally learn about those, beginning with static in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're finally going to learn what is the static keyword and what does it do. Okay, so since the very beginning, we've been working with this default code. In the beginning, I told you to just ignore the static over here. But now, since we have already learned what are classes, now we can finally start to learn what is static. In the previous video, we wrote this code, and I told you to make sure not to write static inside any of this, either the field or the function. What it means is when you define something as static, when you do that, you are making that belong to the class itself as opposed to any instance of that class. So if you make something static, like a static score field, if you do that, then now that symbol, that score, that only exists on the class itself and does not exist as a separate copy for each individual object you create of that type. So here, when we made our custom class, we wanted this function and this field, we wanted that to belong to each instance of that class. We wanted that as opposed to belonging to the class itself, so that is why we made these intentionally non-static. And by doing that, we made it so that up here, in order to call this function, we need to call the function on some kind of instance of our type. So that is why we need to create a CodeMonkey player in order to call the sayHello. And if we try doing player.sayHello, nope, this does not work. This is an error. Because we marked this as non-static means that we need an instance of our type in order to call this function. And it's the same thing for the console.writeLine that we've been using. For this one, we can inspect this function. So we can right click in here, and then let's go into this one, go to definition. And if you do that, yep, it opens up this window, which basically shows the code inside the writeLine function. And over here, we can see this function is indeed marked as static. That is why when we use it through the console class itself, meaning we never do a new console, and then using that console we call writeLine. We don't do that. Since that one is marked as static, we access the console class itself and then call the function directly on the class itself. So static means this belongs to the class itself and not any instance of that class. As to when would you use this, one example is over here on the console. It's super easy to just write console.writeLine and write something to the console. It is much easier as opposed to having to create a new console object, having to keep track of that object in order to call the function. We just access the function directly and makes it super easy to use. And then it can make sense if you have some kind of behavior or some kind of data that you want to belong to the class itself and not all the instances of that class. Like for example, if you have some kind of score that is meant to be shared between all the other objects. If so, then it might make sense to define that in class. That way we have just one score field that is shared between all the various players. In order to make something static, it's really simple. We just add the static keyword. Like for example, over here on the sayHello function, let's mark this as static. However, in doing so, we can already see two errors. There's one over here on the name and one up here on our players. So let's actually, for now, just comment out this code and let's just do player.sayHello. Yep, now this one does work because that function is now marked as static. But now the error down here on the name, like it says here, an object's reference is required for a non-static field. Object reference is really just another word for object instance. This basically means that we cannot access non-static fields whilst inside a static function. That is because, again, static means that it belongs to the class itself and not any instance. So since this function does not belong to any instance, naturally we cannot access any instance variables. That is also why, quite a while ago on the variables lecture, when we were creating some class variables up here, I said that if you wanted to create a variable that you wanted to access inside main, you need to mark it as static. If we just make an int age over here, and over here try to access age equals something, and over here try to access age equals something, nope, this does not work, we cannot access it. In order to make it work, this needs to be static, because main is static. So whilst inside a static function, we can only access static fields. In order to make our code work here, we can really just mark this one as static, with the obvious side effect, which is, like I said, this field now belongs to the class itself, so with this, we could not have multiple players, each with different names. By doing this, there's pretty much just one name field, regardless of how many player instances we have, and by adding static over here, we created yet another error right here, and once again, it has to do with this keyword, which, like I said, this one refers to the object that this code is running on, but once again, this one is a static field, meaning it does not belong to any instance, so we cannot access it through a this, which refers to a specific instance. And if we remove this, then we have the exact same problem we had, which is all of these are referring to the same symbol, so we want to access this one. And as to how we access a static field, if we can't do it through this, the answer is we access it through the class name. So over here, player.name, and once again, put the cursor over in order to highlight, and yep, now it is correctly referencing these two. Okay, so we have no more errors. Now let's see what this is doing. So first, let's call player.hello, and then let's create a new CodeMonkey player, and let's print player.sayhello again, and then let's create an Ironman player, and now let's print say hello again. Now, if you want a quick challenge, try to pause the video right now and try to guess what all of this is going to print on the console. So which name is going to be printed over here on this function call, which one on this one, and which one on this one. So if you want, pause the video right now and try to give that a go, try to get a guess. Over here, let's run the code and see what this says. And yep, it says hello nothing, then hello CodeMonkey, and finally hello Ironman. Here we can clearly see how static data belongs to the class itself and not any instance of that class. Basically, the first time we say hello, the name is going to default to a dash, so that is why it prints dash. Then we create CodeMonkey, and when creating that object, that individual instance of that object is going to access the global name field that is inside the player class, so the static field. So we're going to update that one from dash into CodeMonkey, that is why it prints that. And finally create an Ironman, and again, same thing, that is going to modify and update and override the name, so the name no longer says CodeMonkey by the end, it only says Ironman. The important takeaway here is that even though we are creating two instances of that object, since over here we are accessing a static field, remember the static field belongs to the class itself, so we have just one of these, even though we have two instances of our player. Now, it might seem like I'm repeating myself a little bit too much in this lecture, but this really is a crucial thing to understand. The difference between making a field static or non-static, the difference between how many instances of a field you have, this is really crucial to fully understand so you don't get confused. If it's static, you have just one field that is shared between all the classes, and if it's non-static, then each instance of that type will have its own field. Like back here in the diagram, we define a static int score, and this one is basically shared between all the other objects, but then we have a non-static string name and int health, and each object has their own copy, has their own data within that field. Now, we already saw how we cannot access a non-static field from a static function, but the opposite is valid. So here on say hello, if I remove the static to make this a non-static function, and yep, there is no error down here. Whilst on a non-static function, we can indeed access static fields. Although again, remember how a static field, this one belongs to the class itself, and there's really only one field that is shared between all instances of that class. So for example, up here, let's create a new Ironman CodeMonkey, so let's actually uncomment this code up here. For example, let's create a new CodeMonkey player, then let's create an Ironman player, and then let's print hello on the CodeMonkey player itself. So once again, if you want a mini challenge, try pausing the video right now and try to guess what this one will say. And if we test, and yep, look at that. It says hello Ironman, even though we are calling the say hello on the CodeMonkey player object. And the reason is once again because this field is static. So when we create a new Ironman, that one is updating that static field to just say Ironman. So down here, when we access static field, we are accessing the only field that exists within the entire class. Now let's just learn one more tiny thing about static, which is how you can mark the class itself as static. So here you can write static class, and basically by doing this, the compiler forces you to make everything inside that class as static. So we cannot have a regular instance of our player constructor, we cannot have this, and we cannot have a non-static function. It needs to be marked as static, so just like this. So this can be helpful, for example, when you want to make sure that everything is static. If there's some kind of class, like for example the console, here if we once again right click and go to the definition, we can see, yep, the console is marked as static. You are never ever intended to create a new object of type console. That is never supposed to happen. Everything inside this console class, all of this should be static. All the functions, all the fields, all of this should be static and used as static. So in order to enforce that, you can just add the static keyword, and basically the compiler will force you to make everything within that class marked as static. So when you want that, add static. But when you want to mix between static and non-static, then just don't add it and simply add static to the things that you do want to make static. Alright, so that's static. Now if you're a beginner and you're slightly confused, go ahead and watch this lecture again. Learning the difference between static and non-static is really important. You need to fully understand the difference between what belongs to an object and what belongs to a class itself. Next, let's learn about access modifiers. This is something that is extremely important in order to write good, clean code, so let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about access modifiers, specifically private and public, learn what they do and just how important they are. Okay, so access modifiers. Like the name implies, it controls what kind of access we have with something. We've already seen them a little bit. A while ago, when we defined these functions inside our class, I told you that you need to make this public. This is the access modifier. In general, you have two access modifiers. You have public and private. Now, technically, there are more. There's also protected, and there's also internal, and a bunch more. So technically, there are more, but most cases, you will only be using either private or public. Now here, I told you to make this public because if we don't define the access modifier, if we just do this, just like this, then up here we can see our function has an error. It is saying the sayHello function is inaccessible due to its protection level. That is because if we don't specifically say public, if we omit the access modifier, then this one basically defaults to private. So if we write nothing, is the same thing as if we explicitly write private. And like the error says, we cannot call the function because we have no access. It is private. When we make something private, it is only accessible to that class and nothing else. So up here, we cannot call the sayHello function, but for example, over here, inside any code, inside of the player class, over here, we can call sayHello, and yep, this one works perfectly. So by making something private, it means it can only be accessed by that class where it's been defined. And what I'm saying here applies to functions, but also to fields. For example, if this one is public, then up here on the main, we can access ironman player.name, and we can set it to something. So this works, this is valid code. However, again, if we omit this, which again is going to default into private. If so, then yep, now this one is inaccessible. If we do want this field or this function to be accessible from outside, then we do need to mark them as public. So public string, and over here, public void. Now, if you're a beginner, you might be thinking this is just adding needless confusion to the code. You might be thinking, why wouldn't you just make everything public so you can access everything from everywhere? And that is one of those questions that is perfectly reasonable for a beginner to ask. And as you grow your skills, you will actually see just how valuable this is. The next two lectures are going to be on the theory behind how and why to write good clean code, and one of the main clean code principles is simply to limit access. The reason why public and private exists, the reason for this is all about helping you manage complexity, and the best way to manage complexity is to limit accessibility. So access modifiers are really extremely important. Like I said, I'm going to cover this topic in much more detail in the next two lectures. For now, just know these are extremely important, and as a general rule, you should always default to making everything private and only make it public when you have a very good reason to do it. So by default, we should define all of these as private. So this one is private, this one make it private, and the public string make it private. Yep, so by default, we should start writing our code like this. And then for each piece of code we write, we should be able to ask ourselves, okay, does this need to be public? And if so, like for example, over here, we do intentionally want to create some player objects. So we do want this one to be public. Then for the function, we also want this code up here to be able to call the function. So this one should be public. However, for the name field, this one is meant to be an internal piece of data that is only used by this class. So this one should be marked as private. And out here, we should not have access to that field. So as a general rule, just follow that basic guideline. Default to making everything private and only make it public if you absolutely need to. If you just follow that one very simple rule, you will write much better, much more high quality code. And like we saw, technically we don't need to write the access modifier. If you want it private, you can just omit it, and this is going to default to private. However, personally, I like being as explicit as possible. So even though technically you don't have to write it, personally, I always write it every time. I want to be very, very clear that I want this to be private. I don't want to have to remember what are the defaults, because actually defaults default to different things depending on what code you're working on. There is a great guide on the C# docs that goes into this topic in a lot more detail. So you can see all of the various access modifiers and from where you can call some kind of thing or access some kind of variable. And then down here, if we scroll down, we can see, yep, the default access summary table. And you can see how for some things, if we omit it, it defaults to private. But for other things, it defaults to public, and for others, defaults to internal. I'm going to cover all of this in detail in future lectures, interface, structs, enums, and so on. Since the default actually defaults to various different things depending on what type we're working with, that is yet another reason why I really believe you should be as extremely extremely explicit as possible. So over here, do not just omit this, let's write it properly, private. And now that I've taught you what are access modifiers, I can finally explicitly define them over here on this code. Honestly, this is something that has been driving me crazy throughout this whole course. I didn't want to use them until I explained them. I really don't like how this default code is set up, but now that you know what they are, now I can finally refactor this code. Over here for the player class, this one is only going to be used inside the program class, so let's make it as private. Again, by defining this one as private means that we can use it inside of anything within this program class code block. Then for main, let's also default this to private. This is our main entry point for our code, so we don't want any other code calling this function. And then for our program class, instead of making it internal, let's make it public. Public because in this case, this one is a global class inside this namespace. And if we try making this as private, then nope, this actually throws an error. Basically, elements defined in a namespace itself, these need to be either internal or public. So let's put it as public. Okay, so now the code is much more explicit, everything is much more clear. We can know for certain that the main is only going to be the entry point and is never going to be called from anywhere else. We can see that this player class is only going to be used inside the program class. And within the player class, we can see that the constructor is meant to be accessible from outside. This function also accessible outside, but this name field, this one is meant to be only used by this class. Okay, so with that, we have learned about the basic access modifiers. And this pretty much concludes the absolute basics. So now, like I said, in the next two lectures, let's learn a little bit more on the theory behind how to write good clean code. Starting with one of the most important guidelines for that, which is naming rules. So let's learn that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn something extremely important. Let's learn about naming rules. This is a very important lecture that you should definitely refer back to whenever you have any questions. Following good naming rules is something that will make you a 10 times better programmer. So first, what exactly are naming rules? These are really just the rules you define and then follow while writing your code. It is extremely important that you are consistent in applying your rules. You don't want one class in your projects to be written a certain way and a different class using a completely different naming scheme. That would create a ton of confusion and make it really hard to read the code. So naming rules and writing code correctly is very important. One mistake that I see a lot of beginners do is they send me some code and ask why it's not working. Then I take a quick look and see all the code written in a very messy way. Some functions are in lowercase, others using snake case. Some fields are in Pascal case, some in camel case. Always remember, code is case sensitive, so it is really extremely important that you write the code correctly. If you change a character from lowercase to uppercase, then you are suddenly referring to something completely different. If you are a beginner, always keep that in mind. Code is case sensitive, so don't just write code semi-randomly. Write it properly as if you were doing some kind of English test. Now with that said, when it comes to naming rules, you can use whatever rules you want. Different people like different rules. For example, some people like to use a prefix in variables. They like to add an underscore or m underscore. Or other people like to use a postfix. Some people like capitals for constants, camel case for properties, snake case for fields. Which, by the way, here are the definitions for those terms. Pascal case, this one starts with a capital letter, and then it is lowercase, and then a capital for every word afterwards. Then camel case, this one also has a capital for every second word, but the first one is lowercase. And finally, snake case, for this one you just use an underscore to separate the various words. These are usually the various ways you have of naming some kind of symbol. And like I said, the specific rules you follow don't necessarily matter. Every rule can be valid. The most important thing is just that you are consistent and always following through your rules. So define some kind of code style and always stick with it. For me, here are the rules that I follow and the code style that I use. For function names, I like to use Pascal case. This is also the C# standard, so always capitalize the first letter of every word. Then for the function parameters, for that I use camel case, so it starts lowercase and then uppercase after every word. Then for properties, this is something that I'm coming to cover in detail in the intermediate section. For these, I use Pascal case. For constants, again, another thing I cover in the intermediate. For this one, normally use uppercase snake case, so everything is uppercase and use a little underscore to separate the words. Events are in Pascal case, and then fields, these are in camel case. Then another one of my personal rules is something that I mentioned in the beginning lectures, which is the position for the opening of the curly braces. Now personally, I do like opening it on the same line, but some people prefer to place the opening on new line. I know some people have some really strong opinions about this, but really this is just the visual style that I personally prefer. It's probably due to the fact that when I started learning programming when I was 10 years old, I was writing some Mirk scripts which usually use this style, so I'm very used to it and I like it, but it's really just a visual thing. If you like the curly brace on new line, then by all means go ahead and use it. And for some more very useful general rules, first is spend time deciding on a proper name. Don't just use the first name that comes to your head. Actually think what would be the proper name for this symbol. Also, do not use single letter names. A lot of beginners like to use this just because for some reason they want to be as compact as possible. But remember, the goal with code is not really to be compact, it's to be understandable. And single letter names usually are terrible. The only exception for that would be iterators on a for loop. For those, it's perfectly fine to use just an I or a J. But for pretty much anything else, use a proper name and not a single letter. Related to that, also don't use acronyms or abbreviations. Those might seem really clear to you right now when you're writing the code, but in a few weeks, when you yourself get back to the code, you might not remember what those mean. Again, don't be be afraid of being verbose. If the most accurate name you can come up with is somehow 20 characters long, then really that's a name. Remember, you don't get bonus points for writing extremely compact code. So always value making your code readable and understandable, even if it requires functions and variables with very long names. And the final extremely important rule is simply don't be afraid to rename things. If you come up with a name and later on you come up with a much better name, then just take a second to rename it. With Visual Studio Shortcut, it's insanely easy. You just place the cursor over something like, for example, the player class. Let's say instead of this being used just for players, let's say it was also used for enemies. So I want to really name this unit. The shortcut is Ctrl plus RR, and it shows up this window, and now we can easily rename it. And yep, look at that, it renames every instance of this type. So renaming things is really super easy, so definitely make sure to do it. If you come up with a better name, come back and rename that symbol. Always remember, code is not fixed. It is meant to adapt and grow as you work on it, and part of working on it is refactoring and renaming things, so don't be afraid to do that. Okay, so these are my general rules and the code style that I personally follow. Like I said, you don't have to follow my rules. Figure out what works for you and follow your own rules. But naturally, here in this course, I won't be using my code style. So if when following this course, you're not sure how to write some type of code, come back to this lecture and watch it again. Like I've mentioned many times, the code that I teach you how to write in my courses, that is on the same level of quality as my professional Steam games. So as such, this lecture, this topic on making rules, this is extremely important. If you just follow these rules, or whatever rules you can come up with, if you just do that, you will save yourself a ton of headaches. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn more on the theory on how to write good clean code. So first of all, what exactly is clean code? Now there are many definitions for this. For me, it simply means writing code that is easy to understand and easy to modify. With bad code, you need to look at it for a real long time to try and work out what on earth that code is doing. Whereas with clean code, the intent of the code should be immediately obvious. Everything is very clear and straightforward and requires no effort to understand what exactly it's doing. That's the goal. The most important thing is simply following a good set of naming rules like I covered in the previous lecture. Always choose good descriptive names for all your variables, all your functions, classes, and really anything. If you just do that, then your code will be infinitely higher quality than someone who does not follow any naming rules. Beyond that, here's some more general guidelines. Starting off with a simple one, try to avoid magic numbers. These are numbers that are used directly in the code with no context for what exactly they mean. Like for example in this code, this one has a bunch of numbers, and just by looking at it, you can't really tell what those numbers are supposed to mean. After studying the code for a little bit, you might be able to tell that, for example, over here, this is supposed to be the super bonus damage amount. And for example, over here, if you see an if testing if the distance is under 5, and if so, call the attack, then probably this means this is the attack distance. And over here, testing if the distance is above 10, then go to jump, so this should be some kind of jump distance. So it requires spending some time in order to understand what the code is doing. So by using magic numbers, it obfuscates what the code is actually doing. So instead of this, we can improve this code by quite a bit by simply defining proper named local variables. So over here, just define an int for the super damage amount multiplier, just set it to 2, and over here instead of that, just use this one. And now it is very clear what exactly this line of code is doing. Same thing over here, let's define an int for the attack distance, and over here an int for, let's say, the jump distance. And yep, so now the code is much more clear, much more understandable. You can literally just read this and it makes perfect sense as if it's in proper English. So if the distance is under the attack distance, you attack. If the distance is above the jump distance, you jump. Super simple. So with this, there's no need to waste any brain power trying to understand the code. All of it is immediately understandable. Another simple one is how you should never ever use strings as identifiers. Strings are terrible as identifiers because they make it extremely easy to make all kinds of mistakes. For example, look at this code. Over here, I'm using a string identifier in order to find the name of a child object. And here in Unity, you can see that this code actually throws an error. It throws a null reference exception. Here the code is doing a transform.find to get the child sprite, then goes, gets the sprite ren and changes the color. So quick question, can you spot the error instantly? And I'll give you a hint, the error is actually not in here. The error is actually over here in the editor. So again, can you spot it? And the answer is no. I know for certain that you cannot spot it because the error is literally invisible. Here in the code, I'm looking for a child that is named exactly sprite. And here in the editor, it doesn't look correct. Over here, looking in the hierarchy, it does look like it has a child named sprite. However, if I go in the inspector and I click over here on the name, yep, look at that, that's the issue. It turns out that this child name, this one has an invisible space at the end. So the code is indeed perfectly correct. There are no compiler errors here because everything is correct, but it is looking for a child with this exact same name, just sprite. And since the actual object has an invisible space at the end, it does not 100% match the sprite name identifier. This exact mistake is something that has happened to me several times and drove me insane every time it happened. Or here is another example. Look at all of these strings. So can you quickly at a glance tell the difference between all of these? It probably takes you a little bit because visually they all look quite similar, but identifiers are case sensitive. So looking quite similar does not matter. If it is not 100% exact, it will not work. So if you had an object with any of these names and you accidentally mistyped or wrote any of these other names, if you did that, you would get an error and you would not know what exactly is going wrong. Whereas if you don't use strings, like for example over here, I've got a variable named player10, I construct a brand new player and I call some kind of function on the player. If I use this instead of using a string, if over here I mistype, like for example, I change this one into a lowercase l, which looks quite similar, but right away the compiler tells me there's an error. So with this, I can fix the error without ever needing to run the code. Strings should pretty much only ever be used for text, so use them to store the player name or the name of some kind of object, but never ever use a string to identify an object. If you need to identify an object, use a direct reference or some kind of strippable object or an enum or a tag component, literally anything except a string name. Now, as always with every rule, there are exceptions. Sometimes, especially when working with things like web development, that usually involves a lot of JSON and some simple HTTP text requests, sometimes you really have no choice and have to use some kind of string identifier. In those cases, you should still avoid strings whenever possible. If you need a string to define some type of data, consider defining a constant and never use the string itself, only use the constant. If you do that and you mistype the constant name, the compiler will tell you. But basically, try to avoid using strings as identifiers at all costs. Then, one extremely important principle in writing good, clean code is the concept of managing complexity. That's really the main difficulty as you write bigger and more complex projects. The difficulty is in successfully avoiding becoming overwhelmed by managing that complexity as the project grows. And for that, your best tool is called information hiding, meaning for any code that you write, like a class, you should only expose as little as possible in order for the class to be usable. For example, specifically in Unity, a lot of Unity tutorials target at beginners teach you to make every single field public, but this is absolutely a terrible code practice. I made an entire video on this subject. By making it public, it makes this field easily accessible in the Unity editor, which is usually the goal. However, it has a side effect because it makes it also accessible from any other script. Now, for a beginner, this might sound like a good thing. You can easily access anything from anywhere. But that means that every single class in your entire codebase, which could be 1,000 classes long, every single one of those could potentially access and modify that field. So as you write your code, you have to constantly keep in mind that scenario, so that's a lot of wasted brain power. So like I said, the simple but extremely important guideline to follow is simply only expose as much as you need to and no more. So do not default to making everything public all the time. Instead, default everything to private and only use public when absolutely necessary. If a field is only ever used in that class, then there's no reason to make it public. It should always be private. That way, when working inside of this class, you don't have to keep in mind the entire codebase. You can just focus on this one single class since you know for certain no other class can ever touch any of these fields. You could have a project with 1,000,000 classes, but if this field is marked as private, then it does not matter. Nothing else can touch this field other than this class. Same thing for functions. If you have a function that is only ever used by a single class, then keep that function private. Do not make it public. If you do, then some other class in your thousands of classes, some other one could call that function, which could cause some unintended results. And if there is some kind of field that you need to access, instead of making it public, consider instead keeping it private and simply exposing some functions to get it and set it. That way you have a lot more control over how the underlying field is modified, and you can even add some logs over here if you need to. Alternatively, properties work as well. You can make it a property and add some code in the getter or setter. I cover properties in a lecture in the intermediate section. So in general, whenever you write a field or function or anything, always default to making it private. Only switch to public if you absolutely need to. Just following this one simple guideline will help you limit how much access different pieces of your codebase have towards other parts of your codebase, which in turn helps you minimize the total number of connections, which in turn helps you manage complexity even as the project grows. One great principle is the single responsibility principle. This means that each class or function should do one thing and one thing only. So if you have a game and you have some kind of player class, you probably should not keep any kind of enemy logic directly inside that class. That should probably exist in a separate enemy class. Same thing for functions. Each function should do one thing and one thing only. Don't write 1,000-line functions that do 10 different things at once. One good heuristic for seeing if a function is too big is simply if the best name that you can come up with contains the word and. If so, that probably means that function is doing more than one thing and would probably be best split into separate functions. Another related one is to keep your functions short. So this kind of follows the same as the previous principle. If your functions only do one thing, they will probably be quite short. If they are big, then chances are they are doing more than one thing. But this is also a very adaptable guideline that you should adapt to the situation. For example, in my game, Dinky Gardens, I have quite a few relatively large functions. Breaking those apart into smaller functions would actually make the code hard to understand instead of easier. So all of these guidelines do depend on the specific use cases, but on average your function should be relatively short. If your program is mainly composed of 500-line functions, chances are there's some room for improvement. Remember that refactoring is your friend and a perfectly natural part of the process. Another good one is group logic together, meaning, for example, let's say I have some stats in my player class. I've got these in my player class, and let's say I've got some sort of UI class that I want to display these. Since these three separate fields, these are all really part of the same thing, these are all player stats, instead of working with three separate fields, instead of having to, for example, call some function on the UI that takes in three separate parameters, instead of that, consider making a custom type just to hold these stats. So something like player stats, that inside contains all those, and then you would simply have a field, just one field of type player stats that contains all of the player stats. That way, data that belongs together is actually together. This simplifies things and makes it quite easier to understand. In terms of comments, the guidelines are the ones that I already mentioned in the comments lecture. In general, you should avoid using comments. If you need a comment, before you actually write that comment, see if you couldn't just rename some variables to make the code intent a bit more clear. In most cases, well-written code is going to be self-documenting, but at the same time, comments can be useful if your code is already extremely clear, but you'd still like to provide some extra information on something, like for example, why you're doing that code or how that function should be used. Another good one is simply called dry, or don't repeat yourself. Basically, if there's some code that you need to run 3 times, you probably should have a dedicated function instead of copy-pasting that code 3 times. Although remember, these are just guidelines meant to help you, so don't look at these as some unbreakable laws. In general, code should be unique, although sometimes you might need to copy-paste twice in some scenarios, that's fine. But if you find that you need the exact same code copy-pasted 3 or 4 times, chances are that's a signal for some refactoring. And speaking of refactoring, this is an extremely important process that you should be doing at all times. Refactoring is the act of rewriting or reorganizing code to keep the code quality as high as possible. This is a very, very important topic, and there is a dedicated lecture on refactoring in the beginning of the intermediate section. So these are just a handful of nice guidelines to keep in mind to help you write good, clean code that will help you a lot as your projects grow in scale and complexity. Although also, do keep in mind these are just guidelines. They are not holy rules that must never be broken. The ultimate goal of all of these guidelines is to help you achieve your goals. Always remember that. It is always up to you as a programmer to figure out when to follow the guidelines and when it's okay to break them. There are some people that follow some specific code rules so rigidly that it actually makes the code worse, so don't be like that. Follow these guidelines, which will help you in most scenarios, but also always be willing to adapt to the specific code you're writing. Now on this topic, personally I'm a huge believer in writing good, clean code. If you're a regular on my YouTube channel, certainly you've heard me talk quite a lot about it. The reason why I love it so much is because I spent a lot of time writing a ton of code where I did not care about code quality. I've been writing code since I was 10 years old, and I really only started being very careful with the code that I write since I was something like 25. So I've already suffered quite a lot because of code that I would write with some nonsense variable names or some obscure acronyms, and then later on when getting back to that code, I would have no idea what I wrote or how I could expand upon it. Because of that, I really hope to help you avoid the suffering that I went through. If you are a beginner, I hope you can start off on the right foot by focusing on writing good, clean code right from the start. If you do that, it will help you learn faster and grow your skills by a massive amount. Now, if you're looking for some more info on this topic, there are tons of sources to learn from. The one that I highly recommend is the book Code Complete. Reading this book alone massively improved my code skills by 100-fold. It really is that good. It's a pretty massive book, it's over 800 pages long, and it's all really technical. So it takes quite a while to get through it, but if you do read through it and you fully understand everything, if so, you will come out the other side an excellent programmer capable of building any program or any game you can think of. Hello and welcome, I'm your Code Monkey. In this lecture we're going to see a nice beginner project that incorporates everything we've learned so far. Okay, so let's inspect this project to see how everything we've learned so far is being used. It's in the Unity project, so just go inside lectures, then inside the beginner project and load up this scene. Then let's go ahead, hit on play. And yep, so here is the minigame running. There is a player and I can move it by pressing either the arrow keys or WASD. Every time I press, I move a certain amount. We can see the player is currently holding 0 coins. So I can move around, and as I approach and touch one of these coins, yep, it picks it up. So I can pick up a whole bunch of them. Yep, that works. Then there are 2 buildings. I can approach to interact with them. And when I'm close enough, I can press space. And this building, this gives me 1 coin. And if I go onto the other building, so I go straight to the right, and once again I interact, and yep, no, this one gives me 3 coins. Alright, awesome. So this is a super simple demo, and importantly, it's using everything that we've learned so far. So let's inspect how all this is working. Here in the project files, we can see how this demo is really pretty simple. We just have 2 files for our 2 classes, and the coin file, this one is super small. Let's go ahead and open it. This one is mostly meant to just tag an object as of being of the coin type. By the way, right now you can ignore this syntax where it has a colon, then says mono behavior. This is a Unity specific thing, and this colon here has to do with class inheritance. I'm going to cover that in detail in a lecture in the intermediate section, but for now, don't worry about this. Here, coin, this one is really just a simple class, so just like we covered. And inside we can see the use of a nice function. It is called destroy self, returns nothing and has no parameters. And in turn, really this one just destroys this game object. If we look in the editor, over here in the hierarchy, we can see a whole bunch of coins. So all the coins spread out throughout the world. Each coin is really just a game object, and in turn it has a sprite render in order to show the coin visual, and then just has the coin script that we attached. So on this function, all we're doing is just destroying that game object. And also note how the function is marked as public. This is important because we're not going to call this function from inside the coin class, but rather from the player class. So let's look at that one. Here is the player class. So most of the logic for this little mini game is over here inside this class. So first of all, the player itself is yet another class. Then we can see up top we have some nice class fields. We have a field for a TextMesh Pro object. Looking in the inspector, we can select the player and we can look in the inspector. Looking in the editor, we can select the player game object and look in the inspector. And again, this one also has a sprite render for the visual, and then we have our player script. Here we have the reference to the coin TextMesh object, and that's really just a child object of the player. This is really just what shows the text. Then we can also see that we have a float for the move speed. And the movement logic, that one is handled over here inside the update function. Now this update, this is a special Unity thing that runs automatically on every single frame. So don't worry about the fact that technically we're not calling this function from anywhere, as you can see. This is actually called automatically by Unity on their backend. So we have the update function, and then over here we have some examples of some simple ifs. So we're doing an if, and then for the condition, here we have 2 conditions. And first we are testing for the input get key down for the double key. This is a function from Unity that checks if the player is pressing some key, so in this case pressing the double key. And this function we can inspect and see this one is going to return a boolean. So when the player presses the double key, this is going to return true. And then here we also see an example of a logical OR. So we are testing if the player is pressing the double key or if they are pressing the up arrow. This way the game is playable with either WASD or with the arrow keys. So it evaluates these 2 conditions. And when the player presses either W or the up arrow, when so, this is going to return true, so we're going to run the code inside the if. And over here, this logic simply takes the transform. This refers to the transform that this script is attached to. So in this case, it's the player transform. The transform field itself, this is another Unity specific thing. So don't worry about the fact that there's no reference of it up here. That is actually inside the mono behavior base class, which again, I'm going to cover inheritance in detail in a future lecture. So here we access the transform and we're going to modify the position. We do plus equals, meaning we're going to add onto that position. And then we are creating a vector3, which is a type inside the position. So this is really just a struct that contains an X, Y, and Z. Again, it's another Unity type. So we take that and we're going to increase it by 0 on the X, 0 on the Z, but plus 1 on the Y. Meaning we're going to move our player upwards. And for the movement amount, we're going to multiply it by move speed, which is our variable that we have exposed in the editor. That way we can easily modify how fast we move. So that's the logic. Just a basic if, some conditions, and doing some basic movement. Applying that to all of the keys, W, S, A, and D. So moving up, down, left, and right. And here in the game, we can test it. So like this, if I move, I am moving by this amount. And if over there on the move speed, I modify this, let's say put it on 5. And yep, now it moves quite a lot more. Okay, so we've already seen classes, functions, variables, and if statements in action. Now up here, we can also see 2 lists. There is a list of type coin for our coin list, and a list of type transform for the building transform list. Here in the editor, again selecting the player, and we can see both of our lists. And these are referencing the objects that are assigned in the hierarchy. So basically what I did is this list started off as empty, and I just dragged and dropped each element individually. So I dragged all the references to all the coins as well as all these buildings. So back in the code here, we have our lists, and then over here on the update, we are calling this function handle coins, and the function does exactly what it says. It handles all the coin logic. It is being called up here on update, meaning that this function is going to run on every single frame. And inside here, we have an example of loops. We are cycling through all the coins in the coin list using a for each. And then first we do a test to check if the coin is not null. And then first we do a test to check if the coin is not null, meaning that the coin has not been destroyed just yet. So here we see an example of a useful comment. It is easier to understand this code by reading the comment rather than the code. The comment provides some extra clarification on what exactly this code is doing. Since checking for null, that could technically mean a bunch of things. So in this case, we are checking if it hasn't been destroyed. We do that, and then we're going to test the distance. So we're going to use this static function inside the vector3. This tests the distance between 2 points. So we're testing distance between transform.position, meaning the position of the actual player, and then the coin.transform.position, meaning the position of the coin. If that is under a certain amount, so again, over here, we're keeping our code clean and using a proper local variable in order to make this much easier to understand. So we test it, and if it is under this amount, if so, then we're going to pick up the coin. So here we add a coin to the player, and then we tell the coin to destroy itself. So again, this is why it's important that the destroy self is marked as public. It's so that the player class can call it. If this function was marked as private, then the player would not be able to call it. So we have this, and on the add coin function, it's all super simple. It just increments a coin amount, so this is just a simple int field that we have up here. So just a coin amount. We have that, and then we assign the coin amount to the text object in order to update the text. However, also note how coin amount is an int, whereas the text field, this one expects a string, so that is why we need to convert our int into a string, which we can do by calling toString. So here in the game, I can move around, and as I approach a coin, yep, I can pick it up, and yep, it works, it increments the text, and everything works. Okay, great. Then here on the update, another function we have is over here, the interact action. For this, we're doing the same thing that we were doing up here. So we're testing if the player is pressing down the spacebar. And if so, we're going to run this code. So we're going to run our handle building interaction function. And this function, like it says, is going to handle the building interaction. Over here, we're cycling through all the buildings. Now here, I went with a for loop instead of a for each. Normally, I would also use a for each over here, but I just wanted to use different loops in this demo. So just do a simple for, cycling through the entire list. So we cycle through it, and we access the list on that index in order to get the current building transform. Then does pretty much the same distance logic that we saw. So we test the current player position against the building position. If it's under a certain interact distance, then the player is close enough to interact with this building. And then over here we have an example of a switch. So this one does a switch on the building transform.name. Here in the editor, in the hierarchy, we can see our two buildings, and we can see they have different names directly on the game object. So we're doing a switch on that, and if it is named this, building coin 1, if so, then we're going to add just one coin. Case it is named building coin 3, if so, then we're going to add 3 coins. And then on default, if it does not match any of these two names, if so, that shouldn't happen. So over here, I just fired the log error. So over here, if I move towards this building, and I'm close enough and I press on space, and if there you go, it does add 1 coin. And if I go here and I press on space, and yep, this one adds 3 coins. Okay, so that's really it for this simple demo. Here we can see examples of variables being used. We can see how we're using various data types. We have both simple types like ints and floats, as well as more complex types like lists. Then we see some simple if statements. These are going to make sure that we only run the move logic if the player is actually pressing a button. Then on the buildings, we can see a switch in action, doing different types of logic depending on the name of the building. We can also see how we define various functions. We can see how those functions have different access modifiers. So all of these that are only used by the player class, these are all marked as private. Whereas this one on the coin, this one is marked as public, so the player can call it. Then we also see how we're using multiple different classes. And then we also see how we're using different types of loops, a for each and a for. And very important, note how throughout this whole script, there are only a handful of comments, very few. There are really no useless comments. Instead, all of the code was written carefully with good names. Every function variable has a proper name that makes it very clear what exactly it represents. So this way, all the code is self-documenting. There's no need for comments. You can just read the code directly itself and easily understand what exactly it's doing. So here in this nice simple project, we have indeed incorporated everything we have learned so far. Now here, let me also make a quick note, just in case you're a more experienced user and not a beginner. I made this demo intentionally as simple as possible. Normally, for building a demo like this properly, I would use multiple classes to separate all kinds of logic, instead of putting it pretty much all in just one player class. I would use events and various other things to massively increase the code quality and readability. I would make these fields serialized private. I would make these serialized private fields instead of making them public. I would remove coins from the list when they were destroyed, or I would simply use continue to skip them. I would perhaps use collisions instead of distance checks. So there are plenty of ways to improve upon this code, but on this demo, I wanted to only use as much as was taught by this point, so that is why I simplified it so much. If you are an intermediate user and you want a simple challenge, then perhaps try refactoring this demo to make it work with some good clean code. And if you are a complete beginner and you have no idea what I'm talking about, then don't worry about it. Just keep watching the course, and after you get to the end of the intermediate section, maybe come back here and do that mini challenge. Alright, so that's our beginner project. Hopefully you fully understood everything in this beginner section and had no problem understanding everything in how this project works. If there is something you found confusing, maybe go back and rewatch that lecture or just post a question in the comments. I highly encourage you to make sure you fully understand absolutely everything in this beginner section before continuing on to the intermediate section. Hello and welcome, I'm your Code Monkey, and congrats on completing the beginner section. In this section, we'll learn a lot of stuff, starting with installing and setting up Visual Studio and Unity. We also learned the absolute basics of Unity, which isn't necessarily needed if all you want is just learn C#, but I really hope you've been following the course using the companion project. I really hope you've been doing all the interactive exercises, answering all the quizzes, and reading all the frequently asked questions. You really learn so much more by doing rather than just watching. Then we learned about various common errors, what they mean and how to solve them. Like I said, this one is a great lecture that works as a general reference. So even in the intermediate and advanced section, still come back to this one if you get stuck on some kind of error. Then we start learning from the absolute basics of programming, learning how code executes line by line, what is a code block, and just how important it is that code is case sensitive. Then we start writing some code and learn about variables, how they store some data, and what are those data types. Then was about if statements, which help us do some conditional logic. Related to that, we learned about the switch statement, very useful to have tons of conditions. After that, we learned about functions, one of the crucial components of any kind of programming. Then we learned about scope. This is one of those things that's a little bit tricky for beginners, so I truly hope you understood this one. After that was a lecture on comments, what they do, and importantly, whether you should and should not use them. Next was a lecture on arrays and lists. This is a really important data type for storing multiple pieces of data. Then was another crucial thing in all of programming. We learned about loops. This is how we can execute logic multiple times. And then since C# is an object-oriented language, we finally learned about objects which we build using classes. Then we learned about the static keyword and what it means. Also, what are the access modifiers, public and private? After that, we had one of the most important lectures of all. It's all about what makes a good name and how to define some good naming rules. And then yet another really important one about how to write good clean code by following some simple guidelines. And finally, in the end, we put it all together in a nice beginner project involving every single element that we learned about. Hello and welcome, I'm your Code Monkey, and congrats on going through the entire beginner section. I really hope you learned a ton. I hope you took your time and really focused on learning everything over here in this beginner section. If you did, then hopefully by now you have a lot more knowledge and a lot more skills than you had when you started. If you want to try out that knowledge with some interactive exercises, you can go ahead and check out the premium version of this course. The companion project includes the interactive exercise along with frequently asked questions and quizzes for every lecture in the course. Remember, you won't learn by doing, so definitely make sure you apply everything that you're learning. Now would be a really great time to pick up the premium version of the course and go through all the sections, all the lectures, all of that content on the companion project. Or at this point, if you want to change things, if you want to focus on making a game as opposed to learning about the language itself. If so, then you have enough knowledge to start following my free Kitchen Chaos course. So if you want to try making a game, you can go through that one. There's a free course making the game in single player and a second free one on making the game in multiplayer. Or in general, for some Unity knowledge, you can check out my Ultimate Unity Overview course. That one covers over 70 tools and features that Unity has. But if you want to just keep learning the language, then let's keep going. So once you're ready, let's jump into the intermediate section. Hello and welcome, I'm your Code Monkey. Welcome to the intermediate section where we're going to take things up a notch and learn some more intermediate concepts. But before we do, let me just quickly say, if you are still very much a beginner, if the previous section was your very first exposure to any kind of programming, if so, then just be aware that it's perfectly normal that it takes you some time in order to understand the context of this intermediate section. That's perfectly normal. Learning and truly understanding all that we're going to see, all of that takes quite some time. Remember that the only thing that really matters is that you're learning. How long it takes you isn't really relevant, so really just focus on actually understanding, actually learning. For me, it took me literally decades to learn all of this. So if it takes you 6 months to go through this intermediate section, if so, then you're still going to be doing much better than me. So all that to say, take your time and just focus on learning. Now, if you took a break between the beginner section and this one, then I encourage you to go back and at least rewatch the naming lecture and the clean code principles. I put those two lectures in the beginner section just because I want beginners to be aware of it, but as you grow as a programmer, as you become an intermediate, those two concepts, naming rules and clean code principles, those become even more important to fully understand and fully apply. So if it's been a while since you saw the beginner section, go ahead and rewatch those just quickly. Also consider checking out the premium version of this course with a bunch of awesome bonuses. The companion project is really excellent for helping guide you in your learning journey. It contains frequently asked questions and fun quizzes to test your knowledge for every lecture in this course. And importantly, it contains interactive exercise so you actually put into practice what you're learning. I designed all of these specifically so you can learn by doing. Now would be a great time to pick it up and go through all of that content for the beginner section. And beyond that, the premium version has a bunch more bonuses, including simply the fact that it has no YouTube ads. So if you're enjoying the course so far, then check it out. Also remember to like the video and subscribe if you haven't already. So let's go into the next lecture where we're going to see a nice overview of everything that we're going to learn in this intermediate section. Hello and welcome, I'm your Code Monkey. In this intermediate section, we're going to go one level up relative to the beginner section and learn some more complex stuff, so let's see an overview of all the lectures. Beginning with something very important that I debated whether I should put in the beginner section, it's going to be Visual Studio Shortcuts. I end up putting it here because for beginners, technically it's more important to learn how to write the code, and it's not as important to be extremely efficient with how fast you use your IDE, but for intermediates this is a must-have. So we're going to learn about a ton of shortcuts to help you write code and navigate your environment much better. Then comes one of the most important lectures in this whole intermediate section. It's all about refactoring. This is the process of rewriting your code to make sure it is as readable and understandable as possible. As an intermediate, you absolutely need to know that this is a natural part of the code writing process and something you should not skip. Next is a lecture on enums. Pretty simple and very useful. It's how you can define a specific list of values that you can use in many ways. After that, we'll learn about properties, which are kind of like a mix between variables and functions. Then we're going to learn about multidimensional arrays, meaning arrays that can hold multiple dimensions of data. After that, we're going to learn about nested loops, which is especially important in order to cycle through multidimensional arrays. Next, we're going to learn another method for doing some looping logic. We're going to learn about recursion. This is something that, for people with a math background, it might actually be similar to understand than Readonly loops. Then we're going to learn about an extremely useful data type, the dictionary. This is a key-value pair that has tons of really awesome use cases. After that, we're going to learn about some more collections like queue and stack. Then we're going to learn about the params keyword and what exactly does it do in a function. Next, we'll learn about optional parameters, how to define them and how to call them from a function. Then another crucial lecture for intermediates. This one is on learning the differences between value and reference types. This is extremely important. If you don't know this difference, then you will go crazy at some point in the future, wondering why something isn't changing, and it's usually going to be because you don't know you're working with a copy and not a reference. Related to that is the lecture on structs. These are similar to classes, but importantly, they are a value type. Next, we're going to learn some more intermediate use cases for classes. We're going to learn about inheritance, polymorphism, and a bunch more. Then learn about interfaces. This is one of my favorite features of C#. It allows you to write some really nice modular code. Related to that, we're going to see various ways of testing for types and converting to and from various types. Also related is the lecture on switch pattern matching. This is a really simple way to do a switch, not just on value, but also on type. Then we're going to learn all about delegates, lambdas, and anonymous functions. This is how we can store a function itself inside a field. Next, we're going to learn the differences between lambdas and local functions. After that, we'll learn about events, which is how we can have one class be notified when something happens. Then the next lecture, that one is going to be all about generics. This is another super powerful C# feature that makes your code work with multiple types. Next is a simple lecture on constants and read-only, what they are and what are the differences between those two. After that is a lecture on exceptions and how to handle them with a try-catch. Then a lecture on implementing IEnumerator, so we can add support for something like a for each for some custom types. Next, we're going to learn about namespaces, what they are and how to make your own. Then a really important lecture on one of the most important design patterns, the Singleton Pattern. And after that is a general overview of a bunch more design patterns. And finally, after doing all of that, we're going to check out the intermediate project that uses all of this to make something really interesting. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about a bunch of really useful Visual Studio shortcuts. Okay, so as we get to the intermediate stage, it is really important to be good at using your tools. And as a programmer, your main tool is going to be your IDE, so you should be very comfortable with shortcuts and moving around in your codebase. But also this is something that you pick up with experience. So this lecture, this one is really not meant to be a step-by-step lecture, but rather I just want to show you a bunch of shortcuts that I use myself, just so you are aware they exist, and over time you will pick them up and they will become more and more natural. Okay, so the most basic, but honestly most useful one is simply moving the cursor. Normally beginners, they use the mouse to move around, so they scroll down and click wherever they want to write. And then sometimes beginners use the arrow keys and they press it like a million times in order to get wherever they want to go. Technically this works, but it's obviously not very efficient. There are many ways to speed this up, and importantly, many ways to navigate your codebase without your fingers ever leaving the keyboard. For example, when moving left to right, technically you can indeed just press the right arrow key and eventually you will get there, but as you can see, going left to right like this takes quite a while. I gotta press like something like 50 times in order to get to the beginning or the end. So one of the best super simple shortcuts is simply to hold down the control key, and now as you move left and right, instead of going letter by letter, it goes word by word. So that way now I can get to the beginning or the end of this line in just about 4 or 5 presses instead of being like literally 50. So it is literally 10 times faster. Then of course you also have the home and end keys. I use these all the time, especially when combined with shift for quickly selecting something. So for example, if I want to move this line above this other line, if so, then usually what I do is press N to go to the end of this line, then hold shift and press up to select, and now press End again in order to select just that one. Then I press Ctrl X to cut, I move up, press Ctrl V, and like that. So if you do it pretty quickly, it goes quite fast, very easy to do all this. And again, I did all of that without ever my fingers leaving the keyboard. If I were to use the mouse, I would have to select like this, Ctrl X, go like this, and like this. So in this case, not much of a speed difference, but just the fact that your fingers never have to leave the keyboard, that alone is a huge bonus. And again, on all these shortcuts, we're going to see how difference is usually pretty small, like saving like a second, 5 seconds, or fractions of a second. So that does sound like a super tiny amount, but considering how you're probably going to be programming for many years and you're going to write millions of lines of code throughout your entire life, when you look at it like that, those tiny amounts of time, they really add up. So that's the main thing, just moving left and right, holding control to go between each word, or using end and home in order to go back to the beginning and the end, and combining all of that with shift in order to really move around super quickly. So that's the first tip. And then for something that is sadly not default is moving the cursor up and down. So by default, if you do that, it obviously only moves one line at a time. So again, the same thing, in order to move down 20 or 30 lines, it actually takes quite a lot of pressing in order to move. And by default, the alternative is using page up or page down. Although personally, I'm not a big fan of this. I find that these move the cursor way too much. So every time I press page down, it takes me quite a while to realize where the cursor is and how much actually moved. So I don't like how this moves way too much. So in my code, I added something so that I can move the cursor up and down vertically by just 5 lines. That way I can very easily go down and continue scrolling down, and I'm never lost because the screen never changes a massive amount. I'm always moving down, moving up, select this line of code, do something, move down, write something, and so on. Now sadly, this behavior isn't available by default in Visual Studio, at least not that I know of. So for this, I installed this extension called Visual Commander. This one lets you basically apply some hotkeys to literally anything you can do in Visual Studio. And then with that installed, just go up here into extensions, and here is the V command. And on this one, here are some commands that I made. So here is the window, so I've got move up and move down. So I can edit in order to see what this is doing. And yep, it is executing the command line up, so literally just moves the line up. And the other one, this one does the same thing, but line down. So I've got these two commands. Here, if I have the cursor somewhere and I go into that extension and I use the move up command, yep, it does move up by 6 lines. So then as you can see, I just assigned some keyboard shortcuts to those. So control up and control down. Then I just went into tools, options, and over here go down into the keyboard shortcuts and then find VS command. And up here, command 1, command 2, those are the 2 ones that I made. And as you can see, I've assigned them to control up arrow and control down arrow. So with all that, if I press Control Up or Control Down, as you can see, the cursor moves quite a lot faster. So I find this to be much better than just pressing 1, just moves one line, or pressing Page Up, which always causes me to lose and get lost. So with just these steps, you can see how I can move in the code really fast without ever touching the mouse. Like, let's say I want to go down, I want to find, for example, the awake, I want to select the awake, I want to cut it and paste it down here, and there you go, just like this, and remove these lines, format, and so on. So as you can see, just using these, control in order to move between the words, using this shortcut in order to move vertically really fast, and combined with home and end, and with shift and all that, put all those together, and yep, you can move through the cursor, you can move in your code base really quickly without ever leaving the keyboard. Then of course, if you're working on some kind of big file, like for example, this is the player class from my Steam game Dinky Gardens. So this is a pretty massive class. For this one, if I want to get to the bottom, and if I go even with this shortcut, this is going to take quite a while. So for that one, if you want to move a massive amount, you can use Control Home or Control End in order to go to the beginning or the end of the file. So this is yet another way to very quickly move around. And another very useful one for moving around is simply put the cursor on top of some kind of symbol. Like for example, let's say this one, this event on player picked up the experience. And then if you press Control Shift and either up or down, this will move the cursor to the next or previous reference of that symbol. So for example, over here, you can see how it's really useful, how in this huge line of code, this script has almost 1,000 lines of code, but I can very easily see exactly where this one is being referenced. I just move up and down, and yep, here's the definition, and here is where I'm using it. So whenever you want to see all the various places in which you are using some kind of symbol, that can be a function, can be an event, can be a variable, can be literally anything, just hold down Control Shift and then up and down, and you can see all the places in which that symbol is being used. Then another extremely useful shortcut that I use all the time is Control and comma. This one pops out this window, and now here you can search for any class. You just type a name and find it. Like for example, I want to open up the Dinky class, so I'm going to type in Dinky. And now just one thing is this shows actually every symbol. So in this case, in this game, since it's all about dinkies, I've got tons of references to dinkies. So you can see all of these in lowercase. I usually write my variables in lowercase, so I know that's not the one. I know the one that I want in order to open the file is the actual file itself. So I can type in dinky.cs, and yep, that does show the file. Press enter, and yep, here I am in the dinky file. And again, press Control Home to get to the beginning. Yep, here's the dinky definition, and I can see all this code just like this. So if I want to move to like the tutorial manager, so I just write tutorial manager, just write a little bit, and yep, I can already see this one. So this is the class. We can also see the icon over there. So that one means a field, that one means a class, this one means an event, and so on. So I can see this one, press enter, and yep, here I am in this one. And again, move up, move down, everything works. Again, note how throughout all of this, my fingers never leave the keyboard, I never touch a mouse. So personally, whenever I'm making my games and I want to open another class, I never go into Unity and manually double click on that file. I always do it over here. Press Control, comma, search for anything, press enter, and it opens. Or alternatively, for example, that one that I mentioned, when you got tons of references, something like over here, tons of references to a dinky. So I can just go into this one, and then I can put the cursor on top of the type itself, and I press on F12, and yep, this one takes me to the class definition. F12 is a shortcut, but if you want to use the mouse, you can also just right click on it, and over here we can see, yep, F12 is indeed a shortcut to go to definition. Now, since we're here with the mouse, one really useful one is over here, the find all references. When you click on this is going to show all of the references to that type. So this can work with whatever is under the cursor. So in this case, I select the dinky class. So this is going to show me all of the places in my entire code base where the dinky class is being used. Or alternatively, you can put it just on a field. And yep, now this one is going to show all the places, and you can click in order to automatically go to that line. And of course, it also works with functions. So for example, over here, this function, I'm pressing Control Shift up and down in order to see all the references within this file, but this function is not called from within this file. So in order to find where on earth am I calling this, again, right click, go to references, and yep, I can see, okay, so it's being called from this script right here. Inside the dinky manager, it's calling this function. Another really useful use case for that particular one is when working with interface. So let's say I want to see all the classes that implement this interface. Again, right click, find all references, and yep, I can see all of these. Look at these. These are all implementing the IInteractable interface. Then something that I use all the time is Control-RR. That is the shortcut for renaming the current symbol. So I just place the cursor, for example, over here on top of the isMoving field, press Control-RR, and now let's say I want this to be a little bit more descriptive, so is player moving. So I change that, and note how, again, the other shortcut, Control Shift and up and down, note how this one did rename every single reference of this symbol. So all of those, I don't need to change them, just modify them once, use the rename feature, and automatically renames all of them. And if I find out that the previous one works better, again, just edit, go ahead, remove this, press enter, and yep, there you go, all of those have now been renamed. Remember that refactoring isn't extremely important, and importantly, it's a perfectly normal part of the process. In fact, the next lecture is entirely dedicated to the topic of refactoring. If there is something that you wrote some name, but then later on you think it should have a better name, just take some time in order to rename it. Simply place the cursor over it, press Control-RR, write the new name, and it will automatically rename every instance of that symbol. This works on everything from simple variables to even entire classes, and it even renames every single reference in your entire codebase. So for example, here I am on the dinky class, which is used throughout the entirety of this codebase. I can press Control-RR, and I can modify this whole thing and say something, and yep, like it says here, rename will update 297 references in 58 files. So this rename feature is really awesome, really useful. It automatically handles modifying everything, and everything is handled automatically for you. Then when you have multiple windows open, for moving between them, you can use Control-Tab. If you just use one, it goes back and forth between the last open tab. So this is something that I use all the time whenever I'm working between two files and I want to quickly move between them. But instead of doing just that and letting go, you can hold down Control and Tab, and as long as you hold down Control, you can see this window, and over here you can move up or down in order to move between all the various windows that you have open. So for example, let's say I want to go into the dinky off world. Yep, there you go. Now I'm looking at this class, and if I quickly Control Tab, I go back into the previous class. And this tab over here, this one only works for the windows that are open. So again, the same thing. If you want to open up a new window, just press Control, open the window. Let's say, for example, I want to find the carry vehicle. So I just type in the carry vehicle. Yep, it's right here. Control Enter. And this one opens up the carry vehicle class. Now Control Tab. And if I want, I go back to the dinky and move between them like that. Then here's a really simple one. You can raise an entire line by just having the cursor anywhere on that line and pressing Control X. That one cuts the entire line. That one acts as a cut, meaning if you press Control V, you get the line back. Alternatively, for duplicating, you can press Ctrl D. Although honestly, I rarely ever use this one because I can never remember whether it's going to duplicate on the line above or below it. So usually if I want to duplicate something, I just do the shortcuts that I mentioned a while ago. So and, above, and, cut, move, cut, and so on. Now speaking of copy paste, if you press Ctrl, Shift, and V, if you do that, you get a list of your clipboard history. So for example, a while ago I showed cutting the await class, and yep, it is still saved in here. So if I press on enter, yep, it pastes that one exactly like that. So remember that your clipboard has history. It is not just the last thing that you copied. You can access the entire history. Another useful tiny time saver is actually when using the mouse. When using that, if you want to select some kind of word, some kind of symbol, obviously you can do the basic thing, which is just click and hold and drag throughout to select it. So obviously that works, but it's a little bit fiddly. If you move up or down, it can be quite tricky. So the similar shortcut for that, whenever you want to select some kind of word, you can just double click and it selects it, or alternatively hold down Control and click in order to select the entire thing. This can be quite useful, for example, when you have some copy pasted code and you want to change some kind of name, but for some reason the rename function doesn't work. Like for example, let's say I want to duplicate this code over here. So right now I cannot use the rename because this one is going to conflict with that one. So instead, let's say the active dinky list. So I select this one, Control click, and there you go, like that. And if I want, like that. So Control click in order to do Control V and so on. This one can be quite useful sometimes. Then something that I only very rarely use is Shift and Alt. Hold those and then move up or down. And this one basically lets you select multiple lines of code and edit them at the same time. Like I said, I rarely use this, but sometimes can be useful, for example, for quickly appending or removing some kind of prefix. Like for example, on this enum, I've got these values. I want to write all of them and say tier 1, tier 2, and so on. So I can select all lines and write tier and writes on all of them. Or alternatively, if this one did have it and I want to remove them, just select them all and I can remove them. So basically you can write code on multiple lines at the same time. And if you want to quit this, just press escape and yep, back into a single cursor. Another super useful one is when working with events, like for example, the on any dinky started starving. So I can just write the event name, then plus equals, and then here Visual Studio automatically has a shortcut, so you can press tab to insert. Then if you want, you can rename it, but usually I keep the exact same name that it suggests. So just press enter, and yep, there you go. I've got a new event. Now I can come here and again use the shortcut Control X to get rid of that. Go above, go to the end, press enter, go to new line, then write some new code. So really useful, and if afterwards you decide that you want a better name for this event, again remember just a quick Control RR in order to rename it. Then if you want to find something, of course you have Control F. For example, finding when I'm invoking some kind of event, so just write invoke, and if it finds it, obviously normal. Then the shortcut for going to the next element, that one is pressing on F3, and it goes to the next one, so it finds that one, that one, that one, and so on. In order to go to the previous one, you use Shift F3 and it goes backwards. Also, by the way, this works whether the Control F window is open over there, but if I press on ESC in order to close down that window, and with this, if I press on F3, yep, it still remembers the last thing that I searched. Then for quickly commenting or uncommenting something, you can do Control KC, and yep, it automatically comments that entire line. And if you have multiple lines selected, Control KC, and yep, automatically comments. And the opposite to uncomment is Control KU, and yep, automatically uncomments that. Although personally, I never really use this one myself. Again, it goes back to how I'm so proficient at just moving the cursor. So if I just want to comment all of these, I just do the comment star, go down there, comment star, there you go, just like this. Another useful shortcut is extract method. So you can select a whole bunch of code, then press Control R and M, and this one creates a new method with that code. So let's say setup, and if there you go, it pretty much took that code and placed it in its own method. So this can sometimes be useful. Although again, this is another one that I don't really use myself because again, I'm pretty fast at just moving the cursor. So if I want to do this kind of thing, I really just go into the code that I want. I just go, I move the cursor, move up, move down, then do private void my setup, do some kind of function, then write it just like this, and everything works. If you want to go to a certain line, you can press Control and G. This one lets you input some kind of line number. So let's see, what is that line 500? So just type in 500, and yep, there you go. Here we are on line 500. Now for this one, normally I don't really use it when writing code, but I do use this one quite a lot when writing the text script for my courses. Since normally I write my course in a simple text file, sometimes it has tens of thousands of lines, so for that usually I like to move around by using the line number. Although in the code I never really have such massive files, so I don't normally tend to use it, but it's still a nice thing to know. Then of course the one that you already know, if you make some kind of mistake, Control Z in order to undo, and one you might not know is Control Shift Z in order to redo. Then for moving between Visual Studio and Unity, just a simple Alt Tab, so just once and moves, or if you have multiple files, just keep pressing Tab. And perhaps the simplest and most useful one is simply autocomplete. I really advise you to get comfortable with how autocomplete works. Learn how to just type a few lectures, and then either press enter or dot or semicolon in order to quickly autocomplete. Honestly, I don't remember the last time that I wrote something like, for example, try get component. I just try a little bit and write like that. For example, dinky, just like this, then out, dinky, just like this, super simple. So just get used with how little you have to write in order to press enter in order to automatically write everything else. This works with fields, but obviously it also works with things like functions, it works with classes, it works with literally anything. Okay, so that was a lot of shortcuts. Personally, I use a lot of these all the time, but again, I've been writing code for over 25 years. If you're not used to using shortcuts, then I really don't expect you to suddenly use all of these right away all at once. Like I said, this one is really not meant to be a step-by-step lecture. For the most part right now, I just want you to memorize the first ones that I mentioned about how to move through the cursor quickly. Just memorize those and simply remember that the other ones exist. Then periodically come back to this lecture every once in a while and watch it again. If you do that several times over the next few months, then soon enough, all of these shortcuts that I mentioned, all of these will be natural to you just like they are to me. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about refactoring. Okay, so before we learn some more programming syntax, let's cover some very important theory. One of the types of comments that I get most often is basically beginners asking me, how do I memorize all the code and write everything perfectly the first time? And the simple answer is I don't. What you see in a video like this course, what you see is really after I've done tons of research and written, and most importantly, rewritten a ton of code. This is one of the crucial things that separates beginners from intermediates. Beginners think that when the code is written, that's it, it's written forever and will never change, so you have to get it right on the first time. Whereas intermediate programmers, they know that code is a semi-living thing that is constantly changing as your game or your program changes and progresses. Refactoring, which is the term for rewriting code or simply reorganizing it, that one is a perfectly natural part of the process. A very simple process is simply when you first try to build some kind of system, like for example making a health system, at first your primary goal should be simply to get it working. You should obviously try to write some good clean code, but it's nearly impossible to get it perfectly on the first try, so the first goal is just get it working. And now here's the really important step that separates beginners from intermediates. After you get the system working, then look at it, analyze the code, and see if it could be written in a better way. Perhaps there's some variables that could have a better name. Perhaps there are some functions that are clearly doing too many things and should be split into multiple smaller functions. Perhaps you have a whole bunch of data separated that should make more sense being placed in its own custom class. So the first step is indeed just get it working, but then don't forget the second step. That one is how to get it working properly. Remember that your code is a living thing. You won't continue living and working with that code, especially as you start to make bigger and more complex projects. So since you're going to use and reuse that code in the future, make sure you write it properly. It is perfectly okay to write semi-dirty code on the first time. What is not okay is to leave it dirty. So when it is working, take some time to do some refactoring if needed. So if you are a beginner about to transition into the intermediate stage, I want you to truly learn and fully internalize this. It is perfectly fine. In fact, it's essential to rewrite code. You are not expected to write everything perfect on the first try, but you are expected to constantly be thinking about how the code could be improved, and if you do find some possible improvement, take some time and refactor that code. Always keep that in mind, especially as we go through this intermediate section, which naturally will increase in complexity compared to the beginner section. So keep that in mind, and let's go to the next lecture and learn about enums. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn one super useful feature of C#, which are enums. These allow you to define an enumeration with a set of named constants. It's really useful in so many scenarios. Okay, so enums are really great. Like for example, look at this code, this function over here, get next player action. This is supposed to be something like a turn-based strategy game. So the player has this function and uses this in order to calculate what is the next player action, then does a whole bunch of tests to find out what is the next valid action, and doing so it returns an int, which is going to be some kind of code for whatever action the player should be taking. So for example, the player checks if it has no enemy. If so, then it returns 0, so 0 means no enemy. Then checks if there's no path to the enemy. If so, returns 1, so 1 means no path to enemy. Then checks within attack distance, so 2 means moving towards enemy, or 3 means attacking the enemy. Now, the big problem that is immediately apparent in this code is that returning an int value, that one is really not very intuitive. Int is really supposed to be a number, so matching an int to some kind of behavior, that seems quite strange. Just like this, you have to memorize that 0 means no enemy, 1 means no path, and so on. So numbers really are not the best type to use here, and instead this is one of the many scenarios where enums are really excellent. So first we define an enum, and the way we do that is we just type in enum, then the name of the enum, so for example let's say player action, and then open and close the curly braces. And now here we just define a set of names for our various enum states. So for example in this case we want one to represent no enemy, we want one to say no path to enemy, and we separate them with a comma, and one moving toward enemy, and finally attacking enemy. Alright, yep, just like this. So now we have defined an enum, which inside can have 4 of these possible values. By the way, the enum, just like classes, just like types, just like anything, also can have an access modifier. So again, the same rule: if you don't need it to access from anywhere, make it private. If you do need to access it from somewhere, make it public. Okay, so like this, we have defined our enum. Now we can refactor this code in order to make it much more understandable. So for example, instead of returning an int, let's return of type player action. Then over here, instead of returning a number, we just return player action dot, in this case, no enemy. So instead of having this, we just have this. And yep, right away, this makes a lot more sense. So let's apply the same thing to all of these. So this one is the no path to enemy, and this one is going to be the moving toward enemy. And finally, we have the attacking enemy. And yep, just like this. So now we don't need those comments to explain what the number is supposed to mean. Just looking at the actual value itself, just like this, we can understand what exactly this is meant to be doing. So enums really are this simple. We just define the values for our enum and then use it in any way we want. By the way, here we are returning an enum, but an enum is really just a type. So we can do anything we want with it. Like for example, we can make it a return type for a function, or we can just make a variable of type player action, and we can set it to one of the values in our enum. We can use it as a parameter. We can use it on pretty much anything we want. Anything we can also use any other type in. Then another very common use case for enums is doing something like a state machine. So for example, let's define a private enum for the state. And on this state, let's say we have the state looking for enemy. Then we have moving to enemy, and finally attacking enemy. So these are our various possible states. And then we have some kind of function to handle the state. So this is going to handle our state machine. And over here, we just do a switch and do a switch on our state. So we would have some kind of state variable holding the current state for this unit. And then we do a switch on that state and do case something. So case, for example, moving to enemy. Then we have the moving to enemy logic. Afterwards, we do a break. Then we do all the other cases. So looking for the enemy and so on. So yep, this is a really simple state machine, and you can see how by using an actual enum for the state, that makes it much easier to understand as opposed to if we had the state being some kind of int. And over here, instead of these, we would have just 0, 1, and 2, and we would have to memorize what these numbers mean. So just looking at this, it is very clear just how good enums are. With numbers, it becomes really messy, but if we apply some enums, everything looks really understandable. Now, enums also have an interesting property, which is on the back end, these values are actually stored as ints. So to run some testing code, over here I'm writing some code in the Unity project. So let's just do a private void start, which is going to run this function automatically. So now over here, for example, let's define a player action, just a field of player action, and let's set it to something. For example, let's say no enemy, which is the first one that we defined. So we define this, and now let's do a debug.log on this player action. And if we do this, and up here in the console, we can see it pretty much print out a string of the state, so no enemy. However, like I said on the back end, these values are actually stored as ints. So if we cast this down into an int, let's see what this one says. And yep, the int is going to be 0. However, instead of printing out the int for no enemy, let's say the one for no path to enemy. So this is the second state that we defined. And yep, this one now prints 1. So the order is based on how you define them. So the first one is going to be on essentially index 0, then 1, 2, 3, and so on. And you can also do the opposite. So we can, for example, let's cast onto a player action, and let's cast, for example, the number 2. And if casting the number 2 onto our enum does return moving toward enemy. So due to this property, due to how enums really are stored as ints in the backend, because of this, there are some interesting things you can do with it. For example, another common use case for enums is when making some kind of game tutorial with various stages. So you'd have an enum for the tutorial stage, then have like stage 1, which is like player teaching the movement controls, and stage 2, stage 3, and so on. So you'd have this kind of thing, and then you would define some kind of variable to store the current tutorial stage. So let's say we're starting off on stage 1, and then we can just do tutorial stage ++, and let's do a log on this one. So we're defining it as stage 1, then we're doing ++. Let's see what this one says. And if it says stage 2, so it went on to the next enum value. Then we could simply compare against the last value in the tutorial stage in order to know if we've reached the end. Alternatively, you can also handle the conversion back and forth using strings. So for example, a string for the tutorial stage string. And here let's grab the tutorial stage and call the usual toString function. So this is going to convert onto a string. And now if we take this and we try to cast it to tutorial stage, if we do it, then nope, this does not work. This is an error. We cannot automatically convert a string into our enum. So if you want to do this, the correct way to do it is go inside the enum class. This one exists inside system. So you go inside of this one, And then there's a parse or a try parse. So the only difference is this one returns a bool whether the parse succeeded or not, whereas this one assumes it always succeeds. And you can see these also have versions with these angled brackets. These are generics, which I'm going to cover in more detail later on in this intermediate section. So for example, since we know that the code perfectly matches the tutorial stage, let's just do a parse. We're going to parse onto the type of tutorial stage, and we're going to parse this string. Okay, so if we see this, we should be able to see the usual stage 2, because we got stage 1, we increase it, convert it into a string, and then from a string back into our enum. And yep, there it is, correct. Then yet another thing you can do with enums is simply cycle through all the possible values. And for that, we can do, for example, a for each inside the tutorial stage. Let's cycle through all the tutorial stages. Then in. And now here you can't do, for example, tutorial stage.count.something. No, that doesn't happen. That doesn't work. So instead, in order to get all the values, you go again inside the enum class. And for this one, you can pass in get values. And this one takes in a type. So here to get a type, we want to type tutorial stage. But just like this, nope, this does not work. In order to get the actual type object, for that, we use the keyword typeof and pass in our tutorial stage. So yep, like this it works. So debug.log on this one. And this should print out all of our possible elements inside our enum. So let's just print something just separate from the other logs. Let's see. And if there it is, stage 1, 2, 3, and 4. Alright, so those are enums. Really useful in so many scenarios. They are really easy to use and help you make your code a lot more readable and understandable. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about properties in C#. These are kind of a mix between a variable and a function, so you can store some data and run some logic. Okay, so properties, these are actually pretty simple to define. So we define them pretty much like a normal variable. So we've got the access modifier, so let's make it private. Then we have the type, let's say of type string. Then we give it some name. And the usual naming rule is for properties to use Pascal case, meaning uppercase on the first letter. So for example, player name. And then if we just put a semicolon, if we just do this, then this is a normal variable. It's not a property. In order to make it a property, instead of this, we open and close a code block. And now here we add two pieces of logic. One is called get, so let's do get and then a semicolon. And then the other one is called set, so let's set and then a semicolon. And if that's it, this is a super simple property. And in order to use it over here in our static main function, let's just define this one as static. So then down here in our main, we can use it just like as if it were a regular variable. So we can go inside the player name and we can set it to something like code monkey. So let's do this and then do a console.writeLine and let's print out the player name. Okay, let's see. And if there it is, and it does print out the name, so pretty much the same as a regular variable. However, in reality, this is not a variable. In reality, the C# compiler is doing a little bit of magic in the background. Properties are really not variables. They don't actually store any data directly. So what we have defined here is what is called an auto-implemented property. In the background, the C# compiler is generating a hidden variable that does store data for this property. So we can also just manually do exactly that. So let's do a private static string for the player name. And again, since this one is a variable, we're going to use camel case. And then let's use it over here on the property. So inside this code block for this get and this set, we can actually expand upon it. So for the get, let's add a code block inside it. And over here, let's return our backup field. So let's just return the player name, the underlying one, okay. And then for the set, again, same thing. Let's add a code block. And for this one, we want to set the player name. So player name equals, and then we use the keyword value. So this is basically going to be whatever value we assign to the player name. So when we run this line of code, it is going to run this sort of mini function and it's going to assign the value to whatever we assign here, which in turn is going to assign it onto the underlying value. Okay, so if we test like this, and if everything still works the same, it still prints out code monkey. So what we have over here is literally exactly the same as we had previously. The C# compiler simply builds all of this automatically in the background whenever we do a property where we have just a get and just a set, and we do not define any of these code blocks. Now here, the get and the set, these are pretty much functions, which means you can write pretty much any code here. For example, we can do some validation. So over here on the get function, for example, let's test if the underlying player name equals null. So if it hasn't been set, if so, then we can return some kind of default, so unknown. If we do it like this and we erase the setting, so we just have the player name uninitialized, and if there it is, now it does print out unknown. So we basically added some extra logic onto our get function. And when setting, same thing, we can also validate the value. For example, let's say this player cannot be named code monkey. So we can test if the value equals, for example, code monkey. If so, then either we can set the value to some default value, or for example, we can throw a new exception, cannot name player code monkey. By the way, I'm going to cover exceptions in detail in a future lecture. This is pretty much just an error message. So if down here we can try to set the player name equals code monkey. If we try doing this, And if there it is, right away we see an exception, because again, it is running our validation code, and our validation code does not let us rename this. So usually this is the goal of properties, which is how you can do some validation for processing either the get or the set function. And one extremely useful thing you can do with properties is simply make different access modifiers for each of these. Now, right now, we made the player name, we made this one private, which means that both of these are going to be set to private. And if instead we make this public, if so, then now both these are public, meaning any class in our codebase can access either the get or the set. However, you can also add different accessors here. For example, we can leave the get like this in order for anyone to access it, and we can make the set as private. That means that this class can now access and set the value over here on the player name, but other classes can only use the get. So yep, here we do see an error. So I created a completely separate class named player, and inside I'm trying to access the player name and modify it. Nope, I cannot use it because the set accessor is inaccessible. However, if I do a console.writeLine on this one, if I do it, then yep, this is perfectly valid code. So this property can now be accessed. We can access the get from any class anywhere in our codebase, but only this class can access the set. So right now you might be wondering, okay, so is this really all the same as just making a field with some get and set functions? And yeah, pretty much it is. If we were to make a private static void set player name and receive a string for the player name, if we do this and set the player name, and then we have a private static string for the get player name, and over here we return our player name. So if we have this code and then up here, let's say we don't want any of this validation, so we just have the basic auto implement property, so just get and a set. So yep, just like this, the property that we defined up here, it is doing pretty much exactly the same thing as what we have down here. We have a field with set and get functions, and that's pretty much the same thing that we have here. So these two pieces of code, these are pretty much identical. Now, I have to say that personally, I'm not a big fan of properties, simply because I do not like how they look like variables but act like functions. Personally, I find that needlessly confusing. If I want to store some data, I want to use a variable, and if I want to use some logic, I want to use a function. Combining both in a strange way, to me, just seems really odd. It seems needlessly confusing, but that's really just me, that's just personal preference. A lot of people really like using properties. In fact, the official C# documentation is full of properties. So while personally I don't like them and don't normally use them, it's not because they're bad, it's really just personal preference. So if you do like them, feel free to use them in your projects. For me, the only place where I use properties is when I use the Singleton Pattern. I'm going to cover that in detail later on in the course, but over here, let me just quickly show you how the property helps implement that pattern. Usually in that pattern, you want some field to store the singleton reference, but importantly, you want only the singleton class to be able to set that field while anyone else can get it. So the property accessors are really useful for that. So usually for that, you make a public, make it static for the singleton pattern, make it of the type that you are making the singleton, so for example the program type, then you usually call it instance, and then we have a get and a private set. So yep, this way the access is exactly as intended by that pattern. We have a public property with a public get and a private set, meaning this one can only be set inside of this class, but any other class can get it. Like I said, I cover singletons in detail in a future lecture, but I just want to show that this is pretty much the only scenario where I use properties. For anything else, I normally just make a regular field, and if I need to, I make get or set variables if I need to modify. But again, it's all personal preference, so if you like properties, then go ahead and use them. Okay, so that's properties. They are a really interesting mix between a variable and a function, allowing you to handle stored data and process it in some way when getting and setting. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about multidimensional arrays. Okay, so in the basic section, we already learned about arrays. This is how we can store multiple pieces of data in just one variable. We've got essentially multiple containers at each different index. So now we can just go one step further and essentially make multiple dimensions of these arrays. For example, we can make it have 2 dimensions, so it has 2 axes. And then each position, instead of having just 1 coordinate, it actually has 2. So for example, on this array, we can go into position 0, 0 and place some kind of number. Or we can go into position 2, 3 and place some kind of number. Go into 4, 1 and draw something, and so on. So each of these positions works exactly the same as the elements in a regular array. They can be set or you can get their value. And this is an example of a 2D array. So you've got a certain axis and another axis. But you can have as many dimensions as you want. You can have a 3D array, 4D array, 5D, 6D, or literally anything you want. However, this is also just one type of multidimensional array. There are multiple types and multiple ways to build them. So this is the syntax for building a regular one-dimensional array. So int, then the square brackets, int array, then create an array with some kind of size. And one way to make a multidimensional array is to make an array with multiple dimensions. So to do that, here when we define an array, we include a comma for the dimensions. So in this case, we have 2 dimensions, so one on the left side, one on the right side. Technically, there's no limit, so you can add as many dimensions as you want. So here, let's do a simple 2D array. So we do that, and then afterwards, we just include the size for both dimensions. And yep, like this, we have a two-dimensional array. On the first dimension, it has a size of 5, and on the second one, it has a size of 6. This creates the array, and then in order to modify a certain index, we can just access it with the coordinates. So go inside the int array, and now on a flat array, you would just put an index, but this one is multidimensional, has 2 dimensions, so we need to put the index for both dimensions. So for example, 0, 2, and yep, this will access the element inside the array on position 0, 2. You can use this to read the value or assign it to something else. Then when it comes to arrays, you will eventually want to cycle through them. And normally you would do some kind of for, so for int I equals 0, I less than the int array.length, do this plus plus. So normally this is how you would cycle through an array. However, now with a two-dimensional array, if we do this, then this one, this int array.length, this one is going to return the total length. So in this case, it is going to return essentially 5 times 6. So we can do a console.writeLine to see. So the int array.length, and if there it is, the result is indeed 30, which is 5 times 6. So that's the total size of the array. When we have a multi-dimensional array, in order to get the length of a single dimension, for that we can access the function getLength. This one, as you can see, takes a parameter for the dimension. So let's first cycle through all the elements in the first dimension, and then inside we can do another for loop. By the way, I'm going to cover nested loops in detail in the next lecture. But yep, just like this is going to cycle through every element in the entire array. It will cycle through the first dimension, then the second dimension in order to go through every single element. We can do a console.writeLine and print out the int array on position I and j. This will print out the value stored in that coordinate. Let's also just print out the I, then comma, then the j, then something, so we can see what we're seeing. Okay, let's see. And if there it is, we can see it all working. So first checks position 0, 0, then 0, 1, 0, 2, and so on, until it gets to 1, 0, so on and so on. And all the values are just 0 because we just initialized all with 0. But as you can see, this is indeed cycling through the entire array, through both dimensions of our multidimensional array. Alternatively, for initializing the array contents, we can do this. Note the difference between this syntax and the syntax with just one dimension. So here we have some curly braces, and then inside we have multiple pieces of curly braces, one for each of the second dimension of the actual array. And up here we can see the array being initialized, so in 0, 0 has 1, 2, 3, then on 1, 0 it has like that. One crucial important thing about these kinds of arrays and initializing it like this, the shape needs to match. So on the first one, if we initialize this with 4 elements, then the second one also needs to have 4 elements. In order to have multi-dimensional arrays with differently sized elements, for that we can use jagged arrays, which I'm going to cover in a little bit. But before we get to that, like I said, there are multiple ways of doing multi-dimensional arrays. This is just one way where you have a single array with multiple dimensions, and the other common alternative is simply to have an array of arrays. So instead of int and square brackets and having a common, we have int and then square brackets, open, close, and then open and close again. This is basically creating a new array of arrays. Then we can do the usual cycle through it. So for int I equals 0, less than array.length. Here we can use length because again, this is not a multidimensional array. It is an array of arrays, meaning it's an array, and inside each position, each element itself is going to be an array of multiple elements. So we can do this, I++, and we can go int array on this index, and inside it, we create a new int array of whatever length we want, like for example 6. So basically what we have here is what we had previously when we had a multidimensional array with 5 and then 6 on the other dimension. And then for accessing this one, we access it by int array, then access the first dimension, like say on position 0, and then the second dimension, let's say on position 2. So yep, this is how you set or read some elements from an array of arrays. So this is also a valid way of storing multiple dimensions. Instead of having just one array with multiple dimensions, you have multiple arrays of arrays. And of course, the same thing that I said a while ago about having no limit to how many dimensions you can have, that still applies here. So you can have as many arrays of arrays as you want. So this code looks pretty insane, but yep, this is perfectly valid code. One crucial difference about these two types is basically the defaults that they will use. For example, down here, when we create an int array with multiple dimensions, when we do this, by default, all the elements inside of this array won't be on 0. So yep, like we see, all the elements default to 0. Whereas on this one, since this is an array of arrays, if we just cycle through the main array, if we try to access this one, so let's do a console.writeLine on this one. So let's print out the array on this index. Let's do that and see what this prints out to see basically what each element of this array defaults to. And if there it is, the answer is essentially null. We can compare this equals null. And if there it is true, so all of these elements are set to null. So that is one big difference between array of arrays and multidimensional arrays. These get initialized with every value at 0 on whatever type you're using for the array. Whereas this one, since each element inside of the main array, since each of those is actually an object, it's actually an array of something else. Because of that, by default, the default value for some kind of array is going to be null because arrays are reference types as opposed to value types. which by the way, I cover value and reference types, what those are, I cover those in detail in a future video. And then another difference between these two types. One thing that you can have with array of arrays, but you cannot have with a multidimensional array, one of those things is what is called a jagged array, meaning each subarray can have a different size. Down here when we define this multidimensional array, by default the shape of this array of multiple dimensions, the shape will pretty much be a rectangular size. So over here 5 in one dimension and 6 on another one. It will always have some kind of rectangular shape. However, in an array of arrays that does not have to be the case. For example, when initializing this, we can set the one on index 0 to be a new int array, and let's say this one has a size of 3. Then on the next one, on element index 1, we can say this one has a size of 6. Then on index 2, we can say this one has 10, and so on. So using an array of arrays, technically each array inside the main array, each of those can have whatever size you want. As for what use case this would have, for example, imagine some kind of grid for a theater. When you go to the movies and select a seat, usually different rows have different number of seats. So that's an example where this kind of data structure could be useful. You would have maybe 3 seats on the first row, then 6 on the second one, and so on. So that could work. It does have some use case. Although personally, I pretty much never use them, since in games, usually things have some kind of rectangular shape. Things like an inventory or a world, usually those have some kind of rectangular shape as opposed to some weird jagged shape. Now, when working with multidimensional arrays, we need to cycle through them just like we saw. So let's learn about nested loops in detail in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about nested loops. Okay, so let's see what they are. They are really simply just a loop within another loop. So for example, let's do a for loop for int I equals 0, let's say less than 3, I plus plus, so a regular for loop. And then inside it, we can write another for loop. Let's say int j equals 0, j less than 2, j plus plus. And by the way, usually the convention for these iterator variables, usually use the variable I, then you use j, then if you need more, you need k, l, m, n, and so on. That's usually the standard convention. But it's not a requirement, it's really just a convention. So these can be named whatever you want, but in general, I and j are very commonly used. So over here, let's do this. Let's do a loop inside another loop. And now let's print out the I and j to see exactly how this code is running. So let's print out I, then a little comma, and then j. Okay, let's see. And if there it is, so we start off with an I of 0 and a j of 0. And then we have an I of still 0, but then a j of 1, meaning that for each time this loop is running, this one is going to run as many times as this loop is meant to run. So it goes inside this, runs this line. Then when this one ends, goes back into this for loop and runs this line again. Then this one reaches the end, so that is why this one ends and again goes back into this one, which again runs this loop starting from the beginning and runs more and more and so on. So here it is running 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, and 2, 1. The important thing to remember here is the code execution order, meaning for every time the outer loop runs, the inner loop is going to run multiple times, 2 times in this case. Also remember what we covered in the basic section about variable scope. If you define some kind of variable inside this inner loop, like a int age equals 5, if we do this, and down here you try to access the age, nope, that does not work. If you define something inside the scope of this inner loop, it does not exist outside of it. And here we have one nested loop, but technically we can have as many as we want. Again, the same logic. For every time that this loop runs, any loop inside of it will run as many times as those run. As you can imagine, if you do a ton of loops within other loops, if you do that, it becomes really hard to understand the logic the deeper you go. So usually just having one nested loop, in most cases that is the most you should do. Then we already saw these briefly being used in the last lecture covering multidimensional arrays. That's a very common use case. So here it is, that same code. So we've got the outer loop going through the first dimension, and then we got the second inner loop. That one is going through the second dimension. And by doing this, this is going to cycle through every element inside of this multidimensional array. Then on loops, there are 2 important keywords. One is called break, and this one breaks out of the innermost loop. So for example, if we don't include the break, let's see how many times this prints with the value on j. And if there you go, the value on j goes from 0 to 1, 0, 1, and so on. But if we add a break over here, and if there it is, now the j only goes to 0 and immediately breaks out of that inner loop. Now the important thing to note here about break is how it only applies to the innermost loop. So this one does not break out of the outer loop. As you can see, the outer loop still runs 0, 1, 2, and so on. So break only affects the innermost loop. If you do want to break out of the outermost loop, if so, you can define some kind of bool, break from loop. You set it to something like false. Then inside this one, you do some kind of logic that would eventually set this one to true. And then down here, you would test that. And if so, then call break. And let's see. And yep, now this one does go inside. As soon as it goes inside, sets that break to true and breaks from that one. So breaks from the inner loop, and once this one is true, it also breaks from the outer loop. Now the other important keyword is continue. This one continues or pretty much skips to the next iteration of the loop. So if we write some kind of code after this continue, so let's do a right line and write something like this. Even Visual Studio is telling us, so this line is slightly faded because it will never run, so unreachable code detected. That is because as soon as the code gets to this continue, it is going to ignore everything afterwards inside this loop and go to the next iteration of this loop. So if we run this, and if there it is, it runs through every single element, so the j is always 0, 1, 0, 1, and so on. But note how our second message, this one did not ever show up. If we were to put this inside some kind of if, let's say if I equals 0, then continue. So basically on the first I, when the I is 0, then it should not print this message, but on the other ones it should. And if there it is, so whilst on 0, it is going to continue and ignore this line, but on the others, it is going to run this line. And again, same thing as previously, note how this one only applies to the innermost loop. Even when we're running our continuous over here on I of 0, note that the I still runs all of them, so 0, 1, 2. So again, always remember that break and continue, those only affect the innermost loop. Now I should also say that break and continue are not specific to just nested loops. You can use these keywords with any loop, including just a single regular for loop or some kind of for each. For example, if we have some kind of player class, so for example, here's some simple code. So we've got a basic player class, then we create a list of type player, then we create a new special player, we add that special player onto the list, and then 3 random players. Then we do a for each inside of that player list, cycling through every single one of them. And then we check if that one is a special player. If so, let's continue. If not, let's write in the name. So if you do this, we should be able to see the print of only 3 players and not the special player, because that one will be skipped over here on the continue. And if there you go, exactly that, 3 players and no special player. Now also on the topic of nested loops, here we have a for inside another for, but you can list any loop of any type. So for example, over here we can have a for inside another for, and then inside both these fors we've got our for each, so this perfectly works. Or we could replace this with a while or a do while, so literally anything works. So as you can see, nested loops can be really useful, especially when cycling through multidimensional arrays. But if you go too deep, if you nest too much, it can negatively affect code readability. If that's the case, consider whether you really need to make that nested loop, and if so, perhaps consider making a function that in itself has a loop. Then within some kind of outer loop, you just call that function. So just be aware that nested loops can become messy very quickly, so do be careful to use them properly and only when needed. Okay, now that we've learned some more advanced use cases for loops, we are ready to learn something that some people find quite complex, which is recursion, so let's learn that in the next lecture. Hi there! Are you enjoying the course so far? I hope you're learning a lot. Consider checking out the premium version of this course with tons of awesome bonuses. The companion project is really excellent for helping guide you in your learning journey. It contains frequently asked questions and fun quizzes to test your knowledge for every lecture in the course. And importantly, it contains interactive exercise, so you actually put into practice what you're learning. I designed those specifically so you can learn by doing. If you can afford it, then now would be a great time to pick up the premium version and basically go through all the lectures that you've already seen. And beyond that, it also has a bunch more bonuses, including simply having no YouTube ads to distract you in your learning journey. So if you're enjoying the course so far, then check it out. Also remember to like the video and subscribe if you haven't already. Alright, so let's keep learning. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about recursion, which is a different way of doing loops or just running logic multiple times. Okay, so recursion. This sounds like a really fancy word, but in terms of logic, it's really super simple. It really just means a function that calls itself. So for example, over here, let's make a function. So private static void, let's call it test recursion. So we have this function which does some kind of thing. And then inside this function, we call itself, and up here we call the first function. So yep, that's it. This is recursion. It's pretty much just a function which inside calls itself. Now, right away, you might be able to tell a big issue here. You can probably already tell that this is going to be an infinite loop, since this function will call itself for infinity. And actually, if we try to run this code, we actually get a fun piece of trivia. Yep, here we have an infinite loop that eventually ended, and it ended with this error, a Stack Overflow exception. And yep, this is where the famous website got its name. Basically, as you call functions, your CPU stores references to those functions in something called a call stack. That's a stack of all the functions that have been called in the current process. The CPU needs to know that so that it knows that when a function ends, where should it jump back to. But of course, memory has a limit, so if you call a function within a function way too many times, eventually you reach that maximum, which then causes the stack to loop back, which in turn is called a stack overflow. So with this code, we have an infinite loop, not very useful. But like we already saw in the last lecture and in the beginner section, loops can be extremely useful. And recursion is really just one type of loop. So with recursion, we can do literally anything we can do with normal loops. For example, let's write a while loop. Let's increase some kind of number one by one until 5. So here we have a simple while loop, so we define number of 0, and while the number is under 5, we just increment it. So that's it, pretty simple. Now let's do the exact same thing using recursion. So on this we have a function, and really since recursion is all about a function calling itself, all we really need to do is pass in our variable as our parameter. So we can just receive an int for the number, and inside do number plus plus. However, just like this it won't work, since like we saw on the lecture on scope and functions, function parameters are actually local variables. So when we call this function with this, we're working with a copy and not the original data. So to get some kind of result back from our function, let's simply set it as our return type. So let's return of type int. And then here we can do our logic and basically then do return number in order to return the final number. So now when do we want to return the final number? So now let's do the same condition that we had up there. So if number is under 5. So we do if number is under 5. If so, then we're going to call test recursion again, and we're going to return it with number plus 1. And in order to get the data back, let's call a return on this. And if not, if the number is above or equal to 5, if so, let's just return the regular number. So just like this. Let's just give this a proper name, so let's rename this to recursion incrementer. Then up here, let's call the same thing. And we're going to start off by calling it with number 0, and let's do a console.writeLine on this to see the result. So let's see the result on this one, and also a console.writeLine on the other number made with the regular while loop. Okay, so let's see if both of these do return 5, and if there it is, they both return 5. So we both have this logic that this one is going to run this logic multiple times, and this one is also going to run the same logic multiple times. So over here, as we call this the first time, number is going to be 0, and if number is under 5, if so, then this one is going to return the result of this function, and this function call will pass in the number, so 0 plus 1, pass in number 1. So once again, that is going to go inside this function, now with the number 1, which again, still under. So it is going to return another call of this function, which again, with the number 1 plus 1 equals 2, and so on. And as soon as it gets to 5, just returns the final number. So basically here we are stacking multiple function calls on top of one another. And when the final one returns, they all basically return and the call stack collapses and we end up with the final result. Then if we wanted, instead of having a hardcode maximum over here, we could have another one as a parameter. So an int for the number max. So we have that and we receive it here and we just pass it along the same way onto the next function call. And then we could also have a parameter for the incrementer, so increment amount. So we have this one, and instead of increasing by 1, we increase by the increment amount. So then over here, let's put it 5 and then 1. And over here, let's also pass in the incrementer amount. And yep, same result, 5, 5. And what we have built here is essentially the exact same logic as some kind of for loop. If you remember, the for loop has some kind of initializer iterator variable, then it has some kind of condition, usually some kind of maximum number, and it increments by a certain amount. So what we have here is literally the exact same thing as a for loop, except it's being handled with recursion. So all the logic you can do with any kind of loop, you can do with recursion. This is really just an interesting way to handle running logic multiple times by simply being very clever about how a function can call itself multiple times. Now, I should also say that personally, I'm not really much of a fan of recursion. In general, I find it needlessly confusing. I much prefer to have a simple for loop where I can very easily see the iterator and the end condition, as opposed to having to look at the parameters for a function and trying to guess when it will stop calling itself. So personally for me, I pretty much never use recursion. I always use just regular loops. I find those much more straightforward. But recursion is a valid option, so I definitely wanted to cover it, especially if you're into advanced mathematics. If so, then you might actually like it, since mathematics has a lot of this kind of stuff. If you like that, then perhaps for you recursion might be much more natural, much more intuitive than working with regular for loops. Just always be careful, the same issue with for loops, which is always be careful not to end up with infinite loops. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about one of the most useful collections, the dictionary. Okay, so dictionaries are a super useful data type for storing multiple pieces of data and doing so in a very organized way. Dictionaries are all about key-value pairs, meaning that the dictionary itself is a whole container. And inside that container, you store various keys, so like some key for stone, some wood, and some gold. And then for each key has a corresponding value, and then that value can have whatever that you want. Importantly is both the key and the value. Both these can be of whatever type you want. So for example, in some kind of game storing the resource amount, the resource type itself can be the key, and the amount that you're currently holding, that one can be the value. If you were to build something like that using an array or some kind of list, if so, then you would have to memorize it. For example, index 0, that one refers to wood, index 1 refers to stone, index 2 to gold, and so on. So you'd have to memorize what type each index belongs to. Whereas with dictionary, the key itself can be very descriptive about what value it stores. You can use a proper name or a proper object reference. That makes a lot more sense than keeping in mind what index belongs to what. Now to build a dictionary, this is actually super easy. We just type in dictionary, and then we open up the angle brackets. Now this syntax, these are generics, kind of like we use on the list. I'm going to cover generics in detail in a future lecture in this intermediate section. So we open the angle brackets, and then we have two types. The first one is going to be whatever type we want for our key. So for example, let's define an enum for that. So private enum for the resource type. So we have this, and then inside for the values, let's go with stone, then wood, then gold. Okay, those are the values for our resource type. And over here, we can use that resource type itself as our key. And then for the value type, let's say we just want to store the amount. So let's use a simple int. So let's name this resource type amount dictionary. And then we can simply construct it. So just new dictionary of this type. Okay, just like this. So this is going to create our dictionary, but so far it's going to be just empty. To add a key value pair, we go inside the resource type amount dictionary, inside our dictionary, and we call the add function. Over here, we need to pass in the key and the value. So let's pass in resource type, let's say stone, then for the value, let's say 56. So if this is going to add the key stone onto our dictionary, and it's going to link the value 56 with that stone. This is how we can add a value, and then for reading a value, we do it pretty much as if it were an array. So we use the square brackets, and inside here we put the type for our key. So in this case, our resource type dot stone. So if we do a console.writeLine on this one, let's see, and yep, it does print 56. Okay, great. Now one key point about dictionaries is that the key itself, this one must be unique. So if we try adding a value on the same stone key, if we try adding some kind of value, nope, right away we have an error. An item with the same key already has been added. So remember that each key must be unique. If you want to update the value, we can just access it, so as if it were an array, and then set it to something, and yep, this will work. Now when getting a value, if we try getting a value that does not exist, so if we try going to this on the resource type dot wood, if we try doing a console.writeLine on this one, yep, here we have another error, key not found exception. The given key was not present in the dictionary. So if you don't know whether a certain value exists, you have two options. First, you can just check to see if it contains that key. So access the dictionary and call contains key, then pass in the key. So this will return true or false if this key exists inside the dictionary or not. That's one approach, and the other one is to access the dictionary and call try get value. This one, like the name implies, tries to get some kind of value for some key. So the first parameter is going to be the key. So let's say resource type dot wood. And then the second parameter, this is the first time that we're seeing this. This one is not just an int value parameter, it is an out int. This means that it's an output parameter. This is a more advanced topic that I cover in detail in the advanced section. For now, just know that this is an output parameter. So this function is basically going to return bool, so it is going to return true or false. True if the dictionary has this key, and false if it does not. And if it does have, then it's going to output whatever it is in here. So let's define a variable for the wood amount. So if it does have wood, then it's going to store the amount on that one. So then we can see if this one does have this value. If so, then let's print out the wood amount. Except we didn't add, so this should not run. And if there it is, that doesn't run. But if over here, instead of assigning stone, let's assign it to wood. And if there it is, now it does run. Again, if you're not familiar with this output syntax, don't worry about it. I'm going to cover it in more detail in a later lecture. If you do use it, just know that it has this syntax. Also, like we saw, we can modify values. So we can go inside this, resource type.wood, and set it to something to modify it, so this works. But this also works for simply adding values. So instead of calling .add, you can just do it like this. And if it does work and does add that value. And of course, since we can add values, we can also remove them. So we can call remove and then pass in some type of key. So let's say resource.wood. So this should remove the key, so then this code should not run. And if there it is, doesn't run. So here we are creating a dictionary, and then afterwards on a separate line, we are assigning values. But like we have with arrays and classes and so on, we can also initialize the object directly when we create it. The way we do that is we open and close the curly braces. So the same as we do to initialize some kind of array or list. And then inside it, we put whatever elements we want to initialize inside this dictionary. But remember, dictionary is a key value pair. So we need to somehow define a key and a value pair over here. If we just do resource type.stone and then 10, if we just do this, nope, this is an error. The correct way to define a key value pair is with another pair of curly braces. So put this one inside open and close just like this. And then if we want to initialize more, we can just start with wood and something and so on. Now importantly here, pay close attention to the syntax. So we've got curly braces on the whole dictionary, and then again for each individual key value pair. Now one common thing you're going to do with dictionaries is simply cycling through them. For that we can just do a for each directly on our resource type dictionary. And for this one, the iterator variable will be a type key value pair. Simple like this, and then inside this one, we can access the key or the value. So let's do a console.writeLine, this one .key, then let's do a colon and key value.value. Let's get rid of this code and let's test. And if there it is, cycles through the entire dictionary and prints out stone and then the amount. Alternatively, instead of cycling through the dictionary itself, inside of here we've got a keys collection. And this is just basically going to scroll through every single one of the keys. So over here you would have just resource type. This would be the key, and then you could simply access and print out the resource type, and then go inside the dictionary on this type to see the amount. And if there it is, same result. So this is the other type for each. And also finally, you can also cycle through just the values. And on all of this, always remember that these are really just key value pairs, meaning it's up to you to define what value you want to use for the key and the value. It does not have to be just simple types like ints and enums. For example, the key can be some kind of player class, and the value can be some kind of weapon class. That would be perfectly fine. So just remember that it doesn't have to be just simple types. You can use whatever type you want for the key and the value. Now here's a bonus tip specific to Unity. Let's say you want to build some kind of resource manager, something like this. So you have a resource manager class, and inside you've got a dictionary of resource type and an int. But then you want it to be preset with some amount that you want to set in the editor. But the issue with dictionaries is that Unity does not serialize them. So even if we add serialized field private, even if we do this, here in the editor, nope, we do not see it. The resource manager has no fields. Nothing shows up in the editor. So instead, here's a neat trick you can do. You can create a custom class, and on that class, you basically use the key value pair. So here I've got a resource type and an int amount. Now importantly, we need to mark this type as serializable in order to show up in the editor. And if we do, and then we just make a list of this type, if so, then yep, this one does now show up over here in the editor. So we can set it to something, and then we have all of our elements of our custom type, so we can set all of them to whatever we want. So there it is, all the various values on the various keys. And then on this same script over here on the awake, we just create the dictionary. We cycle through the list that we exposed in the editor, and we just go inside the dictionary on that type and set it to that amount. Then we can just print out the concept of the dictionary, and up here in the console we can indeed see, yep, we did create the dictionary and we did initialize it with our data. Alright, so that's the dictionary. It's a super useful data type, really helpful when you have two pieces of data that can be connected like a key value pair. So this is absolutely essential in things like resource management or linking any kind of data together with one another. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about some other collection types like queues, stacks, and a bunch more. Okay, so in the beginner section we already learned about arrays and lists. Then in the last lecture we learned about dictionaries. Honestly, those are really the only collections that I normally use myself, but there's still a bunch more that can be useful in certain scenarios, so here let's see them. One simple one is called the stack. Think of it like a stack of papers. You can place papers on top, so you can push them. And for grabbing a paper, you can only grab the one that is on the top. In this case on the stack, grabbing simply means pop. So you can push and pop elements. This is what is called a first in, last out collection, or also known as FILO. Here in the code, the way we do it is super simple. We just create a new stack. This one takes a generic type, so similar to the list. So let's say a stack of strings. Let's call it name stack, and we construct it. And then on this one, we can call the function push in order to push values onto the stack. So let's push the string code monkey, then let's push the string for Iron Man, and let's push the one for Spider-Man. Okay, so with that, we push them. And now if we go into the stack and we call pop, this one is going to remove and return the object on top of the stack. So like I said, this is a FILO collection, meaning first in, last out. So ask yourself, what do you think this will return? This is the first element that is added, so technically this is going to be the last one out. So let's do a console.writeLine on this. Okay, let's see what this returns. And you're correct, this does return Spider-Man. Like I said, first in, last out. So we first put code monkey, so this means this is going to be the last element that we're going to grab. And when we pop, we're going to grab the one that we last put on there, which is going to be this one. And eventually, if we don't put up anything, so if we comment out all of this and we try doing a pop, yep, here we have an error, the stack is empty. So to avoid that, we can use try pop, which will try to get an element if it exists. And if you want to just look at the last element without removing it, we can call peek. Okay, so that's a stack. Another related collection is the queue. This one, the easiest way to visualize is some kind of queue of people. So the first person that gets added onto the queue is going to be the first one that gets out. So this one is a FIFO collection, first in, first out. The way we build it is pretty much the same as a stack, except this one is a queue. So then let's make a queue of string. So for the string queue, and let's construct it, so a new one and build it. Then on the string queue, in order to add elements, we call inQueue. So again, same thing, let's add in code monkey, then Iron Man, and finally Spider-Man. Okay, so we queue all of those, and now on the string queue, we call dequeue in order to grab the element. This one, again, like the pop that we saw previously, this one removes and returns the object. So if we do a console.writeLine on this one, again, queue is FIFO, first in, first out, so let's see what this one returns. And if this one returns CodeMonkey, which was the first element that we added. So some practical examples. A queue can be useful in something like a tycoon game, where you have literally a queue of people. Like for example in my own game, Battleground Tycoon, when there's a queue to join each arena. And for the stack, a great practical example is how this can be very useful for making some kind of undo system. So maybe something like a city builder. You can push onto the stack the action to place a building somewhere, and then to make an undo, you simply revert that action which would eventually demolish that building. Now importantly, you always want to do it based on the last building that was built and not the first one. So these two collections definitely have their own use cases. Although, like I said, normally I just use lists. I've built both these systems, like a queue for a tycoon game and an undo kind system. I've built both of these using just lists. Remember how on a list you can access the list on index 0 and call remove at to remove it from a certain index, so similar to a queue. Or you can also just access it, the last element on the index, the last element on the list, similar to a stack. So personally, I normally do all this custom logic using lists, but if you like, these two collections can be quite useful, so just remember they do exist. Next collection is what is called a hash set. This one allows you to store a set of elements. So let's make a hash set of string. So for the string hash set, let's construct it, then go in the string hash set. And this one we call add to add elements. So for example, add the element CodeMonkey. And yep, this one does work. However, one important thing about this type, the hash set, the important thing is that all elements have to be unique. So like this it works, but if I duplicate it, and now I do a console.writeLine, and let's print out the string hash set.count in order to count all the elements. So we're adding 2 elements and then counting it. So let's see what this returns. And if this one returns a 1, because again, we added a duplicate element, so it actually didn't actually add it. So you can add elements, you can remove elements, and you can also do a union to combine multiple hash sets. So the hash set can be useful for some kind of elements where you always want it to be unique. So maybe a player ID. So for those kinds of use cases, it can be a useful collection. The next one, we have the sorted list. This one, pretty simple. Like the name implies, this is the same as a regular list, but it gets sorted automatically. So you can make a sorted list of int. Another collection is a sorted set. So this one, pretty simple, same thing. It records a set of elements, and it is constantly maintained in a sorted order. Alternatively, you also have a sorted list. This one has a key value pair. Then you have the sorted dictionary and so on. So there's a bunch of collections that serve various purposes. Like I said, personally, I really just stick with arrays, lists, and dictionaries. I normally don't use any of these, but it is good to know that the language can do all these things by default. Maybe you have some use case for which the queue is perfect, so definitely make sure you know these collections exist. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the params keyword that we can use in a function, which then allows us to call it with any number of parameters. Okay, so let's make a function to see it. So let's make a private static void. Let's call it print player name and receive a string for the player name. Then over here, just a console.writeLine on the player name. So that's it, super simple, just a regular function like any other. And up here we can call it with CodeMonkey. And if it does work, it does print, great. But now let's say that I want to support 2 player names. I want both of them. I want support for both 1 player name and 2 player names. So in order to do that, I need to copy paste this and make another one with player name and then player name 2. So yep, this works, but now I have 2 functions, one with 1 parameter and one with 2 parameters. And now let's say I want to support 3 parameters. So again, I need to make another function, duplicate a ton of code and so on. So right away, you can see the issue. This is basically the problem that param solves. So for that, let's make just 1 function. And up here, let's call it with 2 parameters. And right now, yep, we have an error because this one can only take 1 parameter. So now here for the parameter, let's write the keyword params. We write params and then we write the type for the parameter. And in order to use it with params, this type needs to be an array. So let's make a string array. And for the player name array. And up here, let's just do a console.writeLine on this one .length just to see how many we call. And right away, we can see we have no errors up here. So calling this function with 2 parameters does work. Let's run it. And up it prints out 2. And now let's call this function with just 1 parameter. And again, no errors. And yep, now it prints out with 1. Also, if we pass in with no parameters, and yep, we do have an empty array. So yep, that's it, super simple. You can just add the params keyword, and that way now we support any number of parameters. This only has 2 requirements. The first one is that the type over here needs to be an array. For example, if you make string, it does not work. If we make it just string, then no, it does not work. If we make an array of multiple dimensions, this one also does not work. So it needs to be an array of some type. It can be string, it can be int, it can be pretty much anything. And the second requirement is that this one needs to come at the end. So afterwards, if we define an int age, nope, does not work. Here we have an error. And the error says here a params parameter must be the last parameter in a parameter list. So if we want to combine a params along with regular parameters, we need to make sure the regular ones come before and the params comes after. This way now, yep, up here we can type in an int and then any number of strings. And yep, all of this does work. That's it, really simple and sometimes quite useful. So anytime you have some function where you would like to receive any number of parameters, whenever that happens, always remember to use the params keyword. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about how we can use optional parameters in a function, meaning parameters that we are not required to use. Okay, so here is a normal regular function. It supposedly spawns some kind of unit. So it takes a spawn position, the type of the unit, the spawn rotation, and some kind of health amount. And then to call this function, we call it as usual. So we call it and pass in all of our parameters. If we run this, if it works, spawning unit of type melee with health 56 on this position, this rotation. But now let's say we want to spawn a ton of units and we don't want to be forced to pass in all of these parameters, especially for example if some of them are going to be defaulting to some amount that is going to be copy-pasted all the time. Let's say for example the only thing we want to care about is the spawn position, and then it will default to all the other ones. So one option would be to simply make another version of this function. So let's make another one and let's make another version that only takes a spawn position. And then in turn, that one calls the other version, passes in the spawn position, and then passes in defaults for all the other ones. So let's say melee, quaternary.identity in order to have the regular rotation, and let's say 100 health amount. So we can do this and now do this and spawn on new vector 3 of 10, 5, 0, something like this. And if there it is, we have no error. And running the code, yep, it did work. It did use those defaults and the 10.5.0 position. So this works. This is one valid option. But we have another option where we don't need to define multiple functions. We can simply use optional parameters. To use them, it's really simple. So we just have our function with our parameters. And then after the parameter, we simply write an equals and then assign some kind of default value. So for example, for the health amount, let's default it to 100. And now up here, when calling this function, we need to include all the other parameters. So for this one, let's include the unit type and let's include a quaternion rotation. But now we don't have to include a health amount. So like that, this one has no health amount. And if we run, yep, the health amount defaults to that 100 default. So it's really this simple. You just add equals and then some kind of default value. We just have a few simple rules for how we can use this. First is how the optional parameters, these have to appear after the mandatory parameters. So for example, if here on the unit type before the quaternion, if on this one I define an optional parameter like this, nope, here we have an error. It is saying optional parameters must appear after all the required parameters. Then another rule simply has to do with default values. Also, by the way, like I mentioned in the beginner section, the compiler doesn't really care about new lines. So if you have something with tons of parameters, you can just place them all in a new line, and that way it becomes a little bit easier to read, so like this. Okay, so like I said, the second rule simply has to do with default values. And the rule is how default values need to exist at compile time. So here we cannot construct an object. We cannot do new quaternion and then construct a new quaternion with something. Nope, this does not work. Like it says here, default parameter for value spawn rotation must be a compile time constant. So we cannot do this, but we can use, for example, the quaternion.identity. This is a constant, and yep. So we cannot use that, but we can use the default keyword. This will basically use the default value for that type. So in the case of a quaternion, which is a struct, it is simply going to initialize that struct with everything at 0. So for this struct, we can use this. And for the vector 3, same thing, we can use that. And for the unit type, this one is an enum, so we can just assign a default value. And if like this and everything works. Alternatively, we can also use constants, which is something that we're going to cover in a few lectures. So you can define a constant and then you can definitely use that constant as a default value. So optional parameters need to have certain defaults in order to work. And then over here for passing in the parameters, since we marked all of those as defaults, we can call it just like this. And if the code runs, it works and works with all the defaults. Then alternatively, we can pass them in one by one. So for example, if we want a spawn position, let's put some kind of spawn position. And then for the unit type, let's say we want like this. So yep, we just assigned 2 parameters. And yep, it did work. But now let's say that the only parameter that I want to assign is just the health amount. So for that, I go up here and I just write some kind of int, so just 56. And nope, this one obviously has an error because argument 1, it expects a vector 3, not an int. So just like this, you need to pass in all the parameters in order. However, you can actually pass them without being in order. And for that, we really just need to write the name of the parameter. So in this case, the parameter is the health amount. So we write that and then a colon, And yep, just like this, it does work. This is basically calling the function and assigning the health amount parameter to this value. And on the other one, since we didn't assign them, these remain the defaults. And if you're running the code, we do see with health of 56. Also, by using the same method, we can pass in parameters in any order you want. So for example, the health amount, then let's pass in the unit type. So unit type and unit type dot something. And yep, this is definitely valid code. As long as I write the name of the parameters and then a colon, then give it a value, everything does work. Alright, so that's optional parameters. It's quite a useful feature to help you avoid having tons of function versions for all kinds of parameter combinations. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn something very important, the difference between value types and reference types. If you don't know the difference, then at some point in the future you will go crazy because you think something is behaving as a reference when it's behaving as a copy. So in C# you have several types, and mainly they are either value types or reference types. Reference types, they store references to their underlying data, whereas value types, they contain that data directly. Some examples of value types are the symbol types like int, float, bool, and so on. These are all value types. And for reference types, these are things like class, object, arrays, and strings. However, importantly, struct is a value type. We're going to cover structs in detail in the next lecture. They look similar to classes, but this is the one big difference between them. Structs are value types and classes are reference types. And over here, as you can see, arrays are reference types. Even if the underlying data, if you're making an array of ints by themselves are value types, but if you make an array of int, the array is going to be a reference type. And then strings are a bit of a special use case, in that they are technically reference types, but in some cases they behave like value types. So the big difference is shown down here. With reference types, you can have multiple variables, and you can have all those variables, all of them pointing to the same underlying object. Whereas with value types, any variable you make with some kind of value, if you then assign that variable to another variable, you are making a copy instead of a reference to the original value. Another difference is how reference types can be null, whereas value types cannot. So for example, if you have some kind of enum for your weapon types, if the player does not have any weapon, you cannot set it to null. Enums cannot be null, neither can ints, floats, bools, and so on. So here let's see some code. First, let's define an int, which is a simple value type. Okay, very basic, just the variable named a and contains the value 7. But now let's make some kind of class which is going to work as a reference type. So here let's make a class, call it myClass, and inside let's just expose an int a, okay? And now up here, let's create a new myClass. So myClass equals a new myClass, and then let's go inside that one and set the a to some kind of value, let's say 7. And then let's make another myClass, call it mySecondClass. And now let's assign this one to the myClass. And over here we go inside the mySecondClass and modify a to a different value. So here now we have two different variables. We're initializing the first one like this, then we're assigning it to the second variable, and then we're modifying the value inside of the second variable. So if we print out over here the myClass.a, what do you think this will say? So let's do a console.writeLine and print this out. Let's see if it says 7 or 5. And if there it is, it does say 5. Again, that is because classes are reference types, so over here, even though we have two separate variables, they are both pointing to the same underlying class. So they're both pointing to the same underlying memory position, they're both pointing the same actual object, both of them are referencing just a single instance of our myClass. So by going through either of these, we're actually modifying the same underlying object. We do not have two objects, we have just one and two references to that same object. So when we modify this one, we're not modifying it just on this second object, but since this one has the same reference as this one, both of them are modifying the actual underlying object, so by modifying either of them, we are modifying the same underlying object. Now let's look at this exact same example, but using our ints, which are value types. So you've got an int a of 7, then let's define an int b, and let's assign it to the value of a, and then let's go inside b, and set b to something else. Let's put it on 5, and now let's do a console.writeLine on a, and let's see what this one prints. So will it print 7 or 5? And if there it is, the result is 7. Again, this is because int is a value type and not a reference type. So over here, we're defining a variable a and assigning the value 7. And then we're assigning b, and then we're defining b and assigning it to the value of a. But again, since a is a value type, this is going to essentially copy the data that is currently stored inside a. So after this point, we have two variables, and each of them holds a copy of their data. And then over here, when we modify b, that is only modifying the copy that was created in here and not modifying the original data that we have in here. This is the one big difference between value types and reference types, is how up here we are working with a reference and we have two references that both of them point to the same underlying object, whereas down here we have copies. So we have one copy here, one copy there, and by modifying the second copy, this has no relation to the original data. Now the scenario that is most important to know this difference is when working with structs, which we're going to cover in detail in the next lecture. For now, don't worry too much about what they are, I just wanted you to see the difference. So a struct is made pretty much the same way as a class. We just change the keyword into struct, and let's name this my struct. So like this, and up here we can write literally the exact same code, but write it with a struct instead of our class. So up here, use my struct, then over here, this one is my struct, and my second struct, and then modify this one here, and we print out the my struct.a. Okay, so here's our test. Literally, we have the same code down here as we have up here. The only difference is one code is working with a class, another one is working with a struct. So let's see the difference between these two. And yep, with the exact same code, we have two different results. That is exactly because of the difference between value types and reference types. The class has a value of 5 and the struct has a value of 7. That is because the class up here, again, both of these are referencing the same underlying object. So when we modify the second one, we're both modifying the same underlying object. So when we print out the data stored in the first one, again, same object, so this one prints out 5. And yep, we do have 5. And then down here, when working with structs, structs are value types. So over here, we create a brand new struct. But then on the second one, when we assign it, we're actually creating a copy of the data. So now this one has a completely separate copy that has no relation, no reference to the original data, to the original my struct. So when we modify this one, we're only modifying this copy and not touching this one at all. So that is why on the struct, the result is 7, which is the original value that we set over here, because when we modify this, we're only modifying this copy and have no relation to this original data. Now, this difference between value and reference types is also very important in functions. For example, private static void my function. Let's do some kind of test function. And here, let's receive of type my class, another one of type my struct. Then let's just go inside and put it on something. So my class and my struct. Let's modify to do the exact same test as previously. Let's just comment out this testing code. And then over here, let's create a my class. My class, let's create a brand new one. And let's put my class, set the a to 7, and create a new struct. We also set it at 7. So both of them have the same value in their a field. And then we call my function, pass in our my class and our my struct. And then let's do a console.writeLine on the my class.a, then some space and my struct.a. Okay, so again, let's see what happens. And yep, there it is. My class has a value of 5 and my struct has a value of 7. Again, that's the same difference between value types and reference types. It's how when we call this function and we pass in our values, the class is going to be passed in as a reference. So as we modify this one, we're actually modifying the reference. So we're modifying the underlying object that was sent into this function. Whereas for the struct, the function receives a copy of the data. So the copy that we receive over here inside the function, this has no relation to the actual data defined up here. So whilst inside this function, modifying this class modifies the actual data outside of it, but modifying this struct only modifies a local copy. Also, what I mentioned a while ago about how arrays are reference types. So for example, let's do another test. So let's make our function, take in some kind of int, and then an int array. Then over here, let's modify the value of a. And let's go inside the int array on index 0, and let's modify the value. Okay, so now up here, let's define some kind of int, and let's define an int array. Let's construct an int array and just put a value on there. Okay, so now we call my function, pass in a and the int array, and now let's do a console.writeLine. Let's print out the a, and then print out the int array on index 0. Okay, so again, let's see what this does. And if there it is, same thing. The int was not modified inside the function, but the array was. That is because ints are value types, so this one is passed in as a copy, but int arrays, these are reference types. So when we pass in an int array onto our function, we're passing in a reference to the original data. So when we modify this inside the function, we're modifying the actual original data. And also, since we're on the topic of value types and reference types, I mentioned a while ago how value types cannot be null, so you cannot define an int b equals null. So this is not possible. We have an error, cannot convert null into int because it is a non-nullable value type. However, if you really want to do this, you can do it. Instead, you just have to use a custom type called Nullable. And with this, you can make any value type like ints, bools, floats, and so on. You can make any of those into nulls. And this is something that can sometimes be useful. I cover Nullable in detail in a lecture in the advanced section. Okay, so that's the differences between value types and reference types. Be very, very careful with this difference. It might sound like I repeated myself way too much during this lecture, but that's because this is really so important. Always keep in mind whether you are working with a copy or a reference. One of the most important ways to see this difference in action is in the difference between classes and structs. So let's learn about structs in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about structs. These are structures of data that are similar to classes, but also a little bit different. Okay, so structs, like I said, are pretty similar to classes in how you define them. You literally just swap class for struct. So over here, for example, let's make a class named player. Right now this is a class, and just by swapping this into struct, yep, now this one is a struct. So that's it, super simple. However, just doing this has some really important implications. The main one is how classes are reference types and structs are value types, which is what we covered in the last lecture. This means that when you use something as a class, like a class parameter, it gets passed in as a reference, whereas with a struct, it gets passed in as a copy. So here we can do a simple quick test, make a player struct and a player class. Then just run this code, just making the usual start function, because over here I'm working in Unity. Let's make a private void test function struct, and another one test function class. Okay, so here is some code. We create a new struct and new class, and we assign a field inside of them to the value 1. Then we have two functions, and these functions, these do the same thing. So they just set that field into 2, and then we do a log. So let's see whether this one keeps the number 1 or whether it keeps the number 2. And yep, like the log says here, the struct keeps the number 1, whereas the class keeps the number 2. Again, that is because struct is a value type, meaning these are passed in as a copy. So over here we are modifying the copy and not the original data. But classes are reference types, so when we modify a class inside a function, it modifies the actual position in memory, the actual original object. So the reference type gets changed, but the value type does not get changed. This difference is really extremely important, so I truly hope you fully understood everything in the previous lecture. If not, go back to it and rewatch it. It is really important so you don't get confused like I did many times before I memorized this. This is one of the main differences between structs and classes, how classes are reference types and structs are value types. In general, structs are mainly used as just data containers meant to organize your data. The simplest example is really just the vector3 type inside of Unity. So we can inspect this one, so let's right click and go to the definition. And yep, over here we do see this is a struct, and it's a struct that pretty much just holds 3 components, so x, y, and z. So rather than having 3 separate fields whenever we want some kind of position, we just make a struct that in itself has these 3 fields. Whenever we have several pieces of data that all of them make up one logical unit, then perhaps consider making that a struct. However, again, remember how it's a value type. For example, in Unity, you cannot even directly modify one of those components. So if I set the position .5 equals something, if I do this, nope, it does not work. Now, technically, this is more related to the fact that this position is actually a property and not a variable. But still, the reason why it's a property is because it actually copies the data and sends it over to the backend of the engine itself. So in Unity, when you need to modify something, you need to assign it to a new vector3. So basically, you need to give it another copy of another piece of data in order to actually modify it. So usually, structs are used in an immutable manner, meaning they never change. Once you create a struct with a certain value, usually you keep it at that value. However, that is not an absolute requirement. It's really just a good convention to follow. For example, the vector3 struct, so let's do a position, define it as something, 10, 21, something. And like this struct inside actually contains the normalized function. And if we do this and then do a debug.log on this position, let's see. Yep, this function does indeed modify the underlying data. So in theory, structs can indeed be mutable, they can change, but in order to avoid confusion, you should probably avoid this as much as possible. You should probably always treat your structs as immutable. Just following that one simple rule will make things much simpler to understand. Now, structs, like classes, they can have fields, they can also have functions, like we saw here to normalize, and they can even have properties. One big difference is how they cannot inherit. I talk about inheritance in more detail in the next lecture, but basically with a class, you can make it inherit another class. So public class, base class, and then public class for some kind of unit class, and this one can extend base class. So this works, this is valid code. But over here on this player struct, if we try extending base class, nope, an error, structs cannot extend classes. The one thing they can do is actually what this error message is telling us. They can indeed implement interfaces. I will also cover interface in detail in a few lectures. Then structs can also have constructors, just like classes. However, in most C# versions, you cannot have a parameterless constructor. So over here, public player, just like this with no parameters. And nope, we have an error. So as you can see, parameterless struct constructor is not available in C# 9. But if you're using a later version, this is possible. Instead of defining it yourself, it always has one by default. So up here we can do new player, and yep, this works. So for the constructors, if we define any of them, it has to have some kind of parameter. So usually on the constructor, you add some kind of thing to initialize the actual struct itself. And then one common error with constructors is this one right here, which is all of the elements, all the fields must be fully assigned before control is returned to the caller. So if we define a constructor like this, we must initialize all the fields. So over here, this .a equals a, and yep, now it does work. So every constructor you make has to initialize every single field within that struct. Again, this has to do with difference between value types and reference types. As soon as you define something of struct type, like for example some kind of variable, like a kind of player variable like this, as soon as you define it like this, If you define it like this, it's an error because it is uninitialized, but we can initialize it. We can just use default. This is a keyword that pretty much returns the default of whatever type we have. So if we do it like this, let's see what this says. And yep, the default of a struct is indeed a struct. And then we can even go inside of it. So let's print out the A. And yep, so it creates a struct and initializes the variables, all of them at 0. So that's what default does, initialize everything with a 0 value. However, if we now make this into a class, and if there it is, default value for a class is null. And since it's null, that means it has no object, so we cannot access anything inside of it. Again, goes back to the difference between value types and reference types. Reference types by default are null, whereas value types, they always have some kind of value. So when you make a struct, you can create a new struct like we saw by using the default parameterless constructor, or we can use any custom constructors, or we can just make the struct and over here define any kind of thing, so a equals 2. And yep, this is valid code for initializing a struct. One more important thing about structs is, once again, how they are related to value types and not reference types. So one big difference is how they are stored in the stack instead of the heap. These are two different positions in memory. One is much more efficient than another. I actually have a nice story about this. In my first Steam game, Survivor Squad, for the implementation of the Fog of War, the world basically has a ton of tiny quads on top. Then as the player sees some area, those quads are marked as invisible and they are not rendered. So each of those tiny quads needs a little bit of data in order to know the position and know whether it's visible or not. In the first version of this system, I stored that as a class and it was terribly slow. And then I literally just swapped class for struct and suddenly got a massive speed boost. All because of how structs are very efficiently stored in memory. So in general, use structs to hold different pieces of data together. And in general, you should use them as immutable pieces of data, meaning they should not change, and consider using them when you have some kind of memory performance issues. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn some intermediate topics related to classes, things like inheritance, polymorphism, protected, override, and a bunch more. Okay, so in the basics section, we already learned the absolute basics of classes, how we can define a class which has fields, properties, and functions, and then you can create instances of that class. So that's the basics, but of course classes can do so much more. One of the main things they can do is simply the concept of inheritance. That is how you can have one class that inherits something from some other base class. For example, let's say we have this general unit class, meaning this represents any kind of unit in our game, and all the units are going to have some kind of speed and some kind of move function. And then we can have the player, and the player is a type of unit. And to define that relationship, we can make the player class extend the unit base class. That means that the player is going to inherit everything from this unit class. So on the player class itself, we are not defining any speed field or any move function. Instead, just by making it extend the base class, it is going to inherit all of these elements. Essentially, the player class, this one contains everything inside player and everything inside unit. Then we can have another enemy class, which again is also meant to be some kind of unit, so we also extend the same unit base class. And again, this one is going to inherit everything. So the enemy class itself is also going to have a speed, move function, and so on. So anytime we have some common logic that belongs to any kind of unit, we just need to add it onto the unit class itself, and anything that inherits from that unit class, any of those classes are going to automatically receive the new code that we add to our unit. And then each of the classes that inherit from base class, each of those can also have code themselves that is unrelated to the base class. So for example, the player can have some kind of move player function, and the enemy can have some kind of enemy health field. These only belong to these classes and do not belong to the base class. So for example, the enemy has no relation to the player move player, and the player has no relation to the enemy health. So always keep in mind that the inheritance does not go both ways, meaning the above unit, this one over here, has no knowledge that there is a player extending it and the player has this kind of function. So the player inherits everything from unit, but unit does not know anything about player or enemy. Okay, so let's see the syntax. Here is the basic unit class. We've got a speed field and a move function. And now let's make it clear, so let's make a player class. And now in order to make this one extend our unit class, for that, after the player class name, after that we write a colon, and then the name of the class that we want to extend, so in this case, unit. And if that's it, just like this, the player is going to be extending the unit class. If we write any code inside of here, we can already access the unit fields. So for example, let's make a constructor, so a public player constructor. And over here we can access, we can access the field, we can set it to something, and we can call move function. That does work. So even though speed and move are not defined over here in the player itself, since the player extends unit, it also inherits all of this. But then, like I said, inheritance does not go both ways. So up here on this one, let's make one for the move player. Let's make some kind of move player function. And now down here on the unit script, if we try calling that, nope, that does not work. The unit does not know anything named move player. This function only exists on the player class itself. Now, another thing we can do is override some base function. So for testing, let's actually go up here. Let's create a new unit. So let's build a new unit and a new player. Okay, so we have these, and if we call the move function, and on the player, let's call the same move function. So if we run this, it should print this line twice. And yep, that's correct. It only printed 3 times because I included it over here in the constructor, but yep, it did work. So now, like I said, we can override some base function. So for that, over here on the move function, let's add the keyword virtual. And now we can go onto the player, and on the player, let's define a function exactly like this one. So let's define one just like this. Inside, let's say move player. And if we do it just like this, we actually see this green squiggly line, and we can check. And if this is basically telling us that this one is hiding the inherited member. And if we want to override the implementation, we can add the override keyword or add a new keyword if we want a new function. But nope, we do want to override that one. So on the base class, we add the virtual keyword, and on this one, we add the override keyword. And yep, so now like this, using this code, so the unit has this one, it's a virtual function, and this one is overriding that function with a different message. So we have 2 different messages, and up here we are creating a unit, creating a player, and then calling the same move function on both of them. So now let's see what this prints. And if there it is, so when we call move on a unit, it is running move unit, but when calling the same move function on a player, it is actually running the overridden logic. So this is how you can extend some base class, so make it inherit from something else, and then override certain functions to have different behavior from the base class. Now, this is also a great time for me to mention how you can override the toString function. Basically, every single class in C# is always going to extend the base object class, and that base object class always has a toString function. So for example, up here, we did not define any kind of toString in here, but we can call toString. Yep, this does work. As you can see, this exists in the object base class. This is the main way of how any single object, any single type can be converted onto a string. We can do a console.writeLine, and we can print out, for example, player. And yep, this does work because this one is going to automatically call toString in order to convert the player onto a string. So anyways, yep, all objects have this function implemented automatically. However, if we run this, yep, the player just says, essentially just prints out the actual name for the type. So we're inside the namespace C# course, we're inside the program class, so that's the program class up here, and then inside the player type. So sometimes printing this is not very useful, but the toString function, this one is also marked as virtual, which means we can also override it. So let's do the same thing. Let's do public override, and automatically this one already shows us some code hints. So let's override the toString function, and it's like this, so it returns a string and is called toString. And over here, we just return the string that we want to name our player. So for example, let's give the player some kind of name. So let's give it a string for the player name. And let's receive this string over here. So we've got a string for the player name and set this.player name equals this. And then down here, let's print out player and then the player name. Okay, so we do this, and up here, let's print the name as CodeMonkey. And then we do the same thing. So let's do a console.writeLine, and let's just put player. So not even any toString, so just like this. Let's see what this does. And if there you go, now we have overridden that behavior, so we can now say whatever message we want from our custom type. Okay, great. So with this, we can inherit from base class, and we can override some functions. And of course, what I'm saying here applies to any class you want to extend. You can have as many classes extending a base class as you want. So for example, we can make a class for an enemy, and also make the enemy also extend our unit. And for example, on this one, we can also override the exact same move function. So we can do this. This one is move enemy. And now up here, let's do the same testing code, enemy, let's construct a brand new enemy. And then we call enemy.move, and let's see what this runs. And if there you go, like that. So move unit, move player, move enemy, even though over here we are always calling the exact same function. So basically, we have 3 implementations of this, and each of them is slightly different because they're overriding the base implementation. Basically, the only rule with inheritance is how you can only inherit once. You can only extend a single base class. So if over here we were to define a unit2, okay, here's a completely separate class, and over here let's try to extend that one as well, and nope, we have an error. It is telling us that enemy cannot have multiple base classes, so we can only ever inherit from a single base class. If you want to achieve something similar to that kind of result, for that we have interfaces, which we're going to cover later on in a future lecture. But you can definitely go the other way as deep as you want. So over here, for example, we have enemy, which in turn extends the unit class. Then we can go one step further. So let's have another class, for example, the enemy melee. And let's have this one extend enemy. And yep, this does work. Then we could have another one for the enemy melee boss, something like this. So for some kind of boss that also extends melee, this one extends enemy melee, just like this. And yep, all of this is valid code. However, just like this, you can probably already tell how this can become quite confusing quite quickly. So over here, let me point out that inheritance is a tool that can be very powerful, but also can be very easily abused to the point where it's much worse than not using it. There's a common programming joke that goes, basically you wanted a banana, so you construct a banana but end up with an entire jungle. That's because the banana class would extend the fruit class, which in turn would extend the tree class, which requires a jungle class, and so on. So if you have complex, really deep inheritance structures, if you have that, you can end up with some really messy code. One common saying to counteract this is prefer composition over inheritance. This is how you can, instead of having a complex web of inheritance, instead of that, you can compose your complex objects based on separate components that make up the final object. Now, this is a more advanced topic, so don't worry too much if you're not fully understanding everything that I'm saying here. I'm only saying this just in case you were curious and want to research further on this topic. If you want, you can Google composition versus inheritance, and you will get a ton of really interesting results. The only thing I want you to take away right now is just remember to be very careful when you're using inheritance. Always ask yourself if you absolutely need it. Sometimes you do, but many times chances are there's a better way to achieve the same result in a much easier way that does not become insanely complex. But inheritance does have its place, so let's learn a little bit more about it. One extremely crucial thing that is not related specifically to just inheritance is the concept of polymorphism. This is how you can treat an object as a different type of the object as long as those types are related. So for example, up here, if we define a field of type player, so we have this field, and we can assign this to the player that we created. Yep, this does work. However, we cannot assign our enemy object over here. That is because you cannot implicitly convert our enemy into a player. Because again, going back to the diagram, even though they share the same base class, they by themselves are two completely separate types. However, now let's make a field of type unit. So we have a unit, and obviously for this one we can assign our unit type. Yep, this does work. And on this one we can also assign the player type. Yep, this also does work, because again, player extends unit, so it can be used in place of a unit. And same thing for the enemy object. Yep, this one also does work. And now if we go into this unit 2 and call the move function, let's see what this runs. And if there it is, this one runs the move enemy. That is because even though we assigned this to a unit variable, even though we did, the object itself is still an enemy object. So the object itself, the type itself, that one is still overriding our base move function. And for example, if we assign this to player, yep, this does work. But like we saw on the player itself, let's define a public void move player. So let's define this function that only exists on the player type. So we did this, and if we go over here onto player and call move player, yep, this does work. This is valid code. However, if we go through the unit and call move player, and nope, that does not work. It does not exist. That is because again, this field, this one is now of type unit, even though the object itself is of type player. Since we're accessing it of type unit, we can only access the things that unit itself has. So for example, one fun thing you can do with this kind of property is, for example, having a list of units for some kind of unit list. You can do this, and now inside of here, we can place a unit, we can place a player, and we can place an enemy. And yep, this works. It works because our player class and our enemy class, those extend our unit base class, so they can all be cast down into a unit type. Now, like I said, the concept of polymorphism, which is basically using one type as a different type, that concept is not specific to inheritance. For example, it also works with interface, which we're going to see in the next lecture. If we have some kind of function that requires the player-specific type, if so, then we need to receive some kind of parameter specifically as type player, but we can do a bunch of logic that works on just units, and that logic will work on units, it won't work on players, enemies, and anything else that extends our unit-based class. And now that we are looking at inheritance, we can also look at a different access modifier. So far, we've pretty much just been using public and private. Private means that only this class can access it, and public means that anything else can access. But when it comes to inheritance, we have another super useful one, and that is protected. For example, let's go down into our unit, and for example over here for the speed, instead of public, let's make this protected. So by making it protected, we can use it over here inside the unit class. So yep, this works, this is valid code. And importantly, over here on the player, yep, this one is still valid code. We have no errors here. By making it protected, that means that only this class, only the class that defines it, and any classes that extend this base class, any of those can access this protected field. So up here, the player can indeed access the speed, but for example up here in our static, in our main program, over here, if we try going into a unit and try accessing the speed field, and nope, it does not work. Unit.speed is inaccessible due to its protection level. So if you make something protected, it is only accessible from within that class and any other classes that extend that class. So if you have some kind of behavior in your base class that the extended classes should be able to modify and only those classes, if so, then make it protected. Or for example, in a field, make it protected virtual. And yep, like this, all the other class can access. So this one just needs to modify into protected override. And then same thing on this one, protected override. And by doing that, the classes that extend that base class, those can indeed access it, but over here, this one can no longer access. Then one really interesting thing is the concept of abstract classes. These are classes that have a definition but cannot be constructed directly. For example, let's say our unit class here, this one should never be created. This should simply be a base class that should be inherited by the player or the enemy or any other kind of unit type, but we're never meant to have just a base unit class. So for that, we can add the abstract keyword. And yep, this one marks this class as abstract. And now if we go up here, yep, we do see this error. Since the class is marked as abstract, we cannot create an instance of this type. This can be really useful to provide a base definition for something, but also make sure that base definition itself can never be used directly. Only the class that extends it can be created. Along with marking a class as abstract, you can also mark functions. So for example, let's make a public abstract and make some kind of void attack function. So we do this, and then we just do a semicolon, meaning we do not provide an implementation for this function. And instead, just by defining this, we can see we have some errors over here in the enemy class and the player class. And here, yep, it says that we must implement the attack function. So if the base class has some kind of abstract function, we have to absolutely implement that. And over here, by the way, quick tip, Visual Studio actually has these quick tips. So if you click on this little thing, it tells you to implement the abstract class and it's going to automatically write it. And if there it is, so we need to write that one, and yep, no longer have an error. So this can be useful if you have something where you are not meant to provide any kind of default implementation. You just mark it as abstract, and any class that extends this class will be forced to provide their own implementation to this function. But if you do want to provide a default implementation, then just do it like this. Just make a regular virtual function, and then any other class can either override or not override. Then another keyword is sealed. What this one does is it prevents classes from extending this one. So as you can see up here, we have an error. Since we marked that one as sealed, it is telling us enemy cannot derive from sealed type unit. Now, personally, I've never really used sealed, but in complex projects with tons of classes, sometimes it can be wise to make something sealed if it is never supposed to be extended. Again, remember the main clean code principle. The main goal is really to minimize complexity. So if you have some class that is never meant to be extended no matter what, if so, you can make it sealed in order to help you make sure that the compiler enforces that rule. So it can be useful in that way, but personally I rarely ever. So it can be useful in that way, but personally I never really use it. Then yet another more advanced thing related to classes are destructors. So we write those kind of like a constructor. So kind of like up here we have a player constructor. For a destructor, we write it pretty much the same way. So we write just the player as if it were a constructor. So there's no return type, it's just the type. And then before it, we add the tilde key, which by the way, like it says here, this one cannot be marked as public. So it just runs just like this. So this is a destructor. And now any code that we write here, this is all going to run when this object is destroyed. Which if you remember from what I mentioned in the beginning, C# is a programming language with managed memory. You don't need to directly handle the memory yourself. So the destruction of an object happens when there are no more references to that object. So for example here, let's do a console.writeLine for the player destructor to see when this runs. So for example, over here for some testing code, we're calling some kind of my function, and inside we're just calling a player, so pretty much just constructing a brand new player. Then over here I'm calling gc.collect, so gc stands for the garbage collection. So this is the system that automatically handles all of the memory, and calling collect simply forces it in order to do it. If I didn't force, then this would happen randomly as the program grows. And then just calling another function, just keep it running. So let's see this. And if there it is, just like that. So the player was created, then we call the function. This one created a local variable, meaning that this variable ends as soon as this function ends. So as soon as this function ended, this variable was marked for destruction. Then when we forcefully called the garbage collection, when we did that, it automatically destructed the object and then continued running the program. But remember how destruction of an object happens when there are no more references to that object. So that is why over here, this one is a local variable, meaning it only exists inside of this function. So as soon as we exit this function, naturally this object has no more references to it. However, if instead of describing it in here, let's make a player over here, player test. And then down here, instead of defining some kind of function like that, let's set that field to that. Okay, so just like this, and now if we test, and if the destruct does not run because player test, this one is a static reference, and this one continues holding a reference to that object, even though this function has ended. So this is yet another place where it's really important to understand the scope of exactly what code you're writing. One practical example of when to define the destructor is when you have some kind of class that requires some cleanup. Like for example, if on the constructor itself, you open up some kind of file for reading. If you do that, then make sure you close that file on the destructor. So these can be really useful for disposing of any unwanted memory. Alright, so those are some more intermediate topics related to classes. As you can see, there's lots of stuff you can do with them. But also, specifically on the topic of inheritance, remember what I said about how it can become really messy really easily, so always use it with care. And something that I mentioned quite a lot in this lecture are interfaces, so let's learn what those are in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about interfaces. This is one of my favorites and just straight up best features of C#. You define an interface that represents some kind of behavior or type, and then you implement that interface in any class you want. Okay, so interfaces. These are simultaneously really simple and also really powerful. An interface is essentially just a contract. So you define an interface, then you define whatever functions that interface has, then any classes that implement that interface, any of those, they must implement those same functions. So you have a guarantee that anything that implements that interface will implement the functions defined in the interface. By doing this, you can then write code directly against the interface type, and that code will work on any object that implements that interface. This logic is somewhat similar to the class inheritance that we just covered in the previous lecture, except you cannot create an object of the interface type. Another difference is how a class can only inherit from a single base class, but a class can implement multiple interfaces. So for example, with this structure right here, an IAttackable interface that is implemented by both the player and the enemy. With this, we could have some kind of bullet object. Then the bullet could receive an object of type IAttackable for some kind of target. Then the bullet itself would call the damage function on that IAttackable, meaning the bullet itself would not know if it's attacking an enemy or a player, but because those work with the interface, the bullet would be able to deal damage to both players and enemies. So here's a different demo for some kind of interaction system. I've got 3 objects and I want to interact with all of them. And over here on the building I can click, and yep, I can indeed interact with it. However, clicking on these 2 does nothing. Here is the code running that demo. Now don't worry if you don't understand everything that this is doing, it's not really important. This is just a demo just so we can see the interfaces in action. Over here all we're doing is testing for a mouse click, then we get the mouse wheel position and test if there's any collider under that position, and then try to get the type of that collider. So in this case we're trying to test, are we clicking on something that is a building object, so it has the building component attached to it. If so, then we call the interact function, and that in turn spawns that chat bubble. So this works perfectly fine with the building type, but now let's say I want to interact also with the zombie and also with a push button. Right now it doesn't work. I am clicking on the zombie and the push button, nope, nothing happens. The only one that works is the building itself. That's because over here, this logic, this was made specifically just for the building type, so it does not work with any other type. In order to make this work with those other objects, I pretty much just need to copy paste all this code, then make this one to make it work with a zombie, and make this one down here to make it work with a push button. Okay, let's see like this. So interact with the building, it works, the push button works, and the zombie also works. Okay, so now I can indeed interact with all the objects, but obviously the code over here does not look very good. We've got tons of duplicated logic. This is really messy code. If we want to add yet another interactable object, we have to come here and copy paste a ton more code. So you can imagine how this becomes really tricky if we have dozens or hundreds of interactable objects. So this is definitely not a good approach. And this is exactly where interfaces come in. Instead of making this code work with each individual type, instead of that, we can make it work against an interface. Here's a super simple interface that I define. Again, I'm going to cover this syntax in a little bit. Then all the other objects, they are implementing this interface. And over here now for the if, instead of testing for each individual type, I'm just testing for the interactable interface type. And if we test this, click on the building and it works, the button works, and the zombie also works. Okay, great. Because we made this code work with the interface itself, that means that this now works with any class that implements that interface. So if I want to make more interactable objects, I really just need to make a new class and implement this interface, and everything will work. There's no need to touch this code anymore. So this is the practical example. Now let's see the syntax for how we build interfaces. Now the way we define it is really simple. For example, let's define an interface for an object that can be attacked. So we start with the access modifier, and for an interface you probably want it public. Then instead of writing class, instead of that we write the keyword interface. And then we write whatever name we want for the interface. And the general naming rule is to start interfaces with a capital I. This is not required, it's just a good convention to follow. So in this case, to represent something that can be attacked, let's call it IAttackable. Okay, yep, so this is our interface. Now let's think of what functions we need so that something is attackable. And the answer is we probably just need a damage function. So over here, let's type in public, which by the way, everything defined in an interface needs to be public. You cannot define private things inside an interface. That's because interfaces, like I said, they are pretty much defining a contract that other classes must implement. If we were to define something as private, then other classes could not interact with anything inside of this interface. So it wouldn't really make any sense to have any private elements inside an interface. So everything inside of here is public. And by the way, this is actually another reason why I personally really like being as explicit as possible. If you omit the access modifier, if you do that over here on an interface and make some kind of my function, if you do it, then this one will default to public, but if you write this exact same code over here inside a class, if you do it, then now this one will default to private. So this is yet another reason why I like being very explicit. That way there are no questions as to what access modifier we are using for what element. So over here I like to be very explicit and write public void and let's call it damage. And yep, we just define the function and then put a semicolon, meaning we do not write an implementation in this interface. Here we are just defining the function signature. So that's just the name, the return type, and any parameters if there are any. And that's really it. We don't provide any implementation. In our classes, like for example, let's make a random player class. And now on this one, we can implement our interface. And we do that pretty much exactly how we saw for extending a base class in the previous lecture. So we add a colon and then our interface, so IAttackable. And if there it is, just like this, and we have an error, and if we see, yep, the error because the player does not implement the interface member IAttackable.damage. Again, like I said, if you implement an interface, you have to implement everything within that interface. So over here, you absolutely must implement this damage function. And since the interface itself, since this one has no function body, because that we can have whatever implementation we want, meaning the player can have some kind of implementation, then the enemy can have a different one and so on. So pretty much similar to what we saw in the previous lecture on extending base classes, how we could override and provide different implementations for the same function. Over here, it's kind of a similar thing. So let's do a public void damage. And here we can, let's just do a console.writeLine and just print out player damage. Okay, so yep, that's it. And now, for example, up here in our main, let's make a field of type IAttackable. And now we can simply construct a player and we can assign it over here. Yep, just like this works. Again, similar to what we covered in the previous lecture. This is polymorphism in action. Since the player implements the IAttackable interface, we can use a player object and assign it to a variable of type IAttackable. And then through this interface field, through this one, we can access whatever functions we have in our interface, like for example, damage, and yep, this does work. So now we have similar benefits to what we saw in the previous lecture on inheritance. For example, let's make another class. Let's make an enemy class that also implements IAttackable. And yep, just like this, it works. And now up here, if we have some kind of code that works against the IAttackable interface, like for example, let's make a private static void attack object, and we receive an object of type IAttackable. So we can do this, and then on attackable, we can call damage. And now up here, we can call this attack object, and we can pass in an object of type player, and pass in one of type enemy. And yep, both these work just fine. So this function over here that was written directly to work with this interface type, it does not care what object we pass in as long as that type also implements our interface. Now, one limitation of interfaces is they cannot have fields. So for example, down here in the interface, let's make a public int health. And nope, this does not work. Interfaces cannot contain instance fields. Again, this goes back to the difference between an interface and a base class. A base class can contain actual data, since a base class can be constructed. But an interface, this one is just a contract, so this one holds no data. So that is why over here we cannot have any fields, but we can have properties. So yep, this does work, so we can define a public health property. And again, same thing, all of these need to implement that one. Then we can also have functions, of course. Then we can also have events, which we're going to cover later. So the main limitation is really how you cannot have fields, because again, interface cannot store any actual data. Another thing is actually here we define this function with no body, and then the classes must implement that function. And this actually used to be the only way, but in recent C# versions, you can now add an optional default implementation. So you can write a function here and just write the code as normal. So you can do this, and now classes that implement this interface, they are not absolutely required to implement this damage function. If they don't, then it's simply going to use the default one. So as we can see over here, we have no error. And up here, we can still pass in an enemy, and through this function, we can call the damage function. And the only thing is one is going to run the player damage, and this one is going to run default. So let's test. And it picks out like that. So the player did implement their own custom implementation, but the enemy didn't, so it used the default one. This feature for default implementations, this is especially great when working with some complex projects, things that are already using a bunch of interface and you want to add a bunch more behavior. If over here you just add a brand new function, so test function, if you just do this, then all of a sudden we broke all of this code. This is obviously not very good. So if you do this, if you add after the fact and you don't want to break your current code, just provide default implementation, and yep, now everything does work. So like I said, interfaces look slightly similar to class inheritance. However, one huge difference between them is how you can only ever inherit from a single base class, but you can implement as many interfaces as you want. So for example, here we can make an interface, and let's call it iMovable. So this would represent something that can move. Then an interface, call it iHasInventory. So this represents something that has an inventory. Then up here, let's say the enemy can move but has no inventory, and the player can move and has an inventory. And yep, we can implement all of these interfaces. In the previous lecture, I talked about how you should prefer composition over inheritance, and this is exactly one way you can do that. You can have interfaces that each define some kind of behavior, Like for example, whether the object can be attacked, whether it moves, whether it has an inventory. You can do that, and then your classes, you can implement only the interface that are related to that object. So for example, the player can attack, can move, and has an inventory, but the enemy does not have an inventory, so does not implement that interface. This is a much better pattern as opposed to making all of these requirements on some kind of unit base class, and then the enemy would also have some kind of inventory even though they would never use it. So this is an example of composition over inheritance. And for example, in my game Thinking Guardians, I use interfaces all over the place. I use them to define all kinds of behavior and then have tons of code that works directly with those interfaces and really does not care what the underlying type is implementing that interface. So it can be a dinky, it can be a machine, it can be the player, it really does not matter. As long as that type implements that interface, it does work. One extremely common interface in games is simply making some kind of interaction system. So just like we covered in the demo, and if you want to learn more about specifically that type so you can see a practical use case, if you want you can check out my dedicated tutorial on how to make an interaction system, do something that can talk to NPCs, push buttons, or open doors. And like we saw in the demo, if you don't use an interface, then you have to copy paste a bunch of code. But if you do use an interface, then it makes it super simple for your system to work with any object you want. So interfaces are really truly awesome. They are definitely one of my favorite C# features. They are extremely useful, so definitely make sure you fully understand them. They will help you a ton in pretty much any game, any code you want to make. Now that we've covered interface and inheritance, these are two things that deal with a lot of types that work as different types. Now that we've done that, we're ready to handle the various ways of doing type conversion, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn some things about comparing various types. We're going to see whether they're an interface or a base class, and we're going to see how we can convert between them. Okay, so previously we already covered inheritance and interfaces. Those are two ways we have of handling an object of a certain type that also works as a different type. For example, if we have our IAttackable interface and both the enemy and the player implements that interface, if we have a field of type IAttackable, over here we can construct a new player, and yep, it works, and we can construct a new enemy, and yep, this also does work. But then let's say we have some special logic that we only want to run if the object is a player and not an enemy. For example, over here on the player, let's define a public void, player say hello, something like this. So if we have this function that only exists on the player, so it does not exist on the enemy, on the unit, on the interface, nope, only exists on the player. And over here, if we have a field of IAttackable, even though we placed a player object inside that field, if we go through it and try to call player say hello, nope, this does not work. Like it says here, IAttackable does not contain a definition for that. So it does not really matter what is the specific object that we have stored inside this variable. This variable is of this type, so we can only interact with things that exist inside of this type. If you have a field like this and you want to see if the underlying object stored in there is of a certain type or a different one, if so, you can do if attackable and then use the keyword is, and then the type is player. So we can say this, and let's do a console.writeLine just to see if this one is a player. Let's just get rid of this code for now. Okay, let's see if this one prints. And if this print, that object is indeed of type player. And if we replace this for an enemy and run, and if that one does not print because this one is no longer of type player. So this is the simplest way for how you can tell if a certain variable, if the object stored within that variable is of a certain specific type. Alternatively, on pretty much every other object, we can see we have a bunch of functions that are available to every single object, like we already saw the toString, so this one exists on every object. But the other one that is also super useful is this one, the getType. This one returns the specific type of that object. So for example, let's do a write line on this one to see what this one says. Okay, so let's print this and see what this one says. And if that one says the type, so this one is of type enemy. So here we can get an object of type type, which actually tells us the type of the object that this is. So over here we can check the attackable.getType in order to get the type contained within that variable. And instead of using is, we simply compare with the type of player. Except like this, we have an error. Because player, this is the name of the class. In order to get the type, we use the keyword typeof. And this returns the type of whatever is within the parentheses. So in this case, the player type. And yep, this now works the same thing as we saw previously with the is. So this one, this is an enemy, so this is not going to run. And if there you go, it's an enemy. But if we swap this for type player, and if there it is, now it does run. Now, one difference between this getType method and the other one using the is keyword, one difference is this one does not check for inheritance or interfaces. So if we see is of type IAttackable, which again, the player class, this one is indeed implementing IAttackable. So let's see if this one runs or not. And nope, this one does not run. So if you use this method of getting the type and using a typeof to do an equality check, if so, when it comes to interface, instead of that, you can access the function inside of this. Specifically, the function is interface. This will tell you if this type is an interface, and then you have a bunch more. You have a function for checking if it's an instance of a type. You can check if it's a subclass of something, or you can check if it's assignable to and from something. Or alternatively, for this case, for testing against interface, you can use the previous method, which personally is the one that I prefer. So just do if the attackable is IAttackable, which in this case doesn't make much sense, but let's test. And yep, it does work. But if we were to make a new player over here, let's see. And yep, it does work. Alternatively, we could test if the player is a unit, and yep, this also works. So there are various ways to test if a certain variable, if a certain object is of a specific object type. So for example, let's go back to our original demo. So testing if the attackable is a player. And if so, we want to run this specific function on the player class. Right now, even though we have identified that this object is of type player, we still cannot go here and call player say hello. Nope, this still does not work. Even though we have verified that it is of this type, we still need to convert it onto that type. And for this, we also have two options. One is using the as keyword, so let's define a player field. And for this, let's use the attackable as of type player. So if we do this and now do this, and over here, let's just print out something. Okay, let's see. And yep, it does work. It did run that. So here we convert our attackable into a specific player type, and then we can call any functions that are specific to this player type. The other conversion method similar to this one is simply casting, which we already saw when we cast some floats down into ints. So instead of using attackable as player, we just put player in parentheses and then attackable, and like this. And yep, it does work. So these are two ways for converting types, and the difference is usually related to whether the conversion succeeds or not. So for example, let's go outside of the if testing the player. Let's just comment this out. So up here, let's create a new player, and then let's create a new enemy. And now let's do a player test player, and we're going to take the enemy and cast it down into a player, which obviously this will not work. It does not work because enemy has no relation to the player itself. The enemy implements the attackable, extends a unit, but has no relation directly to the player itself. And in this case, the compiler doesn't even let us run this code. However, we can try forcing something that won't work, so let's put it in IAttackable. And up here on this attackable, let's make it of new enemy. So this one is an enemy, meaning this one will not work, but now we don't have a compiler error because technically IAttackable might be convertible into a player. It might or might not be. And if we test this, and yep, if we try to cast something that does not work, we're going to have this error, unable to cast of type enemy into player. And using the other method, so let's see what that one does. So attackable as player. And in this conversion method, we have no error. And let's just do a console.writeLine to see what is stored on that one. Let's see. And yep, it's empty, meaning that one contains null. So this is the difference between the two methods. If you use a cast and the cast fails, it is going to throw an exception. Whereas the as, if the as fail, it is simply going to store null over here on this field. So remember this difference. If you use this method in order to figure out whether this cast worked, if so, then compare this one against null. Or if you use this method, then before you do, make sure to test if the player is actually castable. Which up here, this code is normally what I do. So I just check if something is a specific type, and only if so, that's when I cast down and then do some complicated logic. Also related to type conversion, when working with value types, like for example an int, on this one, if you do some kind of thing like this, so a as float, if you do it, nope, it does not work. The as operator must be used with a reference type. That is because, like we saw, if this one fails, this one is going to return null, but a value type can never be null, so that is why the as keyword can only be used with reference types. So when you ever have this kind of thing, you only have to use the cast option. And something related that I mentioned briefly in the beginning of this course is how every type in C# is convertible down into the object type. This is the base type for pretty much anything in C#. You can convert any type into an object. So for example, something you can do is define some kind of int, then you define some kind of object, and you can place an int inside of that object, and then you can define another int, go inside the object, and cast it down back into an int. And yep, this does work. This is technically something that is called boxing, which I'm going to cover in more detail in a lecture in the advanced section. This is basically how you can convert anything onto an object and then convert it back. This topic of type conversion is also something that will be very important in a few lectures when we cover events. The default type for any kind of event is the event handler. And this one, if we inspect how it is, yep, this one has a parameter of type object. So when working with this, we're going to need to do some conversion. And usually for events, you know what type is firing this event, so you can just use a cast in order to convert this object onto whatever type you want. But like I said, I'm going to cover events in a few lectures. So with that, here we'll learn the various ways of handling type conversion. These can be very useful when combined with interface or inheritance. Anytime you need to do some kind of type checking or convert back and forth between one or two types, Now you know the various methods for doing it. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about switch pattern matching. This is how you can do a switch on a type instead of just a value. This is a super quick lecture since it's actually really simple, but I wanted to make sure you definitely know about this. Okay, so we already learned how to handle multiple types with inheritance and interfaces. Now let's see a more advanced use case for the switch that is perfect for this scenario. So in the last lecture, we already covered how to check if an object is of a certain type. So for example, if I have an IAttackable field, and I set this to a new player, then we can check if attackable is of type player, and if so, do some kind of logic. Then we could also test if attackable is of type enemy. We could check if it's of type of the red barrel. So yep, this works perfectly fine. But just like we saw on the lecture on the regular ifs, if you have to do a ton of them together, then at that point a switch is better. And actually on a switch, we can also do this kind of logic, testing if a certain field is of a certain type. So instead of this, let's do a switch and switch on attackable. And then on the case, we can add the type definition. So for example, case player, and then assign it to some kind of variable name, player. And if there it is, this is valid code. What this is going to do is if the attackable is of type player, then it's going to cast attackable onto a player type, and it's going to assign that reference over here on the player. So for example, over here, we can access the player and call a function that only exists on the player, like this one, player say hello, so this one. And yep, this should work, so let's run. And yep, exactly, it does work. So here, this is both testing a specific type, it is also casting that type and assigning a variable reference. So with this, instead of having all those ifs, we can do here case enemy, enemy, and case red barrel, red barrel. And yep, all of these now work. So now inside of this, we can put any kind of enemy-specific logic. And of course, we always have the default case, just in case it does not match anything, then it's going to run this code. Also, this actually lets you do one more thing that I actually didn't know until I did the research for this course, which is on this case, you can add extra conditions. So for example, up here on the player, let's define a int for the player health, something like this. And now up here on the player, we can use the keyword when, and then define some kind of condition. So for example, when player.health is above 50. If so, then we're going to run this and put one without it, and it's going to run this. So over here for test, let's do a console.writeLine on this. So this one health 50 and the other one is the default. Now up here on the player, let's construct it. And let's put the health on 100, so that should go inside of this one, so let's see. And if exactly goes inside that one, whereas if over here, if the health is 20, and if there it is, it only runs the other one. So this whole thing is called switch pattern matching. So as you can see, we can do a switch and then define all kinds of patterns, and depending on which pattern it matches, is going to run different kinds of code. With this, the switch can be used in tons of ways, so not just testing for a specific value. You can cast into a type and then couple it with some kind of condition, and doing that, you can do all kinds of logic on different switches. But again, always remember the number one rule, code is meant to be readable and understandable. So if you end up with a mountain of switches with tons of complex when case conditions, at that point, it's probably best to refactor your code in some way. But for simple use cases, this is really useful, especially for this kind of use case, where we have some kind of base class or some kind of interface, and we want to do some specific logic depending on what type it is. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about delegates, lambdas, and anonymous functions. Okay, so delegates, they are a really powerful C# feature. They basically let you store a function inside a variable or use it as some kind of parameter. Here is a working demo. So I can click and it spawns a chat bubble. Then I can press a button to change the action. And now if I click, yep, now it spawns a regular sprite. And now press another button. Now I click and yep, now it's spawning some particles. So the same action clicking is doing different behavior based on what action I select. Here is the code for the click actions. And the delegate is this one over here. It's something of type action. This is a delegate. And then I've got a bunch of functions defined here. So spawn chat bubble, a sprite, or a particle effect. And I can see over here on start that I'm assigning the click action to this function. So importantly, it is not calling the function. Nope, it is passing in the function itself and storing it over here inside of this field. And then on mouse click, I simply run whatever is stored inside that variable. So the variable stores a function, and then by calling this, I can run whatever function is stored within that variable. Then these buttons simply do that. They simply assign a different function onto that variable. And with that, I can click, do one behavior, press to select something else, do another behavior, and another one just like that. So this is a practical example. Now let's see the syntax. To define a delegate, first let's write the access modifier. Let's go ahead with private, and then let's use the keyword delegate. And then you write essentially a function signature. So let's make something super simple. For the return type, let's use void. Then for the name for this delegate, let's call it attack delegate. Then we add any parameters we want, or basically none of them. Okay, so yep, so just like this, we have defined our delegate type. Now we can use this type just like we can use any other type. So for example here, let's make a field of this type. So let's make it of type attack delegate. And let's give it some name like attack action. Okay, so just like this. And then, like I said, the goal is you can store functions inside a delegate variable. So over here, let's make a regular function. Let's call it melee attack. And let's just do a console.writeLine, and let's print out melee attack. Yep, just like this. Now, importantly, we need to make sure that this function signature has to match our delegate signature. So it needs to match a return type, so both need to return void, and needs to match a number of parameters, so in this case 0. So with this, yep, now we can go inside our attack action, and we can assign it to our melee attack. And again, importantly, we assign it just like this, so we assign the function itself. We do not call the function. No, this is very different. We assign the function itself just like this. So you can do this, and then basically we can run whatever function is stored within this delegate. And we do that by calling it like we call any other function, so just like this. Okay, let's test. And if exactly it ran our melee attack function. So for example, you could have multiple enemy types, each with different attacks. In order to trigger those different attacks, you would simply assign a different function onto the delegate variable. Then, like I said, the delegate can have whatever return type and whatever parameters you want. So for example, let's make another delegate. Let's make one that returns int, call it my delegate, and let's receive a string parameter. So you have just like this is the delegate reference. And like I said, when assigning something of this type, so for example, down here, let's make a field of this type, my delegate. And now when assigning it, like I said, it needs to match the function signature. So if I try assigning melee attack, and nope, we have an error. It is telling us that there is no version of the melee attack function that matches the delegate my delegate. So there's no version of this function that returns an int and takes in a string. So in order for this to work, let's go make a private static void my test function, and actually not void, so actually in here let's return an int, and let's receive a string parameter. So we have this one, and now up here we assign this to this field of type my delegate, and yep, now it does work. Let's just return 0, just fix that error. And yep, like this does work. It works because the function signature now matches, so they both return an int type, and they both have a string parameter. Also, by the way, over here you need to define some kind of name for the parameter. So like this, it's an error, so you need to define it with some kind of name. But down here, when you assign the proper function, this one does not have to have the exact same name. It needs to be the exact same type, but not the exact same name. Okay, great. So this is the basics of delegates. So up here we define a delegate, and then we assign it. So that's great. And delegates are really super useful. I use them all the time. But always having to define them before you use them, that is a little bit of a pain. So for that, C# has some really awesome default delegates that are super useful. One of them is simply called action. So let's make a field, and let's make it of type action, which by the way exists inside the system namespace. So action, let's call it my action. And we can inspect the action in order to see the function signature for this delegate. And yep, this is a delegate that returns void and takes in no parameters. So pretty much exactly the same that we defined up here. So down here, if we grab my action and we assign it to the melee attack, and yep, this does work because again, the function signature matches. This one returns void and has no parameters. So rather than having to constantly define your own custom delegate with void no parameters, if you want that, you can just use action. And then there are actually various action definitions. You can add the angled brackets. This means a generic. We're going to cover what are generics in detail in a future lecture. So this, you can see there are 16 versions of this type, and these are basically just different amounts of parameters. So you can see there's all the way up to 16 parameters. Basically on these, you can include whatever type you want for the parameters. So let's say an action that takes in an int. What this means is a function that will return voids, and it's going to have an int for the parameter. So the equivalent, for example, up here would be some kind of int like this. So this would equal pretty much this. And down here, of course, since we changed the delegate that we're using, this one is no longer valid. So in this case, we would need to make something that returns void and then takes in an int parameter. Yep, just like this, and if we assign this one to that one, and yep, it does match. So action is really awesome. It's a built-in type, so rather than having to define your delegates, you can just use this directly. The only thing is that action always returns void. So on the various versions that we saw, on the 16 versions, every single one of these is just affect the number of parameters, but they always return void, meaning they cannot return any value. If you do want a delegate that returns something, for that you have the func. And this one works pretty much the same as the action, so this one also has tons of things. So let's put in the generic in order to see all the types. And this one, as you can see, has a generic named tResult. So this is basically going to be the return type, and then has all kinds of those for all kinds of parameters. So this is basically going to return some type and then have any kind of any number of parameters. So for example, in this case, this my func, this one is of type int, meaning it's going to return an int. So let's actually define it. So let's take this one, go down here, and we're going to need to assign it to something. So let's make another function that matches that delegate. So again, this one has no parameters, and it's going to return an int. So let's make it return an int and with 0 parameters. And if we take this and let's just return 0, and if we take this and assign it, and yep, it does work. So the built-in action and func delegates, these are super useful. If you have some common use case, you can really just use these two. There's no need to define your own delegates, but defining your own delegate is also still something proper. The one big benefit is, of course, this one has a custom name. So even though this one perfectly matches an action delegate, with the name attack delegate, that makes it a bit more clear as to what the intent is, as opposed to this one func. This one has no clear intent on what it's doing. So they both have their use case, but in many ways, for simplicity, when you just need something basic that works, using func and action, those are excellent. Then for assigning a delegate, so over here we are creating something of some type, then we are creating a separate function and then assigning it. So this works. But we can also do what is called an anonymous function, or sometimes called a lambda expression. So for example, let's define a field of type action. And now when assigning it, we can just put in the parentheses for the parameters, which in this case action has no parameters. And then we do a little arrow symbol, and then let's open and close a code block. So yep, just like this. This is valid code. What we have here is a lambda expression for defining some kind of function that takes in no parameters and returns nothing. So what we have here is pretty much the same shorthand as what we have here. We can place the console write line there, and yep, this is exactly the same as this. Except when doing this, we didn't have to define a completely separate function. So these lambdas, this is another really super useful thing. I use them all the time, especially when writing any code for buttons. In Unity, buttons have a click action, and normally I just use a lambda in order to define what behavior I want when I click on a button, as opposed to having to write a separate function and then assigning it to the delegate. So lambdas are really great time savers, and you can use them on any delegate type. So over here, an action with no parameters, but if we make an action that takes an int parameter, if so, then we just need to define the int parameter over there. And if this does work, and alternatively, if we make a func, let's make a func that takes an int and returns a bool. So this one takes an int parameter, and then over here just needs to return some kind of boolean. Yep, that works. And then alternatively, if you want, you can even simplify this even further. So let's erase all this. Let's put just false, just like this. And yep, this is perfectly valid code. This is doing the exact same that we saw previously. The compiler is smart enough to know that if this delegate expects a return value, it is smart enough in order to add the return into whatever statement we write. So this is perfectly valid code, although normally, like I said, I prefer being explicit. So personally, I prefer to always write everything perfectly. Now, one interesting property about delegates is multicast, meaning how you can store multiple functions inside a delegate. So for example, let's see here our attack action. So we're assigning it to just the melee attack. Let's make another one. Let's make a range attack. And over here, if we do this and then assign it to the range attack, if we do this, and let's just get rid of the other code. So if we run this code, and if there we go, it only runs the range attack. However, instead of assigning, we can do plus equals. And now if we run this, and if there we go, now it ran both. Even though over here on the delegate, we only ran the delegate once, since the delegate itself is storing the reference to two separate functions, it is going to run both those functions whenever we run our delegate. So this means that the delegate itself, it can store multiple objects. It kind of has a list in the background of all of the functions that are stored within it. And since you can do plus equals to add it, you can also do minus equals. So let's run that one, which should run both, then do a minus equals and then print, and let's see this. And if there you go, so the first time that we ran the delegate, the first time it ran melee attack and range attack, but the second time, since we raised the range attack, we did minus equals, because that the second time it only ran the melee attack. Now, one really common use case for delegates is doing asynchronous programming and handling callbacks. If you're familiar with JavaScript, you're certainly very familiar with this. And in game development, for example, one very common use case is for pathfinding. You tell a unit to move somewhere, and you can pass in a delegate for what to do when the unit gets there. So for example, here's a basic unit class, and it has some kind of pathfinding, so it has some kind of move to function. It takes in a target position, then an action for the onReach target action. So we would create a unit, we would tell it to move somewhere, and we would pass in a delegate. So in this case, it could be a simple lambda, so a simple anonymous function. We could pass that in, then the unit would do all kind of movement, and eventually it would reach the target, and when it reaches the target, then it would call that function. And in doing so, then it would run whatever logic we set when we call the move to function. So if we test this, yep, there it is, now the unit is moving, and after a while it gets there, and yep, it reaches the target. Another common use case is when doing something that contacts a web server, so some kind of web request. I made a tutorial on that, and for that, I made the class receive a delegate for the callback that is called whenever the server responds. So delegates are super useful, extremely versatile. It can be sometimes a little bit tricky to understand at first, since they look like variables, but they're actually storing functions. If there's something you didn't understand, definitely go ahead and rewatch this lecture once again and go through the interactive exercises. This is an extremely powerful feature that you absolutely must understand. Now here I mentioned lambdas for making anonymous functions, but there's actually another way of doing something similar. We can create normal local functions. So let's learn the differences between them in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about local functions and how they differ from lambdas. Okay, so in the previous lecture we covered delegates and lambdas. Lambdas are one way to make an anonymous function. So if we have some kind of action, my action, we do a lambda by writing the parentheses with the parameters. Then we do a little arrow and a code block just like this. This is a lambda expression. However, there is another method for making anonymous functions. It's called local functions. And they're exactly like the name implies. Just like you can have local variables, so in something, so this is a local variable. Just like this, you can also define a function within another function. And you define them pretty much exactly the same as another function. So for example, void print, let's receive a string message. And then we put a code block, and inside, let's go console and write line, and let's print out the message. And if that's it, here we have a valid local function. We have this function inside this main function. Now, naturally, we cannot call this from anywhere else. So if there's another one, so another private static void. So if we have another function here, from this one, if we try accessing print, nope, this does not exist. So this is a local function, which just like a local variable, is only accessible within this function. And we saw the delegates in the previous lecture, so we can use these exactly the same way. So action, my action 2, and I can assign it to print. And actually this one takes a message, so let's do action of type string. And yep, there you go, this is perfectly valid code. So here this, and here this. Just put a string here, just make it exactly the same. So a string message like this. And yep, both this and this are exactly the same thing. Now let's see the differences. And first is really just the syntax. You can see how the lambda over here, this one does not have a name by default. The only way to reference this lambda expression, the only way is by going through the actual delegate that stores it. Whereas the local function over here, this one has a proper name. You don't need to assign this to any kind of delegate field in order to be able to actually use it. Then another thing is how the local function can be defined anywhere. So for example, I can define the print in there, and up here I can call print. And yep, this is valid code. There's no errors. Again, only inside the actual function code block because it's a local function, but I can define it down here and use it up here. This is valid. Whereas with the lambda, you cannot do this. If I try accessing the my action, nope, obviously there's an error. I cannot use a local variable before it is declared. Whereas for the local function, that one works just fine. The difference for this is because local functions, these one are defined in compile time, whereas lambdas, these are defined at runtime. So because of that, the compiler knows that this function is coming, so it can use it, but this one can only be used after it is declared. Also importantly is how the delegate over here, the lambda, this anonymous expression, lambdas are actual objects that are declared and assigned at runtime. They are actual objects that exist in memory. So every time we run this my action, every time we do that, it is going to create a brand new object. Every time we run the main function, every time we do it, it is going to create a brand new instance of this object. It's going to create a brand new lambda. Whereas local functions, these are defined as compile time, so in memory they only exist once. So we could call the main function 100 times, and it would create 100 instances of this lambda, but only one instance of this print function. So in terms of memory, if you're memory limited, then local functions would be a better option than using lambdas. So in general, both local functions and lambdas serve a somewhat similar purpose. They allow you to define functions whilst inside another function. Local functions can be great for organizing logic within a function, assuming whatever you're doing in that function is only ever done within that other function. And lambdas are great for super quick things like assigning logic to a button click. For the most part, personally I really only use lambdas, but local functions also have their use case. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn all about events. This is another extremely powerful feature of C#. It helps us write much better code with much fewer dependencies. Okay, so events. This is basically how you can have one class, and that class fires off events when something happens, and the subscribers that listen to that event, those will be notified whenever that event happens. For example, here's a working demo. So there's a tower and I can click to damage it, and by using events we can have some kind of health bar, and that health bar is listening to when the tower takes damage, and when it does, the health bar listens to that event and updates its own state. So the UI element over here, this one is listening to the build damage event itself, and then updates the health bar. Events have publishers and subscribers, or sometimes subscribers are called listeners. Those two terms are really used interchangeably. The event is defined within some kind of class, and then you can listen or subscribe to that event from anywhere else. Now what that means is that when the event is invoked, all of the subscribers, those all get notified that the event happened. And note how this relationship only goes one way. So the subscribers attach to the event in order to be notified, but the event publisher, this one has no idea that there are any subscribers. This is really excellent for keeping your code decoupled. The event publisher does not know and does not need to know if there are any subscribers at all. Maybe there are some, maybe there are none, it does not matter. the event publisher itself is completely decoupled from any subscribers. As far as the event publisher knows, it just knows that it fired off an event. That's it. It does not know and does not care if anyone is listening. And the other benefit of using events is that our code can be based on when things happen as opposed to constantly polling for something. For example, over here on this demo, the health bar does not have to constantly poll the tower to check its health state on every single update, so it does not have to ask that question 60 times a second. The health bar is perfectly idle. It only listens when the event is published, so only when something actually happens does the health bar take action. Here in the code, the tower script, this one has an on-damage event. Then this demo is really super simple. I'm just testing for the mouse click, and if so, calling the damage function. And damage function simply alters the health amount and fires off the event. Again, note how this tower does not know anything about any kind of health bar. It is completely decoupled. And then on the health bar itself, this one does know that tower exists. It attaches itself to the on-tower on-damaged event. And when that event happens, it simply updates the health bar. So in order to show how the code is decoupled, I can just go ahead and get rid of the health bar. So I can just disable this game object, and yep, everything does work, because the tower does not depend on the health bar. Okay, so that's a quick overview of events. Now let's see the syntax. And the way that we make events is actually super simple. This lecture will be really easy to understand because we already learned about delegates, which are quite closely related to events. First, we write our access modifier. And usually for events, you do want them to be public. You want it public so that any other classes can listen to that event. It doesn't make much sense to have one event that is only listenable from that class, so usually events are public. And then we add the keyword event, all lowercase. This is a special keyword. Then we add the delegate. And like we covered in the delegates lecture, we can define our own custom delegate, or we can use the built-in action, for example. So let's use this one just because it's so easy. And then we give it some kind of name. Usually the convention is to start your event names with on, and then whatever happened. So for example, on player damaged. Simple like this, and in terms of naming rules, events are usually Pascal case, just like properties. Okay, so great, so just like this, we have defined our event. Now let's write a quick demo, just see how it works. And for that, let me actually just put this inside a basic player class, just so the demo makes a little bit more sense, so put it inside there. And now let's make some kind of damage function, so let's call it damage. And now here, the first thing we can do with our event is simply fire it. And for that, we do it pretty much as if this was a normal delegate and we were just calling it. So let's go on player damage and simply call it like this. So that's it, super simple. However, this code will actually throw an error, but let's test it like this. Up here, let's just create a new player. Just construct a brand new player, then on player, let's call damage and let's test. And if right away we have an error, we have a null reference exception. So this has to do with the fact that this event currently does not have any listeners. If it has no listeners, then this field is essentially set to null. So before invoking an event, we need to check if it has some listeners. And we can do that just by checking against null. So if the event is not null, if so, then that means it has some listeners, so we can safely call that event. So like this, if we run, and you have no errors, although also nothing happened. So now that we are correctly firing off the event, let's add in listener. Let's make another class. Let's make it a class and call it player health bar, something like this. And now in order to listen to the event, we need some kind of reference. So let's actually make a constructor for our player health bar. And in the constructor, let's receive an object of type player. So we receive that, and now here we can go through the player. And now we can indeed access the on player damage event. Also here in Visual Studio, it shows this little lightning bolt. This means an event. So we can access that event, and then we can do plus equals in order to subscribe to that event. And here, by the way, Visual Studio has this really nice shortcut. It is going to auto-write the player on player damage event. So just press tab to insert. Usually I do this. Then if you want, you can rename it or just press enter, and yep, there's our event function. Now, if you don't see this shortcut, or if you're using a different ID, you can just manually write this function. It's a pretty basic function. The only important thing is, just like we covered in the delegates lecture, the function signature needs to match the event signature. So in this case, for the event, we made it of type action, which means it must return void and must have no parameters. Okay, so here we are listening to the event. Let's just do a log, so console.writeLine. Let's just print out the on-player damage event, just like this. And now up here, let's construct our player health bar. So let's construct a brand new one. Let's make it. And this one requires a reference to our player, so let's pass it in. So first we create the health bar, and then we call damage on the player. So now basically what will happen is when we call damage, the player damage, this one is going to fire the on player damage event. It is going to check against null, and since we have a listener, this one is not going to be null, so it is going to run our event. And by running that event, it is essentially going to run this code and print this line. So let's see. And if there it is, the event was fired and the listener did listen to that event. All right, awesome. Again, note one of the big benefits about events. The player class, this one has absolutely no relation to the player health bar. So the player class is completely decoupled from the player health bar. As opposed to, for example, if we were to make this public, and then up here we would have some kind of private field of player health bar, then we would need to keep this reference, and in doing those on the damage, we would call the player on damage function. If we did this, then the player class would be tightly coupled to this one. So for example, if I remove this one, obviously there are errors because this type no longer exists. Whereas if we go back to what we had previously, here is just the event, here is just the player class, and if I completely remove this one, yep, there are no errors inside the player class. This is what it means to be completely decoupled, is that the player class does not know and does not care if anything listens to that event. If it does, then great. If not, then also great. Then one important thing about events is how multiple classes can listen to one event. For example, if over here I make another one, let's make this a mana bar. So do it like this, do it pretty much the same, and over here let's say mana bar something. And then up here, if we construct a new of type this, if we do it, then now we have two listeners to this event. So when this fires, it is actually going to run both of these listeners. And if there it is, both of them did run. So events can be listened to by multiple listeners. And then over here, we are subscribing. But if you want at some point to stop listening to that event, you can simply swap the plus equals to minus equals. And yep, with that, we can unsubscribe. And at this point, I should point out that unsubscribing to events is actually very important. If you don't, then you might end up with memory leaks, depending on the lifetime of the object. If the listener gets destroyed, but the publisher lives on. If so, then it will actually keep firing events onto a listener that no longer exists. So that could cause all kinds of issues. So always keep that in mind. Either pay attention to the lifetime of the objects, because if the player has the same lifetime as this one, then technically you don't need to unsubscribe. But if they do have different lifetimes, if so, then when this object gets destroyed, make sure you unsubscribe to that event. So yep, we can either do plus equals or minus equals to subscribe or unsubscribe. And on the class that defines the event, we can also call the event. And now right away, you might be thinking that this looks exactly like delegates, especially the delegate multicast function. And yep, that's right, this is indeed very similar to delegates. In fact, if over here I just remove the event keyword, if I do, nope, nothing changed, there are no errors. And if we run this, yep, everything still ran exactly the same. So technically it works like this. However, adding the event keyword had some really useful limitations. First of all is who can trigger that event. If we do not add the event keyword, then anyone with access to this event can invoke it. So for example, down here on the player health bar, I can go on there, call it, and yep, this will work. So this player health bar will be invoking this event. Usually you do not want this. You want the class that defines the event to be the only one that can actually invoke the event. And if you add the event keyword, then the compiler actually enforces that rule. So yep, down here, nope, it cannot call it. The event can only appear on the left-hand side of a plus equals or minus equals, so subscribing or unsubscribing, except of course when used from within the player class, within where the event was defined. So the event keyword is really nice for essentially protecting you for yourself. Remember how the main clean code principle is simply minimizing complexity. So the more you minimize access to a particular field, the better it is. Another limitation that this keyword adds is simply the ability to clear the event. So again, if we remove it, then for example, down here, the player mana bar, this one can go into the event and set it to null. And if we test the code like this, yep, look at that issue. Basically, the mana bar completely erased the original event listener. So the player health bar, this one no longer listens to everything because this one pretty much broke the code. Again, this is something you don't want to happen with events. And again, this is something that just by adding the event keyword, the compiler will help you by enforcing some rules. And yep, like it says here, once again, same thing. By adding the event keyword, the only thing you can do outside of that main class, the only thing you can do is subscribe and unsubscribe and nothing else. So in many ways, events are indeed pretty much delegates, since they in fact actually they use delegates. Like we saw here, we are using the action delegate. But the event keyword, that one adds some really nice limitations to basically protect the code from yourself. And of course, since he used delegates, we can use anything more than just a simple action. If we want to pass in some data for the event, we can really just use a delegate with parameters. So for example, let's use an action of type int. And then over here, when we call the event, we can pass in any kind of int value. And then down here on these, in order to listen, again, the listener function needs to perfectly match that one. So if this one expects an int, then over here, we also need to put an int. And yep, like this, it will also work. And the parameter over here will be whatever you do when you call the event. Now, another thing is over here, we've been using the action delegate. You can use whatever delegate you want. You can build your own delegates, or you can use action, the built-in type. But in general, the C# standard is to use the event handler, this one right here that exists inside of system. This one has a signature where it takes in an object for the sender and an event args. So usually when invoking the event, for the object sender, you pass in this. So you can pass in a reference to whatever object was firing that event. And for the event args, if there aren't any, you can just use the constant event args.empty. So yep, just like this. But again, this is not a requirement. Like we saw, you can use pretty much any delegate you want. You can use action and everything works just fine. But generally, this is the C# standard. If you see a bunch of C# code, chances are they're going to be using the event handler. And then this one actually has a second parameter, that defines what are the event args. Again, that parameter is also used with generics, so let's open up that one, and yep, it has a type of event args. So while following the standard, if you still want to pass extra data, you can. For that, usually you make some kind of class that extends event args. So here, let's make a class, and usually the standard name is to give it the same name as the event, so on player damaged, and then you simply append event args at the end, and we make this a class that extends event args. Simple like this, and then over here we add whatever parameters we want. So like for example, in this case, maybe we would have like previous health, in order to know the previous health before the player was damaged. And then over here on the event handler, we use generics and we pass in our custom type just like this. And then over here, when we invoke the events, instead of event args.empty, we just construct a new object of our type and add whatever data we want. So yep, just like this. And again, on all these other ones, of course, we need to remake the function signature in order to perfectly match. And again, this is something that Visual Studio does by default, so just do plus equals, and it's automatically going to write with the perfect event signature. And over here on this one, in order to access that data, that is going to be over here on the second parameter. So we can access E, and then inside we've got the previous health, and we can do whatever we want. Also, one of the first things we saw is over here, if we do not add this null check, if we don't, then this is actually going to throw a null reference exception, so you always need to check for null. However, there's a special way to make this code a little bit more compact. So you've got the event, and again, just like this, going to fire off null if we have no listeners. So what we can do is we can use what is called a null-conditional operator. I'm going to cover these in more detail in the advanced section, but basically we can just add a question mark, and basically this will mean that the code to the right side, this code will only run if the code on the left side is not equal to null. So we can do the question mark and then call invoke, which is basically going to invoke the event, and just like this. So again, the question mark basically means that it's only going to continue executing code to the right if the code on the left does not equal null. So if this one is not null, if we do have listeners to our event, then we are going to invoke the event. So instead of having a normal test for null, usually with events you have this kind of syntax. So you just do a null-conditional operator and call invoke and invoke that event. Now, one of the best things about events is what I mentioned already about code decoupling. That truly is one of the magical powers of events. It's how the event publisher does not know and does not care how many listeners there are to that event. It simply fires off the event and does not care what else happens. Then all the listeners, if there are any, they will listen to that event and do whatever logic they want based on that event. This is really a crucial thing about events. Decoupling your code as much as possible is one of the best rules you can follow in order to write better, clean code. And like we saw, this is especially great when games, when working with the UI. Usually you want your UI to display your game logic, like for example the health of some kind of tower. You want some kind of visual for it, but you also do not want the tower itself to be dependent on some kind of visual. In theory, your game should work entirely without any UI. And by using events, this is really simple. You can just make it so, for example, over here the tower class just fires off some kind of event, and then maybe we do and maybe we don't have some kind of external display on top that displays some data based on that event. If the UI exists, then great, but if it doesn't, then the tower works just exactly the same. So events, as you can see, are extremely useful in helping you write better, more performant, and more decoupled code. Definitely make sure you fully understand them, which if you fully understood everything in the Delegates lecture, hopefully you managed to quite easily understand this lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about generics. This is yet another really powerful C# feature. This one lets you write code that can be used with a multitude of types. Okay, so let's learn about generics, and we've actually already seen them in action in a bunch of places. For example, quite a long time ago we learned about list, and the list, this type requires putting another type within those angled brackets. This right here, for example, list of int, this is what is called the generic. The list type works with generics, which means it can work with any type. So we can make a list of ints, we can make a list of strings, we can make a list of program types, and so on. If it did not have generics, then we would need to create a separate list class for every single type we wanted to use it with. That would definitely not be very fun, not very easy to use. Whereas with generics, we just define the list class just once, just one time, and then that class can work with any type we want. Also, same thing when we saw the delegates. So we saw, for example, the action, and we saw this one has all kinds of parameters. So we can have an action that takes in a parameter of type int, we can have a type string, we can have a type bool, and so on. Same thing for the func. So again, there's no need to create a specific action class that works specifically with an int, another one specifically with a float, and so on. The action class itself, that one is made to work with generics. It takes a generic t type, and that type can be whatever you want. Now, one of the best practical examples of how useful generics are is actually my grid system playlist. I've built a ton of interesting systems and games on top of that base system, and the reason why I could do that is because the grid system itself, that one is made to work with generics. Here is that class, the grid class with generics. Here it works with a generic type that I named tGrid object. So I can define a specific grid that works with a specific type. Again, it could be something simple like an int, a float, bool, and so on, or it can be a specific custom grid object class that I define. And with that grid object, I can place whatever custom data I want, and the grid system will work perfectly with it. So I don't need to make a brand new grid system for every kind of thing that I want to do with a grid. I just use the exact same grid system for any type, and by writing this class using generics, by doing that, I managed to reuse this base class and build all those complex systems that I made in all those videos. So how we make a generic class is actually really simple. We just write the class name as usual. For example, let's make our own custom list. So let's make a class, let's call it myList. And then we put our angle brackets, and inside here we give our generic type of name, and technically you can give it whatever name you want, there's no rules here. However, usually the convention is to name this T for type, and alternatively if you have multiple types, the convention is to use T, and then perhaps a number, so T1, T2, T3, so this is what the action uses. Or alternatively, if you want a more descriptive name, usually, once again, you would still start the type with T, and then pass in something like, for example, T-unit. Another example of generics that we've also already seen is the dictionary. And if we look inside the dictionary, yep, this one named the generics T-key and T-value. So yep, you can write whatever you want, but over here, let's just write a T. So just like this. So here we have our class with a generic type. And now inside of this code, we can use the type T. So for example, let's make a public field of type T. So yep, just like this. Now importantly is how T doesn't really exist. We don't have any class named specifically T. T is really just a name that we defined. This can be whatever class we're going to use it with. So when we use our myList with of type int, then this field will be an int field. So this is our basic class, and now up here we can make a new, let's create a new myList, and then for type, let's go with int, just like this. So this is a myList of type int, and over here we can go inside, access the field, and yep, note how this field is indeed of type int. And yep, so this does work. Then for example, let's say we want this class to work with bools. Again, since we are using generics, we don't need to make another class definition. We can just go up here, make another myList, in this case of type bool. Let's name it by myList, and then do a new int of bool. And now we can go inside, we can access the field, and yep, this one is now a field of type bool. So over here we have two instances of our class, and each of them is working with a different underlying type. Then in our generic, we define our type T. We're using it over here in the field, but we can also define some kind of functions. For example, let's make a private void my function, and we can receive a parameter of type T. Or alternatively, we can make it return of type T and take in no parameters. Also, by the way, one quick tip, since over here we do not know what type T is going to be, since we don't know that, then for example, we cannot return null. This does not work. And the reason why it does not work is because T technically could be a non-nullable value type. Like for example up here, when we are creating our list of ints or bools, these are not nullable values. These are value types, not reference types. So because of that, over here we cannot return null. So if you do have some kind of logic that is meant to return a default value, instead of returning null, instead of that, you can use the keyword default, and this will return either null on a reference type or the zero equivalent on some kind of value type. So for example, let's do this, let's make it public, and then up here, let's call it. So let's call my function, let's put a right line on this. Let's see what default value is for both these, so let's see. And if there it is, the default value for an int is 0, default value for a bool is false. Then on the generic definition, over here like we saw, we can already define more than one type. So we can define T1, T2, T3, and so on. We can do this, and then we can use different types in our code. This works. So here we have our generic class, but we can also use generics without making an entire class generic. We can have just a single function. So over here, let's make a test function. And on the function itself, let's make that function work with generics. The way we do it is really the same thing. So after the function name, we put the angle brackets, then some kind of generic name. And now we can use this type in any way. Like for example, use it over here for a parameter, or we can use it for the return type. And yep, everything works exactly the same. Over here, let's do a console.writeLine. Let's print out P. And for example, up here, let's call out this one. And we can call in with an int. And yep, this works. We can call in with a string. And yep, it also works. Call in with a char. Yep, this works. Call in with a boolean. And yep, this also works. So here we have a function. The function was defined with generics, which means that we can run this function with whatever type we want. Then you can also make structs that use generics. So instead of a class, this can be a struct. And yep, structs can also use generics. Another one is also on interfaces. So up here, we can define an interface, my interface. And on this one, we can also use a custom type. And then we can use this type, like for example, some kind of function that returns of type T. Yep, this is also valid. So lots of use cases for how you can define generics and how you can use them. Another extremely useful thing we can do is simply apply some type constraints to t. Right now we have no constraints, meaning this can be used with any type for the generic. It can be ints, bools, some kind of custom player class, it can be literally anything. Now let's say, for example, we want this one to only work with classes. For that we can go over here into the class definition, and afterwards we write the keyword where, and then our generic type, so in this case t, and then put a colon, and then let's say, for example, class. Meaning that this type MyList can only be used with a t type as long as that type is of type class. So like for example here we see some errors because ints and bools, these are not classes, so we cannot use with those. We need to make some kind of class for some kind of player, and now up here we can make this of type player. And yep, no, this does work. And again, the issue that we saw a while ago on how we cannot return null from this one. But if we do enforce that t has to be of type class, classes can always be null, so now we can indeed use null here. Then another interesting constraint is, let's say for example we want to construct whatever type we use here. And right now if over here on this function, if I try to do new t, if I do this, nope, there's an error. Again, same thing, we cannot do it because we have no guarantee that whatever type we use here, whatever type we use has some kind of constructor. In order to make that work, again, we can apply another constraint. In this case, this one is named new, just like this. So now we can use this class with any generic type as long as that generic type is a class and has a parameterless constructor. Which over here, the player by default has some kind of parameterless constructor, so yep, this one is perfectly valid code. And over here, yep, we can do new t in order to construct a brand new player. For example, we can put this on that one, and this one is going to construct a new object of type t, which in this case is going to be the player. So when we run this, it should say something of type player. And if there it is, it's done like that. There's a bunch of really useful constraints we can apply to our generic type. There's a great list on the C# docs. We can see how we can force t in order to be of type struct, of type class. We can ensure that it is a non-nullable type. We can ensure that it has a parameterless constructor. Or one of the most useful ones are simply these ones, basically requiring t to extend some kind of base class or implement some kind of interface. And all of these work on a class definition, but also over here on just a single function. So again, where t is a class, and now it ensures that we can only call this function with a type that is actually a class. And when using the one that enforces that it extends some kind of interface, for example, let's make a function get attack winner, and let's receive two types, t1 and t2. Or actually, let's give it proper names, so t attackable and t defendable. Then we receive those. So we can enforce that t attackable does have to implement the IAttackable interface. And we can enforce that t defendable has to implement the IDefendable interface. And now since we've applied these constraints, because of that, now we can assume some things about these types. For example, we can go inside our attackable object and we can call get attack points. Then we can go into the defendable and call the get defense points just like this. Now with this, if we had a player type that implements both these interfaces and a unit enemy type that also implements both of them, if so, we could call this function and pass in either two players or a player and an enemy or two enemies. And all of this logic would work because all of them match the perfect generic constraints that we have. So that means that this function, this single function, is really adaptable and can be used with a ton of different types. Whereas if we were to remove these, then nope, we cannot access these functions because we have no guarantee that whatever types we use here will actually have these interfaces. And generally, one of the best benefits of generics is how they make your code type safe, meaning they help you avoid errors when using incompatible types. For example, let's say we have some kind of resource, so we have a type for gold, a type for wood, and then we have an inventory class that takes in a generic type. So then up here, we created different inventories, one for gold, one for wood. If we go inside the gold inventory, and we try to add, and let's try to add some wood. If we do this, then nope, obviously this one throws an error. This is how generics help us by making our code type safe. If we make an object of a type, and we define that this one only works with gold types, if so, then we cannot add some wood on there. The type itself is going to be forced as soon as we create the object, and we cannot break that rule. Alright, so those are generics. It's another extremely useful C# feature. I use them all the time. They are super useful for making your code really adaptable. So definitely make sure you fully understand this and make sure you use it whenever you need to. This is really powerful, but also for beginners might be a little bit confusing. So if you feel a little bit lost, maybe go rewatch this lecture one more time, maybe go inspect the demo, and definitely make sure you do all of the interactive exercises. This is a really powerful feature you definitely must know about. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about constants and the read-only keyword. Okay, so normally we have regular variables, like for example int age, and a variable, just like name implies, the value inside of it can change. They're intentionally supposed to be modifiable, so over here I can set it to one value and then set it to another value. Yep, this works. But sometimes you really don't want something to modify. Some things are meant to have some kind of fixed value. Like for example pi, it has a fixed value, and in C# you can actually see it with math.pi. Yep, there it is, 3.1415926 and so on. And note over here how this one is a constant, meaning it always has this value. You cannot change to something else. So if here I put it to just 3, nope, this does not work. I cannot assign this to anything else. It's a constant, meaning the value is always going to be fixed. So I need to define some kind of field for something where the value should never change, like for example, some kind of float for some kind of player speed. If we set it like this, then this is a perfectly regular field, so we can read it and we can modify it. In order to make it a constant, we just go here and we add the keyword const. And if there it is, and now we can use this field whatever we want, and this is always going to have this constant value. We cannot modify this. By the way, for the name, like I mentioned in the naming rules lecture, usually constants are uppercase, snake case. So everything is uppercase and split all the words with an underscore. And of course, since constants cannot change, then we have to assign some kind of value. So if we define something as constant, we have to define it with some kind of value. Okay, so yep, this is our constant. And constants are also basically static by nature, meaning they do not belong to any instance of any class, they belong to the class itself. So for example, over here, we're working inside the static main function, and usually we can only access static members. So if this one is just a regular field, if it is like this, then over here we cannot access the player speed. We cannot access it because this one is not static, but by marking something as const, that makes it essentially static by default. So over here we can do console.writeLine, we can print this out, and up here we can indeed access player speed. Also importantly is how constants, they are set at compile time, meaning the value has to be evaluated and defined during compilation, not during runtime. So that means constants are also somewhat limited in what types you can use with them. For example, we cannot make some kind of class. Let's make a class player. So we have this, and now up here we cannot make a private const of type player for the player. We cannot do this because we need to assign a value. And if we construct a brand new player, nope, this does not work because this line would only run during runtime and not during compilation. So for the most part, const can only be used with the built-in types, so things like float, bool, we can use string, and so on. However, classes, custom classes, or even default ones like for example object, these cannot be const. So constants have a bunch of limitations, but for example, if we inspect the vector3 struct, so let's go inside of this one, so let's right click, and over here let's go to definition. So here it is, the vector3 struct, and if we scroll down, we can see it has some things that look kind of like constants, like vector3.0 or .1. But again, a struct cannot be constant, so note how these are not constants. Instead, these are statics, and this is actually a property and only has a get and always returns the same value. So this is one of the workarounds you can do if you're trying to make a constant of a type that cannot be constant. Alternatively, there's another really interesting workaround. You can build something similar to a constant by using the keyword read-only. So let's define a field, and instead of making this a constant, let's make it a read-only. And if this one now does work, we don't have any more errors. What read-only means is that these fields cannot be changed after they are set. So if we try down here assigning it to a brand new thing, nope, does not work, this throws an error. So if you mark something as read-only, it can have some kind of object type, but it must be set either over here directly in the declaration, or it must be set in some kind of constructor. This one works with any type, so it can be custom classes, or it can also be the built-in types like int and so on. It can still be useful to use read-only instead of const even for these basic types. Like for example on the player class, over here let's say each player would have a different kind of maximum health, so they would have a private read-only for the health max, and then on the player constructor we could receive a certain health max, then assign the health max onto this one just like this. Meaning that this would sort of act like a constant, meaning we cannot change it afterwards. But this way, by using the read-only tag, basically we can set it to a different value and does not have to be set directly at compile time. So that's really the main difference between these two. For any data that you never want to change, and any data that can be defined at compile time, for those you can use const, and if not, you can make it read-only. Once again, remember the main goal behind writing good clean code. The main goal is minimizing complexity, and the best way to do that is minimize how many things can change. So if something is never meant to change, then either just make it a constant or read-only. Doing that will help you make your code much easier to understand. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about exceptions, as well as how to handle them and fire custom exceptions. Okay, so exceptions, these are really errors, we've already seen them a bunch. For example, here's some code that is going to throw an error, so I define an int a variable with the value 0. And then I just do 1 divided by a, so 1 divided by 0. You can never divide by 0, so this is going to throw an error. Let's try running. And if there it is, right away, divide by 0 exception. So when you hear the word exception, think error. Now, if I were to write some logic after this, like for example, let's say console.writeLine, let's print out something. So let's try running. And nope, that message does not run. As soon as the code gets to the exception, it stops executing. That's where exceptions are meant to do, but sometimes you don't want it to happen. Usually if something goes wrong, you want to know that something went wrong, but then you also want to handle it. So usually you don't want to have unhandled exceptions. So the way that we can handle exceptions is with a try block, meaning we write the keyword try and then put a code block. And inside that code block, we put whatever code might fire some kind of exception. And then to make this valid, we need a second piece of code, which is called the catch. But first, let's run it just like this. So this is still going to throw an exception. This is still going to throw an error dividing by 0. But now let's see if this line does run. And if there we go, it did run, and we do not have our exception. Now technically the exception still happened. It really just happened silently. For example, if we were to put a log over here inside after our exception, just say something, and we're going to see how this log does not run. And if that one does not run, only this one down here. That's because this line is still throwing an error, so it stops executing anything afterwards. But since we put it inside a try catch, because that as soon as the error happens, basically it's going to drop into after the try. But like I said, usually you want to handle exceptions, not really just ignore them. So for that, over here on the catch block, we can add some parentheses and we can put some kind of exception type. For a general catch-all, you can just use the exception type, then give it some kind of name like exception. And now inside of this object, over here we have a ton of data related to that exception. We can see the message, the stack trace, the source, and so on. So for example, over here, let's do a console.writeLine. Let's print out the exception.message. And then let's also print out the exception, let's say the stack trace. Okay, let's see. And if there it is, that one did find an exception. So attempted to divide by 0. And found in our program on line 19, which yep, it is exactly that one. So yep, with this we are catching our exception. And you can also add multiple catches. You can add different ones to test for specific types. Like for example, let's add another catch. And for this one, let's test for the specific divide by 0 exception. Except one important thing about having multiple catches is how it's going to go from top to bottom. And since every exception always extends from exception, this one is always going to run first, so this one is never going to run. So let's put the specific one before the generic one. Another thing, if we don't need any data inside of our exception itself, if we just want to test out what type happened, if so, then we don't need to give it any kind of value. So just like this, it's going to work. It's going to catch an exception of this specific type. So let's do a console.writeLine. Let's print out our divide by 0 exception. Okay, let's see. And yep, exactly like that. So we have our divide by 0 exception, and then the code continues running downwards. Okay, great. Also, another thing you can add is after the exception, you can add the when keyword, and over here we can test for some kind of condition. So for example, when exception is of type divide by 0 exception. So if we do this, then yep, same thing. This code is going to run pretty much the same thing as this one. So it gets an exception, stores it in here, and tests out if it is this type, and if so, it's going to run this one. So here we have a try and then a catch, but there's yet another block that we can add, and that one is the finally. You add this one after the catch, and basically over here, the code inside this code will always run. So let's do a console.writeLine, and let's say finally. And for example, up here, let's make sure it doesn't go inside of this catch. So let's put when exception, let's make it of the type that isn't going to happen. So let's say, for example, the argument out of range exception, okay, like this. So this one is not going to run, but we're going to see how the finally is still going to run. So the finally always runs no matter what. So like this, if we run, yep, we do catch our exception, then the finally runs, and then the hello there. So now you might be thinking that the finally works exactly the same thing as down here, so we could just put this in here and it would work. But one difference is on the finally. Over here, when we catch our exception, let's say, for example, we want to end this function, so we call return, and let's see what this does. And if we call return, meaning this function is going to terminate, so it is not going to continue running afterwards. However, even though we are returning, even though we still get the finally message. So this finally block runs after the catch every single time. So usually the finally code block, this one can be really useful if you need to do some kind of cleanup code. For example, if over here on the try, you were opening up some file for reading, you want to make sure that if you do open up the file, even if there's any kind of errors, you want to make sure you do clean it up. Also, by the way, you don't need to add the catch, so you can just do a try finally, and yep, this also works. Okay, so this is how we can catch exceptions. Now to throw them ourselves, we can also do that. For example, let's say we have our custom class for our player, and then over here in the player constructor, and then let's make a test function. And on this function, we want to spawn some kind of exception. So the way we throw an exception is with the keyword throw, and then whatever exception we want. Like for example, let's just throw a regular exception. So just like this. And for this one, you can open it up just like this. So just make a regular empty exception, or you can give some kind of message. So for example, player exception. Okay, so yep, just like this. So now up here, let's remove our previous testing code. And now let's create a new player and go inside the player and call test function. Okay, let's see. And if there it is, that one did fire off a player exception. So if you want to throw your own exceptions in your own code, this is how you do it. Just use the throw keyword. And then you can even make your own exception type. For example, let's make a class. Let's call it invalid player name exception. The only rule is that we need to extend from exception. So just like this. And over here, instead of spawning a general exception, we can do our regular one. So just like this, let's run our code. And if there it is, exactly like that. So exception of type, and of our type, invalid player name exception. Also, one more thing is, for example, over here, if we do a try catch, sometimes you might be running this inside some kind of function, and that function might be calling some other function that might throw an exception. So essentially, you've got functions within functions. And sometimes you want to basically just keep throwing the exception all the way up the call chain. So if you want to do that, you can just call throw, just like this. And this is basically going to rethrow the exact same exception. And if there it is in this case, since we are throwing once again on the main, then we end up with a regular exception. So by using the try catch to handle exceptions, you can make your code a lot more robust. For example, when making a game, you really never want the game to crash. If something goes wrong, like for example, the player somehow has 0 items and it causes a divide by 0 exception, if that happens, you really don't want the code to break, you don't want the game to crash. So if that happens, you probably want to have that in some kind of try catch block in order to catch the exception and handle it in some kind of graceful way. And especially when working with some external code, like for example contacting some API on some web server, for those you really want to add try and catch in order to make sure that your program continues running correctly regardless of what the server applies. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about enumerators, how to implement IEnumerable and IEnumerator. Okay, so something we've already seen several times is doing a simple for each on a list. So we can do a list of int, some kind of int list. Then we just construct a list and we can do a for each int I in the int list. And yep, this works perfectly. So we can do a for each and cycle through every element in our list. But then if we try doing a for each on some kind of custom type, so for example here, let's make a player, new player, and then let's try doing a for each on this player. And nope, this does not work, we have an error. Like it says here, the for each statement cannot operate on variables of this type because player does not contain an extension definition for getEnumerator. In order to make the for each work with custom types, for that we need to make our custom types enumerable, so let's learn how to do that. For example, let's define a class for holding a single stat, so some kind of name and value. So just name it stat, and inside just have a string name and just an int for the value. And then let's make a class to hold a bunch of player stats. So class called player stats. And over here, for example, let's have some fields of type stat. Let's say for dex, for strength, wisdom, and so on. So yep, just like this, let's just construct these objects. Okay, so yep, just like this. And now let's say that we want to do a for each, and we want the for each to work on our player stats. So basically we want to be able to cycle through each one of these stats individually. So to do that, the first thing we need to do is over here, let's implement an interface. Let's implement the IEnumerable. This one takes in a generic. So let's say our generic type is going to be of type stat. Yep, just like this. So now we can implement this interface. So it requires us to implement those two functions. This requires us to do something that constructs an object of type IEnumerator. So enumerable and enumerator, those sound similar, but they are different. So let's make a class that is going to be our enumerator. Usually for that, we build it as a nested class. So up here, let's make that. So the player stat enumerator, and we're going to implement IEnumerator, and again, also of type stat. Then let's see what we need to implement on this one. So over here, let's select, and then over here on this little light bulb, let's implement this interface. So yep, there you go. Now we need to implement all of these. And over here, we just need to handle some kind of index. And based on the index, we're going to return either of these ones. So that means we also need a reference to our player stats object. So let's make a constructor here. And on the constructor, let's receive our player stats. So you have this, let's store it inside. So just like this, we have our player stats. And then we also need some kind of index in order to know the move next, the current, and so on. So let's do an int for the index. And for the index, let's default it to -1. The reason for that is because the for each is going to call the move next before it grabs the current. So let's start off at -1, and then on the move next, that's pretty simple. So let's just do index ++. Then since we have just 3 stats, so this one is going to be index 0, 1, and 2. Because that over here, if the index is bigger than 2, if so, let's just loop back to -1. Then this one needs to return true if the enumerator was successfully advanced, and false if it has passed the end of the collection. So we can just return if the index is not -1. Okay, that's our move next function. To dispose, we don't really need to implement that one, and the reset, we can just set the index to -1. So what's important is over here the current. This one is a property, so let's go ahead and implement this property. This one is going to have a get, and on the get, we're simply going to test out our index. So let's do a switch on our index. Let's add a default and let's add a K0. So K0, let's return, go inside the player stats. And on index 0, let's return, for example, let's go up here. Let's see. So the first one is dex. Then Ks 1 and 2. For this one, let's return strength. And this one, let's return wisdom. Okay, so yep, so that's the current. And over here for this other current, we can just do a pass through onto that one, just like this. So yep, this is our enumerator class. So we receive our player stats. So we have the original object. We have some kind of index. Then on move next, we just increase the index. And on current, we just grab the value based on that index. So now up here on the get enumerator, we only just need to return a new player stats enumerator object. And on that one, we need to pass in this. So just like this. And on this one, again, same thing. We can do a pass through function. So return get enumerator. Okay, so now finally up here, we can construct, let's construct an object of this type of our player stats. Let's construct a brand new object. And now, yep, now we can do a for each on that one. This one is going to return a type stat in our player stats, and let's just do console.writeLine on our stat. And just to be able to see that, let's go inside our stat. So inside this one, and let's just override our toString, and let's return the name and then the value. Okay, so just like this, let's test and see if our for each is working and if it's going to go through all of our various stats. And if there is exactly like that, so it did a for each through our custom type, it found dexterity, strength, and wisdom. All right, awesome. So this is how you make your custom types work with a for each. You just need to implement both of these interfaces. Just do that, do some basic logic in order to grab the current value. And with that, you can then use your custom types inside a for each. By the way, alternatively, for this specific use case, where we have a fixed number of elements that we want to cycle through, for this, a simpler approach is just on the enumerator. We can just do a yield return. So over here on the function to get the enumerator, instead of creating a brand new enumerator, instead of defining this entire class and creating all of that, if we just have a fixed number of elements, we can type in the keyword yield, yield return, and then whatever we're going to return. So let's say return dex, then do another yield return for strength, and another one for wisdom. Basically, what this is going to do is this function is actually going to be called multiple times. So by making something IEnumerator and using yield return, by doing that, this function is essentially going to store its state. So the first time that we call this, it is going to return dex. The second time we call it is going to return strength, and the third time we call this, it is going to return wisdom. Let's test this. And if it works exactly the same, we have our three stats. So basically, whenever you have a dynamic number of elements, so if inside your custom type you have some kind of list, some kind of collection, for that you can define an entire enumerator and write all of this code. But when you have just a fixed number, just a bunch of simple stats, a bunch of simple elements, for that, just using a simple yield return, this one is much easier. Also, since we're on the topic of IEnumerator and IEnumerable, let me mention one Unity-specific thing, which are coroutines. If you're just using C# without Unity, then don't worry about this part. But Unity basically has coroutines, which is a way to run logic across multiple frames, and specifically it works with IEnumerator. In order to make a coroutine, we make a function that returns IEnumerator, and then over here you can do whatever logic you want. Then when you want to split the logic, you can do yield return. And then Unity actually has some nice built-in functions. Like for example, we can do yield return, wait for end of frame. This is basically going to wait for the end of frame before running the code down here. Or for example, we have wait for seconds. This is going to wait for a bunch of seconds before continuing to execute the code. For example, let's wait for 3 seconds. Then let's do a debug.log and say something. So let's do debug.log before and after. Okay, so this is going to basically run some code after some time. So this is a great way to handle timing-based logic in your games. With this, we have a coroutine. And now to start, we just need to be working inside a MonoBehavior class. And of course, this script needs to be attached to a game object. So then we do this, and let's make a start. And over here on start, we just need to call the function start coroutine. And this one takes our IEnumerator, so let's just call my coroutine, just like this. Yep, so this is going to start running this coroutine, so we should be able to see this log immediately, then wait 3 seconds and then see this log. Okay, it's running, there's the first message, and after 3 seconds, we should be able to see, yep, there it is, the second message. All right, awesome. So these are coroutines, which is a Unity-specific thing that works with IEnumerator. Now, personally, I must say I'm not a big fan of coroutines, simply because I don't like this pattern that they force you to use. It feels needlessly convoluted to me. You need to be working on a MonoBehavior, you need to call start coroutine, you need to make a special function that returns IEnumerator, use yield return, and so on. So personally, I'm not a big fan of this huge pattern. Personally, I prefer using super simple float timers, but coroutines work great, so if you like this, then definitely go ahead and use them. Okay, so those are enumerators. It's how you can make your custom types work inside a for each and various other settling logic. For example, things like LINQ, which we're going to cover later on in the advanced section. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about namespaces in C#. Okay, so namespaces, this is one of the main ways you have of organizing your code. Think of it kind of like folders for your code. For example, you would have some kind of folder for your game logic, another one for some AI logic, another for the UI, and so on. Basically, it helps you keep things organized. And actually, we've already been using a bunch of namespaces. Up here, all of these using statements, these are all namespaces. For example, the console class that we've been using, this one exists inside of the system namespace. We can access it by writing using system up here, and then we can access the console class. Although actually, when making a console app, the system namespace is included automatically, so technically you don't need to explicitly define it. But in most cases, you do need it, so you do need to add using some kind of namespace. And also over here on this template, when we created the brand new project, it automatically created our program class with our main function, and it put it all inside a namespace. Now I should say, technically you don't need to have a namespace, so if I get rid of this and this, yep, this still works, this is perfectly valid code. Basically when it compiles, it will simply place this class in the root namespace. To create a namespace, you really just follow this simple syntax, so you write the keyword namespace, and then whatever you want to name your namespace. Also, namespaces, they can have nested namespaces. For example, inside the system namespace, there's a whole bunch of stuff, like for example the IO namespace. This is the one that contains a bunch of classes related to input and output and so on. Then here is a script inside of Unity. So Unity normally has most of their things inside the Unity engine namespace. For example, mono behavior, this one exists inside of Unity engine. Then if you want to do things inside of the UI, then you would use using Unity engine.ui. So basically all of the classes are nicely organized in a namespace that makes sense for them. You can also make nested namespace yourself. You can just write some kind of name, then add a dot, then add another name, and so on. Then one big benefit of namespaces is avoiding name conflicts. For example, let's say I want to define a player class. And now let's say I want to define a completely separate class, but I really do want it to have also the same name, so also another player class. Since classes have to be unique, this does not work. Here we have an error that it says that this namespace already contains the definition for our class named player. And right away, this is also giving us a hint as to what the solution to this problem is. The solution is simply put it in another namespace. So namespace, I can give it whatever name I want. Then I can place this class inside of that namespace. And up here, I can use either of them. So I can use player, and this one is referencing this one down here, this one inside of this namespace. Or I can go inside the CodeMonkey namespace, access player. And yep, with this, now I'm referencing the other one in the other namespace. Then another common issue is sometimes you have a conflict that the compiler cannot resolve. For example, over here I added using system and using Unity engine, and now I want to use the random class. But the problem is that there is a random class in both Unity engine and inside of system. So the two namespaces that I'm using up here, they both have a class with the exact same name. So basically the compiler over here does not know which class I'm referring to. So to solve this problem, either we get rid of one of the using statements, and yep, this works, so now there's no more errors. However, that won't probably break any other place where you're using classes from that namespace. So in this case, for example, if I add the serializable attribute, which exists inside of system, by solving this problem, I now cause this problem. So to solve these kinds of naming collisions, usually the simplest thing is to just write the full name. So for example, up here on this one, I can write system, and even though this one works and this one has no problem, or alternatively, I can just add the using system up here. So this one no longer has an error, but this one does have the error. And over here, I can just write the full name unityengine.random. And yep, like this, the compiler doesn't have any questions. It knows that I'm trying to use the random class that exists inside Unity engine. Another thing you can do with namespaces is simply using an alias. So over here, we can say using, then give it some kind of name like Unity random, and then say equals unityengine.random. So basically, this one is now an alias to this. So down here, instead of using all this, we can use this. And if there you go, it does work. This can be quite useful when you have a really complex project with some super long names. When that happens, using the alias can really help simplify your code. Okay, so that's namespaces. It's a simple yet very useful C# feature. As your project grows more and more, they become more and more useful. Hi there! Are you enjoying the course so far? I hope you're learning a lot. Consider checking out the premium version of this course with tons of awesome bonuses. The companion project is really excellent for helping guide you in your learning journey. It contains frequently asked questions and fun quizzes to test your knowledge for every lecture in the course. And importantly, it contains interactive exercise, so you actually put into practice what you're learning. I designed those specifically so you can learn by doing. If you can afford it, then now would be a great time to pick up the premium version and basically go through all the lectures that you've already seen. And beyond that, it also has a bunch more bonuses, including simply having no YouTube ads to distract you in your learning journey. So if you're enjoying the course so far, then check it out. Also remember to like the video and subscribe if you haven't already. Alright, so let's keep learning. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about the Singleton Pattern. In terms of game development, this is probably the most useful pattern, and also one with a lot of pros and some cons, so let's learn about it. Okay, so the Singleton. Like the name implies, we have just a single instance of something. In this case, we have a single instance of some kind of class. So for example, we have some kind of game manager class. And over here, the way that we have just a single instance is usually with some kind of static field. Again, static means that the field belongs to the class itself and not any instance of that class. So usually we make it private, static, let's call it of game manager, and for the name we call it instance. Instance is usually a common name used for Singleton, although sometimes it's literally named Singleton. So either one. So here we have our private field, and we made this private specifically for one very good reason. The reason is because this class should be the only one that is responsible for creating the Singleton instance. Other classes should only be able to get it. So the way that we're going to expose this is by using a public property. So let's make one, also going to return the type game manager, and property usually starts by a Pascal case. So we've got our property instance, and over here on the get we just return our instance. And then for the set, for this one, again, like I said, the instance should only be set by this one. So for that one, let's make a private set. And on private set, just set instance equals value. Okay, yep, so just like this. Basically here we have a field that anyone can access, but only this class can set. Now for actually creating this Singleton, let's first cover the bare-bones C# method, and then I'll cover the Unity-specific method. So Singletons usually have what is called lazy instantiation. This means that the instance is created only when it's needed for the first time. And in order to do that, we just put that logic over here on the get. We just check if our current instance, it is null. If so, that means we have no instance. And if so, then we just create a brand new one. So we create it and then we return it. So basically this means that as our program starts, there will be no Singleton instance. And then the very first time that we use it, it will actually create that Singleton. Also, as a general rule, Singletons usually have private constructors. So if you define some kind of constructor, it's going to be private. That way, any code up here cannot do new game manager. Nope, this does not work because the constructor is private. Again, that's because the Singleton is meant to be the one that is responsible for creating the Singleton instance. So the way that we use this is actually very simple. Alternatively, another way of implementing the Singleton pattern is without lazy instantiation. So an alternative would be to expose the constructor and then just check if the instance, if it is null. If so, set the instance to this. So this is another way that the Singleton pattern could be implemented. But again, usually you have some kind of private constructor that only this one calls. And over here, we don't even need any kind of set because only that one is going to be set. So yep, this is the basic C# Singleton pattern. And now in order to use it, it's actually real simple. We just access the static property. So we just go inside the game manager, access the instance just like this. So let's do a console.writeLine. And now we didn't create any kind of game manager object. Up here, this code is not creating anything, does not know anything about any of that. It just knows that it's accessing the game manager, accessing the static instance. That's it. So if we test this, and if there it is, then we do have an object of type game manager. So just by accessing the static instance, it automatically created that object and returned that instance. Then over here, we can do whatever we want. So for example, some kind of public test function. So we have some kind of function that does something. And then up here in our code, we can go inside the game manager. We can access the static instance. We can call test function. And yep, this will indeed work. Also, by the way, note how just one instance is created. So up here, we are accessing one instance in here and then going through this one to calling the test function. So we're accessing this property twice, but when this code runs, obviously since instance is only going to be null just once, it is only going to create one game manager. So no matter how many times we call this, we end up with just one single instance. And since we made the constructor private, because that nothing else can construct this object, so we know for a fact that this class will only have a single instance, making this the Singleton pattern. As for the benefit of it, the benefit is that it's really super simple to use. Just by accessing the class itself and accessing some static instance, just through this we have a reference to whatever object we have of type game manager. So we can call functions on this class, we can do any kind of thing. We don't need to keep track of any kind of game manager reference. So for example, if we had some kind of class of type player, and then the player does something, it like adds some kind of score, so the player would end up killing some enemy or something. Over here, the player does not need to store a direct reference to the game manager. We can just go inside the game manager, access static instance, and then we would call some kind of add score function. By using this Singleton, we have our instance of the game manager real easily accessible from pretty much anywhere in our codebase. And now that we've seen the Singleton over here, the bare-bones C# Singleton, let's see how to make it in Unity. In Unity, it's a little bit different since Unity components have to extend mono-behavior, and one of the biggest limitations of that is you cannot access the constructor directly. So in Unity, you simply make a regular script, extend mono-behavior as usual, then that script is attached to some kind of game object, so all pretty standard. And over here in the code, here personally this is the only scenario where I use properties. And here I don't even use the backing field directly, I use the auto-implemented property. So I make it public because I want to have a public get. Let's make it static of type game manager. Let's call it instance. And then this one has a public get and a private set. So yep, just like this. So this field has the perfect accessibility that I want for the singleton. So any class can get it, but only this class can set it. And then on the Unity's standard awake function, over here on this one, just set instance equals this. And yep, that's really it. The awake is going to run when this game object runs, and when that happens, it is going to assign the instance into this. Now, this one technically isn't enforcing the singleton rule. If over here in Unity I duplicate this object multiple times, then I'm going to end up with multiple game managers. And the one that is going to be set on that static instance is going to be whatever is the last one that runs. So for this problem, normally the only thing I do is I'm really just careful enough to only make one object that has the static script that I want. But if you want, you can also add some proper safety checks. One way to do it is over here before assigning the instance, we check if instance is not null. If so, that means that this script already exists and the instance has already been assigned. If so, this should not happen, so over here we can probably just fire off a log error. So if over here I duplicate this object and I try running, if there it is, we have a log error and it tells us what the issue is. We can see it's on the game manager class. Then you can either manually fix this, so go into the hierarchy and delete the second one, or over here on the script itself, we can destroy this game object to make sure only one is kept alive. So for example, instead of that, let's just destroy this game object and then call return so the rest of the code does not work. So if we run this, and if there it is, we have our error because we do still have two game managers. However, if we're only in the hierarchy, yep, the second one was indeed destroyed. Now, this singleton pattern is extremely useful when you have some kind of class of which there is only meant to ever exist just one single instance of that class. For example, in games, it is very common to have some kind of general game manager, and again, you have just one. Usually you also have some kind of audio manager, some kind of input manager, and so on. Then for single player games, you might just have one player or even just one world. So if you have just one of something, then the singleton pattern is actually really great. It makes a lot of sense and makes it really easy to access that static instance. For example, if your UI code wants to show the player's health, it doesn't need to have a direct reference to the player, it can just grab the singleton reference. Or if your player needs some kind of input, it doesn't need a reference to the input manager, it just accesses the static instance and that's it. So the singleton is great, especially in game development where you normally have tons of systems that have a single instance. However, the singleton pattern also has some potential problems. If you Google, you will find a lot of people arguing that this is a terrible pattern. Although I should say, usually those anti-singleton comments are always a little bit too extreme. The singleton is a tool, and just like any tool, it can be used or abused. And in general, singleton seems to be worse for regular game development, not game development. For game development, like I said, it does have a ton of benefits that do outweigh many of the possible cons. And in general, if you write some good clean code, you can actually minimize a lot of those cons. Like the main con is simply the fact that singletons are by definition global data. The whole purpose of singleton is to have a single instance of something that you can easily access from anywhere. So because of that, it means that it can have many of the negatives that any kind of global data can have. Your code can easily become really messy with tons and tons of connections between various classes. Since singletons are so easy to use, you might be inclined to use them all the time and make it so that every class pretty much depends on a ton of singleton classes. Doing so ends up with a mess of dependencies. Ideally, your code and your classes should be as decoupled as possible. You shouldn't have a ton of connections. This advice is applicable really all the time, not just in relation to singletons, but singletons make violating this guideline very easy, so that is why you need to be extra careful. And because those issues of classes becoming coupled with tons more classes, because of that, testing can become insanely hard. Simply because in order to test something, if the class you're testing accesses some kind of singleton, then that singleton needs to be created in order to test, and in turn, maybe that singleton then uses yet another singleton and on and on, so you might end up requiring a ton of setup to do even just a basic bare bones test. Another more serious problem is with regards to multi-threaded code. You need to be very careful to make your singletons thread safe, or simply make sure you only access singletons from the main thread. For example, if you use Unity dots to write some super performant multi-threaded code, the simple way to avoid this problem is to do all your logic in tons of threads. Then at the end, after all those jobs are completed, then you do anything that requires a main thread. Like for example, accessing the sound manager singleton to play some sort of sound effect. So singletons can indeed do have some negatives, but they're also extremely powerful and extremely useful. It is a pattern that can be very good when used, but also very easy to abuse. Personally, I use a ton of singletons in all of my games. I just also make sure not to abuse that pattern. I make sure to control how often I use them and limit class coupling as much as possible. So my advice is don't be afraid of singletons, they definitely have their place, but use them properly so they actually help you as opposed to hurt you. Now the singleton pattern is just one of many programming patterns. It is the one that I use most often and I find most useful, so I made this dedicated lecture. Now next one, let's go through a bunch of other patterns that also have their use case. Hello and welcome, I'm your Code Monkey. In this lecture we're going to talk about a bunch of design patterns. Okay, so first of all, what are design patterns? In the last lecture we already covered one specific design pattern, the singleton. These are basically some general, reusable solutions to some common programming problems. The Wikipedia page has a great reference with tons and tons of detail. For example, the singleton pattern that we just saw. This one is a nice solution for the problem of how do you ensure a class has only one instance, and how do you ensure that it has a global point that is easily accessible. That's the entire purpose behind that pattern. And by writing the code like we saw in the previous lecture, that is how we can achieve those rules. So that is a very good solution to that common problem. And within that pattern, we also saw another mini pattern, the lazy initialization. So this is how we made sure that the singleton only gets created the first time that it's actually needed. Another pattern we've actually already seen is the observer pattern. This is a pattern where an observer interacts with a subject to be notified whenever something happens. So yep, this is literally what we already covered in the events lecture. A class subscribes to an event and again gets notified when that event is fired. So using events is essentially the observer pattern. Another common one is the command pattern. With this one, you can basically create commands that can be executed later on. So one common use case for this kind of pattern is making some kind of undo system. So when you do some kind of action, you create a command for the undo action with all the data that is needed to perform that undo. And then when you want to undo, it simply runs that command. So this is the kind of thing that can easily be built by combining a stack with delegates. Another interesting one is the factory pattern. With this one, you basically put the creation of an object in some kind of factory class. And then instead of having every class with a constructor that anyone can call, instead only that factory class is responsible for creating those objects. Again, we also saw a part of that pattern in the singleton pattern, where the singleton itself is responsible for creating the object. So the factory pattern is pretty much just a more dedicated part of this pattern. It can be really useful to limit the number of places from which a certain type of object can be created. Then the object pool pattern, this is a really useful one. This is how you can create a pool of a bunch of objects. And in doing so, it really reduces the impact for creating and destroying objects. Unity actually recently introduced an object pool type that does exactly that. If you have performance issues with spawning and destroying objects, you should definitely be using some kind of pooling. Then dependency injection. This is an excellent pattern for testing your programs. This one uses interfaces quite heavily. It's one of the main reasons why interfaces are really excellent. You can inject different types of objects as long as they implement a common interface. Then the adapter pattern, or simply a wrapper. This is especially great when working with some kind of third-party code. You build a wrapper that only contains the info you care about, and then you don't have to worry about any more of the underlying implementation. So as you can see over here, there are tons and tons of patterns, and pretty much all of these have dedicated pages, so if you want to dig deeper, I definitely encourage you to do so. These patterns were created by some very smart people in order to solve some very common problem. So rather than reinventing the wheel, just being familiar with some of these is really great. But you really don't need to memorize all of these. I highly encourage you to research them just so you know they exist. But don't try to memorize everything in one go. Like with the Visual Studio Shortcuts lecture, this is something that you pick up more and more over time. But definitely do take the time to research these in a little bit more. Like the saying goes, there's no point in reinventing the wheel. Sometimes you have a problem for which a pattern would be the perfect solution, and if you know that pattern, then you can simply apply it rather than having to reinvent a brand new solution. Now for me personally, I normally just use the singleton and the observer pattern specifically. I use those pretty much exactly like they are designed, and then I use various other ones when I need them, even if I don't necessarily follow these strict patterns. So sometimes, for example, I have some kind of factory pattern. I have that where some objects are created only in a specific place, but I don't necessarily create a brand new specific factory class. Then, like I said, sometimes I use something similar to the command pattern, especially in management games to queue up all kinds of actions. And in Unity is all made about composition of various scripts, so technically it is the composite pattern. And I do normally try to compose my complex objects, usually by composing them based on interfaces, rather than just making one huge object with all kinds of logic. So I highly encourage you to research some design patterns in order to be familiar with them, but again, don't worry too much about memorizing them, especially not all of them. I certainly do not have memorized all of these patterns, only a handful of them. Then as you go through in your game dev or programming career, you'll learn which ones you will commonly use as you encounter similar problems. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to see a nice project that incorporates everything we've learned so far in this intermediate section. Although, actually, we've already covered a ton of stuff, and some of it was necessary to get this demo built, which this is actually a great practical example of everything you're learning in this course. This course is all about C#, and C# has a ton of tools and features, but that does not mean you need to absolutely use everything all at once every time. The goal of all this is to use the things that help you achieve whatever goal you're trying to achieve. So let's see the demo. It's inside the Unity project, inside the lectures, and down here at the bottom we've got the intermediate project. So we have our game scene. Let's open it. And here is the minigame running. So I've got a player object. I can move around by pressing the arrow keys or WASD. Then down here I've got an inventory with 3 slots, and there are some weapons and some items that I can pick up. There's also some enemies that are spawning and coming to me, so I can approach the weapon in order to pick it up, and I can click in order to start shooting and start taking down some enemies. So as I shoot, they take some damage, they get a health bar that goes down and updates, and eventually they die and they spawn a bunch of money. Then for the money, it's also something that I can pick up, so I can touch it and pick up all this money. I can see the UI is updating as I pick up some more money, and there's a bunch more items and objects. So for example, there's some bombs. Those bombs are also attackable, so I can attack them and I can destroy them. And then I've got the other weapons, so I'm using a pistol. And then I can pick up a shotgun, and down here on the inventory, yep, I picked it up. So now I can swap the shotgun and I can start shooting, and this one has a different shoot. So this one can now shoot multiple bullets at once. And again, I can pick up all this money. And then over there is also a nice little potion. I can pick it up, and again, that's also another item. It's a usable item. So I can use it, click to use it, and if there you go, this goes into some kind of super mode where the player is now moving much faster. So I can move around really fast, and eventually it ends up. And I can select another different one. So let's go back to the pistol. Let's go into that one, speed it up, back to the pistol, shoot that one, and so on. So yep, this is the demo with lots of stuff happening that involves a lot of the things that we've already learned about. There's player movement, there are all kinds of interactions, there's shooting, there's enemy, there's health, there's damage, there's an inventory, a whole bunch of items, abilities, and so on. So as you can see, lots of stuff. Now let's inspect this to see how it all works and how all the elements of C#, how all of them are being used. Although also, before we look at the code, let me make one quick note. Basically, how I built this project is not the absolute only way to do this. You could build this exact same project in a million different ways. So as we're going through it, if you think to yourself that you would build some element in a different way than I did, that does not mean that you're wrong. There's always many ways to achieve the same result, and the way that I built this demo is simply just one way out of the millions of possible ways to build it. So if you come up with a different way to implement the exact same elements, you can definitely be right as well. Okay, so here in the project files, we can see that this demo is quite a bit larger than the beginner demo. There's quite a few more files. That's due to the fact that it is larger than the beginner project, but also due to the fact that the code is much more well organized. There's plenty of small classes that do one thing and one thing only, as opposed to the beginner project where I tried to make it as compact as possible, which meant putting too much logic on the player class. Whereas over here, you can see how each file is actually pretty compact. You can see most of it pretty much just over here on the quick code preview. Most of these files are actually pretty small. So let's begin inspecting this, and let's actually begin with the most complex script of all, the player script. Let's do just a quick overview of this one before we see everything one by one. And right away, as soon as we open this, we can actually already see a bunch of things that we learned in this intermediate section. So right away, we can see a namespace. So all of the code for this project, all of it is inside this specific namespace. And one of the benefits that I talked about namespace is simply the fact of name collisions. And actually on this companion project, note how all the code for all of the various lectures and all the demos, all of it is inside this one project. And I do have a bunch of other demos that also have some kind of player class. But because over here I'm using a namespace, that makes it sure that this player class does not have a naming conflict with any of the other player classes. So that's the first thing, using namespaces. Then by the way, the mono behavior over here. Here we are seeing an instance of inheritance, and mono behavior is really just a base Unity class. Basically, if you want to attach any script as a component in Unity. So for example, over here, if I select the player object and I look in it, yep, it has the player script attached to it. So in order to attach a script onto a game object, it needs to inherit from that class. Then we can also see over here we have the Singleton Pattern. So we've got a public static player instance with a public get and a private set. And this one, the instance is being set over here on awake. This is a Unity specific function that is called whenever this script is initialized. So on awake, we are instantiating the instance onto this. Since this little demo is meant to be a single player game, it makes perfect sense that the player is a singleton, since there is only ever meant to be just one player. Next, we can also see usage of a bunch of constants. Again, constants are values that are never meant to be changed. So in this little demo, it makes perfect sense to use a constant for the base movement speed, for the damage amount, and for the super timer max. Then we can see a whole bunch of events. We're going to see these in detail a little bit. Then we've got a bunch of fields. And by the way, the serialized field here, this syntax is actually an attribute. This is something that I cover in detail in a lecture in the advanced section. Over here, this specific attribute, this is another Unity specific thing. It is just so I can expose these fields over here on the Unity inspector without having to make these fields public. If I were to just make them private without this attribute, then it would not show up in the editor. So in order to do that and keep the code clean, keep the fields private, in order to do that, they need to mark that serialized field private. Okay, then we have a bunch more fields. Then we got some inventory logic. We're going to see this in a little bit. Then we've got the update. This is another Unity specific function. Basically, the code in here is going to run whenever the frame updates. So if the game is running at 60 frames per second, these functions are going to run 60 times per second. We've got a function here to handle the object rotation. So that's the logic for how over here the pistol is rotating to face wherever I'm aiming with the mouse. Then there's some code to handle the items. I'm going to cover the inventory in a little bit. Then some code to shoot. Then we've got some standard movement code. So just some basic ifs, calculating a certain move vector, and then just moving the transform alongside this move direction. The transform is basically the game object in Unity. Then we've got the super, and let's begin by inspecting in detail over here the collisions. Again, this is another Unity specific function. This one has to do with the Unity physics system. Basically over here for all the objects that can be picked up, like for example over here the money object over here has a little collider. So this little box is a physics collider, and basically as the player goes inside of this collider, it is going to trigger that function. And over here this function will be called with whatever object it collided with. So the first thing we do is try to get a component. Again, this is another Unity specific function. This one tries to get any component of a certain type that is attached to the same game object. So basically as the player collides with this money object, it is going to try to get some of these components. And specifically, it is looking for a component that implements the interface iGrabObject. So here we see an example of an interface. In this case, this is an interface that represents any kind of object that can be grabbed. So in this game, that's a money, that's a weapons, that's a potion, and so on. And the interface defines a bunch of functions which all objects that implement this interface must implement. So one of those is, of course, the money class. So this one, as you can see, it extends the MonoBehavior class. This is the base Unity class, so this can be used as a component, and then it implements the iGrabObject interface. Then for the logic over here, it's pretty simple. This is really just some movement logic. So over here with the weapon, if I shoot a zombie, yep, there you go, the money gets spawned and moves a little bit, just to have a nice little bit of visual polish. So as the enemy dies, it spawns some money and moves a little bit and then stops moving. So that's really this code in action. It moves the transform, then lowers the magnitude, which is how big is the movement direction vector. And if it is under a certain magnitude, then just disables the script, which means this update function will no longer be called. Then down here, it implements the functions for that interface. So we've got one to destroy this object, and then some related to inventory objects. Now in this case, money is not an inventory item. It cannot be placed in inventory. So over here for these functions, just returns false and null. Before we see the inventory, let's actually see how the money is actually connected to the UI. So over here in the UI, we've got a little indicator to show how much money the player is holding. So going back on the player script here, on the onTriggerEnter, over here we try to get a component of that interface type. And basically if the player hits the money object, then this is going to be true. It is going to be able to get this grab object component. And when it does, it is going to fire off this event. It is going to fire it off with some custom event args and basically pass along the grab object that was grabbed. So this event is defined up here. So just a basic event handler that has a custom event args for our grab object. And over here, actually something also pretty interesting, which is how in the events, you can subscribe to the events from anywhere. Meaning you can actually subscribe from the class that actually fires off that event. So that's exactly what I'm doing here. So I subscribe to the onPlayerGrabbedObject event. And then over here, accessing the event args in order to get the grab object, and doing some type checking in order to see if that grab object is of type money. So this identifies what object I picked up, and if so, then it's going to increase the money amount. This is just a basic integer. And as it does, it also fires off another event on money amount changed. And the one that listens to that event is this little UI element. So over here in the hierarchy, if I go inside the canvas, I've got this player UI script. And yep, this one is pretty simple. So on start, which is a Unity function that gets called whenever this object is initialized, so right after the awake. So when that happens, it accesses the player static instance, again, the singleton, which is super easy to use, which in this case makes perfect sense because this is a single player game, there's only one player. So it uses that to easily access the player, and then simply subscribes to the event on money amount changed. And when that happens, it simply calls the function in order to update the text. So it just goes inside the player static instance, again, accessing the singleton, calling a function to get the money amount that the player is currently holding, and just passing that on into string in order to update the text. This right here is a great example of one of the main purposes of events. It allows you to keep your code decoupled, and specifically in games, it allows you to decouple your logic from your UI elements. Note how over here on the player class, this one has no direct connection to any UI class. It does not know and does not care if there is any UI listening to any kind of money amount or anything. Meaning this player class is completely decoupled from this UI class which does display the money. So if I'm playing the game and I pick up some money, yep, the UI up there is indeed updating. It works great. However, if I go there and I disable the player UI game object, so this script is no longer running, but despite that, there are no errors because again, the player UI, that one depends on the logic class, but the logic class does not depend on the UI class. Meaning that the player can exist without or with any UI, it does not matter, it works either way. That is really one of the main powers of events. It is how it helps you make your code much more decoupled so things can exist without other things. Now let's look at how the inventory over here works. So this one also has a nice constant for our capacity. Then it has a bunch of events that get fired whenever some things happen to this inventory. In order to store the inventory items, it is stored simply on a list, and then just keeps an integer for the selected index. So basically which item is currently being selected. Then we've got some basic functions. So when testing if we can add an item, so we're really just testing the inventory list against the capacity. Then we got a function to add an object, and over here we have an example of a custom exception. So basically if we try to add an object without first checking if we can add it, so if we try to add it but we can't, if so, then this is going to throw a custom exception of this type, inventory full exception. So the exception is defined down here. Pretty simple, doesn't even have any extra data, it's really just a type just to be identified exactly what exception it is. But assuming things go well, it simply adds the item onto the inventory and fires off an event to know that the item list is changed. And then just has some more functions in order to set the selected index, to get it, in order to get the entire inventory item list and get the selected item. So here we have a pretty basic inventory. It stores a list of things and exposes a bunch of functions that can do certain things so you can work with the inventory. Also again, note how in this inventory class there is no mention of any UI anywhere. Once again, that is because of the same thing. So this inventory class, this one handles the actual inventory logic. And then we have a separate UI class that listens to these events and then updates the UI. So over here we can see that. So inside the canvas, we've got the inventory UI. So that is this element down here. And on this script, we have a reference to the inventory. This is the one that is currently being held by the player. And then we have a list of all of the inventory slots. These are all of these individual slots. These are individual objects. And as such, they have a custom class in order to handle each individual one. So rather than putting the logic for each specific one inside of the main inventory UI class, rather than doing that, it is nicely separated. So there's one class that handles the entire inventory, another one that handles each individual slot. Then on this slot, this one is a pretty simple script. We just have a reference to an image and the select game object. So the image is the icon sprite and the select game object is this little green arrow in order to show which item is actually being selected. Then over here, the behavior for each slot is actually pretty simple. So we've got one to set the selected state. So this really just either enables or disables that select game object with the visual. Then we've got one to set the item sprite. Again, just setting the sprite for whatever object is placed in that item location. And then we have another one in order to set the click action. So over here we can see delegates in action. So we've got a simple action delegate for the click action. And we're simply just going inside the button and adding a click action. So an action that is triggered whenever we click on the button. And all of these functions, these are all handled by the other inventory UI class. So over here, this one, again, this one has a list of all the inventory slots. And on start, first we access the inventory and we subscribe to the two events that we need to. So one then the item list changes and one when the selected index changes. Then here we can see the click actions. We can see a use of Lambda expressions. So instead of defining proper functions, we're really just using the inline Lambda expression. This works great when it comes to button actions. So we're telling it, giving it a click action for the inventory slot on index 0. So the first slot telling it to select this index when we click on it, then doing the same thing for all the other slots. And then we have the functions listening to the various events. So when the item list changes, when that happens, we want to update the item list and update which one's selected. And on this one, same thing, just update the selected. And then for these, for updating the item list, first thing we do is cycle through the entire list. We set the selected state to false in order to deselect all of them. And we set the item sprite to null in order to disable the items. Then we cycle through the inventory item list that is inside the inventory. We go through each of those elements in order to set the slot to the corresponding item sprite. Basically, this populates all the buttons. And then for the update selected, this one is also pretty simple. So first we deselect all the buttons. Then we access the inventory to get the selected index and set that one to selected as just that one. So yep, here the inventory is empty. And as I pick up a pistol, yep, it sets a weapon and sets that. And if I click on one of these, I can swap which item is selected. Then if I shoot, I can use the pistol. I can pick up the shotgun, click the selected and use it, or pick up this one, click it and use it. So yep, that's the inventory with various slots. Let's also see just over here the inventory. This one has an item list and it's of this type, IEnumerator item. This is another interface. Here we can see the usage of an enum in order to define the item type. So it can be a pistol, shotgun, or a potion. and then various functions, so one to get the item type, to get the sprite, and to use the item. So with this, let's look at the weapons. And first of all, in terms of structure, I decided to separate the logical items that go inside the inventory and the actual items that exist in the world. So for example, over here in the world, there's a pistol that the player can pick up. This one has a script of type pistol object. So there's that one, and then there's an actual pistol that contains the logic. So there's always these two. There's the potion object and the potion, shotgun object and the shotgun. Here for the pistol object, this is the one that implements grab object. So this is how the player can actually pick up the weapon. And this one, unlike the money, this one does return true because it does have an inventory item. And when calling the function to get it, it simply creates a new pistol. So this is the class that is meant to handle the logic for the actual pistol. As to when that runs, it's over here on the player when the player triggers an enter. So when it goes inside another collider, it checks if it has a grabbed object, which again, the pistol object does implement this interface. Then the pistol object can indeed have an inventory item. So then it checks if the inventory can add that item. If so, it adds it onto the inventory and goes into the grab object in order to grab the inventory item. So that is what is going to construct a brand new pistol. And over here is the pistol script. This one has a function to return the item type so that it knows, okay, this is a pistol. It has one to return the item sprite. And over here we see another instance of the Singleton class. We've got the game assets. This is a class that I use in pretty much all of my games. It's just a super simple way to access any kind of assets. So here in the game, in the scene, I've got a game assets object, and inside it has this script. And then this script, I can drag any references that I want to reference anywhere in the code base. So this is another really useful use case for the Singleton pattern. So anyway, so the pistol gets the sprite for the pistol, and then it has a function to use the item, which in turn is going to tell the player in order to shoot. Then the player shoot function, this one is pretty simple. It really just fires a raycast. This is kind of like a laser in the physics world in order to find other colliders. This is basically how it finds other things that it can shoot. And over here, again, note how I'm not looking specifically for an enemy or a bomb, but rather an eye-attackable interface. So this is how the player can actually shoot any kind of object, not just enemies, not just bombs. It can shoot anything that implements this interface. But before we get to that, let's actually go back into the player class. And over here, note the override on all of these. That is because the pistol, this one is actually extending a weapon base class. And this one, here it is. This one is an inventory item, so that is how it can be placed on the actual inventory. And this one is marked as abstract because we are never meant to construct just a base weapon, but rather the weapons that extend from this class. And everything is abstract, so this is all up to the extending classes to implement these functions. So the pistol over here implements these functions like this. And the other weapon is over here, the shotgun. Again, this one also extends the weapon. And this one does override with different things. So it returns a different item type, a different sprite. And over here we've got a bit of different logic. So the pistol just shoots once, whereas the shotgun shoots multiple times. So now we can go back here into the shooting code. So again, this one fires a raycast in order to find all of the physics objects that it hit. If it did manage to hit something. If so, then it's going to try to see if that something is an eye-attackable object. And if so, it is going to cause damage to that object. Here is the eye-attackable interface. Really super simple, just has a damage function. So basically, in order to make something damageable by the player, all we need to do is implement this interface. So for example, here we have the bomb class. This one does implement the eye-attackable interface. And this one is another super simple class. It has the damage function down here for the interface and simply passes that damage function along down to the health system. So the health system, this is a great example of composition over inheritance. Basically, the bomb is meant to have some kind of health, so it has a health system. But specifically, it has the health system in a field as opposed to having all of the health system code directly inside the bomb class. This way it makes this health system reusable, which it is indeed reusable, since the enemy also uses this health system. So let's inspect it. And over here, this is another pretty simple class, just has the basic functions for handling some kind of health. So it just has a health and a health amount max. Then as usual, it has events for whenever all kinds of things happen, so on health change or on dead. Then we've got the damage functions, counts down the health amount, and if under 0, fires off the on dead, and either way fires off the on health change. So that is why over here the bomb, this one we can note on start, this one is listening to the health system on that event, and when that happens, it is going to run this code, which is going to destroy the bomb and fire off this event. The class that listens to that event is over here the game manager, which again, this is another one of there exists only one, so this one is a singleton. And over here we can see that it is listening to the bomb on any dead event. And when that happens, basically just spawns a VFX prefab. Just does that and shakes the camera. So over here, if I pick up a weapon and I shoot a bomb and I destroy it, yep, there you go, it fires off some VFX and shakes the camera. Yep, there it is, that's the bomb. Also note how the bomb also has a health bar that updates. This is another UI element that again is being driven by events. So here in the scene, we can see the bomb. We can see the bomb has a canvas inside the health bar UI. And this one, note how this class is health bar. This has nothing to do with any bomb or any enemy. This one simply works with a health system. It does not matter where that health system is attached. It could be the player, it could be a bomb, could be an enemy, could be a building, does not matter. This health bar works on any kind of health system. And the way it works is super simple, just listening to a bunch of events, and when it does, then just goes into the health system to get the health normalized, and uses that in order to make the bar image fill amount. So another super simple, super short script. It does one thing and just one thing. And then our enemy class, again, this one also implements iattackable, so it can be damaged. It also has a health system, so again, it can be damaged. It also fires off an on any dead event. And note how just on this one, and the same thing is over here on the bomb, note how these are static events, meaning that they belong to the class itself and not any instance of that class. So that is why over here on the game manager, when listening to that event, it does not need a reference to every single bomb and every single enemy. It just listens to the static event, which is going to be fired from any instance of that class. So for example, when any enemy dies, when it does, it's going to run this code, which really this one just spawns the money. So spawns and sets it to go into a random position. Then back over here on the enemy class. So we've got the event, we've got the health system. Then on update, we have some super basic AI, literally just moving towards the player. And again, the player has a singleton, so it makes it super easy to access. And then just listens when the health system dies, and when that does, it just destroys this game object. So yep, this is another super simple class. And the last two scripts that we need to look into are the holding object visual and the weapon animator. So the holding object visual, this one is inside of the player game object. Here we have a holding object. So basically inside of this object, we place either the pistol game object or place the other game objects over here inside the prefabs. We've got one for a pistol, for a potion, for a shotgun. That is how over here, the weapon that I'm rotating, I can select different weapons and rotate that one. So this game object has that script attached. And this one really just has a reference to the inventory in order to know when the selected weapon changes. And when that happens, it really just updates this visual. That involves getting the selected inventory item, then doing a quick null check just to make sure that there is an item selected, and checking for the item type. This one is going to be an enum, so over here doing a switch on that enum, and depending on that, spawning a different prefab. And finally, for each weapon, like for example over here the pistol, it has a weapon animator script. Here is that script, and right away we can see a constant for a string. Like I said, you should avoid using strings as identifiers at all costs, but sadly, actually the Unity animator system, this one requires using strings. So rather than using a string down here for the set trigger on the animator, instead of doing that, I define a constant up here, and then for the rest of the code, I only use this constant. That really helps limit the amount of strings, meaning the amount of potential problems that we have. So it has a constant, a bunch of fields, then we've got the animator. Once again, this one also works based on events. So it subscribes to the onShoot event on the player. And then when that happens, simply just set the animator in order to shoot. It spawns the VFX prefab, the little dirt that gets thrown out whenever shooting, and then just spawns the bullet ray prefab. Finally on this one, since this element is being swapped out, meaning it's spawned and destroyed, we need to make sure to unsubscribe to the event, so we don't have, for example, a dead weapon animator still listening to the same event. So over here on the onDestroy, which is a Unity function that gets called whenever the game object is destroyed, whenever this happens, we are just unsubscribing to the event, so we don't get callbacks for an object that is destroyed. Put all that together, and here's the object. I've got the inventory, I can pick up a pistol, and I can shoot a bunch of zombies. When I shoot them, they drop some money, I can pick up that money. Then I can pick up different weapons, so for example, I can select now the shotgun, and now this one shoots many more bullets. I can shoot enemies, and I can also shoot some bombs, and boom, there you go, they all blow up. It's all really satisfying. Then I can also pick up a different potion, I can use it, and all of a sudden I'm moving much faster, and there you go, just like this. Alright, awesome! So this is our intermediate project. In this really nice project, we have incorporated almost everything we have learned so far. You can go ahead and inspect this project for yourself in your own time in order to see how all the concepts we have learned have been used in this project. Feel free to play around the code and modify some parts to see how it all works. If you make a mistake and you break something, you can always just re-download the companion project, so don't be afraid to experiment. As always, you'll learn by doing, so take some time to do just that. Maybe build upon this in some way, maybe see how you could add another weapon, or another grabbable object, or another enemy type. Hopefully with this video you understood how it's all structured, so with this, plus the knowledge you've gained through this entire course so far, with all that, it should mean you should be able to fully understand how all of this is working, how all of these systems are interconnected. If not, then go rewatch some lectures on some topics that you find tricky, or simply feel free to post a question in the comments and I'll do my best to clarify any doubts. Hello and welcome, I'm your Code Monkey. Congrats on going through the entire intermediate section. I hope you learned a ton. I really hope you took your time and focused on learning all of these topics in this section. If so, then you are now much more skilled than you were when you started this section. If you want to try out that knowledge with some interactive exercise, if so, then right now you can pick up the premium version and go through the companion project. That one includes interactive exercise, along with frequently asked questions, quizzes for every lecture in the course. Remember how you all learn by doing, so definitely make sure you're putting into practice everything that you're learning about. Now would really be an excellent time to do that. Basically go through everything in the beginner section and intermediate section of the companion project. Or at this point, if you prefer to make a game as opposed to learning about the language itself. If so, then by now you have enough knowledge to start following my free Kitchen Chaos course. If you understood everything over here on this course on the beginner and the intermediate section, then you won't be able to understand everything on that course. So if you want to try making a game, then maybe go do that. There's a free course making the game in single player and a second free one on making the game in multiplayer. Or if you fully understood everything in this intermediate section, if so, then you're also ready to try out my turn-based strategy course. That one is also on making a game, but more on the intermediate/advanced level. It's a bit of a more complex game, and doing so naturally requires using quite a lot of these intermediate features. So if you want to see how to use all of this intermediate stuff that we just covered here, if you want to see how to use all of that in a practical project, then this turn-based strategy course, this one is really excellent. Or for something much more powerful, then check out my Dots course. This tool stack helps you write code that literally runs 100x faster. This definitely requires quite a bit more advanced knowledge, but if you understood everything in this course so far, then you're definitely ready for it. Or in general, if you're interested in Unity, then check out my Ultimate Unity Overview course. That one covers over 70 tools and features that Unity has. But if you just want to keep on learning C#, then let's keep going. So once you're ready, let's jump into the advanced section. Hello and welcome, I'm your Code Monkey, and welcome to the advanced section. In this one, we're going to once again take things up a notch. We're going to learn about some very interesting, very advanced topics. So things like what is reflection, what are nullables, what is unsafe code, and even things like multithreading. The topics in this section are definitely quite a bit more niche, but it helps to know that they exist for when you need them. Also, consider checking out the premium version of this course with a ton of awesome bonuses. The companion project is really excellent for guiding you in your learning journey. It contains a bunch of frequently asked questions and fun quizzes to test your knowledge for every lecture in the course. And importantly, it contains interactive exercise, so you actually put into practice what you're learning. I designed those specifically so you learn by doing. Remember, you only actually learn if you put into practice what you're learning. Beyond that, it has a bunch more bonuses, including simply having no YouTube ads. So if you're enjoying the course so far, then check it out. Also remember to like the video and subscribe if you haven't already. Alright, so let's begin the advanced section. Hello and welcome, I'm your Code Monkey. Alright, so here let's see a quick overview of everything we're going to learn in the advanced section of this C# course. This is going to involve a lot of very interesting, very unique topics. We're going to start off with an interesting advanced topic that I actually only started seriously using just recently. It's reflection. I had to learn this myself in order to make the exercise for the companion project. Reflection is how you can dynamically inspect your code and work with it without directly calling any functions or reading any fields. Next is going to be a simple but interesting one. It's how you can make some function extensions. This allows you to extend a type with more functions without having to modify that type itself. This is really useful when you don't have access to the type itself, when you don't have source code access. Then we're going to learn about static constructors. These are kind of like the normal constructor, but they run just once for the entire class. After that, we're going to learn about the typeof keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then a lecture on nameof. This one helps you get a string name for some kind of type. This is really useful to help you avoid strings in your code. Next is the sizeof operator. This one lets you get the size of your types. Like for example, you can see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps you know how much memory your code will use. Then a lecture on default. Simple and very useful way to get the default value of some type. If you do the default of an int, you get 0. If you do the default of a bool, you get false. If you do the default of some object, you get null, and so on. So using this keyword is much better than hard coding some default values. After that, we're going to have a lecture on expression-bodied members. This is a really interesting, very compact way to write simple short functions. There's no need to write all the usual function boilerplate code. This one is basically just a lambda. After that, we're going to see a lecture on records. This is a super simple way to create immutable types to organize your data. Next, we're going to learn about the null conditional operators. This is how you can easily test for null before doing something, like for example, before firing off an event. Then a lecture on the Null-Coalescing Operator. This one lets you quickly test against null, and if it is null, return a default value. After that, we're going to learn about the Ternary Conditional Operator. This is an excellent, super compact syntax for making a very simple if. You have the condition with an if and an else, so it's all very tiny, very useful. Next, we're going to learn about the main function in a console app and how to pass in some command line arguments. This is a really important one because there are many interesting programs that you can build that don't need any kind of UI. So a simple console app that you can control with some command line arguments, that one is always going to be an excellent option. Then a lecture on Nullable. This is how you can make any type support null. Even value types like int or bool, you can make them nullable to support null. This can be much better than having to predefine some special value, something like -1. Next, we're going to see a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create a new object. This one is basically just a pointer, meaning it is insanely performant. Then a lecture on Bitwise Operators. This is how you can work with individual bits of data. In this lecture, I'm also going to teach the basics for how binary works. Next, we're going to learn about Enum Flags. This is how you can turn your enums into bit masks, which then allows you to make some interesting combinations. Then a lecture on Preprocessor Directives. With this, we can give orders to the compiler itself. We can define symbols and include or not include some code in the compilation. Next, a lecture on the keywords ref, out, and in. These are really useful. They help you get more data out of a function than just a single return type. And they also help you work with types as references, even if they are value types. After that, we're going to learn about data boxing. Now, this does not have anything to do with punching people. It's really all about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we're going to learn about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields on that type, on that object, even if they don't really exist. That validation logic is only going to run at runtime, not at compile time. So this dynamic, this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, you can make your own custom types, support access through an index, just like a list or array. You can add whatever logic you want and make it read-only or read-write. Next is a lecture on attributes. With this, you can add metadata to your code. Then that metadata can represent whatever you want. You can use reflection to analyze it and do something to it. After that is a lecture on anonymous types. Really interesting, quick way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that is the next lecture on tuples. These are very similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next is going to be a lecture on using IDisposable. This is a really interesting code block and interface that helps you make sure you don't forget any kind of cleanup code. After that, we're going to learn how to create custom override operators. Using these, we can add support for our own classes to do things like addition or multiplication. We can define the logic of what exactly it means to add two custom player classes together, and also define the logic for comparing two custom types, meaning defining the logic for what exactly does it mean to do an equals. Next is a lecture on LINQ. With LINQ, we can easily do query operations on any collection of data, whether it be a list or array or some XML or some kind of database. We grab that data, then we can query for some conditions and select just a few elements. We can sort some things, we can do a union, and so on. If you're familiar with SQL, then LINQ will be quite familiar. Afterwards, we're going to learn about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop the components. Here, I'm also going to talk about the other visual program tools, things like WPF and .NET MAUI, as well as how Unity itself doesn't have to be used just for making games. You can make normal applications with Unity. Next is going to be a lecture on DllImport, the library import, how to use extern and work with the Windows API. So this one is going to be a great lecture to learn how to interact with external libraries. Then a lecture on asserts and unit testing in general. With this, you can validate your own code to make sure everything is behaving exactly as intended. Next is going to be a lecture on writing unsafe C# code and working with pointers. Now this is a very, very advanced topic. Technically, if you know what you're doing, you can make some impressive stuff with unsafe code. But C# has a safety for a reason, so definitely only use this wisely. Then we're going to learn about asynchronous programming, specifically how to use async, await, and task. This is how you can have some code that takes some time, like for example contacting a web server, and keep waiting for a response without blocking your program. This is extremely important in making sure your program feels nice and responsive. After that comes a super important advanced lecture. This one is all about multithreading. This is how you can take advantage of all the cores in a CPU to make them all do work at the exact same time. When done properly, you can get some insane performance improvements, but it is also very, very easy to make mistakes. So this one is very much a definition of an advanced topic where you must know exactly what you're doing. And yep, all of that concludes the advanced section of this course. As you can see, we're going to learn about a lot of very advanced, unique topics. Some of them you're going to use quite often, and some of those probably less often. But just by learning about them, learning that they exist, that will help you whenever you need to use them. And of course, remember how you can always come back to this course at any time. You're really not expected to memorize all of this. Personally, I Google things all the time, and now actually I have this course in my own words. So anytime that I need to relearn some syntax, I'm really just going to rewatch the lecture to learn myself. So if in the future you want to re-remember something, like for example how async programming works, you can't just come back here and watch that lecture. Alright, so this is everything we're going to learn. So let's start learning some advanced topics with the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about reflection. This is a really interesting topic for how you can analyze and run code in a dynamic manner. So reflection is a name for a bunch of functions that you can run on the types themselves. Like for example, over here I've got an exercise class, and inside I defined a myFunction function. And yep, all this is valid code. Now up here, constructing an instance of exercise, and through that I can simply call my function, and yep, everything works. So no errors, all perfectly fine. This is the usual way for how you call some kind of function on some type. However, another way is using reflection, and the way we do that is first we access the type itself. So we do that using the typeof keyword, and then we use the class name. So in this case, I want to access the things on the exercise class. And then just by pressing dot, over here we can already see a bunch of really interesting functions. So get member, get interfaces, get nested type, get properties, and so on. So we've got all kinds of things. In this case, we're looking for a function. And again, technically the terminology in C# is a function is called a method. So it's called a get method. This one takes in a string for the name of the method that we're looking for. So in this case, we're looking for something called myFunction. So yep, just like this. And now this one is going to return an object of type method info. So method info. And this one, by the way, exists inside system.reflection. So let's add that using. So the method info for the myFunction method info. Okay, so basically now this contains the data that relates to this function. And now using this, we can invoke it. So we can call the invoke function. And this one takes in an object for the target. So in this case, let's use our created exercise. And then for the parameters, in this case, this function takes no parameters. So let's just put out an empty object array, just like this. And if that's it, this works. So let's just put a console.writeLine over here, just test it out. Test it out that we're calling my function. So we should be able to call it over here and also over here. So let's run. And if there it is, exactly like that, the function ran twice. So yep, here you have two very different methods of running the same code. And over here, you might be wondering, where exactly is this useful? I mean, just calling the function directly, that sounds much easier. Now, reflection is actually a topic that I myself had to learn quite a lot in order to make the interactive exercise for this course. For example, this exercise on the class lecture, the goal of the exercise is to define a player class. And basically, in order to test if the student has completed this exercise, the code needs to check that the class does exist. So for example, over here on this testing code, let's do the exact same thing. So let's assume the exercise, the goal over here is to define a player class defined inside of this one. Now, if it does exist, then obviously we can just access it. So we can just access the exercise type, that works. And if over here we define a public class player, if we do this, then yep, over here we can access player. And yep, so this does work, this is valid code. So we can do a typeof in order to find. So if this type is not null, if so, then yep, then the type has been defined. However, by using this code, remember how in the beginning of the exercise, the player class does not exist. So if I raise this as to what this would be on the state in the beginning of the exercise, if so, obviously this code does not compile because there's no such thing as a player class. Basically, we cannot write code assuming something is going to exist when in reality it does not exist just yet. So really the solution to this, and the solution for the validation logic for pretty much all exercises, the solution is to use reflection. Like I said, reflection is really just a name of various functions that work directly on the types. So for example, we can access just the exercise type, just like this. And then let's just do a dot, and now we can see a whole bunch of things. In this case, for this exercise, let's say we want to find a defined player class. So for that, we can use the function getNestedType, and this one takes a string of names. So let's look for a class named exactly player like this. Now we can indeed write this code, so there are no errors, because again, we're just using a string in order to identify the player class by the name itself. So this is valid code, we've got no compiler errors. And this function is going to return an object of type type. So we can do type player type, we can do this, and then we can do a console.writeLine if this one does exist. So let's just print out just the player type. So let's see this. And if there it is, it prints out nothing because there's no player type. But if over here we define it, so public class player, if we define it like this, And yep, now it does indeed find that class. So by using reflection, we can write some code that tests if something exists before that thing actually exists. Alternatively, instead of looking for a specific type, we could also use the other one, so typeof for the exercise, and we can call getNestedTypes. This one grabs all the types. It returns an array of types, so we can just do a simple for each on all of this, type, and all of these. We can look for them, and then let's just print out the type, all the types. So over here, if we've got the player, then some kind of unit class and some kind of enemy class and so on. So if we test this, we should be able to see all of them. And if there it is, we've got the first player over there, then player, unit, and enemy. So on pretty much all of the reflection functions, you always have one to look for a very specific thing, or one to look for all of them. And also on both these functions, you also have all kinds of filters. So there's a function that takes some binding flags, and these binding flags are really just filters. The main ones that I used quite a lot in the exercise was looking for static things. So for example, on static, or for example, this one non-public. Because for example, if we don't assign this, and let's say we mark these as private, if we do it and we run this code, and if there it is, our cycle only found the player class because it is the only one that is marked as public. So in order to find things that are private, if so, we need to use the binding flags. In this case, to find that one, we need to look for non-public. And by the way, if you want to implement multiple filters together, if so, you just need to write a pipe. So that's just a single pipe. This is the bitwise OR operation. So do this, and then we can add another one, like for example, looking for static. So right now, since we defined the filter, this is only going to find things that are non-public or static. Meaning in this case, it will not find the player, but it will find both these. And let's just erase this just to not get confused, and let's test. And if there it is, it's done like that. Finds the unit and the enemy, but no player. So yep, you can use either of these methods in order to find a specific type somewhere. So for example, some kind of player type. Okay, we have it. So we have this player type right here. We can just test this one against null. If this one is not null, then the type does exist. And if it does exist, then again, like we saw previously, we can find and call some kind of function. So for example, over here, public void, call it my function. And then by using the player type, which by the way, another note, we can get the player type either like this, like we did, or also again, using the typeof keyword. This one returns a type. So basically player type or typeof. In this case, since exercise.player, since this one exists, we can do this. So basically both these have the exact same thing. Okay, so then using the type, we can call get method, and let's find our function. So let's find the my function. This one returns a method info, my function method info, and then we can invoke it as usual, except over here, we need an object. So let me just do a new player. I'm going to talk about how you can dynamically create objects in a little bit. So over here, new exercise.player. Then this one has no parameters, so an object, an empty object array. And yep, so this is basically going to run this. So console.writeLine, and we can run my function, and we can see, and yep, exactly, it found the player and ran the function on the player. So yep, all this works. And again, over here, we don't have any direct calls over here to my function. If we select this and we find all references to this, nope, we do not find any references because the code is not being directly referenced. Instead, we're referencing only through reflection. Now, like I said over here, the second parameter, this one is for all of the parameters that this function takes. And just in case you don't remember, object, this is the base C# class. This is basically the base type that all of the C# types inherit from. So this can be anything. So for example, we can define a function with an int parameter. And then over here, we can call like this. So we can do this and then print out that one, and let's see. And if it does work, my function and did receive that one. Although of course, we need to pass in the correct type. Since over here, this is an object, this has no limitations. So we could pass in, for example, a boolean, and there it is, we have an error. We passed in a boolean, which cannot be converted automatically into an int32, which is what the function expects. So even though this is of type object, obviously the types need to match whatever this function expects. And through the method info, we can get pretty much all the info for this function. So for example, through that one, we can get, for example, the return type, and this is going to return, over here in this case, it's going to return void. Or alternatively, we've got all kinds of things. You get the parameters. This returns an array of parameter info, which again contains all the data for all the parameters. So the type, the name, and so on. Again, all of these are things that I use in making pretty much every interactive exercise. There are various exercises that require you to implement a specific function that returns a specific type with a specific number of parameters. So that's pretty much how all of that code works. If you want, you can actually inspect the code for the exercise completion. So you can start an exercise, like for example, this one on defining a player class. So the goal on this one is to define a player class and then define some functions inside of it. And in the project files over here, you can see inside the exercise folder, you see a bunch of files related to the exercise that you have enabled. So in this case, let's open up the exercise scene tester. And yep, over here, if we scroll down, we can see all kinds of reflection being used to make this exercise work. So for example, over here, it's going inside the exercise class and looking for the nested types in order to find the player class. And if it does find it, then it goes inside all the methods within that player class in order to find a say hello method. And if so, then basically, yep, the exercise is completed successfully. For another practical example, you can, for example, just look at the Visual Studio IntelliSense. So if we write some regular code like exercise.player and then put a dot. So for example, if over here we construct a brand new player. So we have a player and then we access the player and we do a dot. And yep, over here, this is basically using reflection. Visual Studio is going through the entire type over here behind the dot, and it shows all the fields, all the functions, and all the events related to that type. So using reflection, you could build something like IntelliSense. Another thing is how code in C# is grouped into assemblies. So for example, let's grab the type of our program type. So that's the default one up here. We can grab that one and grab the assembly. Let's just do a console.writeLine on this one. So let's just print this out and see. And if there it is, that is the name, that is the reference for our assembly. Which again, inside that assembly, that returns an assembly. So inside that one, you can then put a dot. It can get all the types, all the files, all the things, everything that exists within that assembly. Also, if you want to look for any types inside of an assembly, of course, as usual, you can cycle through the types and print them all. But if you're looking for a specific type, if so, then over here on the name, you need to write it exactly as the assembly writes it. So if we print to see what this one up top writes, yep, this one says CodeMonkey C# course, which is the namespace, then the program, so we're inside the program class, and then for example, the exercise class, and then the player class. Again, note the dots and the pluses. If I wanted to get the player type over here, if I were to just write exercise.player, so if instead of this, I just write this, so just exercise.player, if I do this, then nope, it does not find it. In order to find it, over here when you call getType, it needs to be called with the exact same full name, including the namespace. Including the namespace and also including over here the dots and the pluses. If we do this, then yep, now this one does find it. So one more thing is like I mentioned a while ago, which is dynamically creating objects of a certain type. So for example, over here, we constructed a brand new player and we use that to invoke the method. But again, if this code was written before the player class existed, then this would not be valid code. So we need to also dynamically create an object of that type. So over here we have the player type that we dynamically grabbed. And now with this one, we can create it. And for that, we use the class called Activator, exists inside of system. And then we call create instance. And then we can either pass in strings for the names, or if we already have access to the type, let's do that one. So let's just pass in the player type. And yep, this one is going to construct a brand new player object. This one is going to return of type object, because again, we're running this before, let's say, the player class is defined. So we need to use the generic object, so player object. But then again, over here on the invoke, this one also takes in an object for the target. So we can pass in the player object. And yep, so now this one is going to create an instance of our player type. So it's going to create a brand new player object. And then we're going to use that player object over here to invoke the function. So if we run this, and yep, everything works as usual. Now, yet another interesting thing about reflection is how you can bypass access modifiers. So for example, over here for this function, instead of making it public, let's make it private. So in this case, even if you have access to this code right now, if we go inside exercise.player, if we construct a brand new player, and then we go inside player and try calling my function, and nope, this does not work, because again, like it says, this is inaccessible due to its protection level. So if you have a private function, you cannot call it, you cannot access it through regular code, that's the usual thing. However, you can still run it over here through reflection. So if we run this code, it still works. We just need to make sure we find the actual methods over here for the binding attributes. And we need to make sure to find the functions. So over here when looking for it, since this one is private, let's make sure to add the binding flags for non-public. And also for this one, we also need to add the instance because this is an instance function. So if we run like this, even though the function is private, yep, that one still ran the function. So by using reflection, you can run private or internal code. Now again, do keep it in mind, this is probably not something you should do in your own code. If you make something private, then you probably want it to actually be private. But for example, if you're making some kind of testing code, if you're doing test-driven development, if so, you probably still want to test your private functions. So if so, then reflection can be a use case for it. Or another example is when working with some APIs, like for example the Unity API, where some functions might be marked as private or internal. So in those cases where you cannot directly modify the code and you really need to call that function, if so, remember how you can do it through reflection. Related to that is also doing things like modding and plugins. You can allow your game to dynamically load a DLL at runtime and then use reflection to run the code inside that library. So that's reflection. It's a very interesting topic, definitely very niche in terms of use cases. Like I said, I really only had reason to learn about it right now in order to make the exercise for this course. so it's probably not something you're going to use regularly, but do remember that it exists. Remember how there is a way to dynamically run your code if you need to. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about function extensions or extension methods. This is a really interesting C# feature that allows you to extend classes without having to modify the code in that actual class. So usually if you have some kind of class, like for example over here I've got a myTransform, if you have it and you want to add some kind of function to it, usually you just modify the class and write the function inside of it. So for example, a public void move right, and then over here would take the position and increase to the right, something like this. Okay, so yep, that works. Here is the function. And up here, if we have something of type myTransform, if so, then we can go inside of this and we can indeed call the move right function. So yep, this works. This is perfectly valid code. We have modified the class to add our custom function and then we call the function. However, what happens if you can't modify it? Like for example, let's say I do want to implement this kind of move right function. However, instead of making it work with my custom myTransform type, instead of this, I want to work with the built-in Unity transform type. Now that type is sealed, I cannot modify it. So I can put transform for some kind of transform, and we can try going to the definition. So here it is, except this class is compiled, meaning we do not have access to modify this. So the method of just writing the brand new function directly inside this class, this does not work because we cannot modify this class. So that's exactly where function extensions come in. Which again, remember how function and method are pretty much interchangeable names. So if you look in the C# docs, what we're talking about here is actually technically named extension methods. So extension methods or function extensions. This is basically how you can add extra functions to some kind of type without having to modify that actual type. We just need to follow a bunch of rules to make it work. The first thing we need is to be working on a static class. So let's make a static class. And then usually the naming rule is to name it something and then add extensions onto it. So in this case, we want to add some function extensions to the transform type. So let's call it transform extensions like this. That's the first rule. The second rule is the function needs to be defined as static and be public. So over here, a public static void, call it move right. And finally, the third rule, for this one over here inside the parameters, the very first parameter, this one needs to have the this keyword. It needs to have that and then be the parameter of the type that you want to extend. So in this case, we want to extend the transform type. So let's put it transform like this. And if that works, so this is now a valid function extension. And now inside of here, we can do our regular code. So for example, we can do exactly what we were doing. So let's go inside this transform and modify the position and do a new vector 3 and just move it to the right. And if there it is, this is our function extension. And now up here, when we have access to a transform, like for example, the transform that this object is attached to, we can go through that one and we can call the function move right, and yep, it does work. And we can see over here, IntelliSense is telling us, yep, this is an extension function. So we can call this, and yep, this works perfectly. So we've got no errors. Basically, what is happening here is this keyword over here inside the function. This says that this first parameter is special. Basically, it assigns what it was called on and uses that over here on the first parameter. So basically, over here, this is doing the exact same thing as if we were to manually go inside the transform extensions, call the move right function, and pass in this transform. So both of these are doing the exact same code. The only difference is this one is much easier to use. So yep, as you can see, like this, we have added a brand new function onto this type, onto our transform, without having to modify the transform type itself, so we don't need any access to it. We just need to know the type, and we can write an extension, and then we can write some kind of code that works directly on that type. And of course, over here, after using this special parameter, so this parameter, this one has to be the first one, but afterwards you can add whatever you want. So let's say, for example, a float amount, and over here we modify this one by the amount. And then when calling it, we just pass in, for example, 3. And yep, this works. So we call the function extension, which is going to call this function. For the transform, it is going to use this one, and for the amount, it is going to use this one. And again, this works on any type. So over here, we are making a function extension that is extending the transform type. But for example, let's do another one. Again, we just need to make sure to mark it as static. And let's extend, say, the bool type. Let's make is true. This one returns this, bool. And for example, just return if the boolean is true. So yep, again, all the rules are being followed. It's inside a static class. The function is static and has this keyword. So now up here, bool, and we can set it to something. And then bool.isTrue. And yep, this does work. So yep, we can add function extensions to some custom types. Or we can add to built-in types, can be a boolean, can be an int, can be literally anything. All of this works so we can easily extend any type with any functions we want. This works for extending classes, but also works for extending value types, like we saw over here, the bool. So we can also extend structs, and this also works for extending interfaces. So if you want to add extra logic to a type, but either you cannot or don't want to modify the original type, that's where function extensions or extension methods come in. It's one of the best ways to make some helper utilities functions that you use a lot and make them super easy to use. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the static constructor. This is a really useful way to run some kind of initialization code where you can be perfectly certain that it will always run. Okay, so you're already familiar with the regular constructor. So we have the class and then we have a constructor, and this code is going to run whenever a new object of this type is constructed. So basically before you use this type at all, before you use any functions or fields, before that you can make sure that this code always runs. And static constructors are basically the same thing, but just in a static context. And the way that you define them is super simple. You just use the static keyword with no access modifier, so no public, no private. This cannot be either one of those. You cannot manually run a static constructor. It always runs automatically. And then it must have the same name as the class, so player. And it also must have no parameters, so a completely parameterless constructor. Also, you can only have a single static constructor, and it cannot be inherited or overloaded. So it has a ton of limitations, because like I said, this one runs automatically. So that is why we cannot have any parameters over here, because the compiler is going to run this automatically whenever we need to. And basically this will run either when an object of this type is created, so for example before the constructor, or also when any static data or any function is accessed. So for example, let's do a console.writeLine here, just to see when this runs. So the player static constructor, and if we run like this, so we have our player class, we've got the constructor, the static constructor, and up here we are just constructing a brand new player. If we run this code, if there it is, it ran first the static constructor and secondly ran the constructor. So the static constructor always runs before the object is constructed. Now let's say we have some kind of function, so a static void for some kind of test function, and over here same thing, let's do a console.writeLine on our test function. Okay, and now up here before we construct, let's go inside the player and call the test static function. Let's do it like this, so let's run. And if there it is, again, same thing. The static constructor ran, then the test function, and then the constructor. Also note how the static constructor only ran once, so when we construct an object, it did not run a second time. Or alternatively, if we have some kind of field, so a static int for some kind of int field. If we have this, and up here we read it, so let's do console.writeLine. Let's write line on the player.i, so our static field. So by default, if we don't assign any value, this is going to default into 0. So over here, if we set I equals something, let's see what this one is going to print. So is it going to print the 0 that is over here by default? Or is it first going to run this code and basically print 56? So let's test. And if there it is, exactly like that. So as soon as we access the static field, as soon as we do that, before it actually runs that code, it is going to run the static constructor. So first runs that one, then prints the value, which in this case was assigned the static constructor, and then again runs the function and the constructor. And same thing, the static constructor only ever runs once. Meaning that the static constructor, this is really excellent for doing any initialization logic that this particular class might require. One example is exactly this, is if you have a static field and you want to make sure to initialize with some data. If so, you have two options. So basically over here, when you define it, you can also assign it some value, or alternatively, you can assign it on the static constructor. Both are valid options, pretty much just like on a regular constructor. You can also have some kind of regular field. So you can have that one, and over here you can assign it some value, or inside the constructor you can assign it some value. So you've got these two options for non-static context, and you also have these two options for a static context. Now the static constructor, this one can also be very useful for debugging. You can basically place a log over here, and it will let you know when this class is used for the very first time. Whereas if you were to place the log only on the constructor itself, if so, then this would only run when an instance of this type is created. Whereas for the static constructor, that runs whenever any object is created, or when any static element, like a field or a function, when any of those are accessed. So the static constructor, this one guarantees that it always runs the very first time that this class is used in pretty much any way. It is also important to know how in the context of multi-threaded code, the static constructor is guaranteed to be thread safe, meaning if you have multiple threads and all of them try to access some kind of data inside of this class at the same time, if so, the .NET runtime ensures that this class is locked, and make sure that the static constructor runs only once, no matter how many threads try to access it at the exact same time. So the static constructor is relatively simple to understand. Definitely use it whenever you need to ensure some initialization logic happens, and ensure that it happens in a static context and not just on a per object basis. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the typeof operator. This operator lets you get the type object of a certain type. Okay, so typeof. Now, we've actually already used this a few times in the reflection lecture, and also on the one on typecasting. The way we do reflection is by accessing the type, and I don't mean by accessing the type name itself, so if we call just player, if we do this, nope, we are not accessing the type itself. This is not valid code. In order to access the type object, meaning the object of type system.type, the way we get that is with the typeof operator, which works sort of like a function. So we write typeof, then parentheses, and then the type within it. And if we do, then we can see that this does now return an object of type system.type. Like it says here, this represents type declaration, so class types, interfaces, arrays, values, enumerations, and so on. So this is the base type that references pretty much any type you can create. So now with this type object, then over here you can do all kinds of things. So you can get nested types, nested functions, and so on. So this is how you access the reflection that we already covered. Whenever you have some kind of function that requires a type object, meaning system.type, if so, then this is what you want to use. Like for example, when working with some Unity code, if you want to get the component attached to some kind of game object, you use the getComponent function. And this one actually has two versions. One of them is this one with the angle brackets, meaning this one is using generics. This is actually the version that I normally tend to use. So just put this, and then inside you put the type that you want to get. So just like this, it's going to get the component of type player. However, alternatively, you can also use the other version. So this one over here, which is non-generic, and note how instead of having a generic parameter, this one receives a parameter of type type. So this is where you would use it. If you were to use this and you just type in player, if you do just this, then nope, this is not valid code. Again, that's the difference between having an object of type player as opposed to accessing the type directly. So in order to make this work, in order to use a function that receives a parameter of type type, for this one we use typeof, and yep, now this does return the correct thing, and this will return a component of type player. This is the one thing that you definitely need to remember. This is something that drove me crazy for a long time until I finally memorized it. Whenever you see something that takes a type parameter, whenever you see that, always remember you have to use the typeof. Because yeah, for me it has happened many times where I see a function like this, I try to use it like this, and I have no idea what is wrong. And the reason that is wrong is exactly that. We need to do typeof in order to get the object of type type, and now this does work. Or alternatively, like we saw on the lecture on typecasting, you can, for example, create an object of that type. So for example, making a brand new player. And another way to get the type of type player, if you have an instance of that type, you can just call the function getType, and yep, this is going to return the exact same thing. So if you have an object of a certain type, you can call getType, and if you don't, you can do typeof and then pass in the class name itself. So yep, that's typeof. It's very useful when you need to get the type object to use in some kind of code. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the nameof operator. With this one, you can get the string name of a certain type or field or function. Okay, so nameof. This is an operator, meaning you use it sort of like a function, so it's similar to the typeof that we already saw. So you write nameof, and then inside parentheses, you put the name of something that you want to get the name of. Now, the main benefit of this operator is to avoid using strings, which is something that I always highly advise you to do. You should never use strings to identify something. So if you want to reference the player class, if so, do not type a string just saying player. So don't do this, instead do something like this. So player class name, you do nameof of the player class. So instead of using hard-coded strings, use nameof to avoid using strings directly in your code. This also helps avoid issues with refactoring. So if you have a hard-coded string kind of like this one, if you do this and you refactor, so instead of player, let's call this just a general unit. If so, then yep, now this literal string, this is now completely wrong. Whereas with nameof, if you modify the name inside of here, the name of the actual type itself, if so, then what returns from this is going to be updated. Now, this works for classes, but also for fields and functions. So for example, let's actually do a log, just see what this says. So let's do a console.writeLine. Let's print out this one to see what this says. And let's also rename this back into player. Okay, let's test. And if that's it says literally player. This gets just the string name for the class, whereas, for example, if you do typeof in order to get the player type, and then you convert that one automatically into a string, let's see what this says. And if you get the type, then you get the whole thing in order to get to the type. Whereas with nameof, you get just the name of that class, that type, that something. So this works with types itself, like these, but it also works for fields and functions. So we can do this, print out the player speed, and print out is grounded. And if we run this, and yep, this return exactly the name of those elements. So it can work with classes, with fields, with functions, and pretty much anything. One thing this is great for is, for example, for debugging. So for example, if you want to validate some kind of function, so over here, let's say a public void set speed in order to set the player speed. This one let's receive an int for the speed, and then set this.speed equals this kind of speed. However, for debugging, for some kind of validation, we can add some extra logic here. We can say, for example, if speed equals 0. If it is, let's say this is an invalid value. So if so, let's do a console.writeLine. Let's print out to the console error. And then instead of hard coding saying speed must not be 0, instead of hard coding this, because again, if we were to modify this for the something like set speed and so on, if we were to modify it to something, then a hard-coded string would not update. Whereas if we have the name of here, so name of and pass in this speed parameter, so this parameter name, if we do this, yep, now this will indeed work. So up here, let's create a brand new player and call player.setSpeed, and let's set it to 0. And if there it is now, that is correct. So error speed must not be 0. And if we were to refactor this, so speed to set, if we do this, and yep, now it correctly sets the parameter name exactly as it should be. So this can be really great for making your documentation a little bit more robust. Again, anytime you can avoid using hard-coded strings, that is always a better approach. And technically, this one also has a nice performance bonus. For example, if you already have a player, you can technically go and call getType, and then from type, you can just access the name. So this works, and this will pretty much print out the exact same thing as here. So let's actually do that. So console.writeLine. And if there it is, this one prints out player exactly the same. So the one performance bonus is if you do this, if you access the object, you get the type and you get the name, or alternatively, you would just do typeof of the player type and then grab the name. Doing that code would actually run at runtime, whereas over here, the name of, this one is executed at compile time, meaning that when the code goes to compile this code, when it does that, the compiler replaces this line of code over here with a literal string. So as soon as you compile, instead of this code being right here, it will replace it with exactly this. So this is a tiny change, but still a nice bonus. So it's a tiny bit more performant. All right, so that's name of. If you ever need to get the string name of a class or field or function or anything, then use this instead of hard coding a string. This makes your code more maintainable and less error prone. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the sizeof operator. This one lets you see the size in bytes that are used in memory to store a certain type. Okay, so let's see the sizeof operator. Now this one returns the value in bytes of a certain type. Like for example, we know that ints are stored in 4 bytes, so if we have an int I, we know this is going to take 4 bytes. And we can test that. Let's do a console.writeLine, and let's print out the size of. This is an operator, so we use it kind of like a function, so kind of like the typeof and nameof. And this one takes in the type, so let's put in int, and let's see. And it picks out like that, 4 bytes. So we can see the size of an int. We can also see, for example, the size of a boolean. And yep, a boolean is only true or false, so this one only takes 1 byte. Or for example, let's see a ushort, which is a much smaller version of storing whole numbers. And if this one, unlike the int, this one takes just 2 bytes. Or on the other hand, we can see, for example, a long. And yep, a long takes 8 bytes. So yep, basically this one lets you see how many bytes a certain type occupies. Now this is extremely important for memory management. Memory management becomes really important when you're working with some very memory limited devices. Like for example, if you're doing something on some very old mobile devices, or maybe some IoT or embedded devices, or perhaps if you're syncing data in a multiplayer game. If so, usually you want to limit how many bytes you send over the network as much as possible. The less you send, the less it's going to cost in terms of bandwidth. So knowing that a ushort is much smaller than an int, that can be very helpful if the number you are trying to send across the network can't fit within a ushort. Or it's also useful if you're doing some specific low-level memory management where you need to allocate some unmanaged memory manually. This way you know that, for example, if you have 4 ints, you know how big that will be in memory. So as we saw, you can see the size of all of the built-in types, so int, bool, short, and so on. This way, if you have to store, let's say, 1,000 ints, you know exactly how big that will be in memory. However, you cannot use sizeof on classes. So for example, if I put here of the type player, nope, this one does not work. So we cannot use sizeof in class like it says here. Player does not have a predefined size, therefore sizeof can only be used in an unsafe context. Now there is a lecture in the advanced section later on using unsafe. This basically removes all kinds of protection that C# has by default. So that's one option is you would use unsafe and then put this inside an unsafe. And if this would indeed work, you just need to enable unsafe compilation. Or alternatively, if you need to know the size of some kind of class, for that you can go inside the Marshall class, which exists inside this namespace, system, runtime, interop services. And inside you do have a size of, Although this one has a bunch of strange limitations that honestly I'm not very familiar with. I'm definitely not an expert when it comes to marshalling data, dealing with bytes and all of that stuff. But over here, if we don't include this attribute, then this throws this error. It says cannot be marshaled as an unmanaged structure. No meaningful size or offset can be computed. And with that attribute, it does work. It does store it in 4 bytes. But then if I were to add something like a public list of ints for some kind of int list, if we do, then yep, that shows that same error again. So honestly, I'm not entirely sure how to make all of this work. I believe you have to use the marshal as, and then marshal this field as some kind of unmanaged type. And then you have to select the one that is related to whatever type you're trying to marshal. But like I said, I'm not an expert in marshalling, so I'm really not entirely sure how this whole thing works. But basically you can use the standard sizeof to get the size of any of the built-in types. And then for classes, either use marshal.sizeof or put it inside an unsafe context. And for structs, this one also works. So you can do marshal.sizeof of some kind of struct that has some kind of data. Again, it can't have any kind of managed data like a list. But if we do them like this, give this print, the size of that struct is 8 bytes, which makes sense since it has 2 ints inside of it. So if you ever want to get the size of a certain type, then use sizeof or marshal.sizeof. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the default operator. This one is really useful for when you want to assign a value to initialize something, but without giving it a specific value. Okay, so default. Now we've actually already used this keyword in 2 scenarios. So for example, we use it in some kind of switch. So you define something, do a switch on that something, and then do all kinds of cases. So case some kind of number, run this code. And if not, if it does not match any, then run the default case. So basically this is the code I will run if the value does not match any of the other cases. And the other scenario where we've also seen the default being used, for that was on the lecture on the optional function parameters. So if we have some kind of function, public void set speed, and this one receives an int for the speed, and if we want to make this an optional parameter, if so, we just have to do equals and then default it to some kind of value. So you can default it to a fixed value, or you can use default, the default keyword, which will return the 0 equivalent value for that type. Now there are actually 2 ways to use default, the shorthand and the normal way. Now the normal way is using the operator default, kind of like a function. So we do default, and then for example, we pass in the type, so let's say int. Let's do a console.writeLine on this to see what this says. Yep, there it is, 0. Like I said, default will return the 0 equivalent value of that type. So in the case of an int, the 0 of an int is indeed just 0. However, if we try to see the 0 equivalent of a boolean, yep, this one prints false. In booleans, you have either true or false, where true is usually equal to 1 and false is equal to 0. So for the 0 equivalent, it returns false. And then for class types, like for example, a player class, for that class types, the default is going to be null. Remember the lecture on value types versus reference types? Value types always have to have a value. So when we do a default on something like an int, which is a value type, when we do that, we have to get a value. But references, like the player class, these can simply have a reference that points to nothing, meaning null, so default of any kind of reference type is going to be null. Now this is the quote-unquote normal way of using default. Use it as an operator with parentheses and then put the type inside of it. However, another way is just to let the compiler infer the type. For example, if we just define a float variable, if we do this, and then for assigning, we just assign it to the keyword default. And yep, that's it, no parentheses with float, just like this. And yep, this does work. So if we print out df, and if there it is, a float does default to 0, which is actually the exact same thing we are doing down here on the optional function. So we can just write default, or we can write default int, and yep, both of these work exactly the same. Now, another place where default is very useful is when working with generics. So for example, if we have some kind of class for some kind of box, and this box stores an object of type t, then over here, let's do a public going to return t, and let's call it getDefault. So on this function, we want to return the default value that is stored inside of this box. Now, by being generic, that means we don't know what type t will be. Maybe it's going to be an int, or maybe a bool, maybe a player, we really don't know. So over here on this function to get default, we can't really just return 0, because again, t might be something like a player, and you cannot convert a player onto a 0. It can also not be false, it cannot be null, and so on. So in this, if we want to return some kind of default value, again, we can just use the default keyword, either with the shorthand or default t for the longhand. And yep, so now if we create a box of int, bool, and player, so for example up here, let's do a console.writeLine, let's do a writeLine, let's create a new box, let's do a box of ints, and then let's call the getDefault. Let's see what this prints. Let's create a box of ints, then a box of bools, and finally a box of player. Okay, let's see these 3 boxes. And if there it is, 0, false, and then null. So the same code now returns different default values depending on what generic type we use. Or alternatively, when using the ref and out keywords, I'm going to cover these in detail in a future lecture over here on the advanced section. If we were to do an out bool is set, something like this, Basically, the out keyword means that this parameter is an output parameter and must be set before the function ends. So again, for these, if you want, you can define some kind of default value. You can default to that, or you can just use the default keyword. So if you ever need a default value for something, instead of hard coding some value, you can just use the default keyword. It will use the 0 equivalent value of that type. Usually that is either the number 0 or false or null. Hi there, are you enjoying the course so far? I hope you're learning a lot. Consider checking out the premium version of this course with tons of awesome bonuses. The companion project is really excellent for helping guide you in your learning journey. It contains frequently asked questions and fun quizzes to test your knowledge for every lecture in the course, and importantly contains interactive exercise so you actually put into practice what you're learning. I designed those specifically so you can learn by doing. If you can afford it, then now would be a great time to pick up the premium version and basically go through all the lectures that you've already seen. And beyond that, it also has a bunch more bonuses, including simply having no YouTube ads to distract you in your learning journey. So if you're enjoying the course so far, then check it out. Also remember to like the video and subscribe if you haven't already. Alright, so let's keep learning. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about expression-bodied members. This is a way for you to write C# code in an extremely compact manner without having to sacrifice readability. Okay, so expression-bodied members. Like I said, this is a very compact way of writing some code. For example, if I have some kind of player class and inside I have some kind of player name, and then I have a function that returns the player name, so get player name. So I can do this and then simply just return the player name. And if that's it, a very simple function. This is the regular normal C# code. However, we can make this quite a bit more compact by using expression-bodied members. Basically, if you are familiar with the lambda anonymous functions, then this is basically the same syntax. So we define the function, and then instead of opening a code block, instead of that, we do a little arrow, and then we just put what we want to return. So in this case, just player name, just like this. So if that's it, this is the whole syntax, super simple. So basically this and what we had previously, both are doing the exact same thing. The compiler basically sees that this function returns a string, so it automatically adds a kind of return statement here. So this one does do the same as the other version, it just returns the player name. Now this method, expression-bodied members, this is really only meant for extremely tiny pieces of code. In fact, you can't even do a code block with this syntax. So if I try opening and closing a code block, nope, this is not valid code. You cannot do a code block with this syntax, which means that this feature can really only work with single instructions. You cannot use this on things that require multiple instructions. You can use it like this in order to return some data from a function, but you can also use it to set some data. So for example, a set player name and receives a string for the player name, and we can do the little arrow and set this.playerName equals this player name. And yep, there you go, another perfectly valid function. Again, with some limitations, this one can only have a single instruction. So if you need to do multiple things, you do still need to use the regular normal C# code block. But for super simple things like just getting and just setting, then this makes the code quite a bit more compact. In fact, one place where I've used this quite a few times is for function pass-throughs. Like for example, if you have some kind of class, and that class is really just meant to be a layer of abstraction for another class. For example, when I made a turn-based strategy game, I had some kind of level class, and inside that one, I was using the actual underlying grid system. And for some functions, I really just wanted to pass that function call onto the underlying grid system. So for this use case, this super compact function pass-through, this is a really great option. So here we can see how this works for functions, but it can also work for properties. So for example, if we have a public string player name, just a regular property, if so, we can do the get, and now normally we would write a code block. However, we can do the same thing, just a little arrow, and in this case return player name. So this is a read-only property, or we can also assign the set player name equals value. Yep, this is also valid code. Or you can actually also use it in a constructor. So if we have public player, define a constructor with some kind of string for the player name that receives on the constructor. So here we can do the little arrow, player name equals player name. And yep, this is a valid constructor code. However, again, the same limitation. This only works if the constructor has just one instruction. So for example, if over here we had two fields like vector3 for the position, if so, we couldn't set the player name and then set the position on the same line of code. So expression-bodied members are really good for making some really compact code, but as always, you should never sacrifice readability for compactness. So personally, I really like how this has a whole bunch of limitations, which means that it can really only ever be used in situations where it should be used. If you have some extremely simple get and set functions, then this can be quite useful without having to sacrifice any readability. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about C# records. This is a super simple way to create immutable types to organize your data. Okay, so records. The basic usage is actually incredibly simple. So first you write the access modifier, like let's say public, then we write the record keyword, and then some kind of name for this type, like let's say person, and then we open the parentheses, and we write our parameters. So for example, something like first name and last name. And yep, that's it. Just with this, we have created our person record. So as you can see, if you need to organize some data, it can be similar to just define a simple record as opposed to defining a whole class. So for example, something like this, so person class. If we had this, we would then have two properties, so one for the first name with a get and a init, meaning needs to be initialized, and same thing for the last name. So yeah, basically over here, we have the exact same thing written twice. We have two pieces of data, which in the case of records, the underlying compiler, these are actually auto-implemented properties, and they are also immutable, meaning they only have a get and have no set, and also they need to be initialized. So yep, this super simple record is exactly the same thing as this. You can see how this is quite a bit easier to write whenever you need some kind of structure to hold some data. And then to construct a brand new person, you really just find person, and then you can do new person, or really just open up the new like this, and then pass in all the parameters. So in this case, let's say code monkey. And if that's it, here is our brand new person. So we easily defined in just one line of code and easily created in this one. Then with this, let's do a console.write line in order to see person, what this says. And if there it is, the toString automatically writes out the actual type, so person, and then all of the parameters and all the data they have. So yep, this is how simple records are. And now by default, records are indeed like this, meaning they are immutable, they have no set, they cannot change. Here, if we try creating a brand new person and then go inside the first name and modify it to something else, nope, this does not work. This one can only be set once it is initialized. It cannot be modified afterwards. However, if you really need to, technically you can make it mutable. You just need to define the record, and then instead of doing a semicolon, you just open a code block. And now inside you can define all the properties. So for example, first name. And on this one, let's put it with a get and with a set in order to make it mutable. And we just have to do equals first name in order to make sure that the value that it receives over here is the same one that is set to this property. So yep, like this, if we now do a person and go inside person and modify the first name to something else, yep, now this is indeed valid code. However, records really are primarily meant to handle immutable data, so you really should avoid doing this unless absolutely necessary. The fact that they are immutable is indeed part of the purpose. Immutability is really great for handling static data, especially when working with things like multi-threaded code. If you have multiple threads, all of them accessing an object that is mutable, it can cause all kinds of strange issues, all kinds of race conditions when multiple threads try to write to the same field at the same time. Whereas if a field is marked as immutable, meaning that data can only be read, that eliminates all those issues. Now if you want, you can also do something that is called non-destructive mutation, which really just means creating a brand new record based off another record. So for example, over here we can do person, call it person2, and we can start from data contained inside person, and then use the keyword with, then open some curly brackets, and now here overwrite any of these. So for example, let's say last name, set it to gorilla. And yep, just like this, so now we have person and we have person2. And yep, there it is, the first one code monkey, second one code gorilla. Now this is technically called non-destructive mutation because in reality it doesn't really mutate the original data. This one still stores the exact same thing, basically just creates a brand new one using the parameters from the previous one. Also over here we are really just using the record keyword. But what this is really doing is really the same thing as writing record class. So by default, records are going to be classes. However, if you want, you can also make it a record struct. Yep, this also works. So your records can be either classes or structs. However, in terms of equality, they mostly behave like structs. They mostly behave like value types. Meaning if we make this a record class, and up here, let's create two persons. So let's call it and person3. So here we're doing new twice. So technically these are two objects. So if person was a class, these two would be different because they are different objects. However, if we do a console.write line, if we do that and we check person equals person3, if we check this, yep, this one does return true. Now in a normal class, if this were a normal class, this would return false because these two are technically separate objects. However, since this is a record class, because that, the equality behaves more like struct, meaning it checks the underlying values for the equality. Again, this is because records are really primarily meant to be used for data organization, so the equality logic is all made based on that. Then if you want, you can also handle inheritance with records. So for example, we can do a public record, let's call it unit, and inside let's do some kind of float for some kind of speed, and then we can have a public record for some kind of player. This one receives a string for a player name and also a float for a speed, and this one then extends unit, and for the parameter, it passes in the same speed parameter. Yep, that's it, this is valid code. Also, one more note, technically records were only introduced in C# 10, and Unity is actually currently on C# 9. However, it does support records, but in order to make it work, it requires a slight workaround. So here I have some Unity code, and if I define, let's say, some kind of record for a player, receives a string for the player name. So this is a record. However, if we do, we see this error. So predefined type system.runtime.compilerservices.isExternallyInit is not defined or imported. So in order to make this work, in order to make records work inside of Unity, for that we basically need to create this type. So we need to put it inside of this namespace. So we need to create a class inside of a namespace. So let's do a namespace and name it like this, exactly like this. So system.runtime.compilerservices. Let's open and close. And then inside we need to define a class. And the class has to have this exact name. So isExternalInit, and define a class just like this. So it's all completely empty. It really just needs to exist. And if it does exist, then yep, this is now valid code. All right, so records are an interesting way to very quickly define a type to hold some data. Instead of defining an entire class or a struct, you can very quickly define a record and have it with the perfect accessibility for some immutable data. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about non-conditional operators. These are two operators that help simplify your code by eliminating the need to do some null checks. Now, this is actually something that we already used in the events lecture. If you remember, for events, before you invoke the event, before that you need to test whether the event is null or not. Otherwise, it will throw a null reference exception if there are no listeners. And the compact way that I showed you for doing a null check is with this question mark. This is what is called a non-conditional operator. And basically, the code is executed from left to right. So when the code reaches the question mark, at that point it checks the left side. If this left side is null, if so, then this instruction terminates right here and just moves on to the next one. However, if the left side is not null, then it continues executing onto the right side as if this question mark was not here. So basically the question mark, this does a null check at this point, and on the right side you can write any code with the safe assumption that the thing on the left side is not null. Also, when I say that the instruction terminates here if it is null, what that means is that this whole thing gets evaluated into null. So for example, up here, if we do a console.writeLine, let's do a function to print something, so a public string, get player name, and let's just return a string, so something like this. And up here, let's just construct a player, so player, and actually let's leave it in null. And now we do player, then the question mark, and then get player name. So if player is set, if so, then it's going to return the player name. But if the player is not set, then this whole thing is going to evaluate into null. So if we run this, if there we go, it's empty, meaning that it's actually null. So we can test and verify equals null. And if that is indeed true, so if the left side is null, then this whole thing evaluates into null. Whereas if this one is not null, so over here, let's just construct a brand new player. So this one is not null. If so, then yep, it runs the entire thing and calls the function. And by the way, like we saw here, you can call any function after the question mark. So the standard that I showed you for the events is using .invoke, but that's just a event-specific thing. However, the question mark, the non-conditional operator, this one is not limited to just events. So as you can see, it works over here for the get player name and also works for fields. So over here, if we have a string player name, if we have this, and up here we can call the same thing, dot player name, yep, just like this. So basically it's only going to access this field if the left side is not null. And also you can have multiple of these in a single line, you can chain them together. So for example, if the player, if over here it had some kind of player for another target, if so, then you could do player question mark in order to make sure it only runs if not null, target, another question mark to make sure that it runs if it is not null, and then call take damage. Over here, pretty much the same rules apply. So basically, as it gets to this question mark, it checks the player. If the player is null, then it terminates the whole thing with null. But if it is not null, continues running the right side, and then it gets to this question mark and checks the left side. So if the player.target, if that one is null, if so, then again, it terminates over there. But if it is not null, then it's going to call take damage on the player.target. So the same rules always apply regardless of how many non-conditional checks you have. Now the second non-conditional operator is pretty much the same, except it's for index accessing. So for example, if we have a list of strings for some kind of player name list, if we have this, we can do, for example, player name list, do a question mark, and then the square brackets to access on some kind of index like this. So let's do a console.writeLine on this. And here the same thing will happen. So if the list is set to null, if so, then when it gets to here, it's going to stop evaluating. Whereas if this one is not null, so if it has something like, for example, let's say just one element, if so, then yep, it is going to go inside the list and grab it on this index. Like this does print CodeMonkey. And of course, you can combine both of them. So you can combine the one accessing strings and the one just accessing properties and fields. So instead of a list of player names, let's do over here a list of type player. So player list, and we have a new one. And over here, let's construct a brand new player. So now on this, we can go inside the player list. we can do the question mark and then the index, access on index 0, then do another question mark and call some kind of take damage function. So it checks the player list. If it is not null, continues running to the right side. It checks the one on index 0. If it is not null, continues running to the right side and runs the take damage function. So if over here, this element on 0, if this one is null, then it would safely stop the execution right here. However, this will still throw an error if the index 0 is out of range, so do be aware of that. And since the home point of this whole operator is doing null check, it can only work on nullable types like reference types. So if we put, for example, int I and set this something, then I question mark dot compare to, nope, this is not valid. The question mark operator, so the non-conditional operator, this one cannot be applied to an int. Again, that's because int is a value type, so it cannot be null. However, if we make this into a nullable, so we add the little question mark, if so, then this does now work. So we can call toString, yep, this works. If you don't know this syntax, this is nullables, and I'm going to cover nullables in a lecture later on in this advanced section. Alright, so that's the two non-conditional operators. Quite useful for very easily doing some null checks, and especially useful for making your event invocation much more compact without sacrificing readability. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the Null-Coalescing Operators. These two will let you easily test for null and return a value, or test for null and do some logic. Okay, so the Null-Coalescing Operator. Now this one is defined by two question marks, and the simple use case is for testing if something is null, and if so, returning some kind of value. So for example, here we have some kind of string player name, and then we've got a function to get the length of a certain string. This one receives the string as the parameter and just returns the string.length. And then over here, we're trying to get the player name length by passing in the player name onto that one and then printing it out. However, if we run the code like this, without assigning the player name to anything, if there you go, naturally we have a null reference exception. If we don't assign any value to a string, then that one is going to be null. So over here, we can add some kind of a null check. So let's find the player name, then if player name, if it is null, if so, let's put this one equals get the string length and pass in just an empty string. If not, then let's assign the player name length equals our string length. So we do a null check, and depending on that, we get one or the other. So let's see. And if now it does work, so without assigning an actual player name, just return 0. So no more errors. This code is working, and we can do exactly the same thing, but in a more compact manner using the Null-Coalescing Operator. The way you use it is, for example, by writing the player name, then two question marks, and then basically here we want whatever this is going to evaluate to if player name is null. So for example, we can do this, meaning that this will either evaluate to player name or an empty string. So if we use this instead and put it over here and just have one of these, yep, just like this. So basically this one, this instruction here, what it does is it evaluates the left side, left to the question marks, and if this one is not null, then this whole thing is going to evaluate to just this value. However, if the left side is null, then this whole thing is going to evaluate to whatever it is on the right side. So basically, if player name is not null, then it's going to call getStringLength to the player name. But if player name is null, then it's going to call getStringLength with an empty string. So now if we test, and if there we go, no errors, and it does return 0. And now if we give the player name something, so let's say CodeMonkey, and if now the exact same code also tests for the null check and now gives me the actual length of the actual string. So here we are doing exactly the same thing we were doing previously with the null checks, but in a much more compact manner. And I can also link multiple of these together. For example, let's define here a string for a default player name, and let's assign it to something. Then over here we can do player name, double question mark, default player name, double question mark, and 0. So you can chain multiple of these together. If we run this code, there you go, it does return 7, which is exactly the length of this string. So basically this is going to execute from left to right. So if this one is not null, then returns this one. But if this one is null, then goes to the next one. And if this one is not null, then returns this one. However, if this one is null and this one is null, then returns this one. So this operator is really useful for very quickly doing a null check and returning a non-null value. Instead of doing if-else testing for null, you can just write this and everything works perfectly. By the way, on the right side, instead of just returning a value, you can also run some logic. So for example, if player name is null, you can throw a custom exception with a custom message. Now the second operator, that one is the Null-Coalescing Assignment Operator. In terms of syntax, it's exactly the same with double question marks. The only difference is that it has an equals at the end. So for example, if we have some kind of player class and a player field, if we try running some code on the player here, let's just do a player.toString, so let's do a console.writeLine on this. If you do this, then naturally this one will throw a null reference exception because player is indeed null. So as a way of doing some kind of initialization, we can write player, then double question marks equals, and then new player. Basically what this does is it's going to check the player variable, If that one is not null, then nothing happens, just continues executing the code afterwards. However, if player is null, if so, then it's going to construct a brand new player and assign it back onto this variable. So this operator can be really great for initialization. Like for example, let's say the player down here has a list of other players to target. And now usually if you have this kind of thing, you can either initialize this list directly on the constructor. That means that the list will be constructed as soon as the player is spawned. However, you can only initialize it when an enemy is added. So if you have a public void add target player, this one receives a player for the target player. And now here, if you just go player target list and add the target player, if you do this, then naturally this is going to throw a null reference exception because this one does not exist. So before this, you can do $equals new list to initialize the list. So basically, if the left side is already initialized, if this one is not null, then this line of code is going to do nothing. But if the left side, if the list is indeed null, if so, then it's going to evaluate the right side, which is going to construct a brand new list and assign it. So this operator is great for initialization, or really just any kind of null check where you want to run some code only if the left side is null. Also, what we covered in the previous lecture, the non-conditional operator. Like I said, that one returns null if the left side is null. So for example, we can do player then question mark in order to make sure we run the code on the right side only if it's not null, then call some kind of function like get player name, and then have double question marks and say unknown player. So basically what this is doing is if the player is not null, then it's going to go inside the player object and call get player name, it's going to return that. However, if the player is null, if so, then this whole thing is going to evaluate into null, and then we have a null, then double question mark and something, so it's basically going to return this one. So if player is null, it's going to return unknown player, but if it is not null, then it's going to return the player name. And by the way, since the whole point of this entire operator, since the point is to do a null check, naturally it can only work on nullable types, like reference types. So if we define an int, if we do this, then naturally this does not work. Whatever's on the left side has to be a nullable type. However, if we make this instead of a regular int into a nullable int, if so, then yep, now this code does indeed work. I'm going to cover nullables in a lecture later on in the advanced section, but basically they allow you to make any type like a bare bones int and make it into nullable. So that's the two null-coalescing operators, another very compact way of doing a null check, in this case to return some value or do some logic if something is indeed null. Hello and welcome, I'm your Code Monkey. In this lecture we're going to learn about the ternary conditional operator. This is how you can write some super simple if-else statements in a really compact manner. Okay, so this is another simple way to write more compact code. Here I have a function with a regular normal if. It's called getPlayerStateString, just as an if the health is above 0, if so, then it returns an alive string, if not, returns a dead string. So yep, like this, if the player has 100 health, if it works, the player is alive, and if over here set it to 0, and if it works, the player is dead. So this code works. However, a much more compact way to write literally the exact same thing is like this. We just write the condition without the if keyword, so in this case, health above 0. Then we write a single question mark. And then whatever we want to return if the condition is true, so in this case we want to return the alive string, and then we write a colon, and then what we want to return if the condition is false, so in this case we return dead. So you can do this whole thing and then just return it. Basically this entire thing, this is going to evaluate into this code if this condition is true, or this code if this condition is false. Which literally means that over here in just this one line of code we have the exact same logic we have down here. So it really is this simple. Anytime you want to do a super simple if-else, then you can just use this. It is more compact while also being very readable. Now, technically, you can also use it to run some logic. So you write the same thing, and then on the right side, instead of just a normal value, you can run some kind of function with some kind of logic. So technically, this is valid. However, you have to make sure to either assign it to something or return something, because otherwise, like this is not a valid assignment, not a valid instruction. So technically, just to demonstrate how you can run some more custom logic like call a function directly inside of this format. However, for this usage, I would say this is maybe sacrificing a little bit of readability. So personally, I would really not use this. I really only ever use the ternary conditional operator for super simple if-else statements just like this one. And for these, yep, the ternary conditional operator is definitely an excellent way of making them really nice and really compact. So if you can use them without sacrificing readability, definitely go ahead and use them. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about the main function in a C# program and how to receive command line arguments. This is very important to know when making normal console apps, doing things that do not have a UI. By using command line arguments, you can still control what exactly you want your program to do. Okay, so we've already been using console apps a lot in this course. It's the easiest way to write and run some C# code. We just make a console app project and we end up pretty much with this code. Then if we run this, yep, there you go, there's our super basic console app. Now, by default, it creates this main function. This is our program's entry point, meaning as soon as the program starts running, it will automatically call this function and start running it line by line. It continues doing that until this function terminates, at which point the entire program ends. By the way, in case you're wondering, so how do game engines work if the entry point is just a normal function that runs line by line and eventually terminates? If that's the case, how does a game engine run logic on every single update? And the answer is actually quite simple. So game engines, or really any program that lives for more than just the duration of whatever it is doing, usually they have some kind of while loop. So up here, while, either while true do something, and if so, then update some kind of update function. Then when the player presses the quit button, at some point it just breaks out of this cycle, which then terminates this one and terminates the entire program. So it can obviously be more complex than that, but that's the general gist of it. All programs have a single entry point, and then if you want, inside that entry point you can have code that runs constantly non-stop, and at some point the function ends and the program terminates. So main, this is the starting point, and it actually has some very specific requirements. The main one being how it has to be named exactly main. It cannot be called something else. It cannot be called start, or even something like main with lowercase. If we do this and we try run, nope, it does not run, we have an error. Here in the error we can see the program does not contain a static main method suitable for an entry point. So the starting main function needs to be named exactly main, exactly like this. Then another very important requirement is how it has to be static. You cannot make this non-static. If we do, yep, there you go, same error again. Main has to be a static function, and that makes perfect sense. So the reason why it has to be static is because when the program first starts, at that beginning you have no objects. There's no instances of anything. So you can't really start by calling a non-static method inside an object because no objects exist. So that is why main has to be static, so that it can be called in the very beginning of the program when no object exists. Then this function also has to be inside some kind of class or struct, and that one can either be static or non-static, both of them work. Main can also have an access modifier. You can make this either private or public, doesn't really matter. Next, for the return type, for this one it can take many forms. So first one is like this, it can simply be void, meaning we don't need to return anything. Or if we want, we can return something, and when we do, then it simply won't execute any more code. So it can either manually return or just let the function end normally. Alternatively, we can make this return an int. Usually this is done if you want to return some kind of exit code from your program. And usually if you return an int, returning 0 usually means success, means the program ran correctly, so there were no problems. And if not, if something went wrong, then you want to return some kind of number that refers to some kind of error code. And the other two options for return types are task or task with a generic. This has to do with asynchronous programming. It's how you can have your program execute some logic without blocking the main thread. I cover asynchronous programming in the lecture on Async and Await if you want to learn more on that particular topic. So here, just know that main can return tasks, it can be async, but in most cases you are probably going to do either void or int. And if you do return int and you return some kind of value here, you might be asking, so if the main function returns something, how exactly do we know what this returns? If we test the code like this, here at top we don't see anything, but here on default console, at the end it says this message, it says our executable exited with code 56, which is exactly the number that we set. Alternatively, we can also execute our program manually. So here I've got the command prompt opened, and over here we can execute the program manually. So just run the executable, and yep, it does say hello world, but we don't see any return code. Now for that, it is actually stored in an environment variable. To access an environment variable, we use the percentage symbol. Then it is named error level, another percentage symbol. So if we want to print this, let's just do an echo on this. And yep, there it is, 56. So whatever value you return from here, you can access this one in order to get exactly what is the error code. So that's the main return, so either void or int, that's usually what you do. And the other important thing about main is over here, the parameters. Here it can have either no parameters, so this is perfectly fine, or you can have some parameters. You can have a string array, and usually by convention it is named args for arguments. So this will contain whatever arguments you use when running the program. For testing, let's print out the size of this array, so console, let's do a write line, let's do the args.length. Also, by the way, here, this array, this args, this one is guaranteed to never be null, so there's no need to test for that. Here, let's print out the size of the array, and then let's just cycle through it. So a string r in args, and let's just print it out. So a console.writeLine our arg. Okay, so like this, if we run it just over here inside Visual Studio, then we are not passing in any arguments, so naturally it is 0. But now here we are in the command prompt to run our code. And if we run just like this, again, no arguments, it does return 0. Okay, correct. And then for calling it with arguments, we just add a space and then add whatever arguments we want. For example, let's pass in the number 32. And if there you go, it does work. It did receive one argument, and the argument is number 32. Now here we can include as many arguments as you want of any type we want. So for example, for a string, we can include the quotation marks, say code monkey, and then we can include maybe a boolean, so maybe true. And if there it is, 3 arguments, 32, code monkey, and true. In terms of arguments, usually what you might see are some kind of flags. So for example, have a -debug. This would start the program in debug mode. Or alternatively, you could have an argument like mydata.csv. So this would be the file that the program would open to do some kind of analysis. Arguments are really extremely useful when you don't have any kind of UI. When you just want the program to run and just do whatever you want it to do based on whatever arguments it gets. Just like this, don't need any UI and you can still do quite a lot of things. Now, one very important thing here is how arguments, this one is an array of strings. So over here, when we execute our code with the parameters 32, code monkey, and true, technically that's a number, that's a string, and that's a boolean. But in reality, all of these are strings. So if we want to get an actual number and an actual boolean, if so, we need to parse them. Now, all of the built-in types, they have a parse and try parse function to do that. So for example, for the first one, int dot, let's do a try parse. We can try parse, and for the string, let's grab the args, and the first parameter was the int one. We can do out int, and let's call this the int argument. So you have just like this, basically try parse, this one will return true if it does succeed in parsing and false if it doesn't. And alternatively, we have the parse, and this one assumes that it will succeed. Now I covered these two functions in a bit more detail on the lecture on data types, how you can convert from types back and forth, like converting from a string onto an int and so on. So you can do, for example, this, and then for a bool, let's parse out the one on index 2, and then we can print those. So let's print out a right line, print out the arg int, our int argument, then the second one is actually going to be a string. So let's just grab the one index 1, and then for index 2, that one is going to be our arg bool. So let's see, here run our code, and yep, it did work. We did get the int32, the string code monkey, and the boolean true. So this is how you can convert a string into whatever type you want, and then you can do whatever you want using these. Now, there's actually another alternative for getting some arguments. Technically, you don't have to include the string array over here. You can remove this, and if you do, then you can basically go inside the environment, and inside there's a function called getCommandLineArgs, and this one does exactly the same thing. So let's receive a string like this, args. So like this, our main does not have any parameters, but still, let's try. So here, let's run it. And if it worked, although we got one extra argument, so the very first one is a path to the DLL. So you can either include it directly over here or grab it from this. And this can be quite useful if you don't have access to actually modify the main function. If you can't modify it and it's stuck with no arguments, you can still use this to grab whatever arguments were used. And finally, if you have multiple classes in your code base, for example, let's do a public class, another program. And in this one, if we also define a static void main function as well, if we do this in test, nope, here we have an error. It is saying the program has more than one entry point defined. This is how you can only have a single entry point. There can only be one. You can't have multiple possible entry points. Now we can still do this. We can have a different class that also has something called public static void main. We just can't have 2 entry points. So if we have this, 2 classes that both have a static void main, if so, then we just need to define which one we want to be our entry point. So here, let's do a console.writeLine. Let's call it another program. And the way we modify that is over here on the right side. Let's go on the Solution Explorer. Then let's right click on the project. Important, it's on the project, not on the solution. So right click over there on the project. And let's go down into properties. And then it's over here under general that we see the startup object. This one, like says, defines the entry point to be called when the application loads. So it's over here that we can select, and it's basically going to show us the classes that have a main function. So let's say we want to start off from the another program. Yep, just like this. Now let's test. And yep, now it runs and ran exactly starting from that one. Alright, so that's the main function and command line arguments. With this, you can see how you can have quite a bit of control over even some very simple console apps. You can make some very complex programs that do lots of things depending on the arguments they are given. So always remember how you don't necessarily need complex GUIs. For a lot of programs, like just a simple console app, if you just include some arguments, it will likely be simpler and work just as well. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about Nullable. This is a special built-in type that lets you make any type nullable, even value types like int and bool. Okay, so in a previous lecture, we already learned the difference between value types and reference types. How reference types, like for example a class, they can be set to either null or an instance of that class, but on value types like an int, you cannot set it to null. So over here we can define a player field and set it to null. This works. But if we define an int, nope, this one does not work. Here we have an error. Cannot convert null into an int because it is a non-nullable value type. However, C# does have an interesting thing called nullables, which lets us make anything support null, even value types. And there's 2 ways to do it. One is very simple. We just add a question mark to the end of the type. Just like this, yep, this one is now a nullable, and now we do not have the error, we can now set it to null. This works with any type. So here we can make a nullable int, we can make a bool nullable. This works. We can also define some kind of struct, define some struct, and over here, if we just have the struct cannot be null. But if we make nullable, yep, that does work. So we can really make anything support null by adding the little question mark, by making it into a nullable. Now this can be really useful if the variable is only used in certain scenarios. Like for example, let's say we had the player and this was some kind of strategy game. So this would be some kind of player unit. And inside you would have an int for some kind of attack damage that the player could deal. And we could define some kind of value if we wanted the player to actually deal some damage. Or alternatively, we could define it as null if we wanted the player to not be able to deal damage. Like let's say they have no weapon equipped. Setting it to null makes more sense than defining the attack damage as either 0 or -1. That makes it a little bit confusing that this specifically means no attack damage, whereas null makes it much more straightforward. This means we have no attack damage. Or alternatively, nullables can also be very useful as function parameters. So for example, let's say we have some kind of setup function. We use this to set up our player. And in here we can receive an int for the starting health. And if we do it like this, then this one is a mandatory parameter. If we wanted the player to keep whatever health was set in the prefab itself, meaning if we did not want to override it with any kind of starting health, if so, we can just define it as nullable and then default it to null. Again, that would make a lot more sense as opposed to making a normal int defaulting to 0 and then having to remember that, okay, if the health is 0, that means do not override what is on the prefab. Instead, we set it to null, and this one makes quite a lot more sense. So nullables can be quite useful to make literally anything nullable. And if it does have a value, if it is not null, you can just cast it and use the value. So for example, up here, we got our I. It can be null or it can have some kind of value. And to grab that, let's say int attack damage. We can grab the value and simply just cast it. Yep, just like this. Although, of course, this one is going to throw an error if we have null here. So if we do this, yep, naturally we have an error. So in order to do this, before we cast it, we can check if I is not null. If so, then let's actually grab the value. And if it is null, then don't do that. Alternatively, instead of checking it against null itself, if so, we can go inside this one. And inside we have this really interesting property called hasValue. This one, like name implies, is going to be true if a value has been set and false if it's null. So we can check if it has a value. If so, then let's cast it onto our value. Or alternatively, we can also do something instead of doing a cast. So instead of a cast, we can go inside and we can grab direct value. And this one is going to be of whatever type it is, the type that we made nullable. So yep, just like this, no need to test directly against null, no need to cast it, just like this, everything works. Or yet another alternative, we can go inside our nullable, and inside there's a really nice function called getValue or default, and this will either return the value or some kind of default. So we can use this function that returns a default value. So if we put it something like this, like a 12, let's put a console.writeLine on this. Okay, so let's see what this one returns, considering how this one is null. And of course, it returns 12. So that's how we define nullable and how we interact with it. But like I said, there are two ways to do it. This is just one, adding the little question mark. And the other one is to much more explicitly use the Nullable class. So there's a class called Nullable, just like this. It takes in a generic parameter, so we can do Nullable of int just like this. And if that's it, everything else works exactly the same way. It also supports null, it also has the hasValue and the value, it also has this function. Really writing this or adding the little question mark ends up the exact same thing. This one's really just a shorthand, both do the exact same thing. In reality, this class is really just a wrapper around some kind of value. So it has a boolean and has the actual value. So it's essentially just a class with two fields instead of being just one. And then if you want, nullables can also work very well in combination with the Null-Coalescing Operator that we saw in a previous lecture. So we can define, let's say, an int nullable, call it a, set it to null, then int b, and let's set it to either a, if a is not null, but if a is null, let's set it to, let's say, 56. And if this works, so b will be set to the value of a if a has a value. If not, if a is null, then it will set to the default value. Alright, so that's nullables. Whenever you have some code with some value type and you want to make it support null, then go ahead and use it. It is super simple. You just add a question mark at the end and all of a sudden your code, your field now supports null. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about span in C#. This is a really interesting type that lets us do operations on slices of arrays and do so in a super fast performant manner. Okay, so let's see span. This is a really interesting type that was introduced to C# just a few years ago. It allows you to grab a slice of an array and do it super fast and importantly without any memory allocations. That's a crucial part of it. So for example, let's say we have an array of numbers. So an int array for the number array, and we have just a new one, and then just have a whole bunch of numbers, so a whole bunch of random things. Okay, yep, just like this. Now let's say we want to sort this whole array, but we only want to sort the numbers in the middle. We don't want to sort the edge ones. Now, one way you could do this is by making a subarray. So you define another array for the subarray. You would define it a new int array, and basically just use the length minus u. So go into this one, length minus u. You do this, then copy all of those elements, so only these elements, then sort out this array, then copy them back onto the numbers array. Yep, you could do that. Technically, that would work. But doing that would also require creating a brand new subarray. This requires allocating additional memory. Depending on how constrained you are in terms of resources, that might be a problem. It allocates new memory, which of course also then has to be garbage collected. So once again, another potential issue for performance problems. So in order to solve that and many other problems, for that we have the span type. A span is really just a slice, or it can actually be an entire array. But importantly, in creating a span, we don't actually allocate any new memory. It is a very special class that is all handled with pointers to the original memory, all done in the background. So the way we create it is actually very simple. We define something of a span. This one is a generic, so let's use a type. In this case, we want a span of int. Let's call it our int span. And then if we want this span to have the entire array, we can just equals it, so equals number array. And if there it is, that does work. So now this span, again, this one is not constructing anything. This one is not constructing a new object. Instead, this span now simply has a pointer to the entire original array. So you can do this if you want the entire array, or in our case, we only want to sort the ones in the middle. So let's grab a subarray. So we can do a new span. This one has a whole bunch of constructors, which first of all receives an array, so that's a number array. And for the start, like I said, I want to start after 1, so let's start on 1. And for the length, so over here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements, minus 2. Let's grab the length of 6. And if that's it, so here we created an int span. So that's a span. It's basically a pointer in memory that is super fast and is pointing just to these elements. And inside the span, we can do whatever we want. Like for example, we can just call the sort function. That's it, very simple. And importantly, by calling this, we don't need to actually update the original array. So we don't need to cycle through the span and update the new array elements. We don't need to do that because, again, this span isn't actually holding any data itself. It's really just a pointer to the original data. So by modifying the data inside of this span, we are also modifying the original data inside the array. So if we do this and then we print out the values, so let's do for each int number in the number array. Let's do this, and in console.writeLine, let's print out the number. So this should say 5, then all of these should be ordered, and then should have a 10 at the end. Let's see. And if correct, so 5, then 0, 2, 12, so these are all sorted, and at the end we have our 10. So if we sorted all the elements, but just ones in the middle exactly as we wanted. And very importantly, we did not have any new memory allocations, which in turn also means we're not going to have any garbage that needs to be collected, which in turn means that our program will be much more stable and much more performant. Then with this span, you can also have all kinds of functions for working with this data. For example, you can copy just a slice onto another span, or copy this entire slice and convert it into an array. You can do a slice of another slice, or you can fill it all with a bunch of elements. And again, all of this applies to the original data. Remember how the span itself isn't actually holding any data. It's really just a pointer to the original data in memory. So in this case, we made a span that takes all the elements in the middle. Now if we call it fill, and we fill it with some kind of value, let's see. And if there it is, just like that. So the original array still has the first and last one unchanged, but the ones we selected, those have been filled with one number. So span is really great for manipulating slices of arrays, again, without any memory cost. Then if you want something even more efficient and you only want to read, if so, then you can actually use a read-only span. And if this one is really the exact same thing, but limits you to read-only, so you can't write to it on this one, you can't fill it. But if all you need is read-only, if you just need that and you need extreme performance, then this one can be a great type. Now spans work on arrays, and a string is really just a char array. So for example, if we have a string, and inside we have some numbers. Let's say, for example, that we worked with some code that contacts a website and that received this string with these values. Now let's say that we want to parse these values. So one way would be to do a substring. So you do str.substring, and over here put the start index and the length. That would work, but once again, we are wasting memory to allocate this temporary string. So if we are building a performance critical application, and we don't want to allocate any more memory than we need to, again, we can use a span to slice a string. Although in this case, for a string, For this one, using a span doesn't actually work. If we do span char for the char span and do equals str, if we do this, nope, this one does not work. It cannot implicitly convert that one into that one. For strings, it only works the read-only span. And yep, this one does work. So here we have a span, which again is really just a pointer in memory to this data. So now let's say we want to parse out these values. We can go inside this one. Let's grab a slice on 0, go for a length of 2. And this is going to give us our first number. So we can do int.parse. Let's parse out this number for the int for the number 1. And then for number 2, really same thing. Let's slice starting on 3 and go for 2 more values. So yep, then let's do a console.write line. Let's write number 1 and our number 2. Okay, let's see. And if there it is, we do have our 2 separate values. And importantly, just like this, we did not spend any memory allocation cost. Whereas if we had done substrings in order to do the exact same thing, we would have quite a little bit of a cost. Now, one practical example for how this could relate to game development would be perhaps some kind of inventory system where the UI has various pages to show all the items. So you would have some kind of array with all of your items. And then for displaying each page in the UI, instead of creating a brand new temporary array, instead of that, you can just very easily grab a span, just grab a slice of that array, that item array, and use that to display it on the UI. Alright, so that's span. It's a very interesting type for grabbing slices of an array or doing some operations on it without having a memory cost. This is a very useful type in some performance and memory critical applications. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the bitwise operators in C#. This is how we can do operations on individual bits of data. Okay, so like we covered on the beginner lecture on data types, C# has a bunch of built-in data types. You've got things like short, int, long, and so on. All of these, they all store whole numbers, but their ranges differ. For example, a short can only store 65,000 numbers, then an int can store about 4 billion, and a long can store an insane amount. The difference in all of these is how exactly they are stored in memory, meaning how many bytes or how many bits they actually use. By the way, remember how 1 byte equals 8 bits. So over here, a byte, this one literally uses just 1 byte, so 8 bits, whereas a short uses 16 bits, an int uses 32 bits, and a long uses 64 bits. So for example, here we have a byte in memory. We have 8 bits, meaning 8 zeros or ones. This is how memory actually works. It's all binary in the end. So for example, here we have the number 0, then here we have the number 1 in binary. This is a 2, this is a 3, and so on. Now, in case you don't know how binary works, basically every single position on this number, every position represents 2 to the power of something. So this one represents 2 to the power of 0, this one 2 to the power of 1, power of 2, and so on. And those powers equal these values. So this digit over here represents 1, this one represents 2, this one represents 4, and so on. So in binary, you basically just add ones or zeros to whatever number you want to build, and then you just multiply it by whatever is the value on that digit, and simply add them all together. So in this case, this one is a 3, so we've got a 1 over here on the 2 position. So 1 multiplied by 2 is 2, and then a 1 multiplied by 1 is 1, then you do 2 plus 1, and you have 3. If, for example, we wanted to store the number 13, if so, we would have a 1 over here on the 8 position, so that makes 8. Then we would also have a 1 over here on the 4, so that makes 12. And then we would have a 1 on the 1, so yep, this one is 13. This is how you represent 13 in binary. So it's really all just ones and zeros. And the goal with bitwise operators is to basically let you manipulate these bits individually. These are the 4 bitwise operations we can do. We can do an AND, we can do an OR, an XOR, or an exclusive or we can negate. For example, up here we have the number 2, and down here we have the number 3. If we want to do an AND operation between both these, if so, then we just do a normal Boolean operation on each bit, meaning that both of them have to be 1 in order for the output to be 1. So over here we do 0 and 0, and the result of that is going to be 0. This one is also going to be 0, 0, and so on. Then we get to this one, 1 and 1, both are 1, so this one does relate to 1. And then we've got 0 and 1, that one does equal 0. So this whole thing equals a 2. Doing a bitwise AND operation between the number 2 and number 3 equals the number 2. So over here in our code, we can define just the number 2 and define the number 3, and then do a bitwise operation. So we do A and B. Now importantly, it's this one, just 1 ampersand. It is not 2 of them. This one is a Boolean AND, that is not what we want. We want just 1 ampersand to do a bitwise operation. So yep, like this, let's do a console.write line on this one to see what this returns. And if there it is, the number 2, exactly as intended. So what we are doing here is doing an AND operation, but applying the AND to the bits themselves. Another operation we can do is an OR. So this one outputs 1 if either bit is 1. So all of these that are all zeros, these are all going to end up as 0. Then over here we've got 1 or 0, so one of them is 1, so it becomes 1. Then 0 or 1 also becomes 1, and 1 or 1 also becomes 1. So the end result of doing an OR operation between numbers 5 and 3, the end result is the number 7. So yep, let's verify it. Here in the code, we have numbers 5 and 3. And now let's do a bitwise OR operation. So just like this, again, just one pipe. It is not two of them. We do not want to do a boolean. We want to do a bitwise OR operation. So let's see like this. And if it's not like that, we do have a 7. Another operation we can do is an exclusive OR. This one outputs 1 if either bit is 1, but not if both are 1. So in this case, all of these are zeros. Then this one, 1 XOR 0, that does equal 1. 0 XOR of 1 equals 1, because again, one of them is 1 and the other one is 0. But on this one, where both are 1, the XOR does equal 0 on this one. So the end result of this one is the number 6. Again, here in the code, let's verify it. So between number 5 and 3, let's do an XOR. And to do that, we use this little symbol. Apparently, this is actually called a caret. In Portuguese, we just call it a hat. So it's this one if we do an XOR between these two values. And if there it is, we do have our 6. And finally, we have the negate. This one, like the name implies, simply inverts all the bits. So a 0 becomes a 1, and over here 1 becomes a 0, 0, 1, 1 into a 0. Here in the code, the way we do a negation is we add a little tilde. We add a tilde before our number. So this is going to negate the number 5, let's see. And if there it is, the number minus 6. By the way, the reason why the number is negative is because of something called 2's complement. This is how the first bit, the leftmost bit, that one is used to denote either positive or negative values. That is also how back here, if we look at all the types that C# has, you can see how we have both signed and unsigned versions. Basically, the signed one, the leftmost bit, is going to define whether it's positive or negative, whereas the unsigned ones, those don't have a concept of positive or negative, so they can only start from 0 towards some positive maximum. Okay, so these are the main bitwise operations, but we can also construct numbers directly from bits. For example, let's say we want to construct here the number 4. So in binary, number 4 is really just a 1 on this position. It's a 1 on the third position, meaning the one on index 2, so this is index 0, index 1, index 2. In order to construct this number, we can use a bit shift. So this is where we start the number, usually 1, because it has zeros on everything except a 1 on here. We start this one, and then we shift it by several places. So in this case, we want to shift by 1 and 2, and we end up with our 4. Now here in the code, like I said, usually we start with the number 1, and then doing a bit shift, we do 2 angle brackets, so 2 less than signs, and then the amount that we want to shift. So in this case, we want to shift by 2 places. So yep, let's see. And if there it is, this equals the number 4. We can also shift in the opposite direction. So let's pick the number 8, let's shift towards the right, and shift by 2 places. And if there it is, we end up with number 2. So manipulating bits is really interesting, but you might be asking yourself, where would you use this in a practical manner? Now, the main thing this gives you is the ability to store a bunch of data in a really compact manner. So you can have each of these bits represent something, like for example, attributes on a gun. For example, let's say that this bit over here, this one represents that the gun deals fire damage. Then this one, let's say that it deals damage over time. And this one perhaps is it causes stun. So with just a single number, with just a single byte with 8 bits, with just that, you can actually store quite a bit of information. So we can store that the gun deals fire damage, deals stun damage, and deals damage over time. Or more practically, Unity actually uses this a lot in layer masks. As you probably already know, game objects belong to a certain layer. You can change the layer here, and you can add a bunch more layers. Also note how there's a specific limit of 32 layers, so from 0 up to 31. That's exactly why, is because the layer, this one is a bit mask. It's a 32-bit bit mask. And in the code, when you do something like a physics raycast, when you do this, note how one of the parameters is an int that represents a layer mask. This is a bit mask, it is not just a single number. So for example, if you want to hit all the objects on layer 6, if so, you would not put a 6 here. Instead, you would define, for example, an int for the units layer. Let's say it's layer 6. And to construct an int for the layer mask, the way you do this is by doing a bit shift. So in this case, 1, and bit shift to the left by the units layer. So just like this layer mask would mean that it would only hit objects on the units layer. Or for example, if you want to hit units and buildings, so let's say we have another for the buildings layer, and this one is on layer 9. If we have this, we can bit shift this one onto the left, and then do an OR operation with 1 bit shift to the left by the buildings layer, and doing an 1 operation. Again, basically it makes 1 when either of them is 1, so it essentially combines 2 layers. And doing so, this layer mask would then hit things on units and or the buildings layer. Or alternatively, instead of all this, Unity actually already has a built-in layer mask type. So up here, let's just make a type of type layer mask. Let's see. And if there it is, we can see a layer mask. And over here, this one shows a really nice drop-down menu, so you can easily select all the layers that we want. So for example, select the attackable layer, select the UI layer, the water layer, and so on. So here you can very easily select all the layers that you want. And then Unity automatically constructs a bit mask based on all these layers. Then another place where bitwise operations are used quite a lot is with Enum Flags. And that's actually what we're going to cover in detail in the next lecture. Alright, so here we learned about bitwise operators, how we can manipulate individual bits in our data. This is an excellent way to store some data in a really compact manner. With just a single byte, you can store quite a lot of information. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about Enum Flags. This is a special thing you can add to your enums to make them work like bits, which enables you to do bitwise operations on them. Okay, so in the beginner section, we already covered enums. So here's a basic enum that represents various abilities. Now let's say we want to use this to define what abilities our player has. We can easily define a field of this type, and we can say, for example, that the player can jump. Okay, that's it, pretty simple. But now let's say we want the player to be able to both jump and shoot. Like this, we can't actually do it. We can't do something like ability jump plus shoot. That doesn't really work. We can't add it onto here. We can only override it. So inside of this one, we can really only store a single ability. But that's exactly where enum flags come in. First of all, we just add the flags attribute. So up here, an attribute for flags. And this one, by the way, exists inside of system. So we add that attribute. And then over here, we define numeric values to all of these enum values. Meaning we use equals and then some kind of number. Now, specifically for this use case, we want to use powers of 2. That's very important. So for example, for none, let's assign it to 0. For jump, let's assign it to 1. For sprint, let's say 2. Shoot, 4. And fly, let's assign it to 8. Now, on the previous lecture on bitwise operators, we already covered binary. That's exactly what we're doing here. In fact, like we mentioned on the previous lecture, over here, instead of using numbers, which can seem a little bit confusing, instead of that, we can just use bit shifting. So you can do 1, bit shifted by 0, and that makes a 1. Then 1, bit shift by 1, bit shift by 2, and so on. Yep, just like this. So we mark that as a flag, and we define the values as power of 2. Now with this, we can actually solve our original problem. So we want the player to be able to both jump and shoot. And with this, we can now combine our enum values. So we can make a jump or, and this is the bitwise or, so again, just one pipe, or ability.shoot. And if that's it, if we now do a log on this, so let's do a right line on the player abilities. If there it is, the player can jump and shoot. So here we have the player abilities field. That's just one field, just a single field, but it is actually storing two separate pieces of data. It stores that the player can jump and can shoot. So here we define it. Now let's say that we want to check if the player can jump. If so, we can just go inside the player abilities and we can use the hasFlag function. So let's say if the player can jump, let's do a log on this, like this, let's test. And if there it is indeed true, the player can jump. Or alternatively, since over here really we are just working with bits, because this we can really just use some basic binary math. So if we want to check if the player can jump, if so, we can just take our jump ability, so just like this. And then we can do a bitwise AND operation, doing an AND with our player abilities. And basically the output of the bitwise AND, this one is going to be 1 when only both these are 1, which in this case means it's only going to be jump. So we can just compare if this one equals ability.jump. Let's put this one inside parentheses. So let's see if the player can jump. And if that is true, the player can indeed jump. So enum flags are really super useful for combining multiple options in a single enum field. It is just like the layer mask that we saw in the previous lecture. How Unity has this type, which lets you select multiple layers. So here in the editor, we see this field and we can easily select as many layers or as few as we want. And here Unity also already supports the flags enums. So if we do this and we expose a field of our flag enum, then up here in the editor, we do indeed get a drop-down menu where we can select as many or as few things as we want. Now, another thing we can do with enums, not necessarily related to flags, is we can actually define the underlying type we want this enum to use. By default, this one is going to use an int, meaning it is actually going to use 32 bits. But if you want to limit memory as much as possible, if so, we can actually define what type we want this to use. And you do that by adding a little colon, and then define this one as a byte. So yep, now storing a field of this type is just going to occupy a single byte. Now, naturally, byte means 8 bits. So if you want to store it as a byte, you are going to be limited. So yep, like this, if we define more than 8 possible values, yep, here we do have an error. Basically, a byte can only store 8 bits, so we cannot add 9 possible values here. If you want more of those, then you can use a short or just default int. Then yet another interesting thing you can do here is you can also define some combinations. So you can define one for shoot and fly, and you can do equals shoot or fly. And yep, again, this one is going to do a bitwise OR operation, and it's going to combine both the shoot and the fly tag, and both them inside of this one. Okay, great. By the way, I should also mention that technically the flags attribute, this one is not really required for this. You just need to assign the binary values and all of this works. But if we don't assign the flags, if we don't do that, let's see what this one is going to log. And if there you go, that one just logs the number 5. Whereas if we have the flags attribute, yep, that one logs the proper readable thing, jump and shoot. So you don't necessarily need it, but adding it makes it very easy to read. Alright, so that's enum flags. It's a great way to store multiple enum values in a single enum field. This is really excellent whenever you want to store combinations of values instead of storing just a single one. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about preprocessor directives. This is how we can give some instructions to the compiler itself, which are run during compilation time and not during runtime. Okay, so preprocessor directives. With this, we can tell the compiler some things. The simplest thing we can do is just define some symbol. For that, we need to do it at the very top of the file. So over here, we start with a number sign or a hash sign. Then we write define, and now we can define whatever name we want to give to this symbol. So something like testing, and usually as a convention, you write the symbol names in all uppercase. So that's it, this defines a symbol. That's all it takes. It doesn't equal to anything, it's just a symbol. Symbols either exist or don't exist, so they're not variables that hold any data. They are just defined or undefined. So here we define the testing symbol, and then anywhere else in our code base, we can do an if. So for example, let's go over here. Let's do again the number sign, then write if, and then whatever symbol we want, like let's say testing. And then to terminate our if, we do an if. And yep, just like this. So now for example, we can put some line of code inside of this one. Yep, just like this. And now what this is doing is basically telling the compiler to either include or not include this line, depending on if the testing symbol, if that one is defined. Like this, if we run our code, if there it is, it did say testing. But now if we remove this define up here, right away Visual Studio even helps us by graying this out. It means this code is not going to be included in the compilation. So right now if we run this, and if there it is, now we do not see that message. Essentially, this code right here, this does not exist at all in the final program. This if over here is adding some instructions to the compilation itself. And since the symbol is not defined, this code will not be included in the final program. It literally does not exist. One very common use case for this is for debugging. So you can add some complex code for supporting debugging, doing all kinds of log messages and so on. But you might not want that code to be using up performance in the final build. So you define a symbol in order to make some kind of debug build. And then you remove that define when you make the final build so that the debug code does not run. That's one of the main ways that preprocessor directives are used. And just like in pretty much any kind of programming, if we have an if, we also have an else. So you can write else and then do whatever we want. So for example, over here, let's say not testing. And yep, right away in the colors we can see, so this one is not going to run because testing is not defined, whereas this one is going to run. And if we go up here and if we define our testing symbol, and yep, now this one does run and this one does not run. So you can make an if and an else, just make sure it always ends with an end if. Or alternatively, we also have elif. This is basically else if. So elif if something, let's define a testing2, and then let's do an else. So up here, let's put testing2. And yep, so if we define testing, then it runs this one, okay. If we don't define testing, then it goes into this else if and checks, does this one exist? It does not exist, so it runs this one. Whereas if we define our testing2, if so, then yep, it runs this one. So all of this, some simple if-else logic, just like you're used to. And right now you might be thinking, okay, so what exactly is the difference between this and just writing a normal if? So just a bool testing, let's set it to true, if testing, if so, then do something, if not, don't do it. So the difference between this and this, the difference is that the normal if, this one will be included in the final program. This if will only be evaluated at runtime, so only when the code is actually running. Whereas this one, for preprocessor ifs, these are evaluated during compilation times. And whatever does not match the if, like this one is simply not included in the final build at all. So this code literally does not exist at runtime. The compiler evaluates the ifs in order to figure out if something should be included or not. And after the code is compiled, all of this does nothing. All of this is replaced by just the things that are included. So this one is a runtime if, and this one is a compile time if. Another important thing about the define is how it only applies to this one file. So here we have this file, and I created this brand new one. So it's a completely separate file. And over here, let's define the testing and just do our normal testing, just like this. So yep, it does run on this one. But now on this one, if we try doing the same thing, nope, here this code will not run, will not be included. That is because this testing symbol is not defined anywhere in this file. It is only defined on this one. So the defines are on a per file basis. But we also have options for project-wide defines. There are two main ones that are automatically defined by default. One of them is called debug, and the other one is called release. These are the two automatic configurations. So up top here we have a drop-down menu. This one is for the configurations. And by default, it always starts with a debug and a release one. And doing so, these automatically create defines and applies it to the entire project. So here with this set to debug, if we have the if debug, this one is going to run. And same thing on this other file. If we define this as debug, yep, this one also runs. So this debug define applies to the entire project. Like I said, one common use case for this is for debugging. So rather than defining a debug symbol on every single one of your files, instead of that, just use the built-in configuration manager to use this debug, and then when making the final build, you swap it over to release, and doing so, all of this debug code will no longer be included. So setting to release both does that and also creates a new release. So yep, this is a super easy way to enable project-wide defines. And if we go on the configuration manager here we can click on this and we can add some new ones. We can add, for example, testing. And now we don't need to define a testing anywhere, and we can do if testing, and yep, it does work. Then over here, if we just write if and we press space, we see a bunch of auto-completion. So we can see a bunch of defines that are created by default. For example, these over here are related to the .NET version, the .NET Core version, and so on. So with this, you can write some version-dependent code. For example, some code that depends on a specific version, like only works on .NET 6 or greater. So you can do this, run that code, and then have an else. And if the project is not set up with .NET 6 or greater, you can then fire an error, log a message, or do something like that. Now, another place where we can create project-wide defines is in the project properties. So over here on the right side, let's open up the Solution Explorer. Let's right-click on the project. Important is over here on the project, not on the solution. So right-click over here, go inside Properties. And then over here, let's scroll down under Build. Yep, just like this. And up here, we have a bunch of custom symbols that we can add. These are related to the configuration builds that we saw. So we've got debug, release, and our testing one. And again, these are project-wide, so these will work on all the files. So over here, like C# course, just add it. And yep, there you go, it's enabled. And over here on any of these, I can search for C# course, and yep, it does work. And again, project-wide, so it works on both that one as well as on this one. Okay, great. Now, other defines are the ones inside of Unity. So here's a script inside that Unity project. And over here, we can write if. And again, we do see a whole ton of defaults. There's a bunch for all kinds of interesting things. And the main ones are really just over here for the versions. So you want to write some code that requires 2018.1 or newer. Any of these. You can make it based on build, so it has to be on a standalone Windows build and so on. Or actually one that is really important when making tools is this one for the Unity editor. With this, you can either include or not include some code that is specifically related to the Unity editor. Then in Unity, we can also add project-wide defines. So let's go into Edit and down here onto Project Settings. Then over here, let's go on the Player tab and let's scroll down under Other Settings. Let's keep scrolling down. And if here it is, we've got the script compilation, so the scripting defined symbols. And if it's over here that you can add whatever symbols you want. You can write anything, and again, these will be global defines that apply to every script in your entire Unity project. Okay, so that's defines in if, but there are more preprocessor directives. One that I use every once in a while is one that is called region. You write this, and then optionally you give it some kind of name like functions, and then at the end you write and region. Any of this creates a region, and importantly, over here in Visual Studio, this one creates a collapsible menu. So we can collapse or expand. This can become quite useful in large files for organization. So for example, you could make a region for all of your fields and make end region, then make another region for all of your statics. You could have it like this, and even on a giant file, things will look quite manageable. Another simple one is both warning and error. So we just write error, some error. And if that's it, very simply, this creates an error. So it says some error. And if you look down here on the error list, yep, we have an error. So this is basically a compilation error. We cannot compile like this. And as for when would you use it? Well, you can actually combine this with the if. So for example, let's go with if. So for example, if we are not using .NET 8, if so, then spawn some error. If not, then don't spawn that error. So these can be quite useful for validation on your project. And related to that, we have another one, and that other one is the warning. And this one, really the same thing. So this is a warning. This one is not an error, so it does not stop compilation. It's just a warning. So down here on the error list, if we include warnings, yep, we see this is a warning. And related to that is another very useful one for disabling some warnings. For example, let's say we have some code here and we define some kind of variable, but we never initialize it, we never use it. And let's say this was actually intentional. Right now, if you do this, we see the little squiggle line. So this is a warning. It is saying the variable is declared, but never used. And down here on the error list, yep, we do see that same thing. If we wanted to disable this warning, if so, then we can just write pragma warning and then disable, and then the actual number for the warning. So over here, let's mouse over and see. Okay, so this is warning 0168. So up here, disable 0168. And if there you go, it does disable that warning. So that one no longer shows up as a warning anywhere. So if you have some warnings that you know are not a problem, you can use this to suppress them. Or alternatively, you can just do just this, pragma warning disable, and this is going to disable every single warning. Also, this does not have to be written just on top of the file. You can write this anywhere. So for example, right before this line, we can write this one. And then let's say we want to ignore literally just this warning and nothing else. And then afterwards, we can write pragma warning restore. And now if we write a similar error, if there it is, now this one does show up the warning. So it only suppresses the warnings directly within both of these lines. All right, so that's preprocessor directives in C#. It's how you can give instructions to the compiler itself, which mainly allows you to write conditional logic that will run at compile time instead of at runtime. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about ref, out, and in keywords. This is how you can output more data from a function than just a return type, or how you can pass in something explicitly as a reference instead of a copy. Okay, so here's some simple code, and we have a basic function. It's called getUnitState and returns a state. That's it, pretty basic. But now let's say we want to return more data from this function. Let's say I want to return also the unit health and the unit name. So over here, I can't really just add a comma and then add the health and then add some kind of name. This does not work. This is not valid code. Also up here in the return type, I can't just add an int then a string. This does not work, not valid code. Functions can really only have a single return type. Now, by the way, just a quick mention for those of you who already know tuples. Technically, over here, you can make this return a tuple. I cover tuples in another lecture in this advanced section, but for now, let's ignore tuples. So for now here, all we can do is return just a single type, so we cannot return multiple pieces of data. Now, one way to solve this problem is to make some kind of class to hold whatever data we want. So up here, we can define a class, let's say unit data. Then inside we have a state, then inside we have a health amount, and we also have some kind of string name. So we can do this, and then over here we can return this type, and on return we construct a brand new one of that, set the state equals some kind of state, set the health amount, and set the name. So if this does work, and just like this we are indeed returning multiple pieces of data, all composed inside of one type. So this works, this is a perfectly valid option, but if we don't want to constantly have to define a brand new separate type to do this, if not, then there's actually a simpler method. Over here we can define a parameter for our function, like let's say an int health amount. And unlike this is a normal parameter, so it's an input parameter. However, we can now add the out keyword, and just like this one now turns into an output parameter. Meaning that over here in this function, we can assign this parameter to some data, and we are going to receive that data over here when we are calling the function. So by using over here the out keyword, we are defining this parameter as an output. So just like the return type, that is the standard normal output you have from any function, just like you have that one, using the out keyword is another way of getting some output from a function. So inside of this, before our return, let's set health amount equals something. And if just like this is our function. It has a return type, it returns state, so that's the normal thing. And then we're also using this parameter as an output parameter. Then up here, when calling that function, we just need to include this parameter. However, importantly, this is an output parameter, it is not an input. If it was an input, we would write some kind of number here, that would work, that would be an input, but this is not an input. In the case of an output, we define some kind of variable, like int health amount. By the way, it doesn't have to have the exact same name, you can name it whatever you want. So we define that variable, then over here we pass in that variable, and importantly, we have to write the out keyword. And yep, just like this. So we define the variable, and we didn't give it any value directly to the variable, we just defined it. And then we pass in that variable using the out keyword onto the function, and then the function does whatever it does. Now, by the way, if we were not using an output parameter, so let's make this one an input parameter, so it's just a normal parameter. And if we do it like this, then we have an error here. It says use of unassigned local variable. If we're using a variable as an input, we have to give it some kind of value, we have to initialize it to something. But when it's an output parameter, we can indeed pass in just an uninitialized variable. Yep, like this does work. The reason why this works is because this variable is guaranteed to be set inside this function, so it doesn't need to have any value preset before calling the function. Now here, after calling the function, let's do a console.writeLine. Let's print out what's inside the health amount, and let's see. So again, here we are initializing and not giving it any value, passing it into the function. Then the function is doing some logic, and then afterwards, let's log out and see. And if there it is, it does have the value 56. So we define the variable, we pass it in as an output parameter onto the function. Then inside the function, that variable was set, and in doing so, it actually updated the value outside of it. Now this is actually really interesting. Right now, you might be remembering a previous lecture on value versus reference types, and how I said that value types, like int is a value type, when using value types as parameters in a function, these are passed in as a copy and not a reference. So normally, this would actually receive a copy, and modifying this copy would only modify the copy itself and would not actually modify the original data in memory. But that's exactly what the out keyword does. Even though int is a value type, by using the out keyword, instead of passing in a copy of the data to the function, instead it passes in a reference, even though again, the type is actually a value type. So that's how this function can modify the data we passed in, and if we exit outside, we see this variable is actually modifying. Whereas if we remove the out keyword, if we do it just like this, and let's initialize it so it doesn't throw that error. So let's see like this and see if it says 0 or 56. And if like this, it does say 0. Because again, without the out keyword, this one is just being received by this function as a copy. And over here, we are just modifying the copy and not actually modifying the original data. So that's very important. Basically, by adding the out keyword, we are converting this into a reference type. And doing so, anything we do inside this function will affect the actual original data. So the out keyword, this one lets you define parameters as output parameters instead of input parameters, which means, for example, over here for this function, we can actually make it return void. And instead, for returning all the data from this function, instead we can just do it all through output parameters. So let's put an out state, out int health amount, and an out string for the name. Then we just need to assign all of those before we exit the function. So state, let's put it on something. And for the name, let's put it on something. And up here, this one no longer returns anything, so none of that. Here we just need to write all of our output parameters. And by the way, here's a quick tip. You can do this. You can define a variable and then pass in the variable. That works. But we can actually shorten this. So over here, when we define our output parameter, we can define the variable right here. So just like this, out state, so out int health amount. And again, the names don't have to be perfectly exact. And out string name. And now we can print out the state, print out the health amount, print out the name. And let's see. And if there it is, we have our 3 pieces of data and all of them being returned by just this one function. All right, awesome. Now related to this, the other keyword we have is the ref keyword. So instead of out, we write ref. And this one is quite similar. It also defines this variable as being a reference instead of a copy. Then up here when calling, we also define ref. However, one very important difference is when we use ref, we need to initialize our data. So over here, this does not work. We need to define our state, initialize it with some kind of value, and then we can pass in a ref on that state, and yep, now it does work. So we call it, and over here, this function receives this one as a reference, and inside we can set it to whatever we want. And again, since it's a reference, it's going to modify the actual data. So in terms of behavior, ref and out are quite similar, but they do have some very important differences. Both of them have very specific rules you have to follow. So inside the function, an out parameter like this one, you have to set it before exiting the function. For example, here, if we don't set the health amount, yep, we get an error. It says the out parameter health amount must be assigned before the control leaves the current method. So if you have something with an out parameter, you have to assign it. And if you have multiple branches, so let's say bool, set it to something. So if something else something, if we have this and we have a return, and let's put the name before those. Yep, like this one does not have an error because we are indeed assigning health amount before this return, so before this branch ends. But on this one, we have an error because we are not assigning it. So if we have multiple branches, multiple places where the function can terminate, if so, we need to assign all of our outputs, assign all of them before exiting the function. So this is why it's called an output parameter. Whenever the code calls this function, it has a guarantee that the output data will be set to something. That's why up here, we don't have to initialize this one, but we can use it afterwards, assuming it's been initialized. That is because we can indeed make that assumption. We know for a fact that if we pass in an output parameter to a function, this function has to initialize it with something before exiting, so afterwards we can assume this variable has been initialized. Whereas with the ref keyword, this one does not need to be set, so over here if I remove the state, nope, there is no error, no problem with this. We can receive it as a parameter and either do something with it or do nothing, or we can also do something in some branches, like for example on this branch, set it to that one, and on that one don't do it, that's perfectly fine. And then up here when it comes to calling that function, when passing in a state parameter, we have to initialize it. If over here we don't initialize it, then yep, we have this error, use of unassigned local variable. In order to use something as a ref, it has to be initialized before passing into the calling function. Again, the difference between these two is what happens inside this function. For an output, you are forced to assign it to something inside of this one, so you don't have to assign it before. But for a ref, you don't have to do anything inside of this one. You might or might not initialize it, so because of that, up here you have to make sure to initialize it. So these are the compile rules. You have to follow them. If you don't initialize a ref, you get a compiler error. And if you don't assign a value to an output, you also get an error. So you have to always follow these rules. And for these two, the one that I tend to use most is really just the output. The rules for the output parameter are really great. They make it very clear that this one is an output parameter. For example, here we have some Unity code, and I'm sure you've already done many raycasts. And with this, yep, you've already seen an output parameter in action. So the raycast basically sends the raycast over to the physics system. It does whatever it does in order to figure out if this ray hits something. And whatever it hit, all that data will be contained inside of this object. So this is a great example for how you'd normally use out. This function over here returns true or false, depending on whether it hits anything. And then based on that, it also returns extra data in this output parameter. Whereas the ref here, this one is used mainly for converting value types into reference types. So for example, let's say we have some heal function. In this one, we want to heal some kind of health amount. So we pass in the health amount and int for the heal amount, how much we want to increase it by. So if we do this and we do, for example, health amount plus equals the heal amount. If you do this, then obviously this is not going to work. Because again, this one is a normal parameter and it's an int, meaning this one is going to be received as a copy. So up here, we are only healing the copy and not actually healing whatever we want to heal. Whereas over here, if we set this one as ref, then even though this one is a valid type, it will be passed in as a reference, and we can modify the data here, and it's going to modify the original data. Also, one interesting thing somewhat related to this is the discard keyword. For example, let's say on this getUnitState function, let's say on this one, the only thing we care about is just the name. We don't really care about the health amount or the state. If so, then instead of defining variables for it, we can just use an underscore. And yep, this right here, this is the discard keyword. This makes it so that this code is valid, so we did not define any health amount variable. This is valid code and simply means that when this code runs, it is simply not going to assign the health amount to anything, because over here it is never going to be used. So this is the kind of thing that can help improve readability. When running this code, we make it very clear that we care about the state, we care about the name, but don't really care about the health amount. And yet another related keyword is the in keyword. So over here, instead of something being out, we define it as in. And this one, like the name implies, makes this an input field. So it's kind of similar as to without it. So by default, this one is going to be an input field. But when you add the in keyword, now you are passing it in as a reference. So again, the same thing about value and reference types. And by this being marked as in, meaning input, it means it cannot be modified inside the function. So over here we have this error, cannot assign it because it is a read-only variable. Now, one scenario where you would use this would be in some performance-intensive applications where you're working with structs. For example, let's say we have a struct, and this is like a huge struct. It is something that takes up a ton of data, a ton of memory. If you have this, and then you pass it into some function, if you pass it in like this, then this function is going to receive a copy of this struct, which again, if this one has a lot of data and you call this a lot of times, you're going to end up with a ton of uses, a ton of wasted memory, because when you pass it in as normal, it is going to create a copy of that data. So to help solve that problem, to not use as much memory, here you can use the in keyword, and in doing so, no copy is created, because this one is going to be treated as a reference. So this function will receive a reference to the original struct data. Then inside here, you can access it, you can read whatever you want from it. By being an input, it makes sure that the data cannot be modified, and it makes it so that it does not receive a copy, instead it uses a reference. And if you did want to modify it, then of course, over here you would use a ref, and it worked just fine. Alright, so that's the ref, out, and in keywords. These are very interesting, very useful keywords. It's a super easy way to either output more data from a function, or to pass in something as a reference instead of a copy. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about data type boxing. This is an interesting feature of C# due to the fact that everything is based on the object type. Okay, so let's look at data boxing. Which, by the way, the name sounds like it has to do with boxing, as in punching people. But no, it's actually related to putting things inside a box. That's boxing. This is how you can put some data inside a box and then get it out. Data boxing is really just a term for converting something, usually a value type, onto an object type and converting it back. So for example, let's say we have an int and we have some kind of whole number, and then we can assign it to something of the object type. So create an object and assign it to int. And yep, this right here, this is data boxing. With this, we have now placed the I variable. We place this data inside a box, and the box is named O, and it is of type object. Like I mentioned, this is possible because object, this class right here, this one is the base type for every type in C#. Everything extends from this one. And specifically, data boxing usually refers to taking a value type, kind of like an int, or perhaps a struct, anything like that, and converting it into a reference type. This int is a value type, but it is being put inside a box. That box is an object type, and object is a reference type. So in memory, I just stores the value directly. It's an int, which is a value type, so it stores it directly on the stack. But then O, which is an object, this one is a reference type. So when we assign I to O, we are boxing it, so O then contains a reference, and a reference to the actual place where that is stored. Although also importantly, modifying I will not modify the value inside of O, and modifying O will not modify the value inside of I. That is because when it converts into a reference type, it converts a copy of the original data onto a reference type, not the original data. And in terms of performance, it's actually pretty important. Value types exist on the stack. The stack is super fast, super performant memory. Whereas the object, by having a reference, this one is going to be stored on the heap, which is quite a bit slower. Now, since we can box a value like this, we can also unbox it, meaning get the value out of the object box. And the way we do that is just with a cast. So let's go inside of O and cast it down into an int. And yep, just like this, super simple, it works. Now, of course, if we try casting it to the wrong type, let's say into Boolean, let's put here bool being. Yep, if we do this, we don't get a compiler error. That is because object, this one technically can be castable down to a bool. It just depends on what data is actually inside that object. But if we try this, we're going to see a runtime error, so let's test. And if there it is, a simple invalid cast exception. We cannot cast an object of type int32 onto a boolean. So basically, we need to know what data this object is holding. We need to know that so we can use the correct cast. And if you want to protect yourself from errors like this, you can just put all of this inside a try catch and catch for an invalid cast exception. So now as to when you would use boxing, we actually already saw one use case when using events. just like this when using the standard event handler. So this is the C# standard to use this delegate type. And this one, for the signature, we can see it as an object sender and the event Rs. So basically with the sender being of type object, this means that it can be anything, it can be of any type. Usually when you fire off this event, you fire off whatever class is firing off this event, and then later on in the listener, usually you know what type is going to be fired, so you know which type to cast it to. Or another potential use case is doing something like, for example, a list of object. You can do this, do a brand new list, and then on the list, you can instantiate it with whatever you want. So over here, I can put an int, I can put a boolean, I can put a string, all of this does work. Because again, object is the base class upon which everything is extended from. So if we make a list of object, that list can store literally anything. Although this particular use case is definitely something that you would only very rarely use. Using object and data boxing, that's a really interesting quirk of C#, but in most cases, chances are there's a better way to do things. So in this case, making 3 separate lists for each data type, that would make quite a lot more sense. So while you can technically do this, you should really only do this as the last possible option. Alright, so that's data boxing. It's an interesting quirk of C# due to the fact that everything extends from object. Because that means everything is convertible to and from object. Just make sure you use it sparingly, only when you absolutely need it. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about dynamic in C#. This is a really interesting feature of C# that allows us to write code against a type that doesn't actually exist. Okay, so here let's see the dynamic keyword. Now this is a very special, very unique thing. We use it kind of like defining a variable. So we write dynamic, and then we give it some kind of name. Let's say just D. If there it is, with this we have defined the variable D, and it's of type dynamic. Now what dynamic means is we don't actually know what type this is. The type will only be defined at runtime. That's very important. So this is somewhat similar to var. So for example, if we say var v equals something, if we do this, we also don't specifically define a type. However, var, this one is being evaluated at compile time. So when the code is compiling this line, it looks at what comes after it and infers the type. So when it comes to runtime, var doesn't actually exist. When it comes to runtime, var is replaced by an int. Whereas over here with dynamic, at compile time, we still don't know what type this is. We're only going to know at runtime when this code actually executes. So that also means that within this type, we can do anything we want. For example, let's say this type is a new object, something like this. And then over here, we can call whatever we want. So we can call some kind of test function. And if there's no error, we can access some kind of field and do something. And if no error, that is because, again, right now we have no idea if this is right or wrong. Maybe when this code actually runs, maybe the object that is inside of this one, maybe that object does have a test function, or maybe it doesn't. For example, in this case, it will not work. Here we construct a brand new object of type object, and the object type does not have anything called a test function. So if we try running this, and if there it is, we have an error, a runtime binary exception. It is saying object, the type object, does not contain a definition for test. So you can write whatever you want after this, you can write whatever function name, field, property, whatever, and you won't get any compile time errors, but during runtime it will check, and if it does find some function or some property with that name, then it runs it. If not, then it throws that error. This is the really important thing about dynamic. It is how it only runs at runtime and not at compile time. During compilation, it assumes that whatever you did with this dynamic object, whatever you did is correct, it is what you wanted to do. Only in runtime does it actually try doing something, and if it can't, then it throws an error. So in order to see a positive result, for example, every object always has a toString function. So if we run this, if there you go, the program runs, no errors, everything is fine, because again, toString does exist within the object. But we only saw that during runtime. So now with this, you might be wondering, where exactly is this useful? It does seem a little bit strange. I mean, right here, if this is what we want to do, then naturally, instead of making this dynamic, we would make it object, and that way we can't write something like this, we get a compiler error. So if you want to do this, and obviously using dynamic doesn't make any sense, if you know the object type, then just use the object type. However, where this is particularly useful is when dealing with something like JSON data from a web server. The data schema might change over time, so you might not be able to define the exact type over here. For example, here we have some simple JSON. So it's just an object, inside it has an assets, and this asset is actually an array, and within the array it has 3 separate objects. Those objects have a type field, a name field, and a path field. So let's say, for example, we receive this JSON from some web server, like for example, maybe some modding site, and this is the data that we need in order to install our mod in our game. Here with the JSON, now the first thing we do is convert it into a dynamic object, and one simple way to do that is with the Newtonsoft JSON library. That's the most popular, very capable JSON library. In order to install it, let's go over here on the Solution Explorer, let's right-click on the project itself. So not on the solution, right-click on the project. And then down here, let's go into Manage NuGet Packages. And up top, just go into the Browse tab and then search for JSON. And there it is, the main one, newtonsoft.json with 5 billion downloads. So yep, let's go ahead and install this one. And then with that package installed, over here we can use the class JObject, which exists inside of this namespace, newtonsoft.json.link. We can use this and we can call the parse function. This one takes a JSON string and returns an object. So let's parse our JSON and let's put this inside a dynamic object. So dynamic, let's call it JSON dynamic. And yep, just like this. And now here we can do whatever we want inside of this object. So for example, we can go inside of this one, we can access the assets. And again, note how we have no auto-completion because once again, dynamic does not know what type this is going to be. So let's make sure to write it properly. So assets, and assets is going to be an array. So let's access the first element on that array. And then let's just access the type. So it should be this one, it should say texture. So this, let's put this inside a console.writeLine. Let's print out this and see exactly what it says. And if there it is, it does say texture. All right, awesome. So you see how here we define some structured data, but we have no class, no struct, we have no actual type defined that matches up this structure. But thanks to dynamic, we were able to load it onto a dynamic object, and then we were able to go inside it, write all the names for all the properties and get whatever data we want. So it works perfectly fine for accessing something, but if we access something that does not exist, let's say for example, that we go on assets instead of assets, let's call it asset, which does not exist. Yep, of course, we get the same error. So if we want to test if a dynamic object has a certain function or property, for that we have two methods. So one option is using reflection. So we can go through JSON dynamic, we can call getType. This is going to return our type for this, and then we can call getProperties. And yep, we get an array of property info. So the same as with any other type of reflection. You can watch a lecture on reflection for more on this method. Or another alternative is to simply try to access it. So for example here, let's try reading this. So string for the type name. We read this and we read inside of asset, which does not exist. And if this one naturally throws an exception. So this is how we can test it. We can put this inside a try catch. And let's catch for that one. Catch for a runtime binder exception. And if it happens, then that property does not exist. So you can do this to go one by one throughout your dynamic type in order to figure out what exists inside of there. Then dynamic can also be a return type of a function. So here, let's do something and return dynamic, some kind of test function. And then here we can return whatever we want. So we can return an int, we can return a boolean, we can return a float. All this does work. Or we can even actually return an anonymous type. Yep, this is perfectly valid code. By the way, I cover anonymous types in another lecture. And then up here, we can simply call test and grab whatever returns from there. Then inside that one, we can access, for example, the name. Let's do console.writeLine. And if there it is, and it does work perfectly. Now, before we end this lecture, let me also give you just one quick tip that is somewhat related. It's related to JSON here. Like I said, the goal with dynamic is that you don't know exactly what the schema is. If you don't know that, then use dynamic. But if you do know, so if you know your JSON is always going to have this format, if so, then you should create an actual class with all of this data. But doing that by hand is actually quite tricky. You would have to write some kind of class, call it JSON data. Then you would also have to define another class for something like asset single. Then on this one, you define a string for the type, the name, and so on. So you can write it manually one by one, which when you have some complex JSON, that can actually be quite laborious. Or alternatively, Visual Studio actually has a super simple, super helpful answer. You just copy your JSON, the JSON that you receive from whatever web server, whatever you have, just copy it onto the clipboard. And then up top, go into edit. Then let's go into paste special and paste JSON as classes. And if there you go, it automatically creates this. So it creates our single asset that has a string name, path, and so on. And if these were Boolean or a whole number, then it would change the type here. It would not make it all string. And then for our root object, so that's the main object, just has an array of assets. So you have just a quick tip when dealing with JSON. If you don't know the data schema, then use dynamic. But if you do know it, then use that in order to get the actual type and then work with it with the actual type. All right, so that's dynamic. It's a really interesting feature of C# for working with types where you don't really know what the type is until runtime. This is super useful when contacting something like a web server and getting data without knowing the schema beforehand. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to create a custom class indexer. This is how you can access some data in your classes using an index, kind of like an array or a list. Okay, so here let's learn and build a custom indexer. Here we have a very simple player stats class. This one just stores various stats. Then up here we are just constructing it, super simple. And now let's say we want to access these player stats kind of like an array. So I want to access, for example, player stats, access it like this on index 0, and I want this to give me the strength amount. If we try doing it like this, then we have an error. It is telling us we cannot apply indexing with these square brackets. We cannot apply that to this type, the player stats. So let's build it. Now the way we do it is actually like a normal property. So let's go over here. First for our property, let's make it public. Then we can make it return anything. In this case, let's make it return int. And now here's the important part. Instead of having a name kind of like any other property, instead of that, we have to name it with a this keyword. We do that and then we add these square brackets. So basically this property is what is going to happen when we try to access this specific type using square brackets. Then inside these square brackets, we put our indexer. And for the indexer, we can use whatever type we want. Let's go with int just for simplicity, and then name like index. Yep, like this. Okay, so this is our definition. And now, just like with any other property, we can define a get and a set. So let's do a get. So get, open and close the curly braces. And then for the get, we just need to return something. So in this case, depending on the index, we want to return a different field. So let's do a super simple switch, do a switch on the index. And in case we receive 0, let's return the strength. In case we receive 1, let's return dex. And in case we receive 2, let's return wisdom. And in case we receive anything else, so on default, let's just throw a new index out of range exception. Okay, yep, just like this, we no longer have any compile errors. So we define it kind of like a property with the special keyword this. Then we put our indexer. Inside we define the get, and we do whatever logic we want. So now here, yep, this one no longer has any error, so this one is now perfectly valid. So let's try doing a print on this. So console, let's write line, let's write our strength, and it should say 12, so let's see. And you're correct, it does say 12. So by this, we are accessing our custom player stats type, we are accessing it with a custom indexer, and everything works great. All right, awesome. So this is working, and just like with any property, we can make this read-only, meaning only define a get. Or if we want, we can make it read and write by also implementing a set. So let's do the exact same thing. So a set, just like any other property. Let's do a switch on our index. And in case we are on index 0, then let's set the strength amount equals the value that this one receives. Then same thing for all the other ones. So case 1, case 2, and then the same default. And if default, let's throw an exception. Okay, yep, just like this. So now up here, let's read the player strength. And then let's write to it. Let's write something. So let's set it to like 99, and then let's read it again, and let's see. And if there it is, the first one says 12, yep, makes sense. Then we override it, and then that one prints out 99. So yep, everything works, super simple. So here we have our custom indexer. So we have a custom type, and we define this logic so we can access it using simple square brackets, and then we can run whatever logic we want to get whatever values we want. As you can see, it's really simple to build, and it lets us use our custom type kind of like it was a list or an array. However, down here, the index, this one doesn't have to be an int. You can use whatever you want. So for example, we can actually use this stat enum. So let's find a stat for a stat. Then up here, same thing, just do a different switch and doing case on stat.strength, do something and so on. Yep, just like this, everything works perfectly fine. We just refactored and made this one receive a stat instead of an int. So now we go up here and instead of using an int, which, by the way, the reason why this isn't throwing an error is because every enum is automatically convertible into an int. But over here, we want to use a proper player stat. So let's use it. Let's say we're working with strength. Let's print that one out. And on this one, same thing, print the strength and print the strength. Okay, let's see. And yep, same thing, it does work. So over here, we can see how the indexer, the type over here can be whatever you want it to be. And yet another thing this also supports is multiple indexers. So we can add, for example, an enum and then an int for some kind of index. And yep, this works. This is perfectly valid code. Then you can use both of these in any logic you want inside of any of these. So for example, this could be really useful if you're accessing some multidimensional data to receive an index for the X and Y. All right, so that's how you make a custom class indexer. With this, you can make your custom classes much more usable in various scenarios by making it really easy to read or write some data, just as if it were a list or an array. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about attributes. This is how you can add some extra information, some metadata to your code. Then you can read that metadata and do whatever you want with it. Okay, so let's learn about attributes. Now you probably already know exactly what are attributes. If you're a Unity dev, then you've certainly already seen the one that is called serialized field. Here I'm running this code just on the C# console, so that's why it's throwing an error. This is a Unity specific thing. But anyways, usually you use this one, then use some kind of private field. So like a float for a move speed, something like this. And by using this attribute, it means that this field over here, this one won't be shown in the inspector, even though it is marked as private. So basically this attribute over here, this one is adding extra metadata to something, in this case to a field. And then the Unity inspector is running different logic depending on whether this attribute exists or not. So that's really what attributes are. They add extra metadata, and then you can do something based on that metadata. And attributes can also be applied to pretty much anything. So we can apply it over here into some kind of field. Then we can also apply it to a function, to a class, and so on. There's a bunch of built-in attributes. Like for example, one of them is serializable. This makes it so that this type becomes serializable. Then if you want, you can mark some methods as obsolete. If you do and you mouse over an object, it says that it is deprecated. Then you can also use DllImport to import some external libraries and a bunch more. But beyond the default attributes, you can also create your own, and doing so is quite simple. Let's say we want to define an attribute to mark a bunch of classes as being of a certain type. So we want to mark classes themselves as being like a unit, an object, and so on. We want that to be part of the class metadata as opposed to storing some kind of enum field. So the way you construct a brand new attribute is, first of all, you define a class. So let's make a new class. Then you give it a name. In this case, we want to mark certain classes as being of a certain object type. So let's call this isObjectType. And then for attributes, you append the word attribute, so attribute. So isObjectType attribute. Okay, great. This is our class, and then we just need to make it extend system.attribute. Yep, so this one is now marked as an attribute. Then inside we can define a constructor. So isObjectType, we have the constructor. Inside, if we want, we can make it parameterless, or we can actually receive some data. In this case, let's say we want this attribute to receive the object type. So up here, let's also define enum for some kind of object type. Then we have like unit, like object, prop, and so on. And over here, let's receive a field for our object type, just like this. And then we simply store it. So up here, a private for that one, like that. And on the constructor, we just set it, this one equals this. Yep, that's it. Here is our very simple attribute. And like we saw, attributes can be applied to almost anything, but you can also limit that to certain specific use cases. The way we do that is by adding an attribute to the attribute itself. So over here, let's add one. Let's add the one that is called attribute usage, this one right here. And if this one takes a parameter, we can see that it is valid on, and we can see we have all kinds of possible options. So we can make this attribute valid just on assemblies, modules, classes, structs, just on constructors, on any kind of method, fields, and so on. So you can really define where your attribute should be applied to. And also note on the values for all of these. So that one has a value of 1, that one has a value of 4, 32, 4096, 16, and so on. Note how they are all power of 2. So if you've seen the previous lecture on bitwise operators and bitmask, then you already know, yep, this is a bitmask. Each of these occupies a different bit. So because of that means we can also do all kinds of combinations. So for example, for this one, let's say we want to apply to classes or structs. So we can do class, and then we can do the bitwise OR. Again, important, it is not a Boolean OR. Nope, just one pipe, just a bitwise OR. So let's make it apply to classes or structs, meaning it works on either of those. And yep, that's really it. Now to apply to something, for example, let's make some kind of player class. So class, some kind of player. The player is meant to be a unit. So we can apply our attribute. We can use isObjectType. Note how we don't include the attribute, so just the name isObjectType. And then since we added the constructor, over here let's put object type, and let's say this one is a unit. And yep, that is it. Although if we try adding this to, for example, over here to a function, if so, then we get this error. It is telling us this attribute is not valid on this declaration type. It is only valid on class or structs. So yep, just like this, we define a brand new attribute and we attach it to our custom class. So now the next step is for doing something with it. And the way that we run some logic and check for attributes is actually with reflection. Now I've already covered reflection in detail in a dedicated lecture. For example, for up here, let's try doing that. So let's do typeof in order to get the type of our player class. Then from that one, we can call the function. We can get all of the custom attributes. So get custom attributes. And we can either get all of them, or we can look for a specific type. In this case, let's look for just of our custom one. So typeof for the isObjectType attribute. So let's look for that one. And for inheritance, doesn't really matter, so let's put it on false. Yep. So now this one over here, like it says, it is going to return an array of object. The reason why it's an array of objects is because it's going to return potentially multiple attribute types. So they have different types. So up here, an object array for the attribute object array. And now you can cycle through this array and test if it is of that type. Now in this case, we already know it is going to have one of this type. So we can just grab the one on index 0 just for testing. Let's cast it onto our type. So isObjectType attribute. So we have our isObjectType attribute. And then with this object, we can grab whatever data we included inside of our attribute. So let's do a console.writeLine. Let's write a line going to that one, and let's expose something to get the object type. So public object type, get the object type, and just return the object type. Okay, like this. And now up here, let's call that one, and let's see. We are looking for the data inside the attribute on the player class, so this one should return unit. Let's see. And if there is, the player class does indeed have an attribute, and that attribute does indeed have data for unit. Okay, awesome. All right, so those are attributes. It is really just metadata that you can apply to a class or a function or literally anything. It is really just metadata, just extra information. So it's really up to you to define what that data means. Using this, you can do all kinds of analysis or build some helpful tools. Do anything that does any processing or any analysis on any of your types. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about anonymous types. This allows you to essentially create a completely brand new custom type on the fly without having to first declare it. Okay, so here let's learn about anonymous types. Let's say, for example, we want to define some kind of type that will hold a string for a name and an int for an ID. And one way to achieve that is obviously by defining a normal type. So we can do a public class, call it player, then inside define a string for some kind of player name, and then int for some kind of ID. Then up here we can construct something of new player, and then assign whatever data we want. And if that's it, this works. We define the type and then we use it. This is what you should do if this type is something that is widely used, something that you use in a lot of places. But what if, for example, you just need this type, you just need to organize this data just in a single place? What if it's used in just one tiny use case? What if you really just want to organize some data? If so, then for something super quick is instead of defining a normal type like this one, instead of that, you can just use an anonymous type. So let's not define this. And instead, for defining an anonymous type, first we write the keyword new, and then we don't write any type name, nothing like that, nope. Instead, we just open the curly braces right away, so just like a normal object initializer. And now here we can define whatever properties we want with whatever data we want. So for example, let's say name equals code monkey, and ID equals 1. And yep, just like this, here we have our perfectly valid anonymous type. Then we can assign it to something. We can assign it to some kind of variable. But since this type has no name, we can't really write a name for the type. We can't write int or something like that. We can't write a type name because no type name exists. What we can do is simply use var. So var and then the name, let's say player data equals this. And yep, here we have our type. And if we mouse over player data, we can see, yep, here Visual Studio is telling us that this is an anonymous type. And inside it, we have a string for name and an int for an ID. We can also do a log on this and see. So console, let's write line. And if there it is, name code monkey, ID equals 1. So here we have constructed our anonymous type with our data. Then we can also access it, so we can go inside player data. And over here, yep, we can see autocomplete already shows us everything inside of this type. So it has the default functions that every single type in C# has. So get type hashcode equals into string. All C# objects, all C# types have these functions. And then it has the two specific properties that we just defined, name and ID. Now also, one very important thing about anonymous types is they are read-only. They are immutable types, meaning that we can read data, so we can access the name, we can print this, we can read it, but we cannot modify it. If we try modifying, nope, we have an error. It is telling us that the property name cannot be assigned to, it is read-only. We have this error because this is a property and it's a property with just a get defined. Also importantly, they are properties, they are not fields. That is why I named them in this way, using Pascal case instead of camel case. That is because anonymous types, the data that they store it inside properties and not fields. So anonymous types are really meant for read-only use cases. Like for example, you just want to organize some data in some nice structure. And if your goal is just organization, then you probably do want read-only, so this is perfect. If you want something with read and write access, then you should probably define a normal type, or a tuple, which is something somewhat related that we're going to cover in the next lecture. So essentially, anonymous types, those are all based on inference during compile time. You already know how var, this is a compile time feature. During compilation, the compiler looks at the variable. It looks at what var is being assigned to and use that to set the type. So if we do var I equals some number, if we do this, then when the compiler goes to define the type for I, it looks and sees what is being assigned to it. In this case, it's a whole number, so it defines I as being an int. And it's really the exact same thing over here for the anonymous types. The compiler infers the type for each of these properties based on the value assigned to them. So that's why this one is an int, this one is a string. And then the compiler constructs a brand new entire type just to store this data. So literally the compiler in the background is storing something like what we had previously. So something like a class, player data, with a public string name. And this one is a property with just a get no set, and a public string ID with again also just a get no set. So when we do this, the compiler is auto-generating a type just like this one. And then it assigns that type, that instance of that type, assigns it over here to the player data. Now we can actually see the type for this. We can go inside player data and call the get type. Again, the standard function that every single type has. Let's do a console.writeLine on this one to see. And if there it is, we can see this one is of type anonymous type. And inside has two parameters. It has a string and an int. So this is the type. It's an actual type. It's a normal type, just like any class, any struct. But it's simply auto-generated during compilation. Now this is quite different to what we covered in a previous lecture, the one on dynamic. When you make something dynamic, this one is all based on runtime data. Meaning during compilation, it does not run any checks, it does not create any types. Meaning it does not validate any data at compile time. So over here we can access name, which does exist, but we can also access something that does not exist. Again, because dynamic is only handled at runtime. Whereas var, and anonymous types, this is handled during compile time. And if so, over here we have validation, and we know, okay, this type does not have anything called test. So if you ever get confused about anonymous types, do remember this part. It helps a lot in understanding how they work. If you look at it from the point of view of the compiler looks at this data and uses that data to infer and create types. So for the data inside the anonymous type, this can be anything you want, as long as the compiler can infer the type. So for example, you cannot define here something as null. This does not work, this is an error. It is an error because null can be anything, it can be pretty much any type. So just like this compiler has no idea what type to make this name, but we can, for example, define a class, a normal class, and then up here do something like this. And yep, now this does work. Another thing we can do is put anonymous types inside other anonymous types. So over here, let's define a type, let's call it message, and we do a new anonymous type, and just say something like message. Yep, so here we have our nice anonymous type, and then inside player data, we can also add that. So we can add message equals our message anonymous type. And then through this one, we can access message, and inside we have the actual message. Also, instead of writing message equals message, if you're defining a new anonymous type with something that is already stored in a variable, you can just write that variable. And doing this, it will essentially name this property with the exact same name as this variable. So if we go inside player data, we can see, yep, we do have a message there. So when using other data to create data inside our anonymous type, we can just pass in the variable that stores that data, and we don't have to give a specific name. Then, like I said, anonymous types are read-only, meaning you cannot create and modify it. So over here, player data, set the name equals something. Nope, this does not work, this has an error. But what we can do is use a with expression. We can use that to create a new type based on another one. So for example, we can construct a new player data. Okay, great. And then we construct a new one, so var player data 2. And for this one, we can base it on the original player data, based on that one. And then we write the keyword with, and then we can open and close the curly braces and modify some data. So let's say name equals Ironman. And yep, just like this. So basically this is going to start with the data inside of player data, and then applies an override to the name. So here, if we do a console.writeLine on both these, so on player data 1 and player data 2, if there it is, so the first one is CodeMonkey idea 1 with message, and the second one has the same ID, the same message, but a different name. However, importantly, we did not modify the original anonymous type. We did not modify that one. That one is still read-only. We simply construct a brand new one based on a previous one. So here we can define an anonymous type with really whatever data we want. And then we can also define an array of anonymous types. So to create a new array, we do new. And then again, it's an anonymous array, so we don't define any type. Instead, just open and close the square brackets. Then open and close the curly braces to initialize our array. And now here we can define our anonymous types. So let's do one. Let's say something like name equals something. Yep, just like this. And again, we can assign this to a player data array, just like this. And yep, here we have an array of anonymous types, and it has 4 elements, 4 with all of this data. Now, one very important thing is the anonymous types here, they have to have the exact same format, the exact same properties. If we add a different property, let's say an ID to just one of these, if we do, then this one does throw an error. So it has to have the exact same properties. And it's also important that they are in the exact same order. So if we have the exact same ones but are in a different order like this, nope, we still have an error. Again, that's because of what I mentioned, how the compiler is creating an actual type based on this data. And if we have one with a different format, then it needs a brand new type, and the compiler does not let us create an array using multiple different types. By the way, actually, there's one exception to that. If we make this an object array, if so, then yep, no, this one does work. Object is the base class for every C# object, every C# type. So if you make an object array, you can indeed store literally anything in there. I covered something like this in the lecture on data boxing. By doing this, we can store multiple object types, and we can see there are multiple object types if we, for example, put the cursor on it. And yep, Visual Studio automatically highlights the exact same properties on the exact same type. And note how these 3 are highlighted, but this one is not. That is because this one is a completely separate type from these 3. So when making arrays of anonymous types, do make sure they all have the exact same structure in the exact same order. So just like this. Now, one use case where anonymous types are very useful is when doing LINQ queries. I already covered LINQ in detail in a previous lecture. Essentially, LINQ is a way to do operations on collections of data, similar to how you do queries on a database. So here, for example, we have our player data array. Now let's say we just want to get the players just on the red team. So for that, we can do some simple LINQ to get that query. So let's go inside the player data array. And this one, let's call where to write a condition. And for the condition, we're going to have a player data. And we want to select just ones on the red team. So let's go inside player data and select the team equals red. Okay, so we do a query for where the player data team is red. And then let's just call select in order to select some elements. We're going to get the player data. And it's over here that we can construct a brand new anonymous type. Let's say that after getting the red team players, we just want to keep the name. We no longer care about the team. So here we can construct a brand new anonymous type. And you set the name equals the player data.name. Or again, the same thing that we saw previously. Literally just put it player data.name. And yep, this constructs the anonymous type. And over here, just make sure this one is a lambda expression. Okay, so yep, so just like this, we can put the resulting thing inside of our, let's call it the red team array. And then we can cycle through it. So let's go for each var red team in the red team array. Let's do a console.writeLine, go inside the red team and just grab the name. Okay, let's see. And if there it is, CodeMonkey and Black Widow, which are indeed red team and red team. So yep, here we are cycling through some data, and for the selection, we are constructing a brand new anonymous type that holds just the data that we want. Importantly is how this code is actually quite readable, and we were able to do this without having to construct a brand new different type just to store the player name. If we had created a brand new type just for this one use case, if so, that would clutter our project, since this new type would only really be used here just in this one function. So with this anonymous type, it works perfectly for this use case without adding any clutter to our project. Now, like I said the words on this use case, anonymous types are excellent, so you should definitely use them where they make sense, but you shouldn't use anonymous types for literally everything. The rules they have actually make it perfectly clear how they are meant to be used. So first, remember how they are read-only. So you are only meant to use them as a way to organize some data temporarily, not something like long-term storage. They also cannot have any functions or events, just read-only properties. Then, since they are meant for small temporary use cases, you cannot store the anonymous type in a field, you cannot pass it on to a separate function. Although I should say, technically you can actually do that. If we make here a public static void test, and up here for the parameters we receive something of type object. And again, object is literally anything, any type extends from object, so we can call test, pass in the player data, and this does compile. But again, this one really completely defeats the purpose, because right now we have no concept of what data is inside this object. So technically you can do this, but you definitely shouldn't. All the rules of the anonymous types, they are there for a reason. If you ever find yourself running into the limits of all those rules, then that's probably a sign that you should be using a normal type instead. Anonymous types are absolutely excellent for exactly what they're meant for. Small, simple data structures for organization. That's it. For pretty much anything else, just define a normal type. Now, one feature of C# that is quite similar to anonymous types are tuples. They also allow you to create types with no previous definition. They also allow you to organize and structure some data. We're actually going to learn about tuples in the next lecture, as well as a rough guide for when to use tuples and when to use anonymous types, and what exactly are the differences between them. Alright, so here we learned about anonymous types. This is how you can easily organize some data in a proper structure without having to first define a normal type. This can be faster and more readable. And the specific rules that you must follow, those ensure you only use anonymous types in the way they're actually meant to be used. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about tuples. This is how you can basically create brand new types to organize some data without having to normally define it. Okay, so let's learn about tuples. And here in this lecture, I'm actually assuming you've seen the previous lecture on anonymous types. Those two are somewhat related, they solve similar problems, but they also have their differences. I'm going to cover those differences as we go through this lecture, and also a general conclusion of which one you should choose at the end of this lecture. So, just like anonymous types, tuples let us create a type with no name without having to previously define it. And to define a tuple, we have multiple ways. The simplest one is to use var, so let's use var, call it myTuple, and then we do an equals, and then we open our parentheses, and inside we put our data. So let's say on this one, we want to store the string CodeMonkey, and then the int value 56. By the way, tuples need to have more than one piece of data, otherwise this one is really just a normal field. So this is just a string, and this is a tuple. Okay, so here we have our tuple. And right away, we can actually do a log on this and see what this creates. And if there it is, that's our tuple with CodeMonkey and 56. So we construct a brand new type, and that brand new type now holds these two pieces of data. We can mouse over the type and see. And yep, here we do see our tuple definition. It stores a string and an int. So this one over here, we are defining the type. and then we can use it. So we can go inside my tuple and access all kinds of things. And yep, inside we do see these two, item1 and item2. So item1, this one is a string, and item2, this one is the int. And here we can already see a difference between tuples and anonymous types. On the anonymous types, in there we had read-only properties, so properties we just get. Whereas this is a normal field, because that means this one is read and write. So we can read this, we can read it with something, and we can also modify it, and it does work. Although here we also see one thing. We see that it is called item1 and item2. Those aren't very descriptive names, but thankfully we can actually give them proper names. So here when constructing it, we can give it a name. So we can write, for example, let's say name, then a colon, and then some kind of value like that. And now inside my tuple, we still have item1 and item2. We can still use those two, and that is not a compile error. So if we use item1, yep, that one still refers to the string. But since we have proper names, we can also use those. So we can use the name and we can use the value. Alternatively, the name can also be inferred if we pass it in using a named variable. So string player name, let's call it CodeMonkey, and then int for the value with some value. And then up here, we just use our player name and we use our value. And then we can actually access, go inside and access, yep, the player name, the value, it is right there. So yep, all this works great. Then yet another way of defining tuples is with the types over here in our parentheses. Instead of using just var, we can define string and then int. And yep, this is our tuple definition. And again, with no name, we can access it through item1 and item2. Or of course, over here when defining, we can also give it names. So the player name and the value. And then if we go inside, yep, we do see it. Then tuples can also have a very large number of fields. So we can define, let's say, a var, call it big tuple. And inside, just open and close the parentheses. And we can write as many fields as we want. So yep, there's a giant tuple, and if we go inside big tuple and try to access it, yep, here we see item 1, 2, 3, all the way up to 20. Now, one main use case for tuples, and actually another big difference between anonymous types and tuples, is how you can actually use these inside functions. For example, returning some data from a function. Usually you have just a single return type. So you've got some kind of function, and over here you define the return type, but that can only be one thing, just one piece of data. Although, like I've also covered on the ref and out keywords lecture, using those you can return more data from a function, so that's one option, but you can also do that with tuples. So here for the return type, instead of just one type, we can define tuple, so just put it inside parentheses. So just like a string and then an int. We can also optionally assign the names to these parameters, so like this, call it get tuple. And now inside we can return, and we can return a brand new tuple. Yep, just like this, and up here, var tuple equals get tuple. And if we go inside tuple, we can access the name, and if we do a console.writeLine on this one, yep, there's a tuple that we receive, exactly the one that came from the function. So this is one common use case for tuples, returning some data grouped inside a tuple. Or yet another thing tuples can do that anonymous functions can't, is actually being passed onto a function as a parameter. So over here on the parameter, same thing. Let's define a bool, b, and a float f. And if there it is, this one is perfectly valid code. Now, one really interesting thing about tuples is the concept of destruction. This is how you can take your tuple that you have. This one, again, is a type that groups multiple pieces of data together into one anonymous type. And then you can essentially deconstruct it into separate variables. So here we have our tuple, and then we can essentially write the same syntax for defining a tuple, but without a name. So the parentheses, let's define our parameters. So let's say player name, and then for the value. And then instead of giving it a name, instead of that, we just do equals right away, and then equals our tuple. In doing so, what this is doing, this is essentially defining these two local variables, and then taking pieces from inside of this tuple and assigning them to these local variables. So this one is now a perfectly normal local variable. So we can do a console.writeLine on this one, and we can see, yep, that one does say Iron Man. So basically, this line over here, this one is going inside the tuple, and inside the tuple it has a name and a value, and it grabs both those pieces and place them into separate local variables. So what we have here is very much the same thing as doing like string player name equals tuple.name and int value equals tuple.value. So basically up here in this one line, this one compact syntax, in this we are doing the exact same thing as here. Now if you want to simplify it even further, you can actually use var. So we can erase the types from here and set in the beginning write var. And if there you go, exact same thing. Var means the compiler will infer the types for both of these. And again, these are going to be in local variables. So whenever you have some kind of tuple, like some kind of function that returns a tuple, and you want to split it into multiple local variables and do it, then yep, that's where tuple construction comes in. It is really useful for breaking it apart to do whatever you want with each individual piece. Then these tuples that we've been using, these are actually called value tuples. So the actual class that we've been using is system.valueTuple. It is this one right here, actually the one with generics. All this syntax is doing, this is really just a shorthand for value tuple. we can actually verify that. So let's do a console.writeLine and let's print out the myTuple.getType. And if there it is, we can see, so this tuple is of type system.valueTuple and does have a string and does have an int. So as you can see, this is another difference from those anonymous types. Anonymous types create an actual anonymous type, whereas tuples, those are essentially new versions of that tuple generic. And C# actually has yet another type of tuple. This one is called the system.tuple, and there's some big differences between these two. First is how value tuples, those are value types, whereas this one, system.tuple, this one is a reference type. So that has all those normal implications regarding copies and references that we covered in a previous lecture. Another big difference is how system.tuple, this one is immutable, meaning it cannot change, similar to anonymous types, they are read-only. Whereas value tuples, these are mutable, we can modify them. And for value tuples, the data is stored in fields, whereas in system.tuple, that data is stored in properties, again, similar to anonymous types. So out of all these three seemingly related types, which one should you choose? And the official C# docs actually has a great page on it. So here are the key differences. So anonymous types, in terms of the access modifier, they start off as internal, whereas these start off as public. This has to do with if you are working with multiple assemblies. Then anonymous types, those are class. So again, reference types, same thing for tuples, but value tuples, these are struct, value types. Then with anonymous types, you can make a custom number name. So you can name it like player name, value, and so on. Same thing with value tuples, but you cannot do that with tuples. Deconstruction, that really useful thing, that one is only available over here on value tuple. And for expression tree support, that's those lambda expressions that are mainly used in LINQ. For that, you can use these two, but not value tuples. Alright, so that's tuples. Really great way to create a type with some fields without having to define a normal type. They have a bunch of differences related to anonymous types. They are mutable and they are value types. So if you need to organize or structure some data, this can be a really useful tool. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to implement the IDisposable interface. This allows us to write some code with the using statement that will automatically dispose of any resources. Okay, so C# has an interesting built-in interface. It is called IDisposable. This one is implemented automatically by some classes, like for example the file class. So if we go inside the file class and we open some random file for reading, so open, then for the path, let's say myfile.txt, something like that. And for file mode, let's open just opening. So this returns a file stream. Yep, here we are opening our file. And what this is doing, it's using up some memory to open and load the file. Then we can do whatever we want from it. Like for example, let's go inside the file stream and let's read a bunch of bytes. So we read a bunch of bytes. And then after we do whatever we do with this file object, afterwards we need to remember to call dispose. So need to go into file stream and call dispose. We need to do this in order to clear up the memory used by this class. If you forget to call dispose, that's a problem. You're probably going to end up with a bunch of memory leaks. So in order to help you not forget that, C# has a nice way of doing things. So instead of doing this, do that, then read all the stuff and manually call dispose. Instead of that, we can write over here using, then open the parentheses. Inside we construct our object. And then within the curly braces, we do whatever we want with our file stream. And that's it, then we close. Basically, by using this using statement, by doing this, this will ensure that dispose is called on this object right as soon as this code block terminates. And the reason why using exists, again, is because FileStream, this one does implement the IDisposable interface. So this can be really useful for any class that requires any kind of cleanup. It can be memory or really just resetting some kind of state. And if you want your own custom types to also support this format, if so, then all you need to do is just implement the IDisposable interface. So for example, let's say we have a class for some kind of save system. We have something like this, and if we try using it in a using block, so using save system equals a new save system. If we try doing this, then nope, obviously we have an error. It's telling us this type being used in a using statement must be convertible into IDisposable. So let's add that over here, let's implement IDisposable, okay? And this one requires us to implement something. It requires us to implement the dispose function. And here, quite simply, we write whatever cleanup code we need. Basically, this function will be called automatically when this using code block ends. We can actually verify it, so let's add a console write line, let's write a log and say dispose, let's see. And if there it is, it did call dispose on our save object. So now here we can write whatever logic we want, like for example on the save system class, perhaps on the constructor, so public save system, perhaps on this one we would create some kind of file for opening. So we've got a private for a file stream, we would have this. Then over here on this one, we construct a brand new one. So we do a new file.open. Let's open some kind of save file. So you could do this, open it. Then we would have, I don't know, maybe some kind of function to save some data. So save player data. You would save some kind of player data, do something on the file stream, then do another one for like save object data and so on. So you can do that, and all these functions would write to this file stream. But you need to make sure to close it in order to properly save this file. And for doing that, we could run it over here on dispose, just call the dispose inside of this one. So yep, now this simple save system class, this one is very well made and very safe from any kind of memory leaks. So up here, all we would need to do is just call save player data, save object data, and everything works perfect. Yep, just like this. By the way, one extra thing, which is over here, this dispose function, this one is running some cleanup code. But if you forget to call this function, if you forget to put it in a using statement or manually call it, if so, there is one fallback you can use. You can use the class destructor. I covered that in the intermediate lecture on classes. Basically, to define the destructor is kind of like the constructor, except you start just with a tilde, then the name, so save system. And basically, this code over here is going to run whenever this object is deallocated, whenever it is garbage collected. So here, to make sure that everything works, just manually call dispose. And yep, that's really it. Super simple. Implement the interface, implement the function, and doing so, your class can now be used inside the using statement. Alright, so that's IDisposable. That's how you can use the using code block in your own custom types. It's a great way to make sure your custom types support any kind of cleanup logic. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to write custom override operators. These allow us to customize logic on doing various operations with our custom type. It allows us to support addition, subtraction, equals, and a bunch more. Okay, so here's some code. I've got a public class, resource amount. It stores a resource type and an int for the amount. Pretty simple. And up here, let's say I want to add one resource amount onto another one. So let's first make two. So resource amount, call it resource amount 1, and let's construct a brand new one. Let's say for the resource type, this one has wood, and for the amount, this one has something like 5. Okay, then let's make another one. So let's make resource amount 2. This one has wood, but has 12. Now what I want to do is actually add both them. So define another resource amount for the resource amount total, and make resource amount 1 plus resource amount 2. So basically I want the final result to have 12 plus 5 of wood. Except, nope, we cannot do this by default. If we mouse over, we can see we do have an error. So the operator plus, so for doing an addition, cannot be applied to things between resource amount and resource amount. So that is because our custom type, resource amount, this one does not support doing addition. But we can make it supported. So the way we do it is over here on the class. We define a new function. Let's make it public. Then for this one, it needs to be static. For the return type, let's return the exact same type, so also resource amount. And then we use the operator keyword. And then for the name of the function, in this case, the name is going to be the operation. So we want to do some addition, so let's use a plus sign. Yep, like this. And then we have our two elements as parameters. So we're going to have a resource amount for resource amount A, and another resource amount for resource amount B. And yep, this is the syntax. Now in here, we just do whatever custom logic we want. In this case, we want to add both amounts. So let's just return a new object, a new resource amount. And for the resource type, let's just grab the one from inside of A. And then for the amount, let's grab resource amount A.amount plus resource amount B.amount. And yep, that's it. And just like this, up here, our error is now gone. So let's do a log and verify that it does work. So a console.writeLine. Let's print out the resource amount total. Okay, let's see. And if there it is, the math is correct. So we've got wood, we've got 17 wood, so 5 plus 12, that is indeed 17. All right, awesome. So this is how you can support math operations in your custom types. And here, of course, you can write whatever logic you want. Like, for example, we can write some validation. So we can test, for example, if the resource type is the same. So grab the resource type, this one, and check if it is different from the one on B. So if these are different resource types, then over here, perhaps we don't just add them together. So perhaps we just return either A or B. So that's one valid option. Or perhaps we simply return null. That's also a valid option. Or perhaps we simply throw a new exception. This also works. Again, it's up to you to define whatever custom logic you want to do with all the operations of your custom type. And since we can implement a plus operation, as you might imagine, we can implement all the other ones. So we can implement this addition, we can do subtraction, we can do multiplication, and we can do division. All of them works exactly the same. So it's a public static function. It returns the exact same type. It has the operator keyword and then has the symbol for the thing and then has an A and a B. So this syntax up here, that one covers all of the math operations. But then we also have equals. For example, up here, let's put the amount both exactly the same. So both are 5 wood. And now let's do a console.writeLine. Let's print out resource amount 1 equals resource amount 2. If we test this, if there it is, this one shows up as false. And the reason why it's false is because it's really comparing two references. These are two brand new objects, so they are completely separate references. So that is why this equals is returning false. But we can also override this. We can do it if, for example, we want to compare the data inside of it instead of comparing references. So we want to compare if the resource type matches and the amount matches. If so, this one should return true. So let's do that. Let's override over here the equals operator. And that works very much exactly the same thing. So let's make public static. And since this one is an equals, we're going to return a boolean, then operator, double equals. And we've got the A and B. So resource amount A and another resource amount for resource amount B. And now again, here we do whatever logic we want. So in this case, let's compare just the data inside the object. So let's return, go inside resource amount A and make sure that the type matches. So resource amount B dot type. If these two match, and resource amount A dot amount equals resource amount B dot amount. If both those matches, then this one does match. Now here we can still see that we have an error. And this is telling us that the operator, if we override the equals, we also have to override the not equals. So let's do that as well. And the syntax is pretty much exactly the same. And for the symbol is the not equals. And for this one, it's actually quite simple. We can literally just use the equals and invert it. So we can do return resource amount A equals resource amount B. So this right here is going to run this logic. And if we want the not equals, let's just simply invert it. So put inside parentheses and do a not. And yep, that's it. So with this done, now up here, if we have this one, now it should be comparing the amounts inside of it, comparing the actual data inside the object instead of comparing just the references. So this should now return true. Let's see. And if that is correct, it does return true. Okay, great. So this is working, although over here we also see a little squiggle line. So we have a warning here. It is telling us that we did override the equal sign, but we did not override the object.equals function or the object.getHashCode function. If we override these two, we should also override those. Now, this is technically not a requirement. As you can see, this is not an error. It's really just if you override one type of equality, you should really override all of it. So let's do that one. And here we can use Visual Studio to help us implement these. So over here, click on this little icon. Let's override the object.equals. And yep, it creates this one. And let's put the cursor there and override also the object.getHashCode. Okay, we have these two, so now let's implement them. And by default here, it already writes some pretty nice code. So first it does a reference equals, meaning it is testing specifically for references between this and the object that it is equating against. If they are the exact same reference, meaning it's the exact same object, let's just return true. Or if the object, if that one is null, that means we are comparing something against null, so let's make sure to return false. And then down here we can write our own custom equals logic. In this case, we probably first want to test for the type. So let's test if the object, if that one type is of type resource amount. If so, then it is the same type. And then we can just use this one equals that we override. So here we can just return this object equals, so we're going to use this operator equals, then object. We just need to cast this onto a resource amount. And if just like this, so if the object that we're comparing against is the same type, if so, we're going to run our equals logic. And if not, then it's a different type, so let's just return false. And if that's it, this is working perfectly. Now, by the way, this one does show a warning here. It is talking about the nullability of the parameter object. This is actually a setting inside of Visual Studio. Depending on how your project is set up, over here the equals will either be object or will be object nullable. So in this case, the project is set up to this, so that is why that showed up. But yep, all the code is exactly the same. So this should now be working, and up here we can test that one. So instead of using the double equal sign, let's call the equals function. So compare that one to that one, and it should be true. And if there it is indeed true. Great. And then down here for the get hash code. For this one, there are several ways of generating a hash code. And the simplest way is just with the hash code helper class. This one has a function. The function is called combine. That basically combines a bunch of values and generates an entire hash out of all of them. So over here, let's use this. Let's combine both the resource type and the resource amount. So yep, combine those and just return. So this way, if we have the exact same resource type and the exact same amount, we should get the exact same hash code. So up here, let's do that same thing. So let's call get hash code on resource amount 1, then a space, then resource amount 2. Let's also get the hash code of this one. And even though these are two separate objects, because the data is exactly the same, these should match. And if there it is, that number is exactly the same. Okay, great. Now, finally, since over here we're on the topic of equality, there's actually one other interesting interface that we should probably implement. That one is called IEquatable. So this interface like here, like it says, it is used by generic collection like dictionary, list, and linked list. It is used when testing for equality on methods like contain, index of, and so on. So let's also implement this interface. Now for this one, it is actually quite simple. So over here in our type, let's implement IEquatable, and then it takes a generic, so equatable with resource amount, okay? And now this just requires us to implement one function over here, the equals. So let's implement this interface. So up here it is, it's an equal, so similar to this one with big difference. This one is the generic object equals, receives a generic, receives an object, whereas this one down here receives a resource amount. So here we can really just do the exact same thing, just do a normal equals. Since again, the project is set up to use these with Nullable, let's first compare it against Nullable, compare the other with that one. If it is null, return false, okay, but if it is not null, then let's just return this equals the other. And yep, that's really it. So now for testing, let's go up here. Let's construct a brand new list. So a list of resource amount. So resource amount list, construct a brand new list. Let's initialize it with something. So let's initialize it with a new resource amount. And in this case, let's go resource type. Let's say gold. And then for the amount, let's say 12. Okay, that's it. So we stored this object inside of this list. And now we can go inside this list and call contains. And again, the contains function, that one is going to run that logic. So you can call contains and construct a brand new resource amount. So let's do another one that is exactly the same, meaning it has the exact same data, but we are constructing a brand new object. So this reference does not match whatever reference is stored in there, but since we override the IEquitable, it is actually going to contain and compare all the data inside of it. So if we do this, let's do a console.writeLine on this one and see. And if there it is, says true, so it does contain that amount, even though the object is completely different. All right, awesome. So here we learned how to implement custom override operators. We can define custom logic for how to do math operations or do equals on any of our custom types. So this helps make our custom types behave exactly as we want them to and enables a more straightforward usage by using normal operators as opposed to having to call custom functions. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about LINQ. This is a way for you to do queries on your collections in C#, kind of like the same as you would do with some databases. So if you already know something like SQL queries, then this is actually going to look quite familiar. Okay, so here let's learn all about LINQ. If you work with databases or simply do lots of data queries, then this is going to be extremely useful. LINQ is really just a collection of functions that works with collections of data. Importantly is how that collection of data can be almost anything. It works on lists, it works on arrays, it can work on databases, XML documents, and a bunch more. It works on anything that implements IEnumerable or IQueryable. Since lists and arrays already implement those, let's use a nice list for testing. So here I've got a simple player class, just has a string for the name and a team. Then I've constructed a new list and constructed a bunch of players. They got different names and they're on different teams. So right here, this is our data. Now we want to do some kind of query on this data. For example, we want to grab just the players on the red team. Now, one way to do this is obviously by doing a simple for each, cycling through this list, then construct a brand new list, and inside the for each, check out inside the list which one has a team equals red, and if so, add them to the other list. So yep, that would work perfectly fine, but we can also do it somewhat more simply by using LINQ. First thing is we need to go up top, and we need to add the LINQ namespace. So using, and it's inside system, and system.LINQ. Yep, that's it. This is the namespace that has all of the LINQ functions. So now, for example, down here, if we grab the player list and just write a dot, so this right here is the normal list of functions. So this is the normal list functions. And then over here on the size, these are the function extensions. Most of these are actually LINQ functions. This is how LINQ is super easy to use. It is all based on extensions upon other types. So if you have any kind of collection, you can always find a lot of these functions. Now in this case, we want to do the simplest thing possible. Really just query this data for one specific condition. We just want to grab the elements where the team is red. So over here, one of the things we can do is use a where clause. And this one is like the name implies. It's going to select some objects where this condition is true. This one takes in a predicate, which is really just a func, so just a delegate. It takes in a player object as an input and outputs a boolean. So basically, if this output's true, we are going to select this player, and if it's false, then we don't select it. Now in this case, we want a very simple delegate, so we can just use a very compact length of expression. We can define the player, then our little arrow, and then for the condition, in this case, we want just player where the team equals red. And if that's it, super simple. This is our delegate, so this is going to do our conditional logic. And now this function itself, this one is going to return an IEnumerable. So if we want, we can just do a for each directly on this. Or if we want a more, let's say, standard type, if so, we can call something like either toArray or toList. Like the implies, that will convert it to either an array or a list. So let's put this inside a list. So let's define a list of player type, call it the red player list, just like this. And yep, so here we have a list of our red players. Let's actually verify it. So let's do a for each player in the red player list. Cycle through all of them and just do a console.writeLine, do a log on our player. Okay, let's test. And if there it is, it found CodeMonkey and Black Widow both on the red team. All right, awesome. So in this super simple example, you can already see how LINQ is quite useful. Instead of having to do a complex cycle, having to make a brand new list to store all of our selected elements, instead of all of that, we just have a single line of code. And in this, we automatically query for all of our elements based on our condition and make our final list. So LINQ really is quite easy to use if you want to do tons of data queries. then this is going to be much easier as opposed to using tons of for each with tons of conditions. Now inside we've got the where, but we have all kinds of things. So here we can inspect all the operations we can do. For example, all. This one returns a boolean and determines whether all the elements satisfy a certain condition. We can do any to check if it contains any elements. We can grab just the first element of a sequence. We can grab an intersection between two groups of data. We can join them, we can grab the last, and so on. So as you can see, tons and tons of functions to do tons and tons of operations. And LINQ also has one very interesting thing. So we can do this. We can just run the normal LINQ functions. This is the LINQ method syntax. But there's actually another way. There's the LINQ query syntax. Now, if you know SQL, then this is actually going to look quite familiar. The query syntax, that one returns an IEnumerable. So let's make an IEnumerable of type player. So red player IEnumerable, okay. And now after the equals, instead of writing normal code, so first grabbing the list, instead of that, over here, let's write the from keyword, and then we give the individual element some name. So in this case, we're cycling through player, so let's call it player. So this is going to be our local variable that is basically going to cycle through everything. And then in, and then we select the collection of data where we want to work on. So in this case, that's going to be our player list. And then we can do all kinds of operations. So once again, we can do a group, we can do a join, we can order, select, switch, and so on. In this case, we want a simple condition, so let's go with where. Then in our condition, let's do the exact same thing. So where player.team equals red. If the player's on the red team, then we want to select it. So let's just select this player. And yep, that's it. So this code over here is basically going to do the exact same query that we did up here. The only thing missing is really just the tool list. But here we have the IEnumerable, and if we want, we can then convert this into a list. But in terms of the condition itself, yep, these are doing the exact same thing. So this one grabs the list as the input, then cycles through the list and grabs each element and calls each element player. Then for each one, it runs this condition, checks if it is true, and if so, then simply going to select that element. So if you're familiar with SQL, then you're basically familiar with this. Here what we have is essentially, let's say, a select everything from some kind of player list database where the team equals red. So this is some basic SQL, and right here we have pretty much the exact same thing, but written in the LINQ query syntax. Let's just verify it and make sure that it says the exact same thing. So let's cycle through this one. And if they're the same thing, it did find both of them. Okay, great. So yep, these are the two methods for working with LINQ. We can either use normal functions, or we can use the special query syntax. Now, one very important thing about LINQ, it's how up here when defining the query, this line of code, this one isn't actually doing anything. This one isn't actually creating any new list or any new elements. It isn't actually running any kind of conditional logic. This line over here, all it does is just define the query. That's it. This one does not execute the query. The query is only executed down here on the for each. When cycling through all the elements of this IEnumerable, that's where it runs the logic for checking the condition, selecting, and so on. Meaning that LINQ has deferred execution. Writing the query, this one just defines it. It does not execute it right away. Only later on, when actually cycling through the collection, only later on does it actually execute the query. Now, this can be quite important if you're limited in terms of performance. You can safely create the query pretty much whatever you want, and then you can wait until later in order to actually run the query. Or if you want, you can actually run it across multiple frames. So IEnumerable, you can manually get it whenever you want. It doesn't have to be inside of for each. So you could run this over multiple frames, which could be helpful if you're cycling through a massive database. Although also another quick note, which is up here when using this method. When using this one, same thing, it is not going to execute just to find the query. But when we call toList, naturally this is indeed going to run the entire query right away and put it inside a list. And like I said, LINQ works with just about any collection type. So here we're working with a list. This one would also work with some kind of array. It would also work with, for example, something like XML. So for example, if we have some kind of list of contacts, if so, then we can define a query going inside it, inside some kind of record node, then inside grab some kind of field, check if the field value does match something, and select that contact. And yep, this is perfectly valid code. All right, so that's LINQ. It's an interesting way to do queries on collections of data. In many cases, it can actually be simpler than doing normal cycles by normally going through a list and testing for some conditions. The only downside is it can sometimes be expensive in terms of memory and performance, but when not doing anything super performance critical, in many cases, LINQ is a great way to do quick queries on all your data. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about WinForms. This is how we can build visual applications in Windows. If you just want a quick and easy way to make something visual, then this is really great. You can just drag and drop all kinds of controls like buttons, scroll bars, labels, and so on, and everything is pretty easy to use. Then of course, all the C# code that we'll learn throughout this entire course, all of that works on any of these controls. Okay, so in this course, we've been mainly using console apps. They are great for focusing on the code itself, but sometimes you might want to build something a little bit more visual, something with a proper UI. And for that, for making visual applications, we have two main options. There's WinForms or Windows Forms and WPF or Windows Presentation Foundation. Those are the two main ones. In order to be able to use them, we need to first install the modules. So open up the Visual Studio installer, and on your Visual Studio installation, let's go and modify it. Then over here under Desktop and Mobile, here we do see .NET Desktop Development. So we can see build WPF for Windows Forms and console applications using C# and so on. So yep, make sure you select this one and install it. In my case, I've already installed. And now if we open up Visual Studio and let's create a brand new project. And yep, right here we do see the things that we just added. So right away we have the two main ones that I mentioned. We've got WinForms or Windows Forms and WPF. Now for these two, WinForms, this one has been around for ages, pretty much for as long as .NET has been around. So it is very mature technology. Whereas WPF, this one is newer and has some more advanced graphics capabilities. They also have some very different architectures. WinForms, this one is very lightweight and very easy to use, while WPF is quite a bit more complex. Also, by the way, I should mention these are not the only two options. For example, one limitation of WinForms is by default, it only runs on Windows. So for cross-platform development, you have something called .NET MAUI. By the way, you might somewhere see the name Xamarin. That's what this used to be called, but Xamarin has since turned into .NET MAUI. This one is cross-platform, so you can write your code and then you can deploy it onto iOS, Android, macOS, or Windows. And also, just another quick mention. Remember how even though Unity is a game engine, that does not mean that it can only build games. You absolutely can build normal applications in Unity. Unity is really just a rendering engine. For example, I've built a controller module to control my live stream overlay. This whole thing, this is really made with Unity, even though it's really just a menu with some buttons. I've also previously built a launcher to launch all my games. So just remember how you always have that option. If you're already familiar with Unity and you want to make some non-game app, then perhaps using Unity might be a good option. But over here, when it comes to WinForms versus WPF, WinForms is really great for its simplicity, and WPF is great for more serious visuals. But like I said, if I'm building something based on visuals, I'm just going to use Unity. So for making non-Unity apps, let's learn a little bit about WinForms. Now to create, we want to create the template. However, it is not this one. Remember the whole thing that we saw in the beginning of the course? This one is using .NET Framework. That is not what we want. So up here, let's search for Windows Forms. And if we see one without .NET Framework and one with it. So it's this one over here, the one without .NET Framework. This is going to be the latest .NET version. So let's go ahead, select this one. Now let's give it some kind of name. So WinForms C# core, something like this. And let's click on next. Then for the framework, yep, let's go with .NET 8. And yep, here it is. And right away, we actually do see a difference. So instead of the code that we saw right away on the console app, instead of that, now we see a visual window right away. And if we try running this, yep, there it is. Here we have a standard Windows window. All right, awesome. So on this, you can build whatever visual program you want. On the right side, we have over here the toolbox. If we go under all the controls, yep, here they are. You can see all the tons of elements that we can add. So for example, we can add buttons, we can add checkboxes, we can add a datetime picker, we can add some fonts, we can add a label for just some text, we can have a list view, just a panel, just a picture, and so on. So basically all the elements that you're used to in any kind of Windows program, you can all find them here. Let's do something very basic. Let's just take a button. So let's click and drag the button and drop it over here on our visual window. And yep, there's our button right here. Now here we've got the usual controls that you find on pretty much any visual program. So we can move it around, we can scale it, and so on. Then also on the right side, we do find over here the properties window. So this is kind of like the inspector inside of Unity. Here we can customize this object. We can modify pretty much anything. You can modify the font, the color, the text, and so on. So here, let's change the text right here. Instead of saying button 1, let's say click me. And then another very important one is to give it a proper name. So instead of button 1, let's name it the click me button. And yep, there it is. However, if we run this, there's our button, a normal Windows button. We can mouse over and change it and so on. And we can click, and it does work. We can click, but nothing happens. So let's give it some behavior. With the button selected, over here up top, we see these two little things. So this one over here is for the properties, and this one over here is for events. So here we can see all kinds of events. Now, WinForms, this is really all based on events. So you listen to a bunch of events like mouse click, and when that happens, then you can do some kind of logic. So you can hook onto any of these events. As you can see, there's tons of them. The simplest one is really just a click. So here you can write some kind of name for a click event function, or you can just double click for default. And if right away, it opens up a view with some code. So here we've got our event. So as you can see, standard event, so object and event arg. Here we have the event where we can write whatever we want. Now, just make sure you don't modify the code up here. This is the forms constructor. This is what actually runs and sets up the form with all the visuals. We can actually inspect over here the initialized component. So let's go to the definition to see. And up here is all the code for initializing and creating the form. You can see here we are constructing a brand new button. Then it is setting the button location, the name, size, and so on. And then down here, setting up the form itself, setting up the dimensions, the size, the name, text, and so on. So really what we are doing here in this visual interface, all of that is really being converted into code, which then actually creates our form. Okay, so here on the form1 code, when we click, let's just fire off a normal Windows message box. So for that, we go inside the message box class, and let's just call the show function and then show something. Okay, yep, just like this, super simple. This will show a message box with some text. So let's go ahead and run. And okay, here's our button, and I click. And if there you go, here's our nice message box. Okay, great. So this is really the basics of WinForms. You've got over here visual design, you've got your toolbox with a bunch of stuff. You really just drag controls and add whatever behavior you want on it. Now let's just see how to do some logic between events. So let's drag something else, let's drag a label. So this is really just some text. So there you go, just a label. Then here on the label, again, the properties we can modify with all of this. For example, we can change the font. There you go, I just use a random font. We can modify the border style, we can modify the cursor. So let's make it with a nice hand cursor. For the border style, let's make it fixed 3D, just like that. For the padding over here, let's increase it by a bit. And that's it. As you can see, we can modify pretty much anything on our object. And up here, we also do see some events. So again, we can add anything that is going to happen whenever we interact with this label. For example, we can add some logic on click. That works perfectly fine. But now let's say we want to click our button, and on the button, change the text on our label. Now first, let's also just make sure that over here the name has a proper name. We're going to modify the text dynamically, but for the name, yep, here it is. Let's call it our text label. Okay. And now the way we access other objects is actually quite easy. We can look here on the code where we are initializing our form, and we can see, okay, we have the click me button, and over here we have the text label that we just created, and it has all the setup that we just made. And as you can see, this one is a text label, meaning it is just a simple field that is defined on this class. And this class, note how this one is a partial class, and the other one where we have our click code, this one is also a partial class. Both have the exact same name, meaning both are part of the exact same class. So to access other objects, we really just use the name, because again, this class shares the other class, which share the same field. So in this case, we named it our text label. So yep, here it is. There's our field, our text label. And then inside we can do whatever we want. So for example, let's change the back color. Let's call it color dot, let's say sandy brown. Then text label, let's change the for color. So this is the text color. Let's put it color.white. And then for the text label, let's modify the text itself and say, hello and welcome, I'm your code monkey. Okay, yep, that's it, super simple. Let's test. And here we are, and there's our label. And by the way, as we mouse over, the cursor actually changes, so that's fun. Now we can click on click me, and there's the box, click on OK, and yep, there it is, there's our text. All right, awesome. So you can see on a mouse click, we easily changed a bunch of properties on a different object. Now also here we saw one interesting thing, which is over here, it's like this by default, and when we click on this, yep, there you go, look at this. It did not change the text right away. That is because this message box over here, this one is actually blocking the program execution. So the code over here basically stops when it gets to this line, and only continues executing the rest of it when we finally dismiss this window. Basically, this is now pausing the main UI thread, and when we click on OK, that one resumes, and yep, continues running the rest of the code. So this is where things like asynchronous programming become really important. It's so you can do all kinds of logic without blocking the main UI thread, which then is going to update the visual. Alright, so that's the basics of WinForms. This is how you can very easily and quickly build a visual window application. It has a very intuitive workflow by just dragging and dropping some controls. And of course, all the C# code that we learned in this course, all of that can be used with any of these visual elements. So if you want to make a quick, simple visual program, then WinForms can be a great option. But also remember how Unity doesn't have to just make games. So if you want to make non-game apps, if you want something visual, you can also just make a simple Unity window. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about DllImport and the extern keyword. With this, we can interact with external libraries. So we're going to see an example of how to interact with the Windows API. Okay, so while building our program, sometimes we might want to interact with an external DLL library. In order to call that external code, it's actually quite simple. As an example, we're going to see how to interact with the Windows API. So first we need to know exactly what we're going to be working with, meaning that we need to know the exact function signature. So one excellent place to see all the functions inside the Windows API is this website, pinvoke.net. This is a great resource that shows all the libraries and all the functions. So over here on the left side, we can see all the various DLLs. For example, we're going to be working a lot with user32, or alternatively, you can also see all of that in the Microsoft documentation. So for a simple test, let's do a simple Windows beep. So for that, we have this function called message beep. This one exists inside the user32.dll library. And right away on this website, we can actually see the correct syntax. The function is going to return bool. It is called message beep and has a beep type, which is actually, we can see down here, it's a uint, as a uint named utype. So we just need to write exactly that. So over here in our code, let's do that. So make it public, make it static. We're going to return bool, and it's called exactly message beep, like this. And inside we have a uint for the utype. And yep, just like this, except of course, like this, we do see this error. It is telling us we must declare a body, but it also says here that we must declare a body because it is not marked as abstract, extern, or partial. And the way we're going to solve this is by using the extern keyword. So over here, just type in extern just like that. And yep, the error is gone. Basically, extern, this one says to the compiler that this function is external, meaning it is not defined anywhere in our program, but rather somewhere else. And now that it is marked as external, now we need to specify exactly where is it. So that's where up here we're going to use the DllImport attribute. And this one exists inside of this namespace, system.runtime.interrupt services. So use this one, and this one takes in a string for the DLL name. In this case, it's user32.dll. Yep, just like this. And yep, we have no more errors. So as you can see, it's quite simple to work with external libraries. The only important thing is really you just need to make sure to write the function signature exactly. So now for testing this, we really just call it like a normal function. So over here, let's just call message beep, and let's pass in the default one, so just 0. Okay, so let's run this and see. And yep, there's our beep, there's our sound. So we defined an external function and we called it. All right, awesome. So yep, here everything is working. And like I said, the function signature, this has to be absolutely exact. If we give it a different name, like just 1e, if we do this like this and call it, right now we see no errors. But if we try running this, yep, of course we have an error. It is saying entry point not found. Basically, did not find any entry point named exactly message beep. That is because the proper one has 2 e's. So again, you can refer to over here on pinvoke to see all of the various functions we can call. You can see the exact signature. So as another example, let's use the message box. So here we see the signature for this one. Or again, we can just look at the official documentation right here. We can see all the parameters, and over here on this documentation, we can also see all the various values. The only thing is over here on the official Microsoft, this one says our C++ code. Whereas over here in pinvoke, we see some proper C# code. So let's copy exactly this. So here we are, and let's paste it. So same thing. So we've got the DllImport, and just has some extra parameters. Then this one is again, it's static, it is extern, it returns an int, it is named exactly message box, it has a pointer for the window, then it has a string for the text, another string for the caption, and a uint for the type. So yep, now let's just call this. So over here, instead of the beep, let's call our message box. For the window, let's leave it on 0. For text, let's say hello world. For the caption, let's say code monkey. And for the type, let's just go with 0. Okay, so let's try this. And if there it is, look at that. Here's our window, our title, our text, and our OK message. Okay, great. Now let's play with this a little bit more. Here on the Windows documentation, we can see the utype. This one is actually a very special thing. It says here this parameter can be a combination of flags from the following groups of flags, meaning this really Enum Flags or really just a bit mask. We already learned about those in the Bitwise Operators lecture. So here we can just select a bunch of these options. For example, we can have abort, retry, ignore. We can have those buttons, or cancel, try. We can have OK, OK, cancel, or yes, no. So for example, let's say we want yes, no. So here instead of 0, let's put yes, no, just like that. But this is a bit mask, so let's also use another one. So for example, over here we can see a bunch of icons. So let's go with this one, an icon with a question. And since this is a bit mask, let's make sure to use the or. Again, the bitwise or, just one pipe, just like this. Yep. So this should say the exact same message, but now it should have yes and no buttons, and it should have a nice question mark icon. So let's test. And if there it is, exactly like that, question mark, yes, no, absolutely perfect. All right, awesome. Now, if you want another example, you can watch my transparent Unity window tutorial. This is exactly what it sounds like. I made a Unity window with a transparent background. And the way that works is, again, by using some external function calls. So using that, I was able to make the background transparent. That's how I'm able to make this live stream overlay of the characters in chat walking around. This whole thing is a transparent Unity window. And another thing similar related to this one is called library import. This one is also an attribute. This is actually the newer method for doing this. It has improved performance and compatibility. The only thing is it requires source generation in order to work, but nowadays most projects will probably support source generation. In order to use it, in terms of the code, it's actually mostly the same. So in here, instead of using DllImport, we use library import. And since this is based on source generation, instead of using extern, we use the keyword partial. And if we make this function partial, if so, then we need to make the entire class partial as well. And again, make sure we have the exact same signature. And this one is telling us that we need to use the marshal as attribute. Marshalling is basically the concept of interoperating data between managed and unmanaged data. So in this case, we just need to add the attribute to define the return type, marshal as unmanaged type.bool. That is this Boolean type, make sure that it works. And if that's really it, we have no errors. And if we call message beep, and yep, we still have the beep and we still have our message box. So this is another alternate method for also calling external code. Alright, so that's DllImport, extern, and how to work with the Windows API. With this, you can actually do some really interesting things. Like for example, you can show a message box or open a file dialog window. You just call those functions, you don't have to build those windows from scratch. Or you can build a transparent window like I did. The Windows API is really huge, so definitely feel free to browse it to see everything it can do. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to use Asserts. This is a very interesting code validation tool. And then we're also going to talk about unit testing in general. Okay, so Asserts. This is an interesting way to make your code much more robust and free from errors. It is really just a simple way to test for something. This way we can easily validate our code to make sure everything works exactly as expected. For example, here is a player class, and on the constructor we receive a string for the player name. Now let's say the name is never ever supposed to be null. Basically the rest of our code is making the assumption that player name is never null. So we want to make sure that rule is enforced. Basically if that happens, then it's an error in the code that should never happen. So we do want to know if it does happen. And one way to do that is with an assert. Now they exist inside the debug class. This one inside system.diagnostics. Inside we can call the assert function. And this one takes in a condition. We want to make sure this condition is true. So in this case, let's make sure the player name is not null. And yep, just like this, very simple. So now up here, if we construct a brand new player, if we do this and we pass in a valid name, so a proper name, if there it is works, nothing happens. Whereas if we pass in with null, if there it is, our code basically just stopped. Now importantly, this is not an actual error. The program did not crash, it is still running. Instead, it really just paused. So this assert really just acts like a breakpoint. That way we can use our debugger tools in order to figure out exactly what happened. And then if we want, we can click on continue to continue running the rest of the program. And if it continues, terminates, and so on. So basically asserts help you ensure that certain conditions are true. If it is not true, the program will pause. Now one extremely important thing is how asserts are meant for validating code only during development. This is not meant to be used during runtime. In fact, by default, this won't actually even run during the final build. It has to do with up here for the configuration manager for the various configurations. By default, this one, debug.assert, this will only run if you have the debug configuration selected. Now I talked about these configurations a little bit more in the lecture on Preprocessor Directives. So like this, if we select debug, the assert will run, but if we change this to release, this is what you would normally do when making the final build of your game. If so, then even if you pass in the wrong data, if you pass in null over here, nothing would actually happen. If you don't have the debug configuration selected, then it's as if this line of code does not exist at all. It is completely not included in the compilation. So keep that in mind. The goal with assert is to ensure your code is behaving exactly as it should be during development, and then after you verify that everything works, then you make a release build. If you do want to make some verification logic during runtime, for example in this case, let's say the player name was a user input instead of a hard-coded string by a programmer. If it was a user input, then you would not use this. If it was user input, you would make a simple if. So if player name equals null, then do something. So do remember that point. The goal with asserts is to validate your own code, and then you can use regular logic to validate runtime code. Now if you do want to do asserts in runtime, there's actually a way. So over here, debug.assert, like I said, this line will not be included in the compilation if up here we have release selected. But we can use trace.assert, and this one does pretty much the exact same thing, but this one is included in release mode. In general, that's really all asserts are. You just have a simple condition. You add these in various places in your code to make sure your conditions are always true, to make sure the code is running correctly. And if something goes wrong, then you simply know about it so you can fix it. Now, since asserts are all about testing your own code and making sure that it behaves as intended, let me just briefly talk about code testing, or specifically unit testing. This is a huge topic, so I'm just going to briefly mention a high-level overview. So when doing unit testing, that is when you write a bunch of tests to ensure your code behaves exactly as expected. So for example, over here for this player class, let's assume the player should never be null, but then let's also say this one doesn't make that assumption, it just stores the player name. And then let's have some kind of function, so get player name length, and this one just goes inside the player name and returns the length. Now naturally, if over here the player name is null, then this one is going to throw an exception. So if this was our player class and we want to test this, then basically just come up with a bunch of tests, a bunch of edge cases where your code could go wrong. Like for example, up here, define a player class, player, set it to null, and then call player.getPlayerName length. You would put this whole thing in some kind of try catch. And if it throws an exception, then simply we have the test failed. and if not, then test succeeded. So yep, let's test. And yep, this one throws a null reference exception, and we can see indeed our test failed. So this is a basic example of a test. You set up everything to run the test, and then maybe it succeeds or maybe it fails, and if it fails, then you know you need to fix something. So you do that, you would fix that, like for example up here, you would add if this one equals null. If so, then set it to an empty string. And if now with that change, now the test does succeed. So this is really a very rough high-level overview of unit testing. You have a unit, meaning some piece of code. It can be an entire class or just a function. You have that, then you write some tests to test whatever you want. In this case, testing what happens if the player has a null name, and then we try getting the player name linked. So you write all your tests, and then if all the tests pass, then the code is good, and if something fails, then basically you have some work to do. Then in order to write these tests, technically you could do it all like this, build it all from scratch, but there's a bunch of testing frameworks that can help simplify that process. The official one by Microsoft is called MS Test. There's a pretty simple guide here on how to start using it. So basically you have some kind of code that you want to test, then you create some kind of test project. You create a class that is going to test a bunch of things. For example, it tests over here that number 1 should not be prime, so it makes some assertions, does a bunch of things. And instead of having to write all that try-catch code that we just saw, it really just works based on adding a bunch of attributes. So using a testing framework like this can make it much easier to make some tests. Two other very popular testing frameworks for C# are, one of them is NUnit, and another one is called XUnit. So if you want to do unit testing, it is probably wise to use a proper testing framework. Alright, so that's Asserts. It's a way to validate your own code and test your own logic during development. This way you make sure your code is running exactly as intended before making the final build. And here we also covered a high-level overview of unit testing, what it is, and the various frameworks you can use. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to write unsafe C# code. This lets us disable the safety features of C# so we can access raw memory and do anything we want with it. Okay, so let's see how to write unsafe code. Now this is a very advanced topic. When working with raw pointers, it is extremely easy to mess up. You can corrupt some memory and crash your program, or you can simply end up opening your program to all kinds of security vulnerabilities. So this lecture is very much just a quick introduction to the topic, just so you know that it exists. I myself am not an expert in unsafe code. I've never really used it myself in any serious project, I just know that it exists. In order to properly use unsafe code, you need to know exactly what you're doing. If you don't, you're going to cause a lot of trouble, so always keep that in mind. Now, before we cover unsafe, how exactly is C# safe? Well, C# actually has a ton of safety features, mainly to do with memory. For example, when working with a language like C, when you want to create a brand new variable, you need to manually allocate some memory for that variable. Whereas in C#, that is all handled automatically. So if you define an int I equals something, this automatically defines the memory for this integer and automatically assigns the value. Then when reading some memory, like for example a string of text, you need to know how far along to read. You need to read it character by character. Whereas again, in C#, you just got a string with something, and then you can easily read it and say something to it. When working with pointers, you can have pointers to invalid locations in memory, whereas in C# you simply have null. So that and tons more things. Basically, C# tries to protect you as much as possible. And of course, the downside of all of these safety features is naturally it makes the code a little bit slower to do all of these safety checks. That is why, in super performance-intensive applications, usually you write it with C or C++. For example, while you write game code in Unity and C#, while you do that, the engine itself, that one is mostly written in C++. The entire engine has an entire pipeline to basically have your C# code communicate with the backend C++. And the reason why it's in C++ is exactly to have access to all that raw power without that safety overhead. But again, the engineers that work on the Unity backend, they are experts, which is why they can work with pointers without causing all kinds of issues. Now, in C#, in order to write some unsafe code, it's actually pretty simple. You just use the unsafe keyword. Now you can mark an entire class as being unsafe, you can mark an entire function as unsafe, or you can simply define a code block, and just this code block is marked as unsafe. Now inside of this we can write any unsafe code, like accessing pointers and allocating some memory. Although right away you can actually see an error. It is saying unsafe code may only appear if compiling with the unsafe. So we need to first set up the project to actually support writing unsafe code. By default it does not support it. So for that, let's go onto the Solution Explorer, let's right click on the project itself, go into Properties, and over here let's scroll down, and over here under Build, we can see, yep, here's a checkbox to allow code that uses the unsafe keyword to compile. So yep, let's enable this, and yep, the error is gone. Okay, great. So now in here we can use pointers. For example, we can define an int pointer. And the way we define a pointer is first to type int, and then a little asterisk. So this is an int pointer. Let's call it like int array pointer. And in order to allocate some memory, we can use stack alloc. Then let's allocate memory for an int array with, let's say, 10 elements. And if this is going to manually allocate some memory for an int array, then for example, if we want to read the memory location for this, we can grab the int array pointer, we can cast it down to this type, the int pointer, and let's just print this to see what this says. So let's do a console.writeLine. Let's print out this. Let's just do a toString to convert this into hexadecimal. So toString with format of X. Okay, let's see. And if there it is, we allocated our pointer, our int array, and it ended up being allocated on this exact memory address. Now let's read the entire memory address location. So let's do a simple for int I equals 0, I less than 10, I plus plus. And for this int array pointer, we can access this as if it was a normal array. So just access that one. Let's do a console.writeLine on this one. Okay, let's see. And yep, it's all in zeros. Makes sense. But now let's see another thing. So we are allocating with 10. And over here, let's actually read 20 positions. And if you look at that, this did work. Usually, if you try doing this in non-unsafe code, in normal code, if you try to access this array on something bigger than the index, if so, then basically normal C# code would have a bunch of safety. And that safety would stop us from looking beyond the index bounds. If we tried, we would get an index out of range exception. But over here, when working with unsafe code, we don't get that. We can read the memory beyond the array, and doing so, we're basically going to get gibberish. So the first 10 positions, those have been initialized as new int array, so those are guaranteed to be initialized to 0. But these other ones can have really any memory. This memory does not belong to the int array, it belongs to something else. But as you can see over here, the unsafe code does not stop us from accessing it. So even though the int array only has a size of 10, we can go all the way up to 20 and even more. By the way, this is actually the basics for how hacking programs work, things like aimbots and wall hacks. Usually they read memory they're not supposed to, and then interpret it in some way. Like for example, display an enemy behind the wall. And the pointer itself, this one is also, like we saw here, it's just a position in memory. So we can take this one and, for example, let's increase it. Let's increase by some amount. This basically means we're going to look at a memory location for it, which again is going to let us read a bunch of garbage. So up here, let's read just 10 elements, which without adding this one, we would see everything with zeros. But now, yep, we see a bunch of garbage values. So pointers are really just numbers to a location in memory, and you can increase that number. You can do whatever you want to read a different location in memory. Now the asterisk over here, this one defines a pointer, and then another symbol, the ampersand, that one defines the memory address. So for example, let's make over here a simple struct. Importantly is that pointers need to work with unmanaged memory. Again, the entire concept of managed memory, that's a C# thing. C# automatically manages memory for you. But when working with pointers, when working with unsafe code, we are intentionally not using any of that. So when working with unsafe code, we're pretty much limited to just using unmanaged data. So that is why over here, let's find a struct for some kind of game data. Then inside, let's define some kind of value for some coins, and then maybe a bull is game over, something like this. So now up here, let's say we construct a brand new one, game data equals just a new game data. And now let's define a game data pointer. So this is not of type game data, it's a game data pointer, so game data pointer. And for this one, let's make this pointer point to this structure right here. So for that, we use the ampersand in order to get the actual address in memory of this game data. And yep, so now we have this pointer, and this pointer is going to point to this data. And now, for example, for accessing data inside a struct, for that, we access our pointer. And now, normally, when working with C#, you would do .coins, something like this. But over here, we are working with pointers. And when working with pointers, or when writing some C code, to access a sub-element of this object, for that, we do a little arrow. And then we access, for example, the coins, and we can set it to something. And then same thing for the other one is game over, we can set it to something. So yep, this is how we can access some members of some data, some type. We grab the pointer using the location memory, and then access those members and do whatever we want to. Then you can also declare pointers as function arguments. So for example, let's make here a function to raise something to the power of 2. So let's make a static function, just because over here we're in the static thing. Let's make it void and call it power 2. And over here, let's receive a pointer as a function argument. So instead of an int, let's receive an int pointer. Yep, just like this. Except, of course, we see an error. We can't use pointers. We can only use them in unsafe contexts. So let's mark this entire function as unsafe. And yep, that does work. And now we want to modify this value. So to modify the value, we access the pointer itself. And then we're going to set it to something. So in this case, power of 2, we want to basically put this value to the power of value. So let's do times equals, just to do the multiplication. And then times equals, again, the value stored inside a value. So not value like this. This is an error. We don't want to get just the pointer itself. Instead, we want to get the data where that pointer points to. So let's put a little asterisk to get that one just like that. So that inside of here is going to multiply itself by that one, and that will basically do a power of 2. So then up here, let's use it. Let's find some kind of value. So int a equals 5. So just a simple integer. Now call the function, so power 2. But now we need to pass in a pointer, not that itself. If over here we use just a, yep, we have an error. It's telling us cannot convert an int, meaning just a simple integer, just simple value, to int star, meaning an int pointer. So we need to pass in the pointer, which means we need to pass in the memory location, just like this. And if that's it, that works. Now, one interesting thing, since we are working with pointers, meaning that this is going to point to the original position in memory, even though over here we are working with an int, which is a value type, and normally if we made this kind of function and over here we receive just a normal int, with that, if we then multiplied it, we would only be modifying the copy itself and not the original data. But since over here we are passing the pointer itself, if we do a console.writeLine on this one, on a, if there it is, it says 25, so 5 to the power 5. So the function, this one modified the data on the variable itself, even though it's an int, and the reason is because we're dealing directly with pointers. Then some objects might move around in memory. If you have some kind of managed data, like for example, just a simple managed array, if you have something like this object might go into different positions in memory. So if you want to do something, you can use the fixed keyword, and this one is basically going to generate a pointer, so a byte pointer equals our bytes. And yep, basically this one over here, the fixed, this one is going to generate a fixed pointer to this object. So whilst inside of this fixed code block, we can make sure this byte pointer is valid, but when outside of it, this object might move to a different position in memory. Okay, so that's how you write unsafe code and deal with pointers. Like I said, this is a very, very advanced topic. It is very error prone, so definitely make sure you know what you're doing. Unless you're writing some code in some embedded systems or something super hardcore like that, chances are you really don't need this. C# has a ton of really awesome safety features that are meant to protect yourself. Those are really good, they help you write much more error-free code much more easily. So only disable those when absolutely necessary. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about asynchronous programming. Specifically, we're going to learn how to use the async and await keywords in C#, as well as how to use the task type. Okay, so first of all, what exactly is asynchronous programming? This is how we can have code that executes in a non-linear sequence. Basically, it's how we can have some code pending for execution while some other code is executing. One great example is simply to think about cooking. For example, let's say we want to cook some breakfast. We want some coffee, eggs, bacon, toast, and so on. Now, if we do it in a non-asynchronous manner, meaning if we do it all sequentially, one task after another, then first we pour some coffee, after that's done, we heat the pan, after that's done, we fry some eggs, then afterwards do this, and so on. So basically we do each task to completion one by one until the end. So in total with this, we would spend maybe 30 minutes. But obviously, in looking at this example, you can probably see that this doesn't really make much sense. You wouldn't really make your breakfast this way. There's no point in standing around doing nothing while the pan is being heated. You can start some of these tasks at the same time. So the asynchronous method of doing a breakfast is like this. So we pour some coffee, and then we start frying the eggs, start frying the bacon, and start toasting some bread. We start these 3 tasks at the exact same time. Then while those tasks are making some kind of progress, we continue doing anything else. As soon as the tasks complete, we get notified and we can do more things. So for example, the eggs get done while the bacon is still cooking. Then the bacon is done while the toast is ready, so we start putting some jam and so on. So basically we start a bunch of tasks, and then in the background we wait for them to complete, and while we're waiting we can do other tasks. So in total, by using this method, naturally we would make it quite a bit faster. Although here, let me point out one extremely important detail. Asynchronous does not mean multithread. Meaning everything, all of it, still runs just on one thread. Making something asynchronous just means there's really a pending task and we're waiting for it to complete. So the common example in actual code is doing something like contacting a web server. We make the request, and then we just sit around and wait for that request to return, for the server to actually send a response. Meaning our CPU is not actually doing any extra work on that task. It sends out the request and just waits for it to complete. So always keep that in mind. Making our programs asynchronous helps us keep the program nice and smooth without freezing, but it does not make it multithread. Okay, so now that we've seen the theory behind async programming, let's learn the syntax in C#. So for example, let's say we have a function to contact a web server. So up here, let's make a void contact web server. And now here we do something that takes some time. So we would make some kind of HTTP request. In order to simulate this, let's use the task.delay. This function basically waits a bunch of time. It's simply going to delay execution. It's not actually going to do any work. It just waits. This one takes some milliseconds, so let's wait for 3 seconds. Okay, so here we're pretending to contact the web server and wait for a response. Let's just do a log here. So console, let's do a write line, and let's print out contacting server. So we're contacting, and then we contact, then let's say by this, the server has finished getting a response. So let's say got a response. Okay, just like this, and for testing, let's run this. Although this one actually quite worked, but let's test. And if that's it, just basically ran both of them at the exact same time. So it didn't actually wait any time. That's because over here, task.delay, note how this one says awaitable and returns a task. So this is an asynchronous function. This task object itself, this is what contains the data for the pending action. If we want to wait until this action completes, then we need to await it. So right before it, we write the keyword await. Yep, just like this. This will basically pause the execution right here on this line until this task ends. And when the task ends, then it continues going on to the next line. Again, remember, this does not make it multi-threaded. When we use await, this logic for the task.delay, that one is still going to run on the main thread. It is simply just going to wait until it is completed before continuing. And also here we do see an error. It is telling us the await operator can only be used within an async method. So in order to make this work, we need to mark this function as async. Yep, just like this. So now let's test like this, except it also didn't quite work. We can see it did start contacting the server, but the program just ended before we got a response. So let's make sure we keep our program alive. We keep it running while we wait. So for that, we can just do a while true, just an infinite loop, just so it keeps running forever. Then we can forcefully close it. So like this, if we test, okay, there it is, and contact the server right away. And now after 3 seconds, yep, there you go, we've got our response. All right, awesome, so this worked. Here we have the main asynchronous syntax. We mark our function as async, and then inside it, when doing some kind of asynchronous work, whenever we want to wait for something to complete, we use the keyword await, and doing so basically it will pause the execution of this function right here, and will only continue after this task completes. However, very importantly, note how up here it did not pause. So down here on this function, when we got to this, it paused and waited for 3 seconds before it ran this line, but up here, we ran this line of code right away, and we went inside the while true immediately. We can actually put a console.log over here just to see exactly, and let's see. And if there it is, it's constantly printing out dashes, so that code is running. This is very important. So we ran this line of code, which in turn started this action and then waited for it to complete. But whilst waiting for this one, the code over here on the main function, that one continued executing. So it did not stop on this function, it continued going on to this one and continued going on forever. So with that, we had 2 branches of code running at the same time, except they were not really running at the same time. Again, this is not multi-thread, we have just a single thread. What we had was essentially 2 pending tasks. So whilst working on the main thread, our code was constantly testing, is this task done? Just doing a quick check, and if not, then just continue running the same code as normal. And then when this task completed, then continue going on to this, it finished this function execution, and everything else ran the same. However, also one very important thing, which is how up here, like we saw, the code does not stop. So we start contacting the web server, and then we continue running some logic. So if we do this, if over here our code does not stop, how exactly can we know when our task has been completed? So in this example, how exactly do we know in here when have we finished contacting the server? When can we actually get some data back? So let's say we get some data, so let's just define a string for the server return data. So you have this, and over here, after we contact the server, let's get some data back, okay? So now the question is, how do we know over here in this code, well, inside of this while, how do we know that this data has been returned? If we just try reading it right away, so let's get some in for some kind of data length. Let's just access the server return data and get the length, just trying to access that object. If we do this, naturally it won't work since the data will not be set right away. It has to actually wait for the server. So if we test this, yep, obviously we get a null reference exception. The data has not yet been returned, so this one is still just defaulting to null. So essentially we need to know when is this task done executing. And for that, we can use the same task type ourselves. So over here on this function, instead of returning void, let's make it return a task. And up here when calling it, let's grab our task. And then inside of this one, we can access all kinds of things. So here we can get a bunch of stuff. And the main one is really over here, these properties, so like is completed. This one is going to be true when the task actually completes. So let's just check for this one. So if the task is completed, if so, then let's get the data length. Let's just do a print on that. Yep, so now while the task has not been completed, this code is not going to run. And when it does complete, then we have our server return data, and now we can run this logic. Also, by the way, alternatively, we could just call task.wait. This one would work, but this would block our main thread. So our code would not keep executing like this. It would stop right here until the task actually completes. Whereas like this while is going to constantly running over and over again until the task completes, and then it's finally going to run this logic. So let's test. And up here we are contacting server, and after a while we should be able to see, yep, there you go, we've got our length. Okay, great. So here we can see that our function waited until we were finally able to read some data. However, usually you actually don't want to use this method, the method of doing a while true and then waiting for the task completed. Usually the proper way is exactly like we did it down here with the task.delay, meaning we should use the await keyword. Like we saw here, that won't pause the execution of the rest of the function until it completes. So over here, instead of grabbing the task manually and then manually waiting for it to complete, instead of that, let's just await this function call, just like this. And then any code after here, we can assume this function has been finished, which in turn means we do have our return data. So we can get rid of these checks. We don't need them. Just like this, it won't work. So it starts counting the server and only continues running this code after the server has returned a response. However, again, when you use awake, we need to mark this as async, so we have to do it like this. But if we try this, if we try making main async, if there it is, we actually have an error. And the error is telling us program does not contain a static main method suitable for an entry point. So making this function signature async void main, this is not valid for a main function. However, we can definitely make main into async. We just need to make sure that for the type, instead of void, we return task. And yep, like this, it should work, so let's test. So here we are counting the server, and we are indeed waiting. And after 3 seconds, yep, we get a response, we get the 4, and everything works perfect. So yep, just like this, it worked. We did not have any errors, because again, the program stayed on this line. It did not continue down until this function was completed. Then when this one is completed, then down here, we can make the assumption this has been set, because we do know this task has completed successfully. So now that we've seen this syntax, let's actually see that breakfast example. So for example, we have our functions to do all kinds of things. So let's do a static async, let's return task, say like cook eggs, and in here let's do a console.writeLine in order to say that we are starting cooking our eggs. Then let's do the same thing, let's pretend this is doing something, so let's use task.delay, just wait for a little bit, and let's say the eggs take 3 seconds. Then a console.writeLine saying that our eggs are done. Okay, great, like this, let's make 2 more. So let's make one for cooking bacon, and for bacon, let's say it takes a bit longer, so it takes 4 seconds. And then finally, let's make toast. And this one is quite a bit faster, let's say 1. Okay, great, just like this. So we have our breakfast functions. And now up here on our main, in order to start running those functions, let's first actually see the sequential non-asynchronous method. So let's first cook our eggs, but let's await it in order to make sure the eggs fully finish cooking. Then let's do the same thing, cook our bacon, and let's also await for it to finish. And same thing for make toast, let's also await for it to finish. So this is essentially going to be our synchronous method, meaning we're going to fully cook the eggs, then fully cook the bacon, and then fully make the toast. So let's see this. And okay, there it is. Eggs are starting to cook. And after a while, eggs are done. Now starting to cook some bacon. And after a while, bacon is done, starting to make toast, and toast is done. So yep, with this, we met our breakfast, but we also wasted a ton of time. We can essentially do all 3 of these tasks at once, assuming we have 2 pans. There's really no need to wait for the eggs to finish cooking before we start cooking bacon or before we start making toast. So instead of this synchronous code where we fully finish one task before starting another one, instead we can start them all at once, meaning they all start cooking right away, and then we just need to wait for all of them to be completed. So instead of waiting it, let's grab the task from that, so the eggs task, and over here task for the bacon task, and finally a task for the toast task. So we have all 3 of our tasks, and again this code is going to run sequentially right away. So we're going to immediately start cooking eggs, immediately cook bacon, immediately make toast. And then after starting all of these tasks, now we do want to wait for all of them to finish. So in order to basically await multiple tasks, we can use inside the task class, there's a when all function. This one takes an array of tasks. So let's wait for the eggs task, the bacon tasks, and the toast tasks. And yep, this one is going to be an awaitable call. So let's await on this, which means the code is going to pause execution on this line until all 3 of these tasks are done. And then down here, we have our breakfast done. So console, let's write line. Our breakfast is done. Okay, so yep, just like this, let's test and see. And if right away we can see cooking eggs, bacon and toast, all of that starts and toast ends right away, eggs done, and finally bacon done, and we have the full breakfast done. All right, awesome. So we got our breakfast done, and we made it much faster because we started all our tasks right away, and we just had to wait for them to complete. So instead of cooking each task individually, instead of that, we started them all, and then they all finished. So this is really how async works. You start doing some work, and then while waiting, you can go do other work. Now with all of this, there's really only one thing missing, which is how do we return data from one of these functions? Right now, this is just returning a task, meaning it's actually not returning anything, but we can indeed return some data. So on the test type, we have a generic version for exactly that purpose. Then over here, we use whatever type we want. So for the contacting web server, let's say we want to get a string back, just like this. So instead of setting some kind of field, let's just return our data. And yeah, just like this. So now here, the way that we call this is we call the function, but we want to wait for it to complete. So let's await it. And in order to get results, we really just put it over here. So server return data, just set it equals to that one. And now we can do a console.writeLine on this one. And since we awaited, it's going to pause in this one before going into this one, So this one should have the correct data received from the web server, so let's see. And okay, it's calling the server, it's waiting for a little bit, and after a while, yep, got a response, and response was indeed data. Okay, great. So this is how asynchronous programming works in C#. We have tasks, we can start those tasks right away, and then we can wait for all of them, which will essentially pause the code execution until those finish completing, and then it continues running the rest of the code. Then if we use await on some kind of function, we also need to mark it as async. And when using async, we can either return void, which usually doesn't make much sense. Usually you want to return whatever task you are awaiting. So you usually want to return either task or the generic in order to return some more data. Now, like I said many times, and let me repeat once more, just because it's something a lot of people get confused about, asynchronous programming is not multi-threaded. All of this code right here, all of it is still running just on a single main thread. We're actually going to learn all about multi-threading in the next lecture. Alright, so that's asynchronous programming using async, await, and task in C#. It's how you can keep your program running and not freeze while waiting for some kind of external result to arrive. This is extremely important in order to make sure your applications stay nice and responsive. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about multithreading in C#. This is how we can create separate worker threads to do all kinds of work on multiple threads at the same time. When done correctly, we can improve the performance of our program by a massive amount by utilizing all the cores to their max. Okay, so multithreading. Right away, let me say this is a huge topic with many potential pitfalls. This is very much a definition of an advanced topic. Writing properly multi-threaded code is actually quite difficult. It is very easy to make mistakes. So here we're going to learn just the basics, but then do make sure you dive deeper into this topic before you start using it in production code. So let's start with the absolute basics. First, what exactly is a thread? Now, a thread is really just a unit of execution within a process. It does not automatically match up to a core in your CPU. We can technically create as many threads as you want, but usually you want to create as many threads as the processor has cores, and then you want to try to split the workload evenly in order to achieve 100% CPU core usage. That way, all the cores will be busy doing something instead of doing everything just on a single main thread, which is actually how a lot of code runs. And also, I should point out what exactly happens if you create too many threads, or if you have multiple programs, all of them running multi-threaded code. If you do that, then the answer is actually quite simple. The CPU will schedule the threads to run on different cores if possible, and if not possible, then it will simply queue up the threads. So if you have 10 cores and you make 20 threads, 10 of those will be queued waiting for a core to be available to do some work. It won't magically create 20 cores if you make 20 threads. It will use all the cores as much as possible, but naturally it can't use things that don't exist. That as well, like I said, usually first you check how many cores your CPU has, and then you define the number of threads to create based on that. Now here in C#, in order to create a thread to do some work, it's actually quite simple. Now first we define the function where we want to do some work. For example, one very common use case in game dev is doing some kind of pathfinding. You want the main game logic and all the UI and all of that to be running on the main thread. You want that to be super smooth and not freeze while waiting for pathfinding. And then you want to take advantage of all the cores of the CPU to make the pathfinding super fast running at the same time. So for that, let's start by making a simple function. So let's make a static void, call it calculate pathfinding. And now here, let's just start calculating pathfinding. And to simulate that, let's use thread.sleep. And thread, like it says here, exists inside of this namespace, system.threading. So thread.sleep. This function simply keeps the CPU busy for a certain amount of time, let's say for 3 seconds. So basically this is going to be simulating as if the CPU is doing some complex pathfinding algorithm. Let's just do some logs just to see. So console.writeLine, over here calculating pathfinding, and then over here, let's say pathfinding done. Okay, so this is our function. This is the work that we want to do on a separate thread. Basically we want to be running this logic while the main thread is doing something else. So here, instead of manually calling the function, this would just run it on the main thread. So instead of this, let's create a brand new thread. So we do new thread, and now inside we pass in the function we want to call, or alternatively, we can be more explicit. We can construct a new thread start, and inside use our calculate pathfinding. Now this function here takes in a delegate. It has to return void and have no parameters. So yep, exactly the same signature we defined here. Now this is going to construct our thread. So let's define this as our worker thread. So we have this, but just like this, it won't actually run just yet. All we're doing here is just creating and setting up the thread. In order to run the logic, we need to go inside of this one and call start. And yep, now this will start executing this function on that second worker thread. And then after here, we can run some code that is going to run on the main thread. So here, console.writeLine, doing some main thread work. And then afterwards, when we want to do something that depends on whatever result we have in this thread, after that, we can once again use the thread and call the function join. And this will basically block the calling thread, meaning the main thread. It will block it until this thread that is doing some work, until this one terminates. So we call join, and now down here we can run some code on the main thread, whilst assuming that the second thread has completed. So for example, if we were calculating some pathfinding, then over here we could assume the pathfinding has been calculated correctly, and we could use it to move some unit or something like that. So yep, over here let's just do something like this, just print another log and let's test. And okay, there it is, main thread is doing some work, we're calculating pathfinding, after a while pathfinding done and main thread done. Alright, awesome, so everything does seem to be working. However, right now you might also be thinking this looks a lot like what we covered in the previous lecture on async programming. If we replace what you used with the await and async, then this would actually look quite similar. However, like I mentioned in that lecture, async programming is not multi-threaded. In async programming, we were waiting for an external service to do some kind of work, like contacting a web server. All we were doing is really just waiting to get a response back. Whereas here, we are actually doing some work on both threads at once. We can verify that by actually printing some more messages. So over here on the pathfinding, let's do a for to print a bunch of messages. So let's do a thread.sleep and let's do a write line. Okay, so like this. And then on the main thread, let's do pretty much the exact same thing. So over here, we're going to be doing some kind of main thread work. And let's make this one a little bit faster. Okay, so let's do like this. And if there it is, calculating pathfinding, and we can see both the main thread and the pathfinding thread, both of those are working at the exact same time. Again, this is the really big difference. In async programming that we saw in the last lecture, there is really just one main thread. We simply have some tasks that are waiting to be completed, but we don't actually have two threads doing work at the exact same time, whereas over here we do. We can see the main thread is doing work and the pathfinding is also doing work at the exact same time. Whereas if we were just using the main thread without any extra threads, then we would basically be doing this. So this is fully main thread work with no extra threads. And if you look at that, it's first doing the main thread work, doing all of that, and only then starts doing the pathfinding work. So right away you can see the massive speed up difference. We can get literally double the performance by using multiple cores at once. So this here is really the basics of multithreading. It sounds pretty simple. You create a brand new thread to do some work, then you set it to do a bunch of work, and then it can do some other work on the main thread. So it looks quite simple, but beyond this super basic example, it actually becomes quite complex. One very common problem is what is known as a race condition. That is when two threads are trying to do work on the same data at the same time. So let's actually intentionally create a race condition just to see. So up here, let's define a static int for some kind of resource amount. And then let's make a function that is just going to add a ton of resources. So add resources, and over here, let's just do a giant for, let's say by 10,000, something like that, something super huge. Then let's first grab our resource amount, then we increase it by 1, and then we update the resource amount to this temp resource amount. Okay, yep, so we're really just going to be increasing the resource amount by 10,000. And now up here, let's just create a whole bunch of threads. So let's create a thread array for some kind of thread array. New thread array of, let's say, 10 threads. Then let's go, let's cycle through that array, and let's construct a brand new thread. So just do a new thread and pass in the add resources function. So yep, here we are going to create all of our threads. Then let's simply start executing all of them, and then let's call join on all of them to make sure they all finish. And after this, let's print out the resource amount. So console.writeLine on our resource amount, and just print the resource amount. Okay, so yep, just like this, super simple. We construct 10 threads, all of them running the same function. And on this function, we're going to increase the resource amount by 10,000. So 10 threads increasing by 10,000 means that the final number that we see printed here, that final number should be 100,000. So let's see if that's the case. Let's test. And nope, right away we don't see that. We see 72,000. Let's try again. And nope, now we see 80,000. And now we see 83,000. And now 87,000 and so on. So nope, we do not get 100,000, and every time we run, we actually get a different number. So what we have here is what is known as a race condition. Basically, all of these 10 threads, all of them are running this function at the same time. They're all doing work at the same time on multiple cores, and they're all working on the same shared variable. So what happens is, for example, thread A starts running this line of code. So thread A reads, let's say, 15 resources and stores them in here. But then, let's say thread B already ran that line of code. So thread B already read 15, then thread B incremented it to 16, and then thread B updated the variable to 16. But then thread A, which again has already read the value 15, then thread A is going to increase to 16 and save it again. So because of that, we essentially lost one resource. And it's all because of a race condition. It is because we had one thread just reading some data while another thread was already doing some operations on it. Because they're both trying to execute code at slightly different times, we end up with different read and write values. So that is why the result is always less than 100,000. It is because some resources are going to be lost to race conditions. Now, you can imagine this would be very annoying to the player of the game, losing resources for no fault of their own, just because the threads all read logic at the same time. That's pretty annoying. So this is really one of the big problems of multi-threaded code. It is very easy to end up with race conditions and mess up all your data. Now, to solve this problem, we have a very useful tool. It's called a lock. And to use it, we write the lock keyword, and then within parentheses, we put some kind of object that we want to work as our lock. Now, importantly, this one has to be a reference type, so if we use the resource amount, we can see an error. Int is not a reference type. So the lock over here has to be a reference type. So usually we just create a basic object. So let's go up here, make a private static, make it of type object, and just call the resource lock. And let's construct it just to a brand new object. Okay, yep, we have this lock. Now, importantly is this lock should be shared, meaning we should not have one lock per thread. That would kind of defeat the purpose. We want the lock to be shared between all threads. So we define the lock, we construct it, and down here we use that lock, and afterwards we just open and close our code block. And yep, that's it, and just like this, let's test. And there you go, the resource amount, the total is indeed correct, 100,000. Try again, and there it is, 100,000. Once more, and yep, 100,000. So it always works perfectly. Basically over here, this lock, what this is doing is, like the name implies, it is locking this part of the code to a specific thread. So for example, thread A goes through this line of code, and when doing so, it essentially registers this object as being locked. It is being locked as being actively used by thread A, and then thread A starts running all of this code. And now here's the really important part. If thread A is in the middle of executing these lines of code, if then thread B comes along and tries to grab the lock as well, if so, then thread B cannot get it. The lock is already in use. So thread B has to wait for the lock to become available. It cannot run any of this code until that lock is available. So basically thread A, which has the lock, that one does its thing, reads, updates the value, and so on. Then when thread A exits, then it releases the lock, and then thread B sees that the lock has been released. So thread B registers the lock and starts running the logic on that thread. And same thing again, any other thread cannot go inside this code block until the lock is released. So by using the lock, we are making sure that only one thread can be running this code at once. Now, naturally, this does mean that you'll lose the benefits of multi-threading. All threads are waiting for this lock to become available, and only one of them is actually going to do some work. So this is yet another reason that makes multi-threading so difficult. Technically, you can avoid all race conditions by just putting everything inside of lock, but then of course you also have no benefit. So you have to be very clever as to how you use your locks. Use them as little as possible in order to make your code as parallelized as possible. You don't want to overuse them, but you definitely want to use them to avoid race conditions. Basically, knowing what parts of your code need to be locked versus unlocked, that is definitely a skill you need to learn in order to write proper multi-threaded code. Now, another potential issue is something called deadlocks. So this is where two locks are each waiting for the other one to be unlocked. So here's an example of that. We've got two locks, then we define two threads. So this thread opens up lock 1, and then inside it tries to open up lock 2, and then this thread opens up lock 2 and then tries to open up lock 1. Then we start the threads and then we join them. So if we call this, let's see what happens. Let's see if our program ever exits or not. Let's just return. Okay, let's see. And if there it is, then our program is basically stuck. The issue that is happening is over here, thread 1, this one immediately grabs lock 1, and then thread 2 immediately grabs lock 2, but then they are both waiting for the other lock. And that is never going to happen because thread 2 is stuck waiting for lock 1, and thread 1 is stuck waiting for lock 2. Both are waiting for the other one to do something, so nothing really happens. So when working with multiple locks, you also need to take care of this. Make sure you don't have interlocking locks. That in turn means that your program ends up frozen. Then another potential issue of multithreading is simply how it makes your debugging much more difficult. Usually if you have some kind of bug in your code, like for example pathfinding is calculating some wrong path, usually you can just follow the stack trace to figure out exactly what went wrong. You can see exactly what called this function, where the data came from, and so on. But when using multiple threads, those will not run in a deterministic fashion. They will run at different times depending on whatever else your CPU is doing. So you can have bugs that appear randomly every once in a while because the threads ran in one specific order. Because of that, it is really difficult to replicate the bug, which in turn makes it really difficult to debug. Yet another potential issue is simply the cost for overhead. So making threads, this is not free. Creating a thread has some sort of overhead cost, both in creating it and in the CPU managing all the active threads. So in some cases, multithreading can actually end up making your code slower. The CPU might be so busy trying to keep track of all the threads that it actually loses more time than doing some actual work. Like I mentioned, there's no limit. You can create 1,000 threads on a 10-core CPU, but then they're going to run worse than if you just use a main thread because of all the context switching involved. Now, if you want to just do some simple work without the overhead of creating an entire thread, for that, C# has something called a thread pool. Basically, it has a pool of threads that is automatically maintained by the .NET runtime. It efficiently manages all the threads, allowing you to easily reuse them. So you can queue up a bunch of work, and then the thread pool also automatically scales up or down depending on demand. Now to use it is quite simple. So instead of creating a brand new thread, instead of that we just use thread pool, and then we just call queue a user work item, and then we just queue something. This one takes in a wait callback. This one is essentially a delegate that returns void but has an object. So over here, let's make some kind of function for that. Let's call it just do work. This one takes an object. And over here, let's print the thread ID. So let's do a right line, go inside the thread, grab the current thread, and grab the managed thread ID. And let's say this one's starting, then do some work and then finished. So thread.sleep for something. Okay, yep. So we're going to do this work on this thread. And out here, we can essentially just queue up multiple of these. So let's just go for int I. Let's just queue up 10 of these to do this kind of work. Again, we are not creating threads. We are just queuing up some work to work on the thread pool. And then since we don't have a reference to some kind of thread that we can do on join, let's just do a while true just to stop our program so we can read our code. Okay, let's see like this. And if there it is, we can see a bunch of threads start and a bunch of threads finished. So we can see we did a bunch of work on multiple threads at the same time. And it's doing all of this without us having to manually create and start some threads. So thread pool is really great, but it is really meant for small use cases only. If you want to do some complex work on a worker thread, meaning something that does work in parallel for a long time, for that you should probably use a normal thread and manage it yourself. But for small things, thread pool is super easy to use. Now here we've been talking about C# multithreading, how you can create your own threads to do any kind of work. But if you want to properly use it, you need to make some sort of thread scheduler. So something that keeps track of a queue of work to do, and then each thread pulls something from that queue when idle. But if you're working inside of Unity, you don't actually have to build something like that from scratch. In Unity, you can just use the Unity job system. This one is really easy to use, and Unity handles all that complexity for you. It automatically creates a bunch of worker threads and then manages them. It manages those threads alongside a pool of jobs. So then you just create some jobs and add them to the queue, and the job system will pull some jobs and do some work. This one has a bunch of features. It has tons of safety in order to make sure you don't mess up yourself. So when working with Unity, definitely go ahead and use the job system. It is going to be much easier than manually handling threads yourself. You can look at my video on dots to learn how to use it, or you can check out my complete dots course, which also covers the job system, plus ECS, the burst compiler, and a bunch more. Alright, so that's how you write multi-threaded code in C#. This is an extremely powerful skill to know. It is very difficult to do it properly, but if you can do it, you can literally get 10x performance improvements on the exact same hardware. It has a lot of pitfalls like we mentioned, but also a very huge benefit. So this one is definitely a very valuable skill. Although also, like I mentioned, if you mostly work inside of Unity, then I recommend you use the Unity job system to run that multi-threaded code. The job system has a bunch of features to help you write multi-threaded code whilst also avoiding a lot of those pitfalls. Hello and welcome, I'm your Code Monkey. And congrats on completing the advanced section. We started off with an interesting advanced topic that I actually only started seriously learning recently. It's reflection. I had to learn this myself in order to make the exercises for the companion project. That's how they all work. So now you know how you can dynamically inspect your code and work with it without directly calling functions or reading fields. Next we had a simple but interesting lecture. It's how we can make function extensions. These allow us to extend a type with more functions without having to modify that type itself. So this is really useful when you don't have access to that type, when you don't have access to the source code. Then we learned about static constructors. This is kind of like the normal constructor, but they run just once for the entire class. After that, we learned about the type of keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then we saw a lecture on nameof. This one helps us get a string name of some type. This is really useful to help us ensure we don't use strings in our code as much as possible. Next, we learned about the sizeof operator. This one lets us get the size of our types. So for example, we can easily see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps us see how much memory our code will actually use. Then we saw a lecture on default. It's a simple and very useful operator to get the default value of some type. You can get the default value of an int, a bool, an object, and pretty much anything. So this is much better than hard-coding some default values. After that, we saw a lecture on expression-bodied members. This is a really compact way to write simple short functions. There's no need to write all the usual function boilerplate code. It's basically just a lambda. Then we saw a lecture on records. This is a super simple way to create immutable types to organize our data. Next, we'll learn about the null conditional operators. This is how we can easily test for null before doing something, like firing off an event. Then we saw a lecture on the Null-Coalescing Operator. This one lets us quickly test against null and return a default value. After that, we learned about the Ternary Conditional Operator. This is an excellent super compact syntax for making a simple if. You have just a condition with an if and an else. Very tiny, very useful. Next, we learned about the main function in a console app and how to pass in command line arguments. This was a really important lecture because there are so many interesting programs you can build that don't actually need a UI. So just a simple console app that you can control with some command line arguments, just that is going to be an excellent option. Then we saw a lecture on Nullable. This is how we can make any type support null, even value types like int or bool. You can make them nullable to support null. So this can sometimes be much better than having to predefine some special value, something like -1. Then we saw a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create any new objects. It's really just basically a pointer, meaning this is insanely performant. Then we saw a lecture on Bitwise Operators. This is how we can work with individual bits of data. In this lecture, I also taught you the basics of how binary works. Next, we learned about Enum Flags. This is how you can turn your enums into bitmaps, which then allows you to make some interesting combinations. Then we saw the lecture on Preprocessor Directives. With this, we can give orders to the compiler itself. We can define some symbols and include or not include some code in the compilation. Next, we saw a lecture on the keywords ref, out, and in. These are really useful. They help us get more data out of a function than just the single return type. And they also let us work with types as references, even if they are value types. After that, we learned about data boxing. This doesn't have anything to do with punching people. It's just about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we learned about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields, even if, again, that type does not exist. We can write anything and we get no errors. The validation logic only runs at runtime. It does not execute at compile time. So this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, we can make our own custom type support access through an index, just like a list or array. We can add whatever logic we want and make it read-only or read-write. Next, we saw a lecture on attributes. This is how we can add metadata to our code. That metadata can then represent whatever you want. You can then use reflection to analyze it and do something to it. After that was an interesting lecture on anonymous types. This is a really quick, great way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that was the next lecture on tuples. These are somewhat similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next was a lecture on using an IDisposable. This is a really interesting code block and an interface that helps make sure you don't forget any kind of cleanup code. After that, we'll learn how to create custom override operators. Using these, we can add support to our own classes to do things like addition or multiplication. So we can define, for example, the logic of what does it mean to add two custom player classes together. Then we also define the logic for comparing two custom types. So defining what exactly does it mean to do an equals. Next, we saw a lecture on LINQ. With LINQ, we can easily do query operations on any collection of data. So that can be a list, can be an array, XML, or some kind of database. We can query for some conditions to select just a few elements. We can sort something, do a union, do a join, and so on. So if you're already familiar with SQL, then LINQ was probably also quite familiar. Afterwards, we learned about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop components. Here I also talked about other visual program tools like WPF and .NET MAUI. And I also mentioned how Unity itself doesn't have to be used just for making games. You can make normal applications with it. Next was a lecture on DllImport, library import, how to use extern, and work with the Windows API. This was a great lecture to learn how to interact with external libraries. Then we saw a lecture on asserts and unit testing in general. So with this, you can validate your own code to make sure everything is behaving exactly as intended. Next, we saw a lecture on writing unsafe C# code and working with pointers. Now, this is a very advanced topic. Technically, if you know what you're doing, you can make some very impressive stuff with unsafe code, but C# has safety for a reason. So while we'll learn the basics of it, definitely make sure you use this very wisely. Then we also learned about asynchronous programming, specifically how to use async, await, and task. This is how we can have some code that takes some time, like for example contacting a web server, and keep waiting for a response without blocking our program. This is extremely important in making sure our program feels nice and responsive. After that was a super important, very advanced lecture. This one was all about multithreading. This is how we can take advantage of all the cores in the CPU and make them all do work at the exact same time. When done properly, you can get some insane performance improvements pretty much for free, but it is also very, very easy to make mistakes. So this one is very much the definition of an advanced topic where you must know exactly what you're doing. In this section, we'll learn a ton of very interesting, very advanced topics. And yep, all of that concluded the advanced portion of this course. So congrats again on completing this section and on completing the entire course. I hope you took your time and fully learned absolutely everything in this course. This course really started from the absolute basics of programming, like how code works line by line, and we went slowly, little by little, until learning some very advanced topics. So I hope that, regardless of what was your starting point, I hope you learned a lot and you find this course very useful. C# is really an extremely powerful language, and now that you have all this knowledge, now you'll be able to build so many awesome things. You can make games, you can make console apps, you can do electronic stuff, websites, AI, IoT, automation, really just about anything. So I really hope you put all this knowledge to good use. And of course, remember you can always come back to this course at any time. You'll really not expect to memorize all of this. Personally, I Google things all the time myself, and now that I actually have this course in my own words, anytime that I really need to relearn some syntax, I'm just going to come here and listen to my own lectures. So if in the future you need to remember something about C#, just go ahead and rewatch that lecture. So congrats on completing the entire course. I hope you learned a lot and I wish you the best of luck with your future projects. Hello and welcome, I'm your Code Monkey, and congrats on going through the entire advanced section, and importantly, going through the entire complete course. I really hope you learned a ton. I hope you took your time and really focused on learning all the topics covered in this course. If so, then you are now much more skilled, much more knowledgeable than you were back when you started. If you want to try testing out that knowledge, then you can check out the premium version of this course. The companion project includes interactive exercises, along with frequently asked questions and quizzes for every lecture in this course. Remember how you only learn by doing, so definitely make sure you put into practice everything that you're learning. Now would be a really excellent time to do that. Get the premium version, get the companion project, and go through all the content and all the lectures. If you want to test your knowledge, you should be able to go through all the FAQs, the quizzes, the interactive exercises. You should be able to go through all of those without fail. Or at this point, if you want to change things, if you want to try making a game as opposed to the language itself, if so, then now would be a great time to check out my free Kitchen Chaos course. It's on making a game from start to finish, and if you fully understood everything here, then you will have no problems going through this one. There's a free course making the game in single player and a second free one on making the game in multiplayer. Or again, if you fully understood everything in this course, if so, then you have the required skill set to go through my turn-based strategy course. That one is also on making a really awesome game. This one is more on the intermediate/advanced level, so it involves quite a bit more stuff in terms of code architecture, organization, and so on. Or for something super powerful and advanced, for that check out my Dots course. This tool stack helps you write code that literally runs 100x faster. This definitely requires more advanced knowledge, but if you understood fully everything in this course, if so, then you're ready to learn about Dots. Or in general, for Unity knowledge, check out my Ultimate Unity Overview course. In there I cover over 70 tools and features that Unity has. Alright, so thanks for watching this entire free course. I really hope you learned a ton. Thanks for watching, and I'll see you next time.